In our modern age, data is all around us, from the websites we visit, the products we purchase, to the services we use. Every digital interaction leaves a trail of data. But did you know that this vast sea of information holds immense potential for uncovering hidden patterns, making better decisions, and even predicting future outcomes? This is where the fascinating world of data analytics comes into play. Data analytics is the art and science of exploring, examining, and interpreting data to extract valuable insights and knowledge. Throughout this journey into data analytics, you will discover that it's not only about crunching numbers and generating graphs. It's about asking the right questions, using data to find the answers, and making data-driven decisions that create tangible impacts on businesses, industries, and society as a whole. Hello everyone, and welcome to this session by Intellipaat. This session entails everything about data analytics in a beginner-friendly manner. With that, let's take a look at the agenda for this session. We will start with an introduction to data analytics. Moving on, we have statistics for data analytics, under which we will see variance, standard deviation, sampling, probability distribution, and inferential statistics. Then we'll take a look at the data analytics lifecycle. As we move further, we have Excel for data analytics, where we'll understand Excel formulas and functions, linear regression, VBA and macros, and how to use macros recorder. Then we come to exploring Visual Basic Editor, machine learning fundamentals, and an introduction to Python. Then we'll discuss a few important data analytics interview questions. And lastly, we have a data analytics roadmap, where we'll discuss all about the required skills, programming languages, data analytics tools, and basics of machine learning. Remember that becoming a data analyst is a continuous learning process, and practical expertise is necessary for developing confidence. As you begin your career as a data analyst, be persistent, work on real-time projects. Now before we begin, please make sure you subscribe to our YouTube channel and hit the bell icon for regular updates from us. Now let's get started.
What is data analytics? Data analytics is the buzzword you would have heard a lot about in the recent years. To put it simply, it's the process of analyzing raw data to get insights and find patterns about the information. Using various techniques and processes, the raw data is transformed into a format which could be further visualized and be made human readable. To understand the definition in an even clear way, let's take a look at this example. John, who is a digital marketing professional, is running an online advertising campaign to promote a new smart television. John starts by targeting the group of people who might have bought the previous versions of the smart TV in question. As said campaign runs, data analytics comes into the picture through the data generated whenever people clicked on the published advertisement. Now, by inspecting the data about these users' interest and their buying patterns, you might come across that many of them are interested in streaming 4K UHD video. The reason behind this might be that the new smart TV has a better streaming quality than the previous versions. Using this information, you could tune in your advertisements to focus on users who bought the previous version of the smart TV and are interested in getting 4K streaming quality. This data can also be used to attract new customers who did not go for the previous version of the smart TV but are very interested in a better version of the TV. Why is data analytics significant? Businesses use data analytics to optimize and grow by making better business decisions and finding more efficient ways of doing business. The company can build new and better products with the buying patterns and better understanding what the customers need. So how do data analytics work? The data analytics process has some components that can help a variety of initiatives. By combining these components, a successful data analytics initiate will provide a clear picture of where you are, you have been, and where you should go. Generally, this process begins with the descriptive analysis. This is the process of describing historical trends in data. Descriptive analytics aims to answer the question, what happened? This often involves measuring traditional indicators such as return on investment. The indicators used will be different for each industry. Descriptive analytics does not make predictions or directly inform decisions. It focuses on summarizing data in a meaningful and descriptive way. The next essential part of data analytics is advanced analytics. This part of data science takes advantage of advanced tools to extract data, make predictions, and discover trends. These tools include classical statistics as well as machine learning. Machine learning techs such as neural networks, natural language processing, sentiment analysis, and more enable advanced analytics. This information provides new insight from data. Advanced analytics addresses what if the question. Data analytics affects every aspect of our day-to-day lives. You may not even realize it, but you probably use data analytics almost every day. Here are some of the everyday applications of data analytics. Social media stats instantly register anytime there's a visitor or a post to a page. Cell phone bills can pull up months of calling data to show you patterns of usage. Sensors monitor the changing weather and report that data to you instantly on your smartphone. Sports fans collect statistics on their favorite athletes and often use the data to form the term of fantasy leagues. Schools across the nation are involved in high-stakes testing that generates voluminous data on each student's progress. Educators then utilize data generated from extensive reports to drive their instruction. Data analytics is a growing field and will always be a top domain to get into. The average salary of a data analyst in India is 7 LPA and in the US it's $70,000. There are 27,000 plus data analytics jobs available only on LinkedIn, and there are very few skilled professionals to fill that gap.
Let's have a quick quiz question, guys. And your question is, data analytics uses dash to get insights from the data. And your options are statistical figure, numerical aspects, statistical method, or none of the above.
Just a quick info, guys. Intellipaat offers state-of-the-art data analytics course in association with IITM Pravartak. Through this course, you can learn all the important tools and concepts of data analysis such as Power BI, data wrangling, data mining, etc. from esteemed IIT Madras faculties and industry experts. With this course, we already have helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take a first step towards career growth in the field of data analytics.
We've all heard this term somewhere. It pretty much rings a bell that every time we think about it, right? So analytics with respect to data. Well, what are we trying to analyze is what we need to know here, right? So the formal definition of how it goes, it's basically extracting meaningful information from raw data. It's as simple as that. So we have data, right? So consider anything to be data. If that is not useful to you at that point, it is considered as data. But then if you perform some operation on this data and make sure that it is useful for your organization, this is when the data becomes information. And this information is what is usable for you, right? So the process of pretty much converting raw data into information by performing certain analysis on it can be termed as data analytics, guys. I mean, this is just a very rough definition of what goes in the industry. To give you a better insight of what that means, basically it is the pursuit of extracting meaning from raw data using specialized computer systems, guys. And then these systems, they transform, they organize, and they model the data. End of it is to basically draw the conclusions from all of the data. So you'll have, again, as I've mentioned with the raw example, our goal here is to basically draw conclusions, to identify patterns, to make use of this raw information in a better way. I mean, sure, data can just be used in its raw form, but then not with every case, right? And to give you an example, so think of the data, probably you understand. So let's say you're looking at a huge data set which contains thousands of values. Those are just numbers, right? So having these numbers, sure, as a data analyst, you will understand what you're doing. But then let's say you need to explain it to a person who doesn't know what data analytics is, or you need to explain it to someone, probably your peer or someone above you as well. Let's say you have a business meeting where you have to explain this. Giving the numbers will not really be that great, right? It will not make a very good presentation. So converting all of these numerical data, making it into graphs, making it in a way where everyone understands the data, and showing out graphically whatever insights that you can generate from the data, that can be considered as data analytics as well, guys. Again, today basically the field of data analytics is ever so growing rapidly. And why is it growing so rapidly? Well, because the market demand for it is that much. So we have pretty much every startup companies these days have a requirement for big data as well. So big data, to dumb down the definition, it pretty much means a huge amount of data that cannot be handled by just one machine. If you're stretching out your data across multiple nodes, you have data coming in from various sources. Then you need a method to handle all of this big data that's coming in, to process the data and then to perform analysis on it, guys. So this has been in demand in the market for a while, and for the last couple of years, data analytics has been in the boom, and then it's providing a very straight answer to all of the questions being raised about how all these can be handled, guys. And of course, we're going to need the people who have the skills which is needed, skills which are needed to manipulate all the data queries, to translate all these numbers into graphs, and to make insightful analysis on it, right? So that's what is the main key role of a data analytic person. What is the need for data analytics if we have to break it down into 3 steps, guys? So again, we already know that it is on the rise, right? So I can pretty much go about to step out into the open and then tell you that it is not soon that it will be an integral part of an organization. It is already an integral part of every organization there is, guys. So the first important need is, again, we already know that it is a top priority for all of these organizations, ranging from the small organizations all the way till the big guys. And then this is needed to make very good decision making. Well, with respect to you being confused to, let's say, take a decision for you, then looking at this analytics will make your decision making skills and decision taking skills a little bit easier, and it'll be more validable as well, guys. And it'll be more validated as well, guys. And the second thing is to we require new revenue, right? So let's say you have the data which pretty much only a couple of people can make sense of understand. Let's say your market is very niche. In that case, sure, you'll be still making revenue, still be making money on it. But then at the end of the day, if you have to reach out to a broader audience, you need to make sure your data is understood by this broader audience, right? So that forms the second very important need for data analytics, guys. And the third one is to obviously decrease these operation costs for every organization. So this can be a very demanding task if you have to convert raw data into information, process the data, and make out very good visualizations out of it as well. But then if you have the workforce for it, then sure, you can do it. But if not, again, since it's probably a manual task, and until a couple of years ago, it surely was a manual task. And these days you can implement machine learning and data analytics to pretty much automate itself and make your job easier as well. It speeds up your work. It keeps you very efficient in such a way where your data is being visualized, processed very effectively. So again, time is money when it comes to big organizations, right? So on that note, pretty much it helps decrease all of the operational costs with respect to, either waiting in the data pipeline, or waiting to process, waiting to publish, waiting to do some analytics, waiting for visualization. All of these waits, you need not consider them anymore, because they will pretty much be reduced to null, guys. So on that note, you might be wondering, who are data analysts, right? So data analysts are the people who sit at the end of the chain. I'll just explain the chain in the next slide. So these guys form a very good workforce for the company, where they basically, deliver the values by taking in all the data that data scientist might give it to them, a data engineer might give it to them, and then he uses data analyst uses all of these to answer a couple of questions and then communicate all of the results back. And all these results that he just gives back is basically used to take very good business decisions, guys. It might include analytics of past trends, it may be prediction of what the future looks like, and so much more. And then the common tasks done by data analysts are data cleaning, performing analytics, and then creating visualizations. Well, data cleaning to come about it is basically simple, guys. So again, data is raw information, right? To make sense out of it, to pick out information that we only require, and to make sure that, again, efficiency is the game here. If you're pretty much processing data that we pretty much will not require, then it's just a waste of time and resource. So cleaning the data, making sure that your data is just perfect enough for processing, that's a very important first step, guys. So this is the spearhead of a data analyst's role. And then the second one is, obviously, as soon as your data is clean, you need to perform some very good analytics on it and create very good visualizations, guys. So these four designations you see on the screen right now is basically the designations a data analyst is also known by. So the first is a business analyst. So data analyst is also a business analyst. He or she can be an operations analyst, a business intelligence analyst, and a database analyst as well, guys. So coming to the tasks that they pretty much do, the first important task that we already spoke about was cleaning and organizing raw unstructured data, right? So this is again a very overlooked concept in today's world, unless you get your hands dirty with the data itself. When you start to go about doing that, you will realize that cleaning and organizing the raw data is extremely important, because at the end of it, your data might be unstructured, your data might be semi-structured, or it might be a structured data. This will not matter if the data you're processing is of no use at the end, guys. So cleaning and organizing raw data is very important. And then the second thing is the analysis of all of the hidden trends found in the data. So making sense of something, again, maybe predictions in the future, or looking at past trends, generating this sort of an information which you cannot figure out upfront just by looking at the data. This is pretty much the umbrella under which the hidden trends function of a data analyst's work. So you'll be looking at a data, you'll find something very interesting. So let's say you find a trend in your data where pretty much you can access a new side of the market with respect to your sales in the next 5 years, 10 years. And then you were not told this, but then your data was telling you this. So you making sense of the data in which this trend was found, which was not upfront, then this is again a very important skill of a data analyst as well, guys. And the third important thing is pretty much the big picture view using descriptive statistics. At the end of it, sure, we know what the past trends of the company are, we know how the company is going on now, but then if you need to just summarize all of this and say even add some predictions for the next 5-10 years, getting this big picture view of what's happened, what's happening now, and what will happen in the future, not just using very simple statistics, but using descriptive statistics, where we'll be picking up each aspect of what's going on and then perform analytics on it and find out what's going on. If we are right at this place, if we are wrong at this place, how can this be improved? How can this concept be checked? How can we reach the clients better, and so much more. So getting this big picture view is again a very important task a data analyst goes about doing, guys. And the fourth one is probably the most important thing a data analyst does, is pretty much the creation of dashboards and visualizations, guys. So as I already told you in the introduction part of the video, where we're starting out with raw information, again a lot of numbers, but if you have to show these numbers at a business meeting, numbers are numbers. Some people like them, but a majority of the people who they might not understand the numbers. So making these numbers as your input, creating very good visualizations, giving them a user interface, and giving your customers, your peers, your superiors, your business meeting members, giving them a very good user experience with all of this data. Again, at the end of it will add up to very good business methodologies, and then it will help you take better business driven decisions again. And again, the same goes for presentations of results to your clients and your internals as well, guys. So coming to the chain of how the data moves around in a firm, I have 3 important things that I just want to walk you through, guys, in a quick gist. So the first person who is the spearhead of the data for an organization. By spearhead, I mean he's the first one who look at the data, or he'll be responsible for bringing in all of the data from various sources, guys. So data coming in from the various sources, right? So think about all the data you can get from Twitter, or if you're performing any sentiment analysis, think of all the data that can come from all of the big data sources. You can have data coming from your various nodes from Hadoop, so much more. You can have your data coming from your own network, away from your network, and so much more, guys. So the data engineer is a spearhead who handles bringing in the data and making it understandable by the organization, guys. And then as soon as the data engineer finishes his part with the data moves on to the data scientist. The data scientist, he's responsible for working on all of these raw data, converting it into valid information. But then we already told this for the data analyst as well. Well, the data scientist pretty much uses machine learning algorithms. He uses deep learning. He uses, let's say, binary classifications, naive bias. He makes use of so many concepts here that a data analyst might not know. And he uses a lot of machine learning and deep learning, as I've already mentioned, to convert this raw data into valid information. And 99% of the time, the information which is being converted into are numbers, guys. So after the data scientist pretty much goes about doing his magic onto the data, and then we have the data analyst who steps in. This person, again, as we've already been mentioning, he is responsible for the prediction of what happens in the future, that is finding out trends, and then the presentation of all these informations to your peers, to your clients, to your superiors, and so much more. This is the basic gist of how data moves around. So the data is first seen by the data engineer. He does his job, comes to the data scientist. The data scientist works his magic via all these fancy algorithms and whatnot, and then pushes the data to the data analyst. The data analyst performs predictions, sees trends, visualizes the data, makes it presentable for everyone to understand, and then eventually goes about analyzing the data, guys.
Data is nothing but any information that can be translated into useful information. The data can be collected through various sources and accumulated in different formats. The analysis and statistical methods are used to make sense of unstructured and structured data to gather useful, actionable insights for decision making in domains such as healthcare, policy making, sports, finance, etc. And now that we have a slight idea about what data is, let's go ahead and understand the various types of data that is available to us. There are mainly two types or categories of data. There are two types or categories of data that can be translated into information: qualitative and quantitative data. So when we talk about qualitative data, it is the kind of data where we cannot express the measure of the information in terms of numbers. Qualitative data expresses the quality of certain features. For example, the data collected through questionnaires, surveys, and similar sources gives the qualitative perspective of information, like what is the qualification of a student, how many schools did one person change during their educational life, etc. Moving on to quantitative data, this type of data gives the exact information in terms of quantity. A simple example would be, what was the revenue for the third quarter of a fintech company? What was the average temperature in the month of January for the city of New York, etc. To understand the difference between the two, let's take a look at some of the key points that can help you differentiate between qualitative and quantitative data. The very first distinguishing point is that qualitative data will describe the quality of the information and the quantitative data will describe the quantity. After that, we can distinguish between qualitative and quantitative based on how the data is collected. In qualitative data, the information often is categorized into various categories, and for qualitative data, the information is gathered based on numerical significance as discussed in the examples in the previous section. Another distinguishing characteristic would be to just observe. Let's say in an event, if the information gives answers to why and how of an event, it is qualitative in nature. As for quantitative data, the event answers the information in terms of how many. The next difference is qualitative data is subjective in nature and contains unique information, while quantitative data describes a fixed information. Last but not the least, the analysis of qualitative data is done by grouping the data into categories, while quantitative data is analyzed through statistical tests and measures. The types of data are further divided into discrete, continuous, categorical, and ordinal data. So let's take a look at each of them one by one with examples. Discrete data is a type of quantitative data that contains finite information which is countable and non-negative in nature. Only a limited number of values are possible in a discrete data. The most common example would be how many students are present in a class that only teaches mathematics. There can only be a finite number of students that will be present in the class and cannot be further subdivided into categories. Another example would be the number of companies that sell healthcare products in a state, or a customer purchasing information in the last quarter, etc. And now that we are done with discrete data, let's take a look at what is continuous data. Continuous data, on the other hand, is the complete opposite of the discrete data. In this type of data, any numerical infinite value can be present in the given range. For example, the daily average temperature of the city, or the revenue of a company over the last 3 quarters. Or another example could be the measure of height for the adult males over the age of 25. And now that we are done with continuous data, let's take a look at categorical data. The categorical data is simple to understand. It is qualitative in nature, first of all, and it contains data that is classified into categories. These categories can be binary or nominal in nature. For example, gender of a person, educational qualifications, species of a virus mutation, etc. The significance is that there will be a finite categories in which the data can be categorized. And now that we are done with categorical data, let's take a look at ordinal data as well. Ordinal data, despite being qualitative data, has some numerical significance. Although there are numerical categories involved, the data is still going to be confined in a categorical state. A simple example would be the world rankings of football players, or the data that describes the shoe size of an individual in a given standard unit of measurement. It will always fall in certain categories that will also be numerical in nature. So that's all for data and different types of data, guys. The significance of learning different data types is to understand how our analysis is going to be orchestrated, since different types of data has specific properties and the statistical analysis uncovers insights in the most efficient way. If the data presented is aligning with the statistical method that is being used. For example, if we have to perform an AD Fuller test of stationarity, we must make sure we present the time series data for the test in order to get efficient results. Another example would be a chi-square test of independence, which only works with categorical features. So what is statistics? Statistics in a nutshell is the study of data where mathematical calculations are used to create assumptions that are backed by statistical evidence and help in understanding the data better. To understand to which extent the analysis can be beneficial, let's understand how data science is driven by statistics in real-world scenario. Data science is nothing but a fancy term that incorporates advanced statistical techniques that draw rigid insights and conclusions about your data. Used in predictive analytics, in machine learning algorithms, the basic idea is maximizing the potential of a statistical problem and quantifying the same in terms of data science. Statistics being the core of any machine learning algorithm, it helps in identifying the trends and patterns in the data for further analysis. Statistics goes on to help in feature selection, for model building, and feature engineering as well. And these are just some of the ways statistics has shaped the data science ecosystem. Now, let's go ahead and learn a few basic statistical measures that define the data. So first of all, we have the mean. So what exactly is the mean of any data? Mean of any given samples is nothing but the average value of the sample. The mean is calculated by adding all the sample values or summing all the sample values and dividing the same with the number of observations in the given sample. In Python, NumPy and statistics modules provide a simple function that will calculate the mean of the sample as shown in the example. Here we have a sample which has the numbers 1, 4, 2, 6, 8, 3, 1, 5, 7 and 9. So to calculate the mean, we're just using this function which is on the back end, summing up all the values and dividing the same with the number of samples. So that is why we are getting the sum or the mean as 4.6. Now that is all about the mean of the data. Let's move on to the median. So coming to the median of the data, the median is nothing but the middle value of the data. In the example shown here, we have 10 observations in the sample and we will measure the median by putting the formula to work, where the sum of the fourth and fifth element of the sample in a sorted setting will be added and divided by 2. Otherwise, if the number of number of observations were odd, the median value would have been n plus 1 divided by 2, which is going to be 11 plus 1, that is 12 by 2, that is the 6th position in a sorted setting over here. And in this case, if the observations, let's say for example, were 11, the median would have been the 6th element in the sorted sample. In our case, it would have been 5, I think. Alright, so now we'll move on to the third concept over here, which is the mode of the data. So when it comes to the mode of the sample, mode is nothing but the most occurring value in the sample. For example, if a sample had 1 occurring the most number of times, the mode of the sample will be 1, as you can see over here in that example. Let's say we had 4 written 3 times over there in the sample, the mode would have become 4 over here. And when you say if we have a distinct sample where all the sample values are distinct observations, the mode of the sample will not be defined and will not exist. And now that we are done with mean, median and mode, which are basically the central tendencies of any data when we describe it in any problem, for example, for exploratory data analysis or for any statistical problem, mean, median and mode will give us the central tendencies of our data or the sample. And now that we are done with these, let's go ahead and learn about variance and standard deviation. So when we talk about variance, in simple terms, variance is nothing but a measure of how far the data point lies from the mean of the sample or population. To calculate the variance of a sample, we will follow the formula shown in the picture over here that we can see. To calculate the variance, we will subtract the sample mean from the actual value and divide it from the number of observations in the sample, the square, and we are going to square the outcome, and we will perform this for all the values. So that is how we calculate the variance of any sample. So what exactly is sampling? Sampling is a technique in which a small subset from a very large set of data is taken for analysis or for performing statistical tests. Now on these samples, we can draw conclusions based on our analysis and deduce the same for the entire data as well. This kind of sampling method saves a lot of computation time since the entire data is converted into smaller samples. To understand this better, let's take a look at what exactly is population and what does it mean to get a sample from a population. To understand the difference between sample and a population, let us consider an example. So let's suppose there is an organization with 1,000 software engineers. Now the sample from the population will be a small set of individuals who are working in the organization. It could be 30 individuals, it could be 50 individuals, and so on. But the entire workforce in the organization consisting of software engineers will be called the population. And we can perform various statistical tests to draw consistent conclusions about the entire workforce. But to know how we have sampled the entire sample with those 30 to 50 individuals, we must understand various sampling techniques that can be used to sample the data for big populations. So let's go ahead and understand the various sampling techniques. The types of sampling can be divided into two groups: probability-based sampling and non-probability based sampling techniques. Here we have four sampling techniques for each probability and non-probability based sampling, and we'll be covering them in the session. So first of all, let's talk about probability based sampling. So the probability based sampling is a random and it presents strong statistical findings. On the other hand, non-probability based sampling takes sample observations in a not so random manner. It is rather motivated based on convenience and other criteria that we will learn about in the next section. Now let's go ahead and learn about the probability based sampling techniques. The first one that we have is simple random sampling. In simple random sampling method or technique, it is easier to understand, or we can say it is the easiest to understand among all the sampling techniques. In this technique, the probability of an observation from the population is the same in order to make it to the sample. For example, if we take the same organization from the example that we have discussed over here, if we were to make a sample of 20 individuals from the population, the chance of an individual from the pool of 1,000 individuals is going to be equal for everyone. Meaning, every individual has an equal chance of making it to the sample, since the entire process is going to be random. And this is it for simple random sampling, guys. Next up, we have systematic sampling. And in this technique, it is quite similar to simple random sampling again, but there is just one catch. So we have specific intervals that are decided for the entire population, and the individuals are picked from those specific intervals only. For example, if we were to get 20 individuals for the sample, we will create an interval of, let's say, after 50 individuals. So after every 50 individuals in the pool, the individual will be picked for the sample. It is similar to random sampling in a way where the intervals can be random. Therefore, an element of randomness is always going to be there in the sample. Next up, we have stratified sampling. In stratified sampling, the entire population is divided into subcategories, and the final sample is taken from each of the categories. For example, we will create subcategories based on years of experience for the individuals in the organization. Now, based on these categories, let's suppose we have taken experience level from 0, 1, 2, 3 until 5 years and so on. So we will pick individuals at random from each of these categories to make up the sample of 20 individuals. So that is how stratified sampling technique works. And next up, we have a cluster sampling. This one is a little trickier to understand. In the cluster sampling, we do create subcategories, but each of the subcategories will have a similar attribute with respect to the entire population. Now, instead of choosing individuals from each category, the entire subcategory is chosen as a sample. So this type of sampling can create some sort of sampling bias and cannot represent an entire population. For example, we will create subcategories of individuals that work in IT sectors, but the employer for all those individuals in those subcategories will be similar, which is kind of a similar attribute for all the individuals in the population, and then choose any of the subcategories at random to be our entire sample for the population. I hope this is clear to you guys. And now that we are done with probability based sampling methods, let's learn about the non-probability based sampling as well. So in non-probability sampling method, the first one that we have is convenience sampling. Convenience sampling are highly prone to selection bias and sampling bias. And because there is no randomness while selecting the observations for the sample, that is why it has bias in it. It is called convenience sampling because the samples are formed quite conveniently. For example, let's say if we have to create a sample of 20 individuals from the entire population of 1,000 individuals from the organization, we will just pick the first 20 individuals that we can get our hands on. So that is how convenience sampling works, because it is convenient. I'll just pick up 20 individuals or the observations for my sample, and that is how convenience sampling works. Next up, we have purposive sampling. In purposive sampling, the sample observations are taken out after an expert provides a useful insight about the sample that must be collected. For example, there is a stakeholder or the expert in this matter who is going to inform the analyst to only choose the individuals between the age of 18 to 20, because that is what the sample needs to be for the analysis or the survey. And all those sample observations will be drawn according to the input given by the stakeholder. So that is how purposive sampling works. And next up, we have snowball sampling. This is also a little bit trickier when it comes to understanding. So when it comes to snowball sampling, the access to the exact observations that are required might not be present in the sample. For example, if we want to conduct a survey on school-going students under the age of 12, but the population only consists of individuals who may or may not have children. In this case, what we are going to do is we will rely on the information collected from the individuals from the sample, and the sample will have individuals who might or might not have kids below the age of 18, or in this case below the age of 12. I'm sorry about that. Repeat. Below the age of 12. And that is why it is called snowball sampling, because we snowball to our sample observations from one sample to another. And last but not the least, we have quota sampling. And in this type of non-probability based sampling, we have to keep the similar population attributes in the sample as well. To understand this, let's take a small example. So let's suppose our population has 40%, or in this case we have population consisting of 50% individuals between the age of 18 to 25. So this means that in quota sample, the sample will also have the same percentage of individuals having ages between 18 to 25. Let's take another example. For example, let's suppose that our population has 40% of females and 60% of males in the entire population. So when I'm making a quota sample, or when I'm doing the quota sampling technique, the same proportion of males and females are going to be present as well in the sample, which is in a sample of 20 individuals, if I'm taking for this population 12 males, which is going to be the 60% of the entire sample, and 8 females, which is going to be 40% of the entire sample, are going to be present according to the quota sampling. So we are going to start this session with descriptive statistics. So what exactly is descriptive statistics? Descriptive statistics is the field of study where you can analyze the various metrics of the sample. That will include the following, which is basically frequency distribution, we have measure of central tendency, and the measure of variability. Although there are two types of descriptive statistics approach, that is univariate and multivariate descriptive statistics. In the univariate descriptive statistical analysis, you have only one variable that you want to analyze. And in the bivariate analysis, there are going to be multiple variables that are involved in the descriptive statistics approach. Now let's talk about these three descriptive statistics approaches, or basically the metrics. First of all, we have the frequency distribution. Frequency distribution is nothing but how the data points are distributed in the sample. For example, you would want to know about various data points for categorical samples that include ages or height or weight of various genders in a class taken from a population of an entire school. The simple frequency distribution or the group frequency distribution, it can tell if your sample is skewed or normally distributed, and getting these insights can help you in further analysis of the samples that you will learn while we are working on the hypothesis testing. In the frequency distribution, we have normal distribution, the skewness, that is positively skewed, and the negatively skewed data. For a normally distributed data, or in a normal distribution, if you plot the histogram of all the data points, it will form a bell curve in which the sample's mean, sample's median, and the sample's mode will all be the same. This basically means that 50% of the samples will be less than the mean, and the other 50% of the samples will be greater than the mean of the sample. Now, when we talk about the positively skewed data, in a positively skewed distribution, also called as a right skewed distribution, the distribution is concentrated on the left side of the curve, where the mode is less than the median and the median is less than the mean. Similarly, in negatively skewed data, or a negatively skewed distribution, also called as left skewed distribution, the distribution is concentrated on the right end of the curve, where the mean is less than the median and the median is less than the mode. I hope this is clear to you guys. So now let's talk about the measure of central tendency. If you have any doubts or if you have any questions mid-session, guys, you can mention them in the comment section below so that we'll be able to help you better and resolve your queries. Alright, now coming back to the session, the measure of central tendency. The measure of central tendency is nothing but the mean, the median, and the mode that we have already discussed in the frequency distribution, and these metrics tell us the central tendency of the sample. The other metrics that are included in this are minimum, maximum, the count of the distribution, that best explains the measure of central tendency of the sample. Alright, moving on, let's talk about the measure of variability. Now, the measure of variability is nothing but the range of the distribution, the standard deviation, and the variance that best explains the variance or the variability of the sample. Now, when we talk about range is nothing but the difference between the largest and the smallest value in the distribution. And similarly, standard deviation is nothing but the average of the distances from the mean. When we talk about variance, it is the average of the square differences from the mean. So we'll cover the theory part here for this entire session, and once we are done with that, we're going to move to the hands-on part where we'll be implementing all these descriptive statistics. Now, after that, we'll discuss inferential statistics. Everything we will be doing on Excel, or we will be using the Google Sheets for that, so that it is accessible to all, obviously. Now, and since now that we're done with the descriptive statistics, let us also learn about the inferential statistics as well. So what exactly is inferential statistics? Inferential statistics is the field of study where you will draw conclusions about the sample using various statistical tests and population parameters. Alright, so the two main fields of statistical analysis include making estimates about the population using the sample statistics, and the other one includes hypothesis testing that draws conclusions about the population based on statistical evidence. We will learn about both of these. And the other major concepts that are involved in the inferential statistics are, the first one is correlation. Correlation is nothing but a measure or metric that defines the relationship between two or more variables. It gives us an idea to what extent two variables are related to each other. The correlation can be positive, negative. The values between -1 to 1, where -1 shows strongest negative correlation and 1 shows the strongest positive correlation. Whereas if you have 0 as correlation, it basically means that there is no correlation at all. And we must not confuse correlation with causality. It's something that everybody must remember if they're working on any machine learning projects or descriptive or inferential statistics as well. Like, although the latter, that is causality, seems quite similar to the correlation between variables, but causation explicitly causes an event, whereas correlation is just the relationship between the variables. So never confuse yourself with correlation and causality. Always make sure that you have a distinguished understanding of both these concepts, so that you don't make any mistakes in the future while you are analyzing any set of data. So next one in inferential statistics is covariance, the measure of two features to vary together. That is known as covariance. And to calculate the variance of two features, we calculate the average of the products of the deviations of the sample features from their means. And the objective of calculating the covariance, it can tell us the extent to which two features will vary together. It helps in estimating the direction of the relationship between the two features of the sample. If both the features tend to increase or decrease together, the covariance coefficient is positive. And if one feature increases and the other decreases, or vice versa, the covariance coefficient is going to be negative. So that is what you have to remember when talking about covariance, because the covariance coefficient is something that you will analyze, and that is how you are going to estimate whatever inferences you're getting from your sample. And last but not least, we have the confidence interval. So whenever we make estimates about a population based on sample statistics, the confidence interval gives us the range in which the estimates will fall for a certain population parameters. For example, the confidence level such as 95% or 99% gives the estimate of how many values from the population will adhere to the sample statistics that was estimated using the statistical analysis on the sample. Now let's just take a real life example here. Let's say the heights of two groups were recorded in a survey, and the average height of the group turned out to be the same for both the groups. Alright, but the variance of height is in one of the groups was more than the other. Now the range of the confidence interval for the group that had more variance will be larger than the other group. So the point estimates that can be used for calculating the confidence interval include proportions. You can use it for population means. You can also use it for estimation of variances amongst various groups. And let's now go on to understand what exactly is hypothesis testing, and how these statistical tests can be used to draw conclusions about the population. So before we move on to the test, let's just discuss what is hypothesis testing in general. All right. So the process of hypothesis testing is carried out to test theories or assumptions on a sample of data that will help in drawing conclusions about the entire population. The statistical test is backed by test statistics that help in accepting or rejecting the hypothesized theory or assumption. The following steps are involved in hypothesis testing. First one, formulating the hypothesis, which can be null and alternate hypothesis. For example, let's say if you are testing if the proportion or the mean of two samples is equal or not. So there'll be a null hypothesis which will state, okay, the means of the samples will be equal, and then there'll be an alternate hypothesis which will say no, they are not equal. The second one is collecting the data to test the hypothesis. You have to collect the data in certain way. For example, if you are running a specific type of test, then you have to make sure that the data is according to the assumptions that are taken by that particular test. For example, if you have a AD Fuller test, we have a AD Fuller test where we check the stationarity of a time series. So to do that, you need a time series data. So that is what I mean when I say collect data to test the hypothesis. After that, we have performing a statistical test, which could be checking the mean, checking the proportions. You can check for the variance, etc. Moving further, we have the fourth step, which is rejecting or accepting the hypothesis based on the test statistics. So basically, whenever you perform a statistical test, you have to make sure that whatever test statistic that you've got, you have to run it by a few pointers that we already have for each test. Now, based on that, you have to reject or accept the null hypothesis so that you can use it for the fifth step, which is form your conclusion about the population. So these are the steps that are involved in hypothesis testing. Now let's take a look at some of the statistical tests that we can use for hypothesis testing and that are also available in Excel for you to perform. Alright, so the first one is the Z-test. The Z-test is used to test if the means of two populations are different or not, like provided the sample follow a normal distribution. Now here we have to pay attention to this particular statement, which means the samples will follow a normal distribution, which basically means if your sample is following a normal distribution, you can easily use the Z-test to check if the two populations are different or not. Now the Z-test can also be performed on one sample, two samples, and for proportions as well. The Z-test can be classified as a one-tailed or two-tailed hypothesis test based on parameters. We will be taking a look at all these, the things that I'm talking about, the one sample, the two sample, the one-tailed and two-tailed test while we are, performing the hands-on demo. Right. Moving back to the session, there are certain key points that must be considered when going for the Z-test, which is, first one is the Z-test is performed on samples that follow a normal distribution, which I've already told you, and are greater than or equal to 30 in size. So for every sample that you have from the population, if the samples are more than 30 and follow a normal distribution, you can use the Z-test for any statistical analysis, basically for checking the means of the two populations. Now it is also used to check whether the population mean samples are equal or not when the variance of the population is known. So for you to perform a Z-test, you must know the variance of the population. That is also an assumption that we have to take, or that is also kind of a necessity while performing the Z-test. In a one sample Z-test, it is checked if the sample mean is different from the population mean when the population standard deviation is also known. So if you know the variation of the population, it is obvious that you can also figure out the standard deviation of the sample as well, or the population. So in a Z-test, there are three things that you have to make sure: that the data follows a normal distribution, is in 30 or more size, you have to know the variance of the population, and you have to know the standard deviation of the population. Now moving further, to perform a one sample Z-test in Excel, what we have to do is basically use the z.test function that is used to perform the one sample Z-test. We have to basically input the range of the variables in the function that we'll see while performing the demo. We have to input the population mean and calculate the test statistics. Based on the test statistics, we accept or reject the null hypothesis. Similarly, in a two sample Z-test, we calculate the variance of the two samples. We navigate to Z-test in Excel Miner. So that will be the add-on we'll be using while working on Google Sheets. Or you can use the Excel Miner add-on on Excel as well. We basically have to input the variable ranges, the variance, and the hypothesized means. For example, if we have our null hypothesis which says the means of the two samples are equal, we have to give the hypothesized mean as well, the mean difference basically. If those are equal, the mean difference will be 0. After that, we analyze the test output, which I'm going to show you while working on the demo. And moving further, we'll have to just reject or accept the null hypothesis based on our analysis. Now let's talk about the t-test that we have. So the t-test is also one of the statistical tests that is used in hypothesis testing, and it is mainly used to compare means of the two samples and determine whether they are different or not. There are three categories of t-test. One is the one sample test, which is basically if you are testing the sample for specific value, then we use the one sample test. And for two sample test, we basically use the two sample test when the groups come from different populations. Now if the two samples or the two groups are coming from the same population, we are going to use the paired t-test for that. And with the t-test also, there can be one-tail, two-tail hypothesis test for means, based on if you are basically looking to get the directions for your assumptions as well. And there are mainly a couple of assumptions made during a t-test. First one is the sample is a random sample, so the sample has to be a random sample in the case of t-test with an approximately normal distribution, or it follows a t distribution, and there is homogeneity of variances amongst the group. Alright, so when we talk about the paired t-test, it is basically used when the two samples are taken from the same population. While using a paired t-test in Excel or in Google Sheets, you just have to navigate to Excel Miner. There you will have your options to choose from, and then basically you get the variable ranges, the hypothesized mean difference, and analyze the output to check one tail or two tail test based on your test statistics, and based on those you reject or accept the null hypothesis based on the findings. Now coming to the two sample t-test, which assumes equal variances, you navigate to the paired two samples with Excel Miner, and then you select the ranges with the hypothesized mean difference, and the entire procedure is same. You just get the different test statistics and the output where you will basically have to analyze a few things, because you have assumed equal variances. Then the other option is unequal variances. So if you don't know if the variances are equal or not, you can use the F test, which we are going to talk about next, and using that you can basically go for either the two sample t-test for equal variances or the two sample t-test for unequal variances. So moving further, let's talk about the F test. Now F test is a statistical hypothesis test that is used to test whether the variances of the two groups are equal or not. Now depending upon the problem, we can get the direction of the variances using a one-tailed F test, or simply compare the group variances with two-tailed F tests. The F test is performed on F distribution, and it basically is to test the group variances, and depending on the F critical and F statistical value, the hypotheses are accepted or rejected. Now we have these steps that we can follow, where we'll basically have to navigate to F2 test sample for variances in the drop down menu for Excel Miner. Then we basically select the descriptive statistics from the menu, enter the columns to be analyzed, and output the format, check the output statistics, and we will be done. Moving further, let's talk about the analysis of variance, or ANOVA, which is a statistical test that is used to analyze the means of two or more groups to find out if there is any significant difference between the means of the two groups. Now depending upon the problem, we can use a one-way ANOVA or a two-way ANOVA test for the hypothesis testing. So we use one-way ANOVA or single factor when there is categorical independent variable, and the categorical variable must have at least three categories. Now in a two-way ANOVA test, we use two independent variables to check how they affect the dependent variable, and we have two factor with replication and without replication that we'll discuss while we are doing the hands-on for this ANOVA test. And now that we are done with the hypothesis testing and various statistical tests, let's learn how we can perform linear and logistic regression using Excel as well. So before we do that, we are going to discuss what is linear regression. So basically, linear regression is a predictive modeling technique in which one or more features are used to predict the outcome of the target variable. Now, linear regression is used for regression analysis, and the efficiency of the linear regression model is calculated by how minimized is the error between the actual and the predicted values. Using those intercept and coefficients, you can use the same to predict values on a new set of values. And let's also discuss what are the various steps that are involved in linear regression. First one is data preparation. You have to prepare the data. You check for any sort of correlation or relationship between the variables using scatter plots, or you can just get the correlation from any functions, whatever you're using. You might be using Excel or Google Sheets or Python or R programming. Then you use the add-in from the Excel Miner, and you evaluate the statistic summary, or basically figure out what are the coefficients and the intercept for that particular problem. Now when we talk about logistic regression is a predictive modeling technique which is used for classification problems, and the target variable is categorical variable in a logistic regression problem. The efficiency of the logistic regression model is calculated by the confusion matrix, from which we can determine the precision, recall, and the accuracy of the model. So these are the steps that we can use to calculate or create a logistic regression model in Excel or in Google Sheets. So we install the Excel Miner add-on in either Excel or Google Sheets. We enter the input ranges and basically get the summary statistics, and based on our summary statistics, we evaluate the confusion matrix, the precision, recall, and the accuracy of the model. So now that I've done explaining the theoretical part here, we are going to start with the demo, where we are going to start from the scratch itself, which is descriptive statistics, and we will move on to inferential statistics, and then we'll talk about how we can do the hypothesis testing, all these tests that we have discussed, linear and logistic regression. So stay tuned, guys. And if you have any questions, you can mention them in the comment section below, and we will be more than happy to help you in your journey towards learning data analytics. Now that we're done with the theoretical concepts, we are going to move on to the demo part, where we are going to implement everything that we have learned so far and see how we can do that in Google Sheets. Alright, so I'm using Google Sheets so that it's more accessible to everyone. People might not have this add-on that we'll be using, the Excel Miner, if you don't have an official Microsoft account. So that's why we are going to use Google Sheets here, which is quite accessible, and all the features, mostly all of the features are quite similar only. So we'll begin with the frequency distribution that is part of the descriptive statistics. So just to have a little recall on this, frequency distribution is nothing but how the data points are distributed in the sample. It could be a normal distribution, a positive skewed or a negatively skewed data. Now to do that, what we can do is, alright, so we'll just create a chart here. So we can insert the chart, and there are a few options here. So I have selected the, alright, so we'll select the histogram here, so that, alright, so you can have any other, we'll just have a normal combination chart. And you can see this is not a normal distribution, the years experience versus age. Alright, so we'll just select this one column. Alright, we'll delete this, and now we'll insert the chart. So it is for years experience, and we will have a combo chart. So since we can see it is not a normal distribution, slightly skewed, and that is how you check the distribution or the frequency distribution. You can do the similar things for the age column, and you can do the similar things for salary column as well. So if we select the salary column, and we'll delete this chart for now, we will select the combo chart again, and it will show the distribution of the salary column. It is also not a normal distribution. And if we select the age column, and if we create the chart again, so none of these are actually normally distributed. There is a slight skewness in the data, and that is how we check the frequency distribution of any sample. So in our sample, alright, so we'll delete this chart, this also. So we have somewhere around 22 entries for age, salary, and years experience. Now when we check the measure of central tendency, so if you recall the session in the beginning, we discussed the measure of central tendency is measured by the metrics like mean, median, and mode. So let's say if I want to check the mean of the year's experience, I'll just apply the average function here, and the values will be these. Now I'll just press enter, and alright, so as you can see, the average of the year's experience column is 4.27. Similarly, we can check it for year's experience as well. So if we take a look at here, we just copy this entire thing. Instead of C1 to C23, we will write as B1 to B23. Alright, so this is the average of the salary column, and similarly we can change the values for age column as well. So that is how you check the mean or the average of the distribution. And after that, you can also check the other metrics like median and mode. So for median, you can use the function over here, that is so we'll have C1 to C22. Alright, so the median is 4 for the year's experience. Alright, so it has to be 23 in fact. And if we check it for the salary column, have median, and we'll just write B1 to B23. So the median for the salary column is 380,000, and for the years, for the age of the employee, let's say, we'll also put the median here, that is A1 to A23. So this is about the median of these three columns, that is for the average or the mean. And then we can also check the mode of these columns by so we check the mode for age first, A1 to A23. Alright, so that is 58. We'll check the mode for the salary column, and we'll check the mode for year's experience. So this is a simple way of doing this, and we'll also be taking a look at the add-on, that is the Excel Miner. Before that, I'm just telling you how you can get these values using these simple methods. And going further, let's also take a look at how we measure the variability. And for that, there are three things basically what you have to take in mind, which is the range, the standard deviation, and the variance. So to find out the range, we have to find the minimum and the maximum of column. Let's say we take the range for the age here. So first of all, we'll get the minimum value. So minimum for A1 to A23, so that is 28. So and the maximum will be using the maximum column. All right, so A1 to A23. All right, so the maximum is 60. Now for the range is equal to maximum minus the minimum value. So we'll just do F minus E4, and that is 32. So the range is 32 for our age column, and for the standard deviation, we'll just use the standard deviation formula, and we'll just put the values here, and voila, we have the standard deviation for the age column. And for the variance, we have the formula again. We can use the variance formula, A12. I think we made a mistake here. So this is the variance for the age column. Similarly, you can find it out for the other columns as well. Now to make it all simple, what we'll do is we'll just use the extension. Alright, so to have this extension, you can just go to the add-ons, click on get add-ons, and then you can search for Excel Miner that we are going to use in this session. So when you type Excel Miner, so this is the tool pack I'm talking about. This is what you have to install. It's already installed in my system, so we're not going to go ahead with that. Alright, so now I'll just use this Excel Miner tool pack. Now you can see all of these services that this tool pack is offering us. We are going to use the descriptive statistics. We're going to input the range here, which is going to be our all three columns. We're going to get it for all three columns. It's updated. Now the labels are in our first row, so we'll take this one. For the output range, we are going to use, let's say, E12, and the confidence level for me will be 95. Let's say what the output is. Alright, so when we analyze the output, this is for the age column, this is for salary, and this is for years experience. Now if you remember, the mean for the age column, did we calculate the mean for the age column? Alright, so we had calculated the mean for years experience, I think. So we'll just check for years experience, the mean is 4.27, like we have calculated over here. And for the mode for all these columns, 58, 60,000, 600,000 and 2, that is also there, the mode for the years experience column. Alright, so the thing is, we were calculating these values by using all these functions, but simply using the Excel Miner add-on, we are getting all these values for descriptive statistics, that is mean, the standard error, even the median, mode, standard deviation, the sample variance, the kurtosis, the skewness. We have got the range also, the minimum, maximum, sum of the values, and the count, largest, the smallest, and the confidence level as well. So this is basically an advantage of how you can perform descriptive statistics on your sample or any data basically using Google Sheets. And the Excel Miner toolpack not only works on Google Sheet, it works on Excel as well. So you can use the same thing or the same procedure if you are using Excel also. Now moving further, we are going to discuss some inferential statistic concepts, and we're going to start with correlation, guys. So let's say we have the same data, and we have to check the correlation for these three tables, like how these are correlated to each other. Now the procedure is simple. We'll just open the Excel Miner toolpack, alright, and we'll hover to correlation, that is here. We just have to put the input range, which is going to be the same, A1 to C23. Alright, so we have labels in the first row. The output range, we'll just randomly select this cell, for example, and when I click on OK, I have this table which has all the correlation coefficients. So if you check here, the column with each other will always show a positive correlation of 1, which is basically the same column. So since you can see over here, now when we check for salary and age, the correlation is 0.30, which is not as strong as we cannot say it's a strong correlation, although it's a positive correlation. But when we check it for, let's say, years experience and age, it is 0.49, somewhat strong. We can say this is a correlation, a positive correlation, which is somewhat strong. So in my opinion, the strongest correlation that you can consider for any problems would be ranging somewhere around 0.7 to 1, or in the case of negative correlation, then same, somewhere around minus 0.7 to 1. Since we do not have any correlated values here, we'll move on to the next metric that we have, which is covariance. So we want to see how these variables are going to correlate to, covary together, like we vary together. Then again, we have to follow the same approach. We go to the Excel Miner analysis toolpack, we start it, go to covariance. Now the input range will be A1 to C23, labels in the first row. Output range, let's say, we'll have E2. Click on OK, we have the covariance coefficient. So all of these have positive covariances except for years experience and salary. So these are showing negative covariance. Now if you remember in the beginning of the session I told you the covariance coefficient helps in estimating the direction of the relationship between the two features. And if both the features tend to increase or decrease together, the covariance coefficient is positive, which means that for all these values, salary and age, years experience and age, the covariance coefficient is positive, which means they're going to increase or decrease together. But in the case of years experience and salary, it is a negative coefficient, which means if one feature is going to increase, the other is going to decrease, or vice versa. Like let's say if years of experience is going to increase, salary might decrease, and if the years experience decrease, the salary is going to increase, vice versa. Which is quite bizarre for this sort of data, because in real life if you check for these features, if the years of experience increase, the salary also increases. So I think that's going to be a problem with the data. And yeah, that's how you find out if the data is accurate or not, or if there's something wrong with the data. And that's how we do the inferential statistics and the descriptive statistics in the first place, to understand how our data is, how the distributions are, and all these values. Now for checking the confidence interval, it's quite easy, guys. So since we do not have any services or any functions here that can do that for us, we'll do it the conventional way. We'll use some functions, and after that we'll be able to get the confidence interval for our data. Alright, so we'll move on to that in just a while. Alright, so for the confidence interval, we're going to need three values. First one is going to be the average. Alright, so we'll create the confidence interval for, let's say, the salary column. So we'll check the average for our 2 to B23. That is going to be our average. Now for standard deviation, we will have standard deviation B2 to B23. Alright, and we are going to count the samples, or the sample size, to count. So we have all these values. Now to find out the confidence interval, we're going to use the formula. So we're going to use the confidence interval for the 95% confidence level, and for that we have to use the formula. The formula is T inverse 1 minus 0.95, and then so we're going to use the formula T inverse 1 minus 0.95, and then we have the degrees of freedom, which is going to be sample size minus 1, which is 22 minus 1, and then we will have to add, we have to multiply this with the standard deviation divided by square root of our sample size, and that is how we get the confidence interval. So that is how you calculate the confidence interval for any of your samples. And so now that we're done with the the basic constructs of inferential statistics, the correlation, covariance, and confidence interval, we are going to move on to the hypothesis testing. So just to recall, for hypothesis testing, we have all these samples where we have to make a few assumptions, and after that we calculate the test statistics. Based on that, we reject or accept the null hypothesis. Alright, so we're going to start with the t-test first of all. So in the t-test, which is also one of the statistical tests that is used to check basically if the mean of two samples are equal or not. So in a one sample t-test, we are testing the sample for specific value, and in a two sample t-test, we use the two sample test where the groups come from different populations, and for paired t-test, we basically have the samples from the same population. So let's assume these two samples have come from the same population. So we are going to use the paired t-test on this. If it had come from different populations, we could have used the two sample test for this, and if it was just one sample test, we could have done that as well. Alright, so there can be one-tailed and two-tailed hypothesis test for means, and basically if you're looking to get directions, you can have the one-tailed or two-test. So we'll just have a two-tailed for here, because we just want to check if it's equal or not. Alright, so the assumptions basically is we'll just assume that the sample is random and it's approximately normal distribution, and there is basically homogeneity of variances amongst the group. Alright, so to perform the t-test, what we have to do is go to the Excel miner once again, and we go to the t-test here, Now here for t-test we have three options. So we have paid two sample test for means, which you can do assuming the samples are coming from the same population, and we can have two sample assuming equal variances. So we're going to assume the variances are equal, and for two sample assuming unequal variances. So now just to clear the air here, we just check the variance of these two samples. Alright, so to do that we'll just use the variance formula, all these values. Now this 54, and now we'll check for our other sample, I mean the female in the sample. So the variances are obviously not equal, so we cannot assume that the variances are equal. So we are negating this one for now. We can't use the two sample assuming equal variances. Now the other one is two sample assuming unequal variances, which is okay, but now we are assuming that these two samples are coming from the same population. So for that we have paired two sample for means. I mean, if you use these one also, the procedure is going to be same. You just have to give the range of the variable 1 and 2, the hypothesized mean difference and everything. Alright, so for pair two samples, the mean difference is going to be 0. For the variable range 1, we'll have A1 to A16. For the variable range 2, we will have B1 to B16. So there are basically 15 samples here. Labels in the first header. The output range will put it to B. Alright, I think the variable range, the output range was not updated. So now if you check the output, we have all these values: the mean of the columns, the variance, the observations, Pearson correlation, that is basically, and the hypothesized mean difference. Now for that we have the degrees of freedom, which is sample minus 1. The t statistics we haven't got, the one tail p value, the t critical one tail value, the p two tail value, and the t critical two tail value. Alright, so based on these test statistics we can assume. So we haven't got the t statistic value here, so I think we will go for two sample assuming unequal variances. We'll assume the populations are coming from different samples. Alright, so for variable range we'll have, and for variable range 2 we'll have B1 to B16, hypothesized mean difference 0, labels, the alpha value is 0.05, the output range is D. Okay, alright. So now when we check the test statistics, we have all these values: the t statistic, the critical t value for two tail, the critical t value for one tail. Now based on these numbers or statistics that we have got, we can reject or accept the null hypothesis. So the null hypothesis is the mean of these two samples is equal. Now if for one tail, if you are, that is basically a two tail test, if the p value is less than 0.05, we can assume that the mean of the samples is equal. So that is how you perform a t sample test on various samples. Before that, you just have to check if it's the variances are equal or not. You have to check for the distribution. We have just assumed that this is an approximately normal distribution, but then again, if you want to have efficiency for your test, you have to measure the distribution, the frequency distribution, and figure out if it's a normal distribution or not. Now moving further, alright, so now that we are done with the t-test, let's move on to the next hypothesis testing or the statistical test that we have, which is the z-test. Now to perform the z-test, we can do it on a one sample, on a two sample as well. And it is basically used to check the means of the two populations or not. And it's basically performed on sample that follow a normal distribution and are greater or equal to size 30. But we have only 15 samples in the data. So we'll do one thing. We are going to use a different sample for this. So we'll copy these two columns. Alright, so these also have only 18 values. Let's check for other samples that we can use. Alright, so we'll have these two. So let's use these two, and let's just paste them here. Alright, so let's say we have more than two samples now, and let's hover down to z-test here, two sample for means. If you want to do it for one sample, we have a function also that you can use, that is z-test. And basically, let's say this is one sample that you want to analyze, we'll just do that. Alright, so I think we made a mistake here, and we have to give the value in this. Alright, the value is going to be the hypothesized mean, basically the population mean. So let's just take 75 for instance, and after that we have to give the standard deviation. Let's say standard deviation for our sample is somewhere around 25, for example. This is just the hypothetical value, and this is how you get the test statistics or the Z statistic for your one sample test. And since we are using two samples here, we'll just put a variable range 1, which is going to be this. Alright, so we'll just do that manually. Okay, so we've got it, D1 to D30 and E1 to hypothesized mean difference. So we'll assume that the mean of these two samples is equal, and we are going to do the two-tail test on over here, because you don't want to check if it's larger than or smaller than. If you want to do that, then we can use the one-tail Z test. So we'll put the hypothesized mean difference as 0. The variable 1 variance, we have to check the variance also. So for that, we'll just quickly check the variance of D2 to D30, and the variance of the other sample, which is E1, E2 to E30, that is 39.14. I think we have made one little mistake here. So we don't have 30 samples, we have 29. So I'll do just one thing here, get a couple more values from this data, and I'm going to add them here. Alright, so we'll check the variance again. I'll just make this 31 and this also. Here also we'll have to make a few changes. We're good to go. So the variable 1 variance is this. Alright, so the variable 1 variance is going to be the cell G3. Variable 2 is going to be G4. The labels in the first row, output range we'll put here. So let's check the output. Okay, so variance 1 must be greater than 0. We just manually put this 26.32, 37.81. So we have got our test statistic. Similarly, like we have done for the t-test, we have got the Z statistic, we have got the Z critical 1 tail, critical 2 tail. Now here also we'll check for the 2 tail. If it is less than 0.05, we can reject null hypothesis, and that's how we know that the mean of the two samples are not equal. And yeah, if I had not mentioned this about the t-test, yeah. So if the p value for 2 tail is less than 0.05, we can reject the null hypothesis and assume that the mean of the two samples are not equal. I think I had mentioned the other way around, so apologies for that. Now that we're done with the Z test also, we're going to move to the F test. Alright, so there are a few assumptions that we have to take for the F test. Basically, we have to make sure, first of all, we have to know that the F test is used to check the variances of the two samples. Alright, so we are checking if the variances of the two groups are equal or not. Now, depending upon the problem, we will be using 1 tail or 2 tail, if we want to check if the variances are greater than or equal to or not. Now, we simply compare the group variances with the F test, and it's performed on the F distribution data. That is the assumption that we have to take now, and let's go ahead with that. So now to get the F test done, alright, so 2 sample for variances, it's pretty easy, guys. You just have to bring in the first sample. Alright, this is going to be B1 to B16. Labels in the first column, the first row. The alpha level is 0.05, which means the confidence level is 95%, and the output range, let's say D2, D3. Alright, so when we check the test statistic over here, we have the F value, the F1 tail, and the F critical 1 tail. So so we do not have the 2 tail value for this. So since we do not have a 2 tail value over here, we can check if the variances of the groups are greater than or equal to, or basically more than each other or not. So these are the test statistics. So if the F critical 1 tail or the p value for the 1 tail is less than 0.05, then we can assume, or we can reject the null hypothesis. Since it is not, so we can assume, or our hypothesis says that the variances might be less than, the variance of the first group is less than the variance of the second group. Alright, so now that we're done with the F test as well, let's go on and check how we can calculate the single factor ANOVA. So if we recall the session in the beginning, like we use a one-way ANOVA or a single factor ANOVA when there is one categorical independent variable and the categorical variable must have at least 3 categories. So we have group A, group B and group C. So 3 categories for us. Now we are going to perform the single factor ANOVA on this. For that we have to put the input range. Alright, label in the first row, the output range will have this E2. Alright, so we are getting an error over here. So let's just check what we are doing wrong. Okay. Alright, so I think the input range is a little, so we have to correct the input range. I think that's why we are getting the error. So the input range is A1 to C24 and we'll put the output range similar to that. Alright, so now we are getting the test statistics for all these groups and we are getting the, basically the DF, the F value, the P value and the F critical value as well. So the P value can give us the between groups variance, within group variance is also given, and that is how you evaluate or get the single factor ANOVA for your sample of data. Now, since you remember, ANOVA is basically a statistical test that is used to analyze the means for 2 groups or 2 or more groups. We are basically finding out if there is any significant difference between the means of 2 groups. And these F values and the F critical value will play a very important part while doing that. So between group variance, we are getting 0.68, 3.13 and 0.50, that P value. And based on this, we can reject or accept our null hypothesis. Alright, moving further, we have the ANOVA 2-factor as well. In ANOVA 2-factor, the only difference is we use 2 independent variables to check how they affect the dependent variable. Alright, so we have 2 independent variables, which is basically male and female for gender, and we have all these categories over here. Now to do the ANOVA 2-factor with replication. Alright, so we'll do ANOVA 2-factor with replication over here. So we have 2 categories, male and female, we have all these values, and for replication we'll put the input range over here. Rows per sample, we have to check the rows per sample as well. Alright, so we'll quickly check the rows per sample. Let's say, alright, so the rows per sample is going to be 36. Let's say the output range is E2. Let's see what the output we're getting. So we're getting the summary statistics for all these: gender, weight, everything. The count, sum, average, the variance for each group, the count, sum, average and the variance for male, for female separately. We're getting the ANOVA, and we have the within interaction, all these values, the F value, the critical F value and the P value. And based on this, we can accept or reject our null hypothesis. And one more is there. One more ANOVA test is, provided by the Excel minus tool pack. That is 2-factor without replications. And in this, we're going to use these values. So the input range is going to be, it's a little tricky, guys. And if you are not aware of how ANOVA works, I suggest you check out our tutorials on our YouTube channel. And once you're done with that, you'll be able to understand how it works, and then probably you'll be able to understand this better. And we have the labels in the first row, the alpha and the output range. Let's put at A7, and we have our test statistic. Alright, similar to what we have got in the replication part. Without replication, this is also this, and we have the DF, the degree of freedom, which is basically the F value, P value and the F critical value for rows and columns, and the error as well. And based on these statistics, we can create inferences for our data. And now that we are done with the ANOVA as well, we will move on to the next part, which is nothing but linear and the logistic regression that we have. So first of all, we'll go ahead with linear regression. I'm sure people who have come to this part of the session are basically eagerly waiting for this. So we have these 2 samples, or basically 2 columns: years, experience and salary. Now before we begin our linear regression analysis or linear regression model, we'll just quickly check the correlation over here. And to do that, we'll use the correlation service here. The input range, put it to A1 to B31, labels in the first row. The output range we'll put at E5. So this is going to be our correlation. Since it is showing quite a very strong correlation, very strong positive correlation with years of experience, we can go ahead with the linear regression model over here. And to do that, first we'll get the model done, and then I'll explain the summary statistics so that you will be able to understand it better. So the Y range, which is basically the salary, we'll put it first. Y is basically the value that you're going to predict using the linear regression, which is B going to be 31. The X range is going to be B A1 to A31. Labels in the first column. Confidence level we are putting at 95%. And let's get the summary statistic. Okay, so output range is missing. We'll put the output range as E11. Okay, wait just a minute. Did not get updated. So E11. Alright, I think there's something. So we've got the test statistic, the regression statistics. We are getting the multiple R, the R squared value, adjusted R squared value, the standard error as well, and the number of observations. Now these are the regression statistics. Basically, how you evaluate your model using the R squared value and the adjusted R squared value. Just quite good in this case. We have 0.95 for R square and 0.95 for adjusted R square. Now the most important part is the intercept and the coefficients. So using this intercept and coefficient in the linear regression equation, we can predict the future values basically, and that is how you create a linear regression model. You have the T statistic, the lower 95%, upper 95 percentile, the lower 95 percentile and the upper 95 percentile, the P value, everything is given over here. The F value, the significance, F, all these values are given in this test statistic. And if you have worked on Python for linear regression, you must be wondering, how is this so easy? I mean, this is a very simple example of how you can use a linear regression to your avail for a single dependent variable and one independent variable. And that is how you create a linear regression model using Excel or Google Sheets using Excel Miner. Alright guys, so without any further ado, we'll move on to the last part of the session, which is logistic regression. As you can see, there are a few values here which are missing. So we have to do a few changes to the data before we can begin. So we'll fill all these the null values with the mean of our sample, which is basically the age. Alright, to do that, what we'll do, we'll use a simple form. Alright, so we have the data for the logistic regression as well, and so we have 4 columns. This is taken from the Titanic dataset. We have only taken the 49 samples here. We have the survived column, which is the Y, the Y input range, and we have the passenger class, the sex, and the age for those passengers. Alright, so what we have to do to perform logistic regression here, we just go to the Excel Miner tool pack. And after that, we have to hover down to logistic regression over here. We have to put the input Y range, which is basically our A1 to A50. And then for the input X range, we're going to have B1 to D50. Labels in the first column. And the confidence level is 95%. The output range, we'll put it to E2. And now when you press OK, you will have the summary output. Alright, so I think we have we have the summary statistics, which is giving us the chi-square value, the residual deviation, the number of iterations, that is 21, and the observation, which is 49. Since we have a very small data set over here, I'm just telling you how you can perform logistic regression. Then again, you have to make sure that your data is correctly classified into something that you use for logistic regression. For example, the number of samples here are very less, so that the training will not be very useful over here. We have the coefficients, which is the intercept, and the coefficients for each class over here. Now, if we put these values into our equation, the logistic regression equation, we'll be getting the output value such as survived or not. So we have the standard error, we have the p value, the odd ratio, the upper lower 95 percentile. Alright, so this is how you create a logistic regression problem or logistic regression model for classification problem, checking if the passenger has survived or not.
Probability in data science help the data scientist gather useful insights about the data backed by evidence that in turn helps us evaluate the likelihood of events in a given problem statement. When it comes to probability, a simple definition is that it is the certainty by which an event or outcome is likely to occur. For example, if we roll a dice, what is the probability of rolling an even number if we draw, or what is the probability if we draw a card from a deck? What is going to be the probability of drawing a face card? These are the sort of problems that we have in probability. And now these probability problems can be of various types, and we have summarized a few types of probability problems that we can assess. But before that, let's also take a look at some of the common nomenclature that is used while addressing problems related to probability. So the first one that we have is experiment. An experiment is an event where various outcomes are possible. For example, rolling a fair dice is going to be an experiment. Now, event is something which is the favorable outcome. For example, rolling a 5 in the experiment is going to be one event. And outcome is the result of the experiment is the outcome. Basically, when, for example, when a fair dice was rolled, 3 had come, that is the outcome of the experiment. And probability again is the likelihood of an event occurring, that is called the probability. For example, drawing a red card in a deck of cards has a probability of 1 by 2. Because we have 52 cards and 26 cards are red cards, so drawing a red card would be 1 by 26. Repeat. So drawing a red card would be 26 by 52, which is 1 by 2. Alright, now let's try to understand the various types of probability problems. So when we talk about types of probability problems, they can be further divided into marginal, joint, or conditional probabilities. So when we talk about marginal probability, the marginal probability of an event can be explained as the unconditional probability of an event occurring. It means that the event does not depend on any other condition that can be seen with joint or conditional probability. A very simple example would be, what is the probability of drawing a red card from a deck of 52 cards? Here, the event occurring does not depend on any other event. So that is going to be the marginal probability. Now when we talk about the joint probability, it is the intersection of two events happening simultaneously. Now to understand this, let's take another example. What is the probability of drawing a red card that is also a 4 from a deck of 52 cards? So here two events are there. One is drawing a red card and one is drawing a 4 that is also a red. So these are two events that are happening simultaneously. Then we are conducting, or we are calculating basically the joint probability of an event. Now when we talk about conditional probability, it's a little trickier to understand, but it is the probability of an event occurring given that another event has occurred. Now for example, what is the probability of drawing a 4 when the card drawn was already a red card? So here just a little bit of conflict here when we talk about joint and conditional probability. In joint probability, the events are happening in tandem, but in conditional probability, we have to calculate the probability of an event knowing that another event has occurred. And now that we have a fair understanding of types of probabilities, let's go ahead and understand conditional probability in detail. So when we define conditional probability, we understand that it is given as the likelihood of an event A occurring given that an event B has already occurred, and it is given as or it is written as a probability of A given B, where it equals to the probability of A and B, which is A intersection B, and the probability of B, which is we are going to divide it by. To understand this, let's again take a very small example. So let us take an event A where a fair dice is rolled and 5 is drawn, and an event B where an odd number is drawn. Therefore, what is the probability of A given B? So here if we check the probability of event A, only one outcome of the 6 outcome is favorable. Therefore, the probability will become 1 by 6. But if we bring in the event B that has already occurred, the sample space can only have one outcome out of the 3. Therefore, the conditional probability of the event A given B occurs becomes 1 by 3. Now to understand this, let's just for a number to be odd in a sample space, we only have 3 values, which is 1, 3 and 5, and we know that it has occurred. Then the probability of A happening will become 1 by 3, because in the sample space the intersection is just 5, and that is how we have come to the conclusion the probability of event A given B will be 1 by 3. Now, to understand the practical implementation of conditional probability, let's take a look at Bayes' theorem and how it can be used in probability theory. So in probability theory, Bayes' theorem is used to explain the likelihood of an event in a conditional probability where the information about the other event is also given. So the conditional probability of an event A given B according to the Bayes' theorem is given by probability of B given A multiplied by probability of A and divided by probability of B. As you can see in the formula over here, we have mentioned A and B are events, then probability of A given B is true, then probability of B given A is true, and the independent probabilities of A and B. So these all information we need to calculate the conditional probability using Bayes' theorem. Now to understand this again, let's take a simple example. For a school, 10% of students failed all subjects in the examination. Out of all those students, 5% of the students failed in mathematics. Out of all the people who failed in all subjects, 8% of the students failed in mathematics. So if a student fails in mathematics, what is the probability that she will fail in all subjects? So here we will use the Bayes' theorem to get the results. First, we will compute the probability of event A, which is given as 10%, that is 0.1. Because we are going to check the event A is going to be what is the probability that he or she or the person will fail in all subjects. So probability of that is already given, that is 10%, because 10% of student has already failed in all the examinations, and we are going to take it as 0.1. Then the event B, which is failing in mathematics, is given by 5%, which is 0.05. That is the probability of event B. Now probability of B given A, that is person failing in mathematics, given that he has failed in all subjects, that is given by 8%, that is 0.08, I'm sorry. And finally, we will put the formula to the test. So our conditional probability for the given event will be 0.16 approximately, and that is how you use a Bayes' theorem. According to Bayes' theorem, basically we have concluded if a student fails in mathematics, the probability of student failing in all subjects is going to be 16%. So what exactly is a probability distribution? As you can see in the picture over here, it is often depicted using graphs or tables. Or probability distribution is just a function that is going to portray the probability of different possible values of a feature or a variable. What it means is that, say we have a feature or a variable, it has values in intervals, or it could be any specific value. The probability distribution will tell us what is the probability of a value in that particular distribution is going to be. Normally depicted using graphs. Let's take a simple example to understand how we can use probability distributions. So here we have the graph, the frequency distribution of revenue for a company, and here we can see the distribution is kind of in normal distribution, like a bell curve. That we'll also cover later on in this session. So what we can do here is, let's assume that this is a normal frequency distribution, and then we can create inferences based on some statistical evidence that a normal distribution also provides. So we can assume we can assume characteristics of a normal distribution, and create inferences like what is the standard deviation going to be, how many values or how many percentage of values are going to fall within certain range based on our analysis. So to understand how we can create those inferences, let's take a look at what exactly is a normal distribution and how we can use it to create inferences. Now a normal distribution, or it is also called as Gaussian distribution, have the frequency of the data distributed in a bell curve, as we have already seen, and the majority of the data is distributed in and around the central region, as you can see over here. The centroid or the central point of the normal distribution is going to be the mean, and the data will be distributed below the mean and after the mean. So that is how the data is distributed in a normal distribution. So some of the properties of a normal distribution can be the mean, median and mode of a normally distributed sample is going to be always same. For example, if let's say we have a distribution of 1,000 employees salary, and the mean is 20,000 for example, the median is going to be the same and the mode is always going to be the same for that distribution. If there is any discrepancy in that, there might be skewness in the data, and that is how we can differentiate between a normal distribution and any other distribution. Symmetry is always going to be present in the data, where half of the data is less than the mean, which I already discussed, and the other half is going to be greater, which is on the left side or the right side of the graph. And mean and standard deviation are two deciding parameters of the normal distribution curve. The curve you see over here, it is going to be thicker or leaner. That depends on standard deviation and the mean itself. The other properties includes 99.7% values in the sample are 3 standard deviation away from the mean, and 95% values are going to be 2 standard deviation away from the mean, and 68% values in the sample are going to be 1 standard deviation away from the mean. So as you can see over here, the segments that are given, the first 2 segments are going to be 1 standard deviation away, then we include the other ones, and then the other ones. So that is what computes the 68% values, the 95% values, and the 99.7% values. So these are some of the characteristics of a normal distribution. Now there is another term called standard normal distribution, which is the standardized version of normal distribution, where the mean and standard deviation will have the values 0 and 1 respectively. A standard normal distribution is also known as a Z distribution. So let's say if we have a mean and standard deviation as 0 and 1, we can say that the distribution is a standard normal distribution. And it is basically a standard for all the normal distributions, and it varies for peak and stretches in the curve when the median and standard deviations vary. The mean will always going to be 0 and 1 for a standard normal distribution. Moving further, let's discuss Z-score as well. So Z-score measures how many standard deviation away the values are from the mean. As we have discussed, in a normal distribution, it can be given, like we can generalize, 68% values will be in the first 1 standard deviation away from the mean. But what if the distribution is not a normal distribution? How do you calculate? So how will you calculate the values or the interval, or basically how many standard deviations away your score lies? So that is where a Z-score comes into the picture, and we can use Z-score to calculate this. As you can see over here in the formula, Z-score is given by x minus sigma by standard deviation, which is Z-score is associated with probability, that's for sure, where the p-value for each Z-score will tell us the likelihood of values below this Z-score. And the p-value or the critical and the p-value can be calculated or can be tallied from the Z distribution table, where we can go and check the Z-score, whatever we have calculated, and for the corresponding Z-score we will get the p-value as well. Now to understand Z-score, let's just take a simple example and we'll know how it works. So let's say for a sample we need to check the probability of a value being less than 1150. But to get the Z-score, you also need to know the mean and standard deviation. So the sample mean over here is given by 1000 and standard deviation is just 100. So we'll put that into the formula, and we will have 1150 minus 1000, that is 150 by 100, which is 1.5. So for the corresponding Z-score, that is 1.5, the p-value in the Z distribution table is 0.93. So we know for sure that the probability of value being less than 1150 is going to be 93%. So that is how Z-score can be used in normal distribution or any other distributions where we know the standard deviation and mean of the sample. And we can get the probability of or how much or how many values are going to be within a specific range. Now that we are done with the Z-score, let's also take a look at some of the types of probability distributions. So as you can see over here, we have 2 types of probability distributions. First one is discrete probability distribution, and a discrete probability distribution is for categorical or discrete variables. Now if you remember or you recall, in the first session itself, we had discussed types of data. In that we had discussed categorical, discrete, ordinal and continuous variables, and that is exactly what we are referring to here. And for discrete probability distribution, it uses probability mass function to describe the discrete probability distribution. So that is one of the one of the other differences between both of these probability distributions. For continuous probability distribution, it is only used for continuous variables, and it uses the probability density function to describe the continuous probability distribution. Now we have two different terms, or the new terms over here, which are probability mass function and probability density function. So let's go ahead and talk about these two. So first of all, we will discuss probability mass function. To understand probability mass function, we are going to take a simple example where a fair coin is going to be tossed twice. The number of times it's going to be tossed is twice, and let's say x is the number of heads that we observe, and we want to find the probability mass function of p of x. So when we are using probability mass function, probability of x of number of times k is given by p of x is equal to k, where k is the Rx which we have mentioned over here, and it is nothing but the range of a random variable. Alright, so in our case, the sample space we have, if we are tossing the coin twice, we have heads, tail, heads and tails, and both are tails. So these are the four possible values that we'll get. Now the range of random variables for our event is if we get a head or not. So first event would be we are getting no heads, so that is 0. Then we can get a 1 head in our sample space, and then we have another one which is 2 heads. So 0, 1 and 2 for R of x. Now the probability of or the probability mass function will calculate the probability for each of these events. Now the solution would be when the number of times it is 0, the number of heads, this is 1 by 4, and if we have one number of heads, then we have 1 by 2. If we have 2 heads, that is also 1 by 4. So that is the probability distribution using the probability mass function. So this is a very simple example. Now let's go ahead and discuss the types of distributions that come under, or basically discrete probability distribution that we calculate using probability mass function. So the first one that we have is binomial probability distribution. Alright, so a binomial distribution summarizes the likelihood of a variable that will be having one of the two independent outcomes. So another thing, a binomial distribution is obtained by performing Bernoulli trials. So Bernoulli trials will have characteristics like there are only going to be two possible outcomes. As we have an example that we have just discussed, tossing a coin will only have two outcomes, either a head or a tail. So that is there, and each outcome has a fixed probability of occurring. So if I toss a coin once, the probability of getting a head is 1 by 2. The probability of getting a tail is 1 by 2 itself. Alright, and each trial is independent of the other. So that is always there. If I am tossing the coin twice, thrice, 4 times, every time the trial is independent of each other. We do not know, or basically we know what the probability of an outcome is, but we're not certain enough. So let's just understand binomial probability distribution using a simple example. So let us understand this by implementing example using Python programming, where a discrete random variable will only have two outcomes. Now in this random experiment where a biased coin is tossed 10 times, if the probability of getting a head is 0.4 in all these trials, we have to find the binomial probability distribution of the entire event. So to do that, we are going to use Python programming. So in this, we have a SciPy module in Python where we can use this binom function in the stats module. So the key or the main important things that we have to consider here is the number of trials, that is 10, that we already know, and the probability of the event of getting a head is 0.4, and obviously if the probability of getting a head is 0.4, the probability of getting a tail will automatically become 0.6. And then we are taking the sample space basically where we have the number of favorable outcomes. So we can, if you're doing 10 times the coin toss, we can get head 1 time, 0 time, 2 time, and so on. So that's why we are taking a list of range, and mean and variance we are calculating. After that, we are just creating a distribution using this binom function. And if you see over there, there is a PMF function, which is nothing but the probability mass function that Python provides. And here we are calculating probability for each of the outcome. And then when we plot it, as you can see, it's kind of forming a bell curve, but you can see for each outcome what is the probability. For 0, it's closer to 0, and then it is the highest for getting 4 number of heads in the in a trial. So the highest probability is getting heads 4 times, and then it goes down towards 0 again. For when it reaches 10, the probability is less than 0 times. So probability of getting tails for all the outcomes is more than probability of getting heads, because we already know that probability of getting heads is 0.4 in those number of trials. And that is how you implement a simple binomial probability distribution using Python programming. Now moving ahead, let's discuss Poisson probability distribution as well. So a Poisson distribution is nothing but a discrete distribution. Now what we have done is we have taken binomial distribution, which was just we can say it was a categorical data where we had only 2 outcomes. Now for a discrete distribution, we will create estimates, or basically calculate the likelihood of an event in a given time duration. Alright, so we will have intervals in a Poisson distribution, not specifically just values like how we had a sample space where each outcome was there in the binomial distribution. Here we are going to have intervals or time duration. So it is given by this formula, as you can see over here, where lambda is a mean number of successes that occur during a specific interval, k is the number of successes, and E is basically a constant that is equal to approximately 2.71828. Now you don't have to worry about this formula per se, because we already have Python programming modules that will work for us. You just have to understand how you can create a Poisson probability distribution and what kind of data it supports. So let's again take a little example to understand this. So we are again going to implement this using Python programming. So let's just suppose, what is the probability of number of schools in the range 0 to 5, where the mean number of schools in a 10-kilometer radius is 3. So we already know the 10-kilometer radius is going to be our interval over here, which is going to be time duration as well for some of the examples, but here it's just an interval 10 kilometer, and we already know the mean values for that. Alright, and we are going to calculate the probability of how many number of schools can be present from 0 to 5 over there. So using Python programming, we're just going to plot the Poisson probability distribution. So we're going to use again a SciPy module where we have a stats module, and inside that we have a Poisson function. So using that Poisson distribution, we have the number of the sample space, basically 0, 1, 2, 3, 4 and 5, how many schools are going to be present, and yeah, the probability of that is presented over here using the plot. So 0 schools having since the mean is 3, the probability of having a 0 school in that radius is going to be very low. And then again, since we had a mean 3, the highest probability of a school in that region is 3, and then for 4 and 5 again it reduces. So that is a very simple example of using Python programming for Poisson distribution or Poisson probability distribution. And now moving ahead, let's discuss the probability density function. Now probability mass function was for discrete variables. For continuous variables, we use probability density function to create the probability distribution. So probability density function, on the other hand, is used to calculate the probability distribution on continuous random variables that I've already told you. And we have given over here the density function for a normal distribution, which is given by f of x is equal to 1 by this entire repeat. So the probability density function of a normal distribution is given by this formula, where x is the value of the variable or data that is being examined, and then we have the mean and standard deviation. Since we already know, let's say if there is a standard normal distribution, we already know that mean and standard deviation is going to be 0 and 1. Alright, so let's just see how we can plot this Gaussian probability distribution using Python programming. So Gaussian probability distribution or normal distribution is based on sample mean and standard deviation that we already know, where the probability density function calculates the likelihood of a point in the distribution, because we cannot have categories or intervals here like we had in binomial or Poisson distribution. Here we have continuous values. So for each point in that data, we are going to calculate the probability, and that is how the distribution will be calculated. So this is the function that we can use. And here again we have the mean, the standard deviation, and the input value. Also again, we don't have to worry about this because Python already has the density functions that we can use to calculate the distribution. Now again, we are going to take a simple example to create a probability distribution for a sample that has 1000 random variables. We know the mean and standard deviation. Now we will calculate the distribution table. Alright, so to calculate the normal distribution, we again have this statistics module from SciPy, where we have the normalization or the normal distribution function as well. So we have the mean, the standard deviation. We have created a random sample within the range -100 to 100, which has 1000 values. So that is our sample, and we are creating so we have this normal distribution, and then again we are getting the probability distribution using the PDF probability density function for the sample. And when we plot this, we are getting this bell curve, which is nothing but the normal distribution or any Gaussian probability distribution would look like. Here the mean will have equal number of values, or the probabilities on the left hand side, on the right hand side, which mean less than mean and more than mean. And that is how you can plot the Gaussian probability distribution. And we can also assume the same properties that we have for standard normal distribution, 68% of values of being one standard deviation away from the mean, and so on. So that is all about the probability distributions. Now let's go ahead and understand central limit theorem. So a central limit theorem states that if we take several random samples from a population that has a finite variance, the mean of the samples will form a normal distribution. Now this is a little trickier. We are taking let's say we have a population which has 10,000 observations. Now we are taking 1000 let's say we are taking 20 samples or 50 samples from that particular population, being 1000 observations each. The mean of those 1000 observations for each of the sample, if we plot them on a graph, it will create a normal distribution. That is what the central limit theorem says. So there are a few limitations, or we can say assumptions, that we have to take. So the sample should not exceed 10% of the population. So if, let's say if the population has 1000 observations, the samples will only have 100 or less than 100. And sample itself or the population might not be normally distributed. So that is also there. It does not necessarily mean that your population is already normally distributed, and then the mean of the samples will be distributed when we calculate the sample means. So that is also not there. Now to understand this, the central limit theorem, you can plot the same for a random sample. So here what we have done is taken sample means for each of the sample. Like we have created almost 1000 samples where we are taking values from -10 to 10 and 100 observations. And when we plot these sample means, basically we are getting a normal distribution that is close to a normal distribution. So we can assume it's a normal distribution, and according to central limit theorem, it is always going to be a normal distribution for the samples.
Let's have a quick quiz question, guys. And the question is, what is the area under cumulative density function? And your options are 0, infinity, 1, or changes with the CDF.
Just a quick info, guys. Intellipaat offers state-of-the-art data analytics course in association with IITM Pravartak. Through this course, you can learn all the important tools and concepts of data analysis such as Power BI, data wrangling, data mining, etc. from esteemed IIT Madras faculties and industry experts. With this course, we already have helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, This course can set your career to new heights. So visit the course page link given below in the description and take a first step towards career growth in the field of data analytics.
What is data analytics lifecycle? So let's actually discuss what it is and why do we need to use it. So guys, data analytics lifecycle is very important, because when you're going ahead with, analyzing data and then creating some kind of result out of it, right? So you need to follow some kind of methodology or some kind of, organizational technique. So here is where data analysis lifecycle comes in, or data analytics lifecycle. So basically it is full of phases that will help to create an end product. So companies use a data analytics lifecycle to figure out what they want to do with the data they have and then create an end result out of it, get some kind of insight into this data or some kind of value from it, and then use that value to increase their profits or increase their data efficiency or the efficiency of their whole business process. All right, so let's go ahead and look at what are the different phases of it. So we have data analytics life cycle and we have multiple phases for it. So the first phase here is the discovery phase. Then we have the data preparation phase, then the model planning phase, then the model building phase. Then you have communication results, then you have operationalize phase. So guys, we have 6 phases here, 6 very important phases. Now let's go through and understand what happens in each of these phases. So we have the first phase, that is the discovery phase. Now this phase is something that is there in almost every kind of methodology. You have to discover what you want. So first you will decide what is your issue, what is the problem that you're facing. So if I took an example of a company has been facing an issue of not being able to create more money in a particular quarter. Why? Because they have not used any of the data analytics resources. They have not understood it. So they want to make the whole business process more efficient. So that is the problem. So you need to first, frame the problem. What is the requirement? What is the issue? And once you've done that, you have something concrete in your mind that you want to solve. Right? So once you frame the problem, you get to know what is the domain. What kind of domain will you be working in? What kind of field will it be? What kind of industry is it in? So, if you're working in a particular industry, if you're a textile industry, then it's going to be clothes based. And that once you've defined the domain, you can understand what kind of resources you'll be needing for that particular domain. So suppose it's a textile industry. So it's all about clothes and how they're manufactured. So that's the kind of data you need to be analyzing, and that's where the problem will be coming through, right? So in that you need to decide and understand what are the resources that you'll be needing, like what kind of people they'll be needing, like you have your teams, how many teams will you need, and what kind of data will you be analyzing. And obviously there's always someone who's financing all of this. Those people are the stakeholders, and you need to understand their requirements also, because in the end you're supposed to deliver the product to them, or the benefits of the product, that is the profits to them. So you have to understand their requirements also, and you need to decide, which is one of the most important factors, that is time. Now time is important because you need to decide how long each team will be working on what kind of thing, and what are your deadlines. You need to follow up on those kind of deadlines also. The teams will then assess the resources that are available to them, and they will assign it accordingly. And important activities in this phase include, basically framing the problem, deciding what kind of resources you have, assigning tasks, scheduling the tasks, and basically going ahead and planning the whole process of your data analytics, right? Then we have the next phase. Now this next phase is the data preparation phase. In this phase you go through many different things. So once you know what kind of data you want, that is the raw data, you know that you want this raw data, and you have collected that data in the, like the example I gave, in the textile industry, you've collected the data on how clothes are manufactured, what kind of clothes are being manufactured, and that's your raw data. Now once you've taken that raw data, you've extracted it, you are going to transform it, because every company has their own way of handling data and their own standards. So you need to convert that raw data into that acceptable format in which you can work with. So once you transform it and you push it to the place where all the data conditioning, data cleaning, data selection, data processing will happen. And all those processes are basically, removing all the unnecessary information away from the data. You have raw data and you remove all the unnecessary things from it, and you just get what you want. And that is the phase, data preparation, in which you're basically preparing the data. The raw data you get, you prepare that data so that you can, basically analyze that data. And that's when the next phase comes in, that is the model planning. So basically in model planning, the methods, the techniques, the workflow, these kind of things are decided, because you need to analyze this data and you need to work with a model that will help you to get the best result. And that's what you do here. You decide what kind of model will you be using, whether you're going to be using clustering, whether you're going to be working with regression or classification, all those kind of things. What kind of rules will you be working with, what kind of variables will you be using, what kind of techniques will you be using. So that will happen, all of it will happen in model planning. And then we come to model building. Now in model building, you're basically creating everything you decided in model planning. So you decided what kind of rules will you be using. You've decided what kind of model will you be using. If you're using clustering, then you're going to start building that algorithm that you're going to be using, or using the particular resources. Like if you already have it, then you're going to apply it. You'll basically be executing everything. And also here you'll be trying to optimize everything, create the algorithm so that it functions as efficiently as possible, because in the end you want the result to be as polished as possible, so that you get the best profits and get the best insights and values out of it. So basically in this phase, the teams that are working on it will basically build and execute the models based on the planning they did in the previous phase. And here they will also consider all the existing tools that will help them to run these models. And if they need to change the environment to make it more tougher to, be able to handle all the data that is coming in, all the prepared data that is coming in, they need to do that also. So this is where all the brunt of the work will be done. All the major and important things will be done in the model building phase. And that is our fourth phase. Let's move on to the next phase. That is the phase 5. So here you will be communicating results. That's what the phase is called, communication results. So in communication results, you will be basically seeing what is the result. As the name suggests, you've gone through your discovery where you planned everything out. You've gone through preparation where you've collected your data, raw data, and you've prepared it. And then in the modeling phase, you planned your model. And the building phase, you build your model and you executed that model. In the communications phase, what you're going to be doing is you're going to be assessing what you've done so far. You're going to get some kind of results after the model building phase, because you've executed the data using the model you have. And now you have some kind of result. So you will assess whether this result is a success or a failure. And once you've seen that, if you see that it's a failure, then you need to go back through the whole cycle, go back to discovery, see, redefine the problem, frame it again, and decide the time, decide the people, decide the resources again, and then go through the whole process again. Because this is a life cycle, it keeps on repeating from the first step to the last step, and then going back to the first step until you get the best value out of everything. So this is the communications results. But we have the operationalized results phase, in which you basically be creating all the documentation. You will be, whatever results you've achieved, you're going to be documenting them for, posterity, for future use. Once you've documented everything you've done, even if it's a failure or even if it's a success, you have to document it so that you can work with this documentation in your next cycle. Because after operationalize, you're going to be going back to discovery, and in discovery you will be deciding your domain knowledge, your resources that you're going to be using, the data, the people, the time, the framing of the problem. So you need some prior knowledge. If you're repeating a cycle, it will be iterative. The whole process of data analytics, where you're going and taking the raw data and getting an end result out of it, it is an iterative process where you will be going through multiple phases and understanding the data and getting some kind of value out of it. It's all right even if it's a failure. In the end, you're getting some kind of value out of all of this. So guys, these were the phases. These are the 6 phases. You have your discovery phase, you have your data preparation phase, you have your model planning phase, you have your model building phase, your communication of results phase, and your operationalize phase. Now, once you've gone through all these phases, you should be set to get some kind of value. And that's what organizations look for. So organizations follow this kind of life cycle so that they get some value or they are able to solve a problem they have. So that is why a data analytics life cycle model is used. That's why people use it. Alright guys, so we have gone through this. Now let's see what are the different key roles or those people who are involved in this life cycle. Alright, so let's start off. So you have your users, you have your stakeholders, you have your project managers, you have business analysts, data engineers, and DB managers. Let's understand what these roles do one by one. Okay, let's start off with users. Now, users are those people who will be basically using the project and they'll be the one giving you the feedback. So these guys are the ones working with the project. They're, using the project. Then we have stakeholders. Now, stakeholders are those people who basically invest in the whole project. They are the one who have the most invested interest in this whole project. If it fails, then it's on them because they're going to be losing money. If it's successful, then they're going to be getting the profits. So these guys are the most important people over here. Then you have project managers. Now, project managers, as the name suggests, are the people who are going to be managing the whole project. It's their job, it's their responsibility to make sure that the whole project is successfully initiated, successfully implemented. And they are also responsible for making sure that the product or the service is of quality over here. So they are responsible for making sure the whole life cycle gets completed in time and delivers the result. Then you have business analysts. So business analyst is a technical role that is involved over here. So these guys are the ones who will be applying the techniques, who will be telling what kind of techniques should be applied, what kind of rules and models should be used, what kind of variables should be used. And then data engineers are those, they basically help to process all the data. You have the raw data that is being collected and then it's going to be conditioned and it's going to be processed. So they are the ones who are going to be handling that. And then you have the DB managers. Now DB managers are basically database managers. So you have all this data coming in and you have to store it somewhere and you basically use databases for it. And this is where a DB manager comes. So DB manager is supposed to handle the data in the storage. So if somebody asks for the data, he sends the data, etc., etc. It's a simplified version of what DB manager would do. Okay guys, so guys, these are the different key roles involved in the whole process of data analytics lifecycle.
How do you work with data frames without really importing any data? You just want to create your own data frame. How can you do that? Right. So one of the ways in which you can create a data frame is by combining multiple vectors. Okay, combining multiple vectors of the same length or of the same, which have the same number of items, can potentially give you a data frame. Okay, I'll show you an example. Okay, and so what I'm trying to do here, everyone, is that I'm trying to create 3 vectors here. The first vector that I'm creating is called X, right? And what it does is it stores the names of 5 different individuals. Okay, it has the first name is Anna, second one is Harry, Michelle, Pete, and Frank, right? Let's call him Peter and Frank. Okay, there are 5 different people. This vector contains the names of those individuals, right? So I'm just creating this vector X. Okay, now there's another vector that I'm creating, which is called Y, and this vector actually contains the age of these individuals, right? For Anna, Harry, Michelle, Peter, and Frank, in the respective order, we also have the age of these people stored in this vector. 20, 25, 29, 31, and 23 respectively are ages of these individuals that we created vector X for, right? So I'm creating vector Y now, which basically captures the age of these people. Okay, and then Z is another vector that I'm creating. It's a logical vector, and this vector basically stores whether these individuals have kids or not, whether these individuals are parents or not, right? Whether they have a children or not. Okay, false basically means that these people do not have children, right? And true basically means that they have children, right? So for example, Anna doesn't have child, right? Hence it's false. Harry doesn't have a child, so it's false. Michelle has child, so true. Child or children, I don't know. Peter also has kids, right? So it's true. But Frank doesn't have kids. Okay, so false. So Z basically stores the information that whether these guys have kids or not. Okay, now what we can do is that we can combine all of these vectors X, Y, and Z to create a data frame which contains names of individuals, their age, and whether or not these people have kids or not. Okay, whether they are parents or not. Okay, so this is how I can use the data frame function. The function that I'd be using is called data.frame. Okay, data.frame. Here what I'm doing is that I'm creating a data frame and I'm naming it as DF. Okay, again, it's a user defined name, so whatever you want to name it, go ahead, do that. You can call it my first data frame, you can call it data frame session first object, whatever you want to call it. I am calling it df. Okay, the assignment operator, leftward assignment operator. Data.frame is the name of the function. Okay, within parenthesis, the next thing that I'm doing is that I'm basically assigning, the first thing that I'm mentioning here is the column name that I want to use in my data frame, right? If I don't specify this column name as name or age or parents, then what would happen? Actually, let me do that, right? If I just do this, right, which is I create df, okay, by just using x, y, and z, right? I just say this. If I do this, right, without referring to the names, if I create data frame, right, it will still get created, right? It's not that it will not get created. So what I'm doing here is that I'm saying data.frame within parenthesis x, comma y, comma z. When I run this, right, you would see df gets created, and when I output it, it basically has all the information that I'm trying to create, that I'm trying to store, just that the column names aren't really appropriate, right? I don't know what x is, I don't know what y is, I don't know z is. They're not intuitive names, right? Hence, it's always useful that while you're creating a data frame, you have intuitive names, right? If this x gets replaced by name, y gets replaced by age, z gets replaced by something like kids or parents, like anyone who's referring to this data will get an understanding of what this information essentially means, right? What this column essentially means. Otherwise, it becomes slightly difficult. Okay, so you can run your code like this as well. But the better way to do it, the better practice here is that just write df, okay, data.frame, and then what I'm doing here is that I'm saying name is equal to x, right? So the column name for x, the first column name is name, okay, name. The second column name is age, okay. The information is coming from y though, and then the third column name is parents, okay. So when I run it now, what would happen is df gets overwritten, right? It gets overwritten, and then the new df that I have has these column names called name, age, and parents, right? Now this is a more it's a better looking data frame, right? It gives you more information. It basically is something which looks more complete. Okay, so I've created my data frame, right? This is how you can combine vectors to create data frames. You can combine multiple vectors, right? You can combine hundreds of vectors, as long as the length of the vectors is same, right? If you try to create a data frame with unequal lengths of vectors, then you will get an error. I can show that to you as well. For example, in X, if I had 6 objects, right, instead of having just 5 objects, Anna, Harry, Michelle, Peter, Frank, if I added another person, let's say Prateek, okay, I did not change Y and Z, right? Now, if I try to run this, right, df of x, comma y, comma z, I will get an error because it says arguments imply different number of rows, right? Because the number of rows for x is 6. The number of rows for first column will be 6 because I have added one additional object, right, which is not present in y and z, right? So then you will get an error. So make sure when you're trying to include vectors, the length of the vectors is same, right? It has to have the same number of rows. Okay, only then it will make sense. Okay, so this is how you create a data frame in R, right? There are several functions that you can use which will give you some information about your about your data frame. str is a function which gives you the structure of your data frame. So let's say if you have hundreds of columns and hundreds of rows in your data frame, right? You could just do str of df and it will tell you that this object that you've created is a data frame. It has 5 observations, 3 variables, and the name of the first object, the name of the first column is name, the second column is age, the third column is parents. What is the data type, character, numerical, logical, etc. It will give you some bit of information that will be useful for you to understand the structure of your object. There's another function called is.dataframe, right? The purpose of this function is to understand, is to check, right, whether the object that you're referring to is actually a data frame or not. Okay, so if you do an is.dataframe of df, you will get a true because the df object is actually a data frame, right? So it's just a check, right, to find out whether the object that you've created or stored, whether it's a data frame or not. There are 2 other objects, there are 2 other functions, nrow and ncall. these functions are typically used to find out the number of columns and number of rows and number of columns of the data frame, right? Sometimes what you might have to do is you might have to store the number of rows and number of columns as variables in your programming, so that if you want to run loops, right, which goes from the first row to this last row or the first column to the last column, you can make use of these functions and store those variables, right? So end row will basically give you the number of rows, 5, and end call will give you number of columns, okay, 3. Okay, so this is like, these are some of the functions which will help you work with data frames better. But what we'll do now is that now that we've learned how to create a data frame, right, let's also try to see how can we extract information out from a data frame. Okay, how can we extend our data frames, which means how can we add more rows, how can we add more columns to your data frame, and then how do we sort data frames, right? If you have to sort your data frames in a specific order, right, based on a variable, based on whatever you want, how do you do that? Okay, let's try to understand that. CV says I'm not able to view data from output. So CV, what you'll have to do is that if you want to view the data frame, right, the DF that you've created, you can either just do DF. Okay, you can either just do DF, okay, and it will give you the data frame in the output window. Or if you click on this object, or let's say if you do view of DF, then it will show up a data frame on the script window itself. Okay, make sure it's possible, CV, that you haven't created the data frame, the DF doesn't exist, that's why the view function doesn't work. Otherwise, the syntax of your view function is okay, right? It should not give you a problem. Just try running the entire code here, right, along with these, and then see if it works. Okay, you see it now. Okay, great. The assignment operator only works when you're trying to assign values to an object. Okay, now name, age, and parents are not objects. These are basically parameters or column names. So there you will have to use equal to, right? It's not, and that's why I said, right, I mean, don't get confused between equal to and let word assignment operators, right? Its usage is different across different codes, different programs. Okay, so it wouldn't, like, it's expected, right? You can't have name assigned through a left word assignment operator, the column name assigned through a left word assignment operator. How do we extract, extend, and sort data frames? We'll take it one at a time. So first thing that we'll do is that we'll see how, like, what are the ways in which we can extract information out of your data frame. Okay, you've created a data frame, but if you want to extract a column, if you want to extract multiple columns, if you want to extract multiple rows, how do you do all of that, right? It's something we're going to see. The first way in which you can extract a column from your data frame is by using the dollar symbol. Okay, dollar symbol is basically a process, or you can call it a criteria, right, or whatever, right? So if you use the dollar sign, right, to extract columns out of your data frame, the output that you would get will always be a vector, right? So if you want to extract one column from a data frame at a time, right, you can't extract multiple columns from a data frame using a dollar sign. Okay, but if you want to extract just one column and you want to store it as a vector, right, which means you want to deconstruct your data frame, right? So here the data frame basically has name, age, and parents as one data frame, right? If you want to deconstruct and like get one vector out, right, the name vector, the age vector, the parent vector out, you can do that using the dollar sign, right? If you do df of name, right, df dollar sign name, it basically will extract the first column out, right, and it will extract it as a vector. Okay, the output that you would get will always be a vector, and you can check that. You can do a is dot vector of df of name, right? Is dot vector doesn't work because I'm using a capital I. It should be a small I. If I do an is dot vector, it gives me true. All right. So if you want to extract the like one column, right, or say one vector out from a data frame at a time, you can make use of the dollar sign. Okay, this is only if you want to extract one column. Okay, you can't extract multiple columns using the dollar sign. Okay, I hope that's clear, right? So this is one of the ways in which you can extract, which is by using the name of the data of the variable of the column. Okay, and use the dollar sign for doing that. Okay, please remember, everyone, dollar sign will only work if you want to extract only one column from a data frame at a time. Okay, you can't extract multiple columns from a data frame. So that's that, right? And the output that you will get as a result is a vector, right? It will always extract the data, the values as a vector. The second type in which you can extract column or more than one column by using the names of the columns itself, okay, is in this manner, right? You could just do df, okay, and within square brackets, just mention the name of the column that you want to extract. Okay, so df of, in double quotes, name, right? Because you're trying to extract a column, right? It has to, a column using a name, so it has to be in double quotes. Df square bracket name. When you do this, what would happen is that your data now gets extracted in a tabular manner or in a data frame, right? The output that you would get as a result of this is basically a data frame. It's not a vector. Okay, so there are two ways in which you can extract data by using the names of the variables itself, right? If you use the $sign, it extracts the data as a vector, and you can only extract one column at a time. But if you use it in this manner using square brackets, okay, using square brackets, that means you can extract the data as a data frame, right? One variable as a data frame, or you can also extract multiple columns at a time, right? How can you extract multiple columns? This is how you do it. You can just do df name comma age, right? Do you think this might work? This might not work, right? It will give you an error. It gives an NA, it doesn't give you an error. But what you have to do here is that you have to combine both name and age in a C function, right? And when you run this now, what would happen is that two columns from your data frame, which is name and age, will get extracted. Okay, so this is a, I would suggest this is a better way of extracting information, because you can extract information out as a data frame itself, right? You don't need to like extract data as a vector. Okay, so you can extract multiple columns out, right? And yeah, that's how you do it. Okay, you can extract one column, multiple columns, up to you, right? And if you want, you can also create other data frames, right? So for example, what I'm trying to do here is that I'm trying to create another data frame, df2, which has two columns, right? Two columns, name and parents, right? Out of the original data frame object, right? So if I run this, which is df2 assigned as name and parents from the df object, right? And when I run this, what would happen is there's another data frame called df2 which gets created here, right? And if I do a view of df2 now, this is the output that you get. Got it? So these are the two ways in which you can extract information out from a data frame by referring to the names of the variables, right? Names of the columns. By the way, in a data frame, right, when I say variables, what I mean is columns of a data frame, right? The columns of a data frame are also known as variables, and the rows of a data frame are also known as observations, right? So rows are called observations and columns are called variables. So if I use variables sometimes instead of saying columns, just like it's, don't get confused. It's basically I'm referring to columns itself. Okay. Keith, if you can just paste the code that you're trying to run, right? I'll tell you where the error is. So this is how you create data frames, right? And you extract data frames using names. The other way of extracting data frame is basically referring to the index of the columns and the rows, right? I hope all of you remember how we did that in Matrix. The same way you can also extract information out from a data frame. Okay. So Keith, the code that you've run is the code that you've written is correct, right? Make sure that you run all at once, right? If just do this, just select all of it, right, and then run it, and it still gives you an error, which could be because, okay, you haven't put a comma here, right? Just include comma. Okay, after x and y, just have comma. So it will run, but it doesn't run for me because I've changed the x slightly. But if I run x again, and now if I run it, okay, this is the same code, just have commas between x, y, and z. Okay, no, z, after z you don't need to have a comma, but after x, right, you should have a comma here. After y you should have a comma here, and then if you run this, it will run. Okay, so you can extract data from a data frame by referring to the column index and the row index, right? This is the syntax, right? The first thing that you have to put is the name of the data frame. Within square brackets, you can refer to the row index and the column index to extract specific variables or specific values out from a data frame. Okay, I'll show you how you can use the row index and column index to extract values. So for example, this is my df, right? This is my df. I have 5 rows and 3 columns. If I want to get the second, or let's say if I want to get the second column, okay, and the second row out, which means this value, which means of the second row, I want the second column out, then I could do something of this side, right? I can do df 2 comma 2, and what it will do is it will go to the second row, right, because you specified 2 as the row index, comma, of the second row it will go to the second column, right, and then it will extract that value out. Okay, when you run this, basically gives you 25, which is second row and second column. Okay, second row and second column. Let's say if you want to extract all the elements from the second row, right, which means you want to filter only on rows, you don't want to filter on columns. If you want to get all the values out from the second row, what you could do is that you could do df square brackets 2, because like I want only the second row to be filtered, right, comma, you leave the column index blank, right. When you leave the column index blank, all the values or all the columns will basically get extracted, right. So you run this, what would happen is that all 3 columns, which is Harry, 25 and false, of the second row will get extracted along with it. Okay, so run this and you'll get all the values, right, Harry, 25, false, extracted as a result of that. Similarly, if you want to extract the second column but all the rows format, right, so for example you want all the values from the second column, you don't want to filter on rows, rather you want to filter on columns, then you could do this, right, df, leave the row index blank and have the column as 2. Okay, so when you run this, you would basically get the second, you'll get the age of the, like all the values or all the age values out. Got it? This is how you can refer to the index, right? It's actually, I'm sure, like this is something that all of you can identify with, because we have discussed this within matrix as well. The same methodology is used to extract values out from a matrix, right, by using the row index and the column index, right? And you can also combine, like you can also extract multiple rows and multiple columns out, right? So for example, you could do, if you want the second and third row, right, and the first and second column, then you can also do that. Okay, so df of 2:3, which means the second and the third row, and 1:2, which means the first and the second column, okay, will get out as this, right? So the second and the third row, which is Harry and Michelle, and the first and the second column, which is name and age, is here outputted. Okay, this is how you can extract observations out. Okay, see, when you are extracting one column out, okay, it will always get extracted as a vector, right? Instead, let's say if you were to extract 2 columns out, right, 2 comma 3, then this will get extracted as a table, right? And let's say if you want to even if you want to, let's say, convert this into a data frame, right, even if it gets outputted as a vector, that's okay, right? You can just do an as.data frame. You can just do an as.data frame, okay, and it will basically do the same thing for you. Okay, it will give you in the form of columns. Okay, it's just different ways in which you can extract data. Always, like, you have another way of extracting the data as a data frame, which is, let's say if you want to extract the data as a data frame, just do df of 2, right? This will extract the data as the second column as a data frame. Okay, so this is basically a method in which you can extract values using the row index and the column index itself. Okay, if you specify only the row index, then the data, basically all the columns get subsetted, and if you input only the row and column index, then all the rows get subsetted. What I'm doing here is that I'm saying that I want to get the second and third row out, second and third row, okay, because the row index is 2 and 3, 2:3, and first and second columns. 1:2 will give me first and second column, 2:3 will give me second and third row. So what would happen in this data frame, that from the second and third row, the first and second column will get subsetted. These 4 values will get output, right? So the second and third row and the first and second column, that's what it's doing. I will show the output to you so that you can. So if you see, Harry and Michelle and 25 and 29 is second and third row of the data frame, and the first and the second column. So that's how you extract data from a data frame, right? We will also, you can specify a different path for exporting the CSV file. You can just mention the path along with the name, and it will export the file in that particular folder. That's definitely something you could do. So 3 ways in which we can extract data. The first one is, of course, using the $sign and using the name of the variables, right? That will extract one variable or one vector out. The second way is using the name but in the square brackets, right? That's a way in which you can export data frames but multiple columns out. You can't subset on rows. The way you subset your data on rows and columns is by using the row index, column index syntax, right, in the square bracket, so that you can extract a subset of your data frames, right, both in terms of the rows and columns. Okay? Now, there's another way in which you can subset your data or filter your data, right? And it's the probably the most meaningful way in which you would probably want to subset or filter your data, which is based on a particular condition. Okay, let's say I have this data frame where I have 5 different individuals, but I'm interested to extract data or to extract only those observations or only that part of my data frame wherein the age of the person that I'm trying to extract data for is more than 25 years. Basically, what I'm doing here is that actually filtering my data based on a variable that is present in my data frame, or based on the combination of multiple variables. Okay, so we'll first look at a very simple example wherein if we want to filter the data just basis one variable, right? Let's say that variable is age, and I'm saying that I want to filter all the observations where the age is greater than 25, then I could do something of this sort. The function name to do that is subset. Okay, subset is a function which comes in your base package, which will help you filter data or subset data based on a condition, based on a criteria. Okay, this is the syntax. You write the name of the function subset within parenthesis df, which is the name of the data frame, then comma, and then the condition that on which you want to filter data. So for example, here I'm saying that the age of the person, which is df of age, is more than $25. It's more than 25, right? Not more than $25, but more than 25. So when or more, actually it's greater than or equal to, which means everyone whose age is either 25 or more than that will get filtered as a result of this. So when I run this, you'd see from my df, there are two observations, Anna and Frank, whose age was less than 25. They get filtered out, and I only have data for these 3 people, Harry, Michelle, and Peter, whose age is more than or equal to 25. Harry also gets outputted because we put a greater than or equal to condition. If we had put a greater than condition and not greater than equal to, then Harry would also have gotten filtered out. Okay, that's the simplest way in which you can subset data, in which you can filter data. Okay, the other way, or sometimes you might also be required to filter data on multiple conditions. Okay, let's say I'm interested in filtering this data. I want to get all the data out where the age is greater than 25, but the person should also be a parent, right? I want to subset data on 2 conditions, which is the age is greater than 25 and the person is also a parent. In that case, what I can do is I can make use of this relational operator, right? Sorry, not the relational, but the logical operator, and operator, wherein I'm trying to combine 2 different conditions. So I say subset of df, where df of age is greater than 25 and df of parents is equal to true, right? When I run this, what would happen is that there are 2 different conditions that will get evaluated. There are 2 different conditions that will get evaluated, and only if both the conditions are holding true because to our data frames. Okay, so there are several ways in which you can extend your data frames, right? We learned at least 2 or 3 ways in which you can extend our data frames. Actually, 2 ways, and I'll leave it to you, right? Whichever you feel more comfortable working on, you should choose that. The first way in which you can add more columns to your data frame is very simple. Okay, it's very simple. You could do something of this sort, right? You could just do df $ height of centimeter, height underscore centimeter. What I'm doing here is that I'm adding a new variable into my data frame, right, by directly putting the values here. So df $height of centimeter, this height of centimeter will be a new variable that will get added to my data frame. Currently my df has only 3 variables, right? Name, age, and parents. If I do df of height $ height underscore centimeter and then c of 120, I basically put all of their heights in centimeters, and if I run this, what happens is that my df now gets a 4th column get added to it, right? So you can directly just input the name of the new column with the $ to the existing data frame and input the values, the same number of values as the existing number of items in your data frame, and you will get a new column that will get added to your data frame. Okay, so this is how you can add a new column to your data frame. Another way in which you can add a new column is by creating a new column using an existing column, creating a new column using existing values or existing variables in your data set. So here what I'm doing is I'm creating a new variable called weight underscore kg, right? where I'm saying that the weight of the person should be calculated as the half of the height of the person in centimeters. It's a hypothetical formula, but like I'm just saying that this is how you can create a new variable, right? You can possibly, let's say if you have a variable called age, right? You could just do an if else condition and say that if the age of the person is greater than 25, then it becomes old. If it's less than 25, then it becomes, let's say, not old, something of that sort. Okay, so using an existing variable, right? How do you create a new variable? This is how you do it. df of weight underscore kg is df of height divided by 2. When I run this, the new variable weight underscore kg gets added to my existing data frame. Okay. So funny, when you add a new column to the data frame, it will always get added at the end, right? You can't add it in the middle. But if you want to change the positions later, you can do that. Right? You always can change positions, right? You can put weight as first, age as second. That's something you can definitely do. But like when you add a new variable to a data frame, it always gets added to the right. So this is how you can add a new column to your data frame. How do you add more rows to a data frame, right? So how to add rows to a data frame, right? Columns is easy, right? You can do either of these two things, right? And add columns. Adding rows is slightly difficult, right? Not difficult, but slightly more complicated. For adding a new row to a data frame, what you'll have to do is that you will have to first create a data frame. You'll have to create another data frame, right? Which has the same number of columns as the original data frame, and then you can append that data frame using a rbind function. I hope you remember there were two functions, cbind and rbind, which were used to extend a matrix, right? If you want to extend a matrix by adding more columns, you can use a cbind function. If you want to extend a matrix by adding more rows to a matrix, you can use a rbind function. The same set of functions work the exact same way with data frames as well. You can use a rbind function to add more rows to your data frame, and you can make use of a cbind function to add more columns to your data frame. Okay. How do you do it? So basically what I'm doing here is that I'm creating another data frame where the person who I'm adding is, his name is Ram, his age is 45, he doesn't have any kids, so he's not a parent. His height I don't know, so it's NA, and his weight is also not known to us, so I'm putting it as NA. But what I'm doing here is that I'm creating another data frame, right, df of new, which basically stores another observation, right, in the same order, right, in the same order and the same number of columns. And now I can make use of rbind, right, and add this df underscore new to the bottom of my existing data frame, right? And because I want to do it to the same data frame df, I'm going to assign it back to df, right? So I'm doing rbind of df, comma, df underscore new. Df is my original object, this object which has 5 observations. Df underscore new is another object which has 1 observation. Now if I do rbind, which is df comma df of new, what happens is in the new df, in the df gets calculated as a result of my output. You'd see Ram, who's basically part of df underscore new, is basically appended to the same object itself. Got it? So this is how you can add more rows to your data frame. This is how you can append more observations, right? Append more rows to your data frame. Okay, so this is how you add a new row to your data frame by using rbind. The way you would add more columns is by using, is of course like one of the 2 ways we've already discovered, right? These two. The another way in which you can add more columns to your data frame is by using the cbind function, right? So for example, in my df, right, in my df, this is my df. If I want to add another column here, which basically is the profession of all of these people, right, then I can do something of this sort, right? I can just do cbind df comma profession, which is the name of the variable, and then the values, right? C of doctor, engineer, and let's say teacher. Okay, 1 2 3 4 5 6 observations, the same number of observations that I have in my original object. So when I run this, my df will get appended with another column which is profession. Okay, so there are 3 ways in which you can add columns. You can either use this, right, which is just use the dollar sign and add new values, right? This is the easiest way of doing it. Then what you can do is you can create new variables using an existing variable. Okay, you can add new columns using an existing column in your data frame. And then finally, the last one is that you can use a cbind function as well, right? I hope the role of cbind and rbind is clear to everyone, right? We've used it multiple times. Yeah, so that's how you can extend your data frames, right? Either in a vertical manner or in the horizontal manner. The last thing that we're going to do with data frames, right, before we move on to a couple of more important functions, right? Or data exploration objects or data exploration functions. Okay, so how do you sort data frames, right? How do you arrange your data frame in a specific order of rows is something you might want to do, and that's something that's a useful sort of a use case as well, because you might be interested in, let's say, sorting data by, let's say, by the age of people in the ascending order, right? Or you might want to sort the people based on their name in a descending order, right? That's also something which is often required. Okay, so the function that you use to sort data frames by specific column is called order. Okay, order is a variable that you can use to sort your data frame. Okay, and this is how you do it, right? Df, right, the name of the data frame that you want to sort, within square brackets, just use the function order, right, and in parenthesis mention the column based on which you want to do the sorting. Okay, let's say I want to do the sorting by name, right? Then in order, in basically in order, the object that I specify is df of name, which means the name variable, and then comma, I leave the column index blank, right? And when I run this, what happens is my data set basically gets filtered. Sorry, not filtered, but gets sorted in the ascending order of age, right? Which means the person whose name starts with A comes on the top, then with F, H, M, P, R, right? So basically in the alphabetical order, ascending alphabetic order, right? My observations get sorted. Sometimes I might be interested in sorting data in a descending order as well, right? By default, if you do not specify the type of ordering, right, the type in which you want to sort, the data will always get sorted in the ascending order. Okay, but sometimes I might be required to sort data in the descending order or in the decreasing order. So to make that happen, what you have to do is that within the order function, right, just add another argument which says decreasing is equal to true. As soon as you write decreasing is equal to true, the order in which the data gets sorted will get reversed, and like observations which start with Z or whichever, like it's basically in the descending order of the alphabetical order then, right? So I'll show it to you. When you run this, the sorting is reversed, right? The person whose name starts with R, right, which is the last in the set of names that we have, right? R is basically the last alphabet. So R, P, M, H, and F, and A, right? So it's basically in the descending order now. Okay. So this is how you can sort your data frames using a variable, right? You can also sort on numeric variables. So for example, if you want to sort on age in the ascending order of age, this is how you can do it, right? If you write, instead of you writing name, if you write order of df of age, right, comma, you leave it blank, this basically gets sorted in the ascending order of age, 20, 23, 25, 29, 31, 45, right? But if you want to do the reverse of it, right, which means if you want to sort in the descending order of age, then you can do decreasing is equal to true. Okay, yeah. Like with respect to data frames, the sort of basic functionality that you need to know with respect to a data frame, right, is something that we've discussed, right? I think what we should do now is that we should see how do you go about exploring a data frame further, right? So let's say if you have a large data frame, right, how is it that you could potentially use certain functions to explore data frames in a better manner? Okay, we're gonna explore certain functions. So guys, join is nothing but it's essentially a way in which we could join two or more than two data sets, right, based on a common variable or a common key between variables. Okay, there are several types of joins, right? Let me first tell you what the different kinds of joins are, right, and then we will try and implement this in R as well. Joins is important because like when you work on a practical problem, what would happen is you will have to sort of create multiple, or you'll have to extract data from multiple data sources, right? And to create a consolidated data set which contains information, right, one common source of information for all of these, like which is a combination of all of these individual data sets, for that you'd have to do something which is called joins. Okay, so for example, I'll give you an example. Okay, let's say there are two data frames here, okay, that we have. The first data frame that we have basically has two columns, right? Name of the student, or let's say roll number, okay, name of the student, and then we also have the students' marks in, let's say, maths and science. Okay, let's say the roll numbers are 1, 2, 3, 4, 5, whatever, 4, 4, 5, 6. Okay, A, just going to put random names here. Okay, and then you have their maths, the score that these guys got between, like, in two subjects, maths and science. Okay, I'm going to randomly populate them. Let's say you have one data set which has this. Okay, and then you have another data set, right, which basically captures, let's say, the name of an individual. Sorry, not the name, but the roll number of the individual, their score in, let's say, another subject called physical education. Okay, so you have two different data frames here, right? In the first data frame, we have roll number, name, and scores of people in two subjects, maths and science. We have another data frame, let's call this df2. Okay, and this df1. In df2 we have scores of these students in physical education. Let's say we have 7 and 8 as well here. Okay, so this is df1. Df1 has more observations than df2 because, let's say, in the physical education exam there were two people who were absent, right? So roll number 7 and 8 were absent, hence we don't have their numbers here. Okay, so we have two different data frames here, df1 and df2, right? What we have to do is we have to join information, right? We have to combine these two data frames in the manner that the information, right, from df1 and df2 can be combined to create one common source of information where you have their subject scores in math, science, and physical education. Okay, there are three ways in which you can do it, right? Or let's say there are two different ways in which you can do it. Okay, the first way in which you can do it is called, actually there's something called inner joins and there's something called outer joins. Okay, inner join basically mean, let's say you have two different tables, right? Table A and table B. Okay, then inner join basically will capture only the common information between A and B. Okay, that's what inner joins do. What do I mean by that? Is, let's say, if I join df1 and df2, right, and I do an inner join between these two tables, right, then I will basically get, and I have to do it on roll number because roll number is the common key between df1 and df2. So when I do that, only the common entries between df1 and df2, the common entries of roll number between df1 and df2 will basically be present in my final output, right? So there is 1, 2, 3, 4, and 5 and 6 which is present in df1, and 1, 2, 3, 4, 5, and 6 present in df2. So when I do an inner join between the two of them, right, then the output that I get will look something like this. The output of df1 inner join df2 will look something like this. These two observations, 7 and 8, who are present only in one of the two data frames, right? They are not common between the two data frames, right? Roll number 7 and roll number 8 is present in df1, but it's not present in df2. Hence, in an inner join, when you do an inner join, only captures common entries of both the tables, right? So when you do an inner join, these two observations basically get removed from your final output. Okay, so it only captures common information between the two tables, right? That's an inner join. Okay, there's another kind of join which is called an outer join, right? It's called an outer join, and there is a left outer join, a right outer join, and there's something also called full outer join. Okay, full outer join. What's a left join, first of all? Okay, left join basically means that, let's say, if you have two different tables, right? Let's say you have table 1, table A, and table B. Okay, table A and table B. Assuming that table A is on the left, right, and table B is on the right, and that's how it looks like as well. Then in a left join, what would happen is that all the observations from table A will be picked, right, and the corresponding common information between A and B will be picked in the final output. So like while you're getting the common entries between A and B, you are retaining all the information which is there in your left table already. That's what a left join basically means, right? So as a result of the left join between df1 and df2, if in the left hand side we have table df1, then what will happen is that all the observations of df1 will be present in the final output, right? And the corresponding common information of df2 will be present in the in the final output, but the last two rows, for example, for 7 and 8, the scores of physical education will be a missing value. You'll have an NA here. Okay. What has happened here is that because we've done a left join, all the information from the left table has been retained in the final output, and the corresponding common information between the two tables has been retained in the output as well. Right? Whatever is not present in the right table has been basically filtered as a missing value. Okay, that's what happens in a left join. Okay, what right join is basically an exact opposite of left join, right? Which means all the information from a right, let's say if I were to, let's say, create a visualization for right join, right? You have two tables again, A and B. Then right join is nothing but all the information from right table and the corresponding common information from left and right table gets output in your final output. So it's an exact opposite of left join, right? Let's say in this example we had another I'm just hypothetically adding another roll number here, right? Roll number 9, and his scores in physical education is 78. Then if I do a right join of df2 and df1, where df2 is in the right, the output of right join will be this.
Let's have a quick quiz question, guys. And the question is, what is the area under cumulative density function? And your options are 0, infinity, 1, or changes with the CDF.
Just a quick info, guys. Intellipaat offers state of the art data analytics course in association with IITM Pravartak. Through this course, you can learn all the important tools and concepts of data analysis such as Power BI, data wrangling, data mining, etc. from esteemed IIT Madras faculties and industry experts. With this course, we already have helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take a first step towards career growth in the field of data analytics.
Would basically be, I'm going to generate it and then I'm going to explain what it means. This is how your output of right join will look like. Basically what you've done here is that you've retained all the information from the right table, right? Roll number 1, 2, 3, 4, 5, 6, 7 and 9, 5, 6 and 9, right? And you've retained the common information between df1 and df2 from the left table, right? So you have in the left table you have only 6 roll numbers, 1, 2, 3, 4, 5 and 6, which are common between df1 and df2. They're all here, right? And you have their name, maths, and like the names of the students, the scores in maths and science as well. But for a roll number 9, because it's present only in the right table, it's not in the left table, you retain all the information which you had in the right table for it, but the corresponding common like from the left table you don't have the name, maths, then the name of the student, the score in maths and science. Hence you've left it as a blank or a missing value. Okay, you'll have a missing value here. Okay, this is basically a right join. Okay, a left outer join or a right outer join. Okay, when you do something, there's another kind of join, by the way. It's called a full outer join. Full outer join is basically, as like you can expect, it basically retains all the information from the left table and from the right table, right? So as a result of the full outer join between df1 and df2, the output that you would get would be something like this. Yeah, so there'll be a bunch of missing values. This will be missing, right? But whatever you could have retained from both the tables, you have it here, right? So you have all 9 roll numbers here, 1, 2, 3, 4, 5, 6, which are common between df1 and df2. 7 and 8, which is present in left table but not in right table, and 9, which is present in right table but not present in left table, right? So retaining all the information that you could have potentially retained, right? But wherever you don't have information available, for example, for 9th roll number, you do not have any entry in df1, so you'd have the name, maths and science as missing value. For 7 and 8 roll number, right, because you have information in left table but you don't have the information in the right table, there's a missing value in physical education score. Okay, this is how join basically works, right? So you find a common key between two different tables and you try to join them based on that common key, and you try to basically match information accordingly, right? It's like a VLOOKUP if you've used Excel. When you try to VLOOKUP, right, information from one array to another array based on a common information, that's what a join equivalent would be, right? VLOOKUP is generally just done on one variable, one column, but in joins you can combine, you can create a key of multiple columns as well. Okay, so I hope like the concept of join is clear to everyone. Let's try and look at a couple of examples, right? I'm going to clear my console and also clear my environment so that it's easier for you to understand. What I'm going to do now is that I'm going to create two different data frames here, right? Two different data frames. The first data frame is called employee data frame. Okay. The second data frame that I'm creating is called the department data frame, right? What do we have in each of these data frames? Okay. The department data frame basically captures, or actually let's look at the employee data frame first. So employee data frame basically captures the name of the employee, right? The salary of the employees, okay, and the department of the employees, right? What department do the employees belong to? The name, salary, and department. This is what we have in the employee table, right? Let's imagine these names are basically nothing but the head of the department, right? So the tech department is headed by Sam, the sales department is headed by Bob, and the analytics department is headed by Annie, right? And this is their salaries. The department table basically captures the location of these departments, right? So you have three different departments here. Tech, the location of tech is in Chicago, the location of analytics is in New York, and the location of support is in Boston, right? These are the two data frames that we have, right? As you could imagine, we can join these two data frames, right? To create a combined data frame which has name, salary, department, and also the location of the department in just one common data frame, right? So let's try to see how we can do this, right? How can we create, how we can join our data frames and combine information, right? Consolidate information. Let's try to do that. Before that, I'll just quickly suggest one change that all of you do is that in the in the code that I've shared with all of you, make sure in the employee, while you're creating the employee data frame, the name of the the department column in the employee table is also DEPARTMENT, right? So the same names across both the across both the data frames. Okay, earlier I think the code that I shared with you had only DPT or DEP, right? Just change it to the whole department. Okay, here. So now your employee table has name, salary, and department of the person, and the department table has department and location. Okay, let's try to see how we can join these tables, right? How we can join these data frames in R by using inner join, left join, right join, and outer joins. Okay, let's try to do that. So the first kind of join that we would study is called basically the inner join. Okay, the inner join. Okay, this is how you would run the inner join, right? So just type merge, or actually it's already here. Merge. Okay, the table on the left, let's call it the employee table. The table on the right, the department table. Okay, and then specify the common key by. Okay, I'm going to repeat it, right, and I'm going to elaborate on it as well. So what you have to specify in the merge function is basically the name of the two tables on which you are trying to do the join. Okay, so the table on my left is the employee table, right? And when I specify the table on the left, right, whatever table I specify on the left, it is generally aliased as X in this code. What do I mean by alias? What do I mean by this term? Alias is nothing but if R has to refer to this data frame by a specific name, it refers to it by X, right? It just hypothetically creates a name for it and it calls it X. Okay. The table on the right, the table that I specify second is taken as the right table, the table on the right, and the alias that gets assigned to it is Y. Okay, so employee is X, department is Y, and then you have to specify the key on which you want to do the join. How do you specify the key? You just have to write by. You have to write by equal to the name of the column on which you want to do the join. Okay, the name of the column on which you want to do the join. So merge employee, department, by, and within double quotes the name of the column, which is department, because department is common between the two tables, right? The department is common between the two tables. When I run this, I get the output. So I have two people from the employee table. By the way, this is an inner join. Okay, this is an inner join. Right? This is the syntax for the inner join. How do we do a left join or right join? I'm going to share it later. But this is the syntax for an inner join, right? And when I do an inner join between these two tables, what has happened is that there's one observation right, from the employee table, which has been removed from my final output, which is Bob, right, because the department that he belongs to, sales, is not present in the department table, right? In the department table, we have three departments: tech, analytics, and support, but we do not have any information for the sales department. Okay, so when I do a join on employee and department on the department column, because the sales department is not present in the department table, the employee Bob, right, whose department is sale, gets removed from here. Okay, and because we do not have any employee, or we do not have the information of the head of the support department in the employee table, this information gets missed from the final output, right? So as a result of the common operations, I have two employees, Sam and Annie, right, who belong to the analytics and tech department, and their corresponding location here available to me in my output, right? Because it's an inner join, we only have common outcomes or the common values from the two different tables, right? The common values were the tech department and the analytics department, right? It's common between these two tables, right? Support is only in department table, sales is only present in the employee table, right? Hence, in the result, in my output, I have only two values. Okay, this is how you would do an inner join. Okay, now sometimes what might happen is, right, in the two tables that you have, the name of the common variable, the name of the common key on which you are doing the join could be different, right? In the employee table, the department table might be referred to as DEP or DEPT. In the department table, it's referred to as DEPARTMENT, right? So now, if you try to run this code, right, which says by is equal to department, because the name of the two variables are different in the two data frames, this code might fail, right? So in that case, when the names of the variables are different, right, in the two data frames, what you could do is that you could say by.x, and I'm going to show you. For example, in the employee data frame, right, the name of the department column wasn't the whole department, rather it was just DEP. Okay, let's say I've changed the employee table again, and I'm saying that the employee table, this column is referred to as DEP, and in the department table, this common column is referred to as department. Now, if I run this, right, merge, it will give me an error. It will give me an error because it's not able to find the department column in the employee data frame. Okay, so to solve for that, what can I do is that I could just do something of this sort, right? I can do merge employee, which is aliased as X, department, which is aliased as Y. I could do by.x, right, which is the key on which in which you should do the join in the X table, which is in the employee table, is DP, and in the department table, it's equal to department. When you run this now, right, which is employee department, by.x is equal to DEP, comma by.y is equal to department, it will give you the right output. Okay, so this is the difference, right, between these two codes. This is the inner join code if the name of common key is same in the tables. Okay, and this is an example if the common key, if the name of the common key is not same in the two tables, right? So if it's not same, then you have to write by.x as the name of the variable in the X table, the left table, and by.y equal to the name of the variable on the Y table. Okay, is this clear to everyone? So for simplicity, what I'm going to do now is that I'm going to change the name to the department name itself, right? Because like, what's the point of writing by.x, by.y every time? So I'm going to go back and say the employee table also has the name as department itself, right? And the department table also has. So basically in the two data frames, I'm just changing the name. I'm saying it's the same name across both the tables. Okay. So now this is how you would do an inner join, right? How do you do a left join and how do you do a right join? Let me show you that. So do a left join, right? The code remains the same. Just write merge employee comma department, by is equal to department. And then if you write all.x is equal to true as the last argument, what you're saying is that I want all the elements of the employee table in my final output, which means it becomes a left join, right? Because in the left join, what happens is that you want all the information from the left table and the corresponding common information from the right table, right? So when you do all.x is equal to true, it basically refers to it as a left join. Okay. So when you run this, you'd see in your output, all the information from the left table, right, name, Annie, Bob, and Sam gets retained in the final output, right? But from the right table, right, because the department or the location of the sales department is not known, you get an NA here. Got it? So this is how your left join basically works, right? So if you just do all dot x is equal to 2, it becomes a left join. If you want to do all dot y is equal to 2, it becomes a right join, right? So let's say if you want to get all the information from the right table, the department table, and the corresponding common information from the left table, then just write all dot y is equal to true. And what would happen now is that all the three departments from the right table, tech, analytics, and support, show up in the final output. But you do not know the name and the salary of the person who's heading the support department because it's not there in the employee table. So now it becomes a right join instead of a left join. Okay, and finally, if you want to do a full join, which means you want to retain all the information from the left table and from the right table both, then just instead of doing just all dot x is equal to 2 or all dot y is equal to 2, mention both, right? Just do all dot x is equal to 2, comma all dot y is equal to true, right? And when you run this, basically becomes a full outer join, right? And you have now in your output 4 different entries. All the information from the left table is here, and all the information from the right table is also here, right? You get a full join output here. Got it? So left join, if you want to do an inner join, right, do not specify all dot x or all dot y is equal to 2, right? That works as an inner join. If you specify all dot x is equal to 2, it becomes a left join, right? And how do I say it's a left join? Because the table that you specified first, right, will become the left table, the table on the left, and it will be aliased as x. The table that you specify on the right hand side will be aliased as y, and it will become the right table, right? So when you do all dot y is equal to 2, it becomes the right join. And when you do all dot x is equal to 2 and comma all dot y is equal to 2, it becomes a full outer join. Got it? So this is how your joins work. This is how your joins work. Okay, so I hope the joins are clear to everyone, right? There's another thing that I want to show you. I don't have an example for it, but I can just tell you. For example, if you want to join on multiple columns, right? Sometimes you might be interested in joining not just on one column, but on 2 different columns or 3 different columns. In such cases, what you can do is you can do something of this sort. So you could do by is equal to C of all the columns on which you want to do the join, right? So let's say the first column on which you want to do the join is department. The second column is name, right? This is how you can do it. It's not possible in this case because the name is not present in both the tables. But let's say imagine, right, that there was variable 1 and variable 2 both present in both the data sets. Then you could have used something of this sort, right? And in this case, only when both the conditions, right, both variable 1 and variable 2 match in the 2 data frames, that's when the join would happen. Okay, so just a hypothetical scenario, but it's an important thing for you, all of us, to know. A couple of other things that I want to just show you. There's one very important function that all of us should be aware of. Okay, and that function is basically called the summary function. Okay, there's a function in your base package that's called the summary function, and that's probably one of the most important functions in R when you want to do descriptive statistics, right? But for doing that, I would request all of you to when you import the data in RStudio, using read.csv, just include this another argument called string as factors is equal to true. It's in something called inbuilt functions. So when you do read.csv, right, just ensure that you are also including string as factors is equal to true. What this does is that it imports data. All the string fields that you have in your data basically get imported as a data type which is called factors, right? And when you're doing some statistical analysis on data, right, all your character variables, all your string variables should be stored in the factor data type itself, right? I will explain more on what a factor data type is and what kind of variables does it help you store. But for now, right, just imagine factor is a data type which is a substitute to character, right? Rather a better substitute of character because it helps you do statistical analysis. And all the string values will be stored as factors as soon as you import the data set if you include string as factors is equal to 2 in your data frame. Right, so just do this, right, and I'll explain later what factors does and why is it important. But for now, just import your data frame using string as factors is equal to true. Okay, so as imagine I've done that, right? I've imported my data frame where the string fields have been replaced by factor fields, right? Which means nothing else changes, just that the data type of the variable is not character anymore, it becomes factor. Okay, now if I run a summary on this data set, if I run a function called summary of customer underscore churn, right? What this function does is that it gives me the descriptive statistics of my entire data frame. Okay, I'll probably clear my data like console and show you what the summary function does. I'm going to run this summary of customer churn. Okay, and when I run this is the output that I get. So what happens as a result of the summary function, okay, is that, guys, please, before you run the summary function, make sure that while importing you include string as factors is equal to true. Otherwise, this function will not give you the kind of output that you're expecting. Okay, so if you get a different output than me, just make the reason could be that you have not included string as factors is equal to true. Okay, great. So now, when you do the summary function, this summary function basically gives you a lot of very critical information, right? So for all the categorical fields, which means all the character fields or all the factor fields, it basically gives me the count of observations across each unique value. For example, for gender, it tells me that there are 3,488 customers who are females and there are 3,555 observations that are made. Similarly, for people who have partner or don't have partner, this is the distribution. Based on dependents, this is the distribution, right? These many people have phone services, these many people don't have phone services, these many people have multiple lines, these many people do not have multiple lines. So basically, a lot of descriptive stats on your categorical variable, right? So it tells you the number of observations on each class of your categorical variable. Okay, that's what it does for categorical variables, right? For character variables. For continuous variables, right? For example, for tenure, which is a continuous variable, right? It's a numeric field. It tells you the distribution of this data set of this variable, right? It tells you that the minimum value of tenure that you have in your data set is 0. The first quartile value, which is the 25th percentile value, which means that 25% of your observations, 25% of your customers have a tenure less than 9 months. Okay, median is 29, which means 50% of your customers have a tenure less than 29 months or more than 29 months. It's 50%, so it's like either of the statements hold true. The mean tenure is 32.37. The third quartile value, which is the top quartile of the 75th percentile value, is 55, and then the maximum tenure that you have of a customer is 72. So it gives you a distribution, basically gives you the distribution of your entire continuous variable, right? And it gives you for all those variables. For example, for tenure, you have it. You also have it for monthly charges. It tells you that the mean monthly charge is around $65. The minimum is 18.25. First quartile is 35. So it gives you a lot of useful information about each variable of your data set, right, in a very, very detailed manner. It also tells you if there are any missing values in your data set, right? So for example, it tells you that in total charges, there are 11 missing values. There are 11 NAs. Okay, there are 11 NAs. So summary function is used for that, right? It basically gives you the statistic, not like it doesn't give you all the statistical information. It doesn't give you variance, standard deviation, etc. But it gives you min, max, mean, median, first quartile, second quartile, etc., third quartile. Okay, it's a very useful information in general. Right? It gives you a lot of information while you're exploring your data set. We're going to get started with data manipulation, right? We're going to see how do we actually make use of certain functionalities in R, right, to manipulate our data better, right? That's what we're going to do today. We're going to also explore an external package, right? That package is called DPLYR. We're going to see how do we import that package into R, and then how do we go about extracting functions from that package and doing certain advanced data manipulation actions within our data sets, right? Now, character data type is a data type in R which is fine, right? But it's not like, there are a lot of functionalities in R, particularly in data science, that don't work very well with a character data type, right? Character data type is usually used for categorical variables, right? Categorical variables are variables that explain qualitative information, right? For example, if I look at this data set, gender would be a categorical variable, right? It's basically representing categories of data, right? So female is one category, male is another category, right? So like both the unique values here, male and female, are representing categories of values, right? Similarly, if I look at this variable like partner, dependent, etc., these are also categorical variables, right? There are like at a very high level, there are two types of variables. There's numerical variables, okay, which is like tenure, which is in the form of numbers, and there's categorical variable, right? There's something that represents categories of information. In statistics or in data science, whenever we want to work with categorical variables, okay, whenever we want to work with categorical variables, the data type that we should ideally assign to those variables should be factors. Okay, there's another data type in R which is called factor. Okay, factor is a data type which is slightly more advanced as compared to character data type. Okay, categorical variables are basically the data type that we're required to assign to categorical variables in R is factor. Okay, factor is that data type which is slightly specialized in the sense that there are two types of categorical variables, right? There's a categorical variable that basically doesn't have any order to it, right? That doesn't have any hierarchy. For example, male and female, right? This is a nominal categorical variable, okay, which means the two types of values that you have in this variable, which is male and female, they're both, there's no order in the sense, right? There's no order, there's no leveling here, right? You can't say that male is a higher level as compared to female or female is a higher level as compared to male. They're both sort of equal sort of values for us. Similarly, partner being yes or no is also nominal categorical variable, right? Which means the two values of the variable that we have are all of the same level, right? You don't have different levels. However, right, there are certain categorical variables that might be ordinal, right? They might have some order. For example, if we say age group, right? Age group of people, right? Let's say there are three different age groups that we have defined. Let's say the age groups are children, young adults, and senior citizen, or let's say middle-aged and senior citizen, right? There are four categories. Now, this is an ordinal variable because there are different levels to this variable, right? There are, like you would know that if there's an order here, right? Young children are possibly the lowest in terms of age, followed by young adults, then middle-aged, and then senior citizen, right? So there's a particular order here. However, it's a categorical variable, but the specialized kind of categorical variable that you have is an ordinal categorical variable, right? Where you have an order. Similarly, when you, for example, when you rate, right? Whenever you fill surveys, right, you would have responses like satisfied, highly satisfied, not satisfied, disappointed, etc., right? So here there is an order, right? Very satisfied probably has the best rating, and not satisfied or dissatisfied has the least rating, right? So there's an order to different values of this categorical variable. Okay, so within categorical variable, there's something called nominal categorical variable. Okay, something like gender, like phone service, etc. And there's another kind of categorical variable which is ordinal variable, right? Where there's a specific order. For example, age groups, right? For example, the rating that you, not the rating, but the response that you give to a survey. Okay, factor is that data type, right, which basically supports both these types of categorical variables, right? Nominal categorical variables and ordinal categorical variables. Hence, when we include string as factors is equal to true, okay, what it lets you do is that it basically saves all the categorical variables as factors. Okay, so I'll show you an example. Let's say I write this customer underscore churn code again without mentioning this string as factors is equal to true. Okay, without mentioning this, if I run this, okay, you see all the variables, right? For example, customer ID, gender, partner, they're all saved as characters here, right? They get saved as characters, right? The data type that gets assigned to them is character. But if I include string as factors is equal to true, okay, the data type that gets assigned to this categorical variable becomes factor. Whenever you import data sets into R, okay, make sure that all the variables, all the categorical variables that you have are saved as factors. Okay, most data science functions expect your categorical variables to be saved as factors and not as characters, and hence string as factors is equal to true is important, right? You should, whenever you import data, just include string as factors is equal to true, right? And it will make sure that your data gets imported, all the categorical variables get imported as factors itself. All right, so that's what string as factors is equal to true does. Okay, it is like a label encoder. That's right. Data manipulation is basically the process of changing the shape of your data in order to make it more organized, and also sort of summarizing your data, aggregating your data, transposing it. All of that comes under data manipulation. Data manipulation is important, or the raw data that you would get from source, right, might not be in the format that you need. For example, let's say if you ask for transactions data, right, from let's say customer transactions data from the telecom provider, you might get a day level data, right? Date for every customer, you would get what was the number of transactions that the customer had done. So you will have to aggregate it, right? You'll have to convert that into a monthly sort of a level, or you might have to change it to at a customer level, right? You'll have to summarize the data, right, to get that information at a customer level, right? You would calculate for each customer what is the average monthly cost or what is the total charges that the customer has paid till date, right? So that basically is a form wherein you do aggregation. Okay, so that's what your data manipulation is all about, right? It basically includes transforming data, aggregation of data, and summarizing data. Okay, now data manipulation is best done using a package called dplyr. Okay, dplyr is the name of the package that basically supports data manipulation. There are many packages, by the way. There are many libraries in R Studio which will help you perform data manipulation in a very, very efficient manner. But the best way to do it, the most popular packages among them is dplyr. So we will explore how to import dplyr and how to start using the functionalities of dplyr just in a moment. But before that, I want to just cover this function here, which is called the apply family of functions, right? Apply family of functions is basically a set of functions, a number of functions, 4 or 5 different functions, which would help you perform iterative operations by writing very simple sort of a syntax. Okay, you could call apply function a replacement to like loops that you typically write in programming, right? You write for loops where you have to, if you have to perform a certain operation or certain function to multiple columns of a data frame, how you would have to do it, you will have to basically run a loop, right, that goes from first column to the last column, and then you keep doing the same operation one after the other, right, and it happens automatically. That's what a loop does. For achieving the same output, right, you could make use of this function called the apply functions. Okay, apply functions are nothing but these are implicit loops, right, but they will make the purpose of, or they would actually make the operation very, very efficient and very, very easy to code as well, right, as opposed to a for loop, etc. Right. So there are 4 kinds of apply functions, right? There's something called apply, right, which is the main apply function. Then there is lapply, sapply, and tapply as well. Okay, so what we'll do is we'll try and see what each of these functions do, right? What is the purpose of apply function? What is the purpose of lapply, sapply, and tapply, right? How are they different from each other, and what is the kind of output that we get across each of them? First of all, let's just create this data frame, right? df. What this data frame has is scores of students, right? 5 different students in 4 different subjects, right? Maths, science, arts, and English. Okay, so df is basically a data frame that captures the scores of 5 different students, right, in 4 different subjects that they appeared for. Okay, so math, science, arts, and English. This is the df. Okay, what we'll do using apply function is that we'll try to see how can we apply the same function. How can we create an operation wherein the same function can be applied across each column of your data frame, and you can get the output, right, a summarized output or a whatever function you apply, right, across each column of a data frame. Similarly, we'll also see how can we apply something that can be run to each row of your data frame, right, which means to all of these values you can apply the same function, to all of these values you can apply the same function, right? Basically writing a function which can perform the same function or the same task in an iterative manner across different columns, right, or across different rows, okay, of a data frame. That's what we are going to try and do. Okay, and that's something we are going to achieve using the apply function. Okay, so what I'll first try and explain to you what is the syntax of the apply function. This is the syntax of the apply function. The name is apply, right? The function name is apply. Okay, you write the apply function. The first argument in your apply function is the object on which you want to perform the operation, right? This object could be a data frame, it could be a matrix, right? It has to be a 2-dimensional object though. Okay, so whenever you have to perform repetitive action, a repetitive operation on a 2-dimensional object like a matrix or a data frame, the function that you would choose is going to be a apply function. Okay, so the object has to be a 2-dimensional object. It could be a matrix or a data frame. The second argument of the apply function is the margin. Okay, margin is basically something that specifies the dimension on which you want to operate, which means whether you want to do the repetitive action across each row of the data frame, right, which means you want to perform actions on a row wise manner, or whether you want to apply the function in a columnar manner, right? Which means it should go from one column, perform the task on all the values of the column, then go to the second column, do the same thing, third column, fourth column, fifth column, etc. So margin is something that specifies that whatever operation or whatever function you are trying to apply, right, whether it has to be applied across all elements of the same row or all elements of the same column, or whether you want to work on both rows and columns, right? Which means you want to perform the operation on each and every element of your data frame, right? So there are three different kinds of margins that you could apply. If you apply the margin as 1, it means that you want to perform the operation in a row-wise manner, right? Which means the same operation will be done across each row of your data frame. Okay, I'll show an example as well. If you put the margin as 2, it means that the operation will happen in a columnar manner, right? It will run the operation on the first column, then the second column, then the third column, etc., etc. And then finally, if you do C of 1, 2, it would mean that the operation would happen on both rows as well as columns. Okay. And the third argument that you would specify in the apply function is the function that you want to run. Right. This could be any function from your RStudio library. It could be a mean, it could be a sum, it could be a user-defined function as well. Right. It's just that any operation or any function that has to be done in a repetitive manner across rows or across columns of a data frame, you would specify that function here. Okay, this is the syntax of the apply function. Okay, now let me show you how this function works, right? How this function works, or how this gives you an output. Okay, so this is our DF, right, which stores the scores of students in maths, science, arts, and English. There are 5 different students. These are their scores. Now, if I want to perform an operation, wherein I want to find out what is the average score of students in the first subject maths, what is the average score of students in the second subject science, what is the average score of students in the third subject arts, and what is the average score of students in the fourth subject English. What you'll have to do otherwise is that you'll have to get the mean of the first column, right? You'll have to do something of this sort. If you did not have, let's say, the apply function, you have to do this, right? You'll have to write the mean function, and you'll have to get the mean for maths separately. You'll have to get the mean for science, right? This is how you'd have to typically run this operation, right? So the mean for maths is 69, the mean for science is 80.8, but you could achieve the same output, right? You could achieve the same output by using the apply function. This is how I'd do it. I'd say I want to apply the function on each column of my data frame. So I'd specify the entire data frame. Okay. Then the margin here, right? The margin here is 2, which means when I specify the margin is equal to 2, it means that I want to perform the operation in a columnar manner, right? Should first apply the function on the first column, then it should go to the second column, apply the same function, then the third column, then the fourth column. Okay. So if I put the margin as 2, it means that the operation happens on columns. Okay. And the third argument that I specify here is the mean, right? I want to run the mean of the scores of students across each of the subjects, right? So when I do apply of df, comma 2, comma mean, this is the output that I get, right? So I run it, and basically gives me the mean of maths, which is 69, the mean of science, which is 80.8, the mean of arts, and the mean of English. So basically what it has done is that it has performed the mean operation on each of the columns, right? Which means it went to the entire column, right? First, did the operation here, right? Got the mean of this column, right? Stored the output here. Then it did the mean of the second column, science, stored the output here. Then it went to the third column, art, stored the output here, and then it went to the fourth column and stored the output here. Okay, this is what your apply function would do, right? If you specify the margin as 2, if you specify the column as 2, sorry, the margin as columns. Okay, if you had to do the same thing, right? Let's say if you had thousands of columns, it means you have to either write 1,000 lines of code wherein you'd have to get the mean of each column separately. That's practically not possible. Or what you could do is you could write a loop, right, which goes from first column to another column, then third column, fourth column, etc., and does this operation. The simplest way of doing this is that you run the apply function, right? Within just one line of code, you get the output. Okay, that's what this thing would do. The apply function would do. We're trying to run the function on columns of a data frame, right? When you specify 2, right? It basically first goes to does the operation in this way, right? It will go to the first column, take all the entries, perform the operation here, then it will go to the second column. Yes, when you it will then go to the third column and then go to the fourth column. That's what it will do if you specify the margin as 2. If you specify the margin as 1, it will basically go in this manner, right? It will perform the operation in this way. It will go to this, it will get the mean of first row, then the second row, then the third row, then the fourth row, and then the fifth. This is what it will do when you do the specify the margin as 1. Okay, and I'll show it to you. Okay, let me see what's the problem with the code. So guys, just select this line, right? Just select the portion that you're trying to run and then run the code. Okay, the reason why you're getting an error is because right before this line, right, there is a special character, right? This line that you see in your code module is a special character. So when you try to run it, it basically tries to run everything from the start. Okay, so just select this line, just select the code that you want to run, and then press enter, and it will run fine. Okay, so that's what happens when you specify the margin as 2, right? Now let's see what would, like, if you want to perform an operation that has to be done in a row wise manner, correct? So let's say I have this data frame. Okay, what I'm interested in getting is that for each student I want to know what is the total percentage of that student, right? What is the total number of scores, total number of marks that this student has gotten, right? If that's what I'm interested in getting, then this is how I could do it, right? I could just do apply of df comma 1, because 1 would essentially give me row wise operations, right? And then if I do a sum, 1 is basically for rows. Okay, and when I run this, I'd get the sum of the scores of each student, right? This is the sum of the scores. So the first student, the total marks that he got out of, let's say, 400 is 237. Then second student got 243. Then third one got 291, 303, and 335. So the operation now happens in a row wise manner, right? The sum of first row, the sum of second row, the sum of third row, and the sum of fourth row, and then sum of fifth row. Right? This is what happens when you specify the margin as 1. Now, if I'm interested in getting the percentages, right? Let's say if I want to know what is the percentage score of the student, right, in across all the 4 subjects, I could just modify it a little bit and divide it by, let's say, the total number of columns, right, which is 4, and then multiply it by 100. Right? If I do this, it will give me a percentage score, right? So 59.25, 60.75, 72.75. The reason why I'm dividing it by number of columns is because I want to get percentages, right? So dividing by number of columns is because I want to get the percentage. So divide by the total number of subjects, right, that you're evaluating. That's what n column df would do. Got it? Okay, so that's what the apply function does, right? But please be very, very careful when you're doing the apply function. Okay, I'll tell you the reason. Okay, I'll tell you the reason. For example, if I create this data frame now, okay, if I create this data frame, wherein along with the scores of students in math, science, arts, and English, if I also include the name of the student, okay, which is this, right? Now, if I perform, let's say if I perform the apply function on the df with name, okay, and I say I want to get the mean, okay, for each column of my data frame, I will get an error here. Does anyone know why am I getting an error on this data frame? One of your columns is basically a character column or a factor column, right? Because you've included string as factors. So you can't perform the mean of Raj 51, 64, 61, and 61. Okay, you cannot perform a mean on a factor variable. So in this case, what you can do is that you can subset your data frame for columns between 2 and 5. Okay, columns between 2 and 5, and you can do something of this sort, right? The apply of df with name, all rows 2:5, and then 2 for column, and then the mean. Okay, and then it gives you the right output. So make sure if you have a lot of columns, right, and it's a mix of characters and numeric, just make sure that you're first subsetting your data set for the numeric columns and applying this function. But the other thing, guys, is that the apply function isn't just limited to the mean, the sum function, right? You can perform any function here, right? You can perform summary, you can perform any function for that matter. Okay, it's just an example that I'm showing you the mean and sum. Okay, this is how your apply functions would work. Okay, So apply function is probably the most important function here, right? Out of all the other apply, like the apply family of functions, because it performs the operation on a multi-dimensional object or a two-dimensional object. Okay, the other apply functions, the L apply function and the S apply function, would work only on one-dimensional variables, right? One-dimensional objects, either a list or a vector. Okay, so the L apply function also does the exact same thing, right? It's just that in L apply function, because you have to work on a one-dimensional object like a vector or a list, right? You don't need to specify the margin. Okay, because you don't have both rows and columns present. You have only, let's say, one column, right, of information. So the operation by default will happen on that particular column. Got it? So the L apply function would work only on one-dimensional objects, one-dimensional variables, right? Vectors, a list, or a column of a data frame. Okay, column of a data frame, and then you have to specify the object and the function. That's all. Okay, the other specialization of this lapply function is that the output that you would get as a result of an lapply function is going to be a list, right? You will get the output in a list format and not as a vector or a data frame, right? You will always get the output as a list, right? So in case you're interested in storing your output as a list, right, that's when you can use the lapply function. Okay, I'll show you an example of lapply. Lapply function can work on data frames as well. Okay, it can work on data frames as well, but by default in lapply, the margin is going to be 2, right? Which means it will only run on the column 2, right? So the margin is always going to be 2. Okay, so Amitav is asking me to explain lapply again. Amitav, lapply works the exact same way as an apply function. It's just that in lapply function, you do not have to specify the margin of your operation, right? Because the margin is always going to be 2 in that. It cannot be 1. You cannot apply the function on rows. It will only apply the function on the columns, right? So you can only perform operations where you want to get the mean of math, science, arts, and English. You can't get the total sum of marks across rows, right? That's not something you could do as in lapply. The other thing in lapply is that the output will always be a list. Okay, you will always get the output as a list. So for example, this is how you would run the operation lapply. Lapply of df comma mean, which means you will go to each column of the df and get me the mean of the scores. Okay, this is how it gives me the output, and you'd see the output is actually stored as a list, right? If I want to check, I could do this. I could do is.list of lapply of df comma mean, and I should get the output as true. Okay. So the output is always going to be a list in the case of an lapply function, right? The apply function and the lapply sapply wouldn't work very differently. It essentially works in similar manner, just that whenever you're expecting the output to be a list, use an lapply. If you're expecting the output to be a vector, right, then you can use your simple sapply function or an apply function. Okay, there's not much of a difference. Can't add marks row wise because the lapply function doesn't support that, right? If you want to do that, you have to use the apply function, right? You can do the operation, but you have to use the apply function. In the apply function, just make the margin as 1 and then it will work. Also, the reason why you're getting a warning in that case in your code is because your df with name data frame, and I explained it before, but the df with name data frame has a character column or a factor column here. Okay, so when you perform the operation on column wise, which means you're trying to get the mean of each of the elements of a particular column, let's say name, then you cannot get the mean for Raj, right? Because it's a character or a factor field, right? You cannot include character fields. So you'll have to remove the first variable, the first column. You have to subset your data frame for the last 4 variables, and then you'll have to apply the operation. Column wise is possible. Yeah. That's what is happening, right? That's the operation is happening in a column wise manner only in the lapply. Great. Okay, so that's lapply, right? It's pretty similar to apply, right? I don't use lapply too much because I generally don't want my output to be stored as a list. It's not a very useful object to sort of store data as well, right? Unless it's very important. But there's another function in R, right? There's another function in R which is called sapply, right? So sapply and lapply are actually the same sort of functions, right? They do the same operation, which means they also, like sapply also works on columns. Okay, sapply works on vectors as well. Okay, but the output that you get in sapply is always a vector, right? So whenever you want the output as a vector, you would use an sapply function. Whenever you want to get the output as a list, right, you would use a lapply. Okay, so this is, for example, if I want to run the sapply, it basically gives me the output as a vector. If I want to get the output as an lapply, it will give me a list. Okay, so that's the difference between lapply and sapply. The operation is always done on the columns of your data frame, right? The difference between the three types of functions that we've discussed so far, right? See, apply function works only on two-dimensional objects. Okay, it will work only on data frames or matrix. Okay, and in the case of apply, you can decide to do the operation either as on rows or on columns. Okay, that's what apply does. Lapply and sapply only work on both one dimensional as well as two-dimensional objects. They will work on lists, they will work on vectors, they'll work on data frames, right? In case of lapply and sapply, right, the margin by default is equal to 2, which means it will only perform the operation across columns, okay, of a data frame. If it's a vector, then it will apply the same function on each elements of a vector. Okay, and the difference between sapply and lapply is that sapply will give you the output as a vector, and lapply will give you the output as a list. That's the only difference between lapply and sapply. Okay, that's that. At the last function, right, the last function of the apply function, which is actually a very important function for all of us to know, right? It's called the tapply function, right? It's a slightly different sort of a function as compared to apply, sapply, and lapply, right? Because the kind of function, the kind of operation that it does with respect or as relative to apply and lapply or sapply is slightly different. Okay, so tapply function, what it does is that it also gives you the option. Okay, it gives you the option to subset your data based on a particular variable first and then apply your functions. Okay, now what do I mean by that? I'll give you an example. Let me first create a data frame. I'm creating a data frame here, which is called df with name. Okay, and this data frame basically has name of students. Okay, let me, by default, let's just use string as factors is equal to true everywhere, guys, right? Don't get confused on why it is false sometimes or why it is true sometimes. Just if it's false in your case, just change it to true. Doesn't change anything. Okay, so let's say this is our df with name. Okay, this is our data frame. What we have here, okay, what we have in data in this df is basically the name of students, okay, the gender of students, and then there's scores in math, science, arts, and English. Okay, now let's say if I'm interested, find out what's the average score of females and what is the average score of males, or let's say what's the total score of males and what's the total score of females on a particular subject, right? We can get that kind of functionality by using the tapply function. So what we can do in case of tapply is that we can subset our data by gender first, which means we can create two different subsets, one for males, the other one for females, and then apply, let's say, the mean function or the sum function on each of those subsets separately. Okay, that's what your tapply function lets you do, right? It lets you first subset your data based on a variable or based on a column, and then it lets you perform the function on each subset of your data separately. Okay, let me show you how it's done. This is the syntax for tapply, by the way. Okay, it is like a group by, right? So you can group by one variable, and you can perform the function on by grouping on a particular variable. Okay, that's what it does. So tapply, right, is the name of the function. The first argument that you would specify would be either a vector, right? Basically a variable, right? It could be one vector or it could be a column of a data frame. Okay. Then you have to specify the index. Index is basically nothing but the column or the variable on which you want to do the subsetting. Okay, based on which variable you want to first subset your data and then perform your function. So, and the next operation is the function that you want to specify, that you want to apply. So for example, if I'm interested in getting the average score of students in maths, okay, then this is how I could run it, right? I could just do tapply. Okay, the object that I want to run the function on is maths, right? I want to get the average score in maths. Okay, and the next thing that I want to do is that I want to subset my data by gender. I want to find out for males what is the output separately, and for females what is the output separately. So I want to do this based on my index, which is gender, right? That's why I say df with name gender becomes my index. And then the operation that I want to run is the mean operation, right? I want to find out what's the average score of males and what is the average score of females in maths, and this is how you would do it. So you would say tapply df with name maths, df with name gender, mean. The output that I get here is that for females, the average score of maths is 62.5 and the average score of male is 73.3. Okay, so based on a particular grouping it by a particular variable, right, which is gender, you basically achieve the average score of maths, right? So this is how you can subset your data, or you can group by your data first, group by a particular variable, and then perform any other function, right? Most probably an aggregate function. And if you want to do it for different subjects, this is how you can run it, right? You can run it for science, arts, English separately. Okay. For example, if you're interested in getting the, let's say if you're interested in finding out from this customer churn data set, right, that we have, what is the average monthly charges for females versus what is the average monthly charges of males, right? Or let's say I am interested in finding out that for different types of internet services that we have here, we have DSL, we have fiber optic, and we have no internet service. What is the average cost that a customer is paying, right? That could be a question. So I could just do tapply, right? And I could say customer churn monthly charges, right? The variable on which I want to do the mean operation, right? Then I'd say the index in this case it's internet service, because I want to find out for each type of internet service, right? What is the average cost, and then the mean operation. So if I run this, the output that I get is here, right? So I get that for the DSL internet service, the average cost is $58, $58.1. For fiber optic, the average cost is $91.5, and for no internet service, the average cost is $21, which basically means that if someone is not using the internet service, or if someone is not subscribed for the internet service, that cost of course is expected to be low, right? And that's what we see here. Out of DSL and fiber optic, it looks like fiber optics is basically a more superior service. It probably offers you a better connection, a better speed, a better network quality, right? Generally fiber optic does that, right? Even within Airtel, or let's say if you're based in India, right, Jio, etc., right, their fiber optic connections are better than their regular connections, right? So yeah, within fiber optic the cost is higher, $91.5, and for DSL it's slightly lower, right? So this is what your tapply function would let you do. So these are the four kinds of functions within the apply function. Naturally, the most important one is apply, right? Apply function is probably the most important one, I'd say, followed by tapply. sapply and lapply are relatively less used. Okay, so the first, probably the easier question, which is how to find the column index, right? Let's say you want to find the column index for a particular column, right? There are several ways, right? The first way is that you can just do something like this, right? You can do column names, right? And then you can write the name of the data frame. Okay, when you do this, right, what the output you would get is that for each column it will tell you what is the index of that column. Okay, so for example, it tells you the index of customer ID is 1, gender 2, 3, 4, right? And this is how you can find the index, right, without having to do too much. This is one of the ways, right? This is one of the ways in which you can identify the index, right, of each variable in your data frame. Okay, I'll run it again. Give me 1 second. This, right? So for example, it tells you what is the index of each variable. Okay, this is one of the ways in which you could do things. Okay, the other thing that you could do, right, is basically a function called which. Okay, there's a function called which, right, wherein, and it's a slight sort of a operation that you'll have to do. You'll have to use this function called which, right? Within parentheses, you have to mention the names of customer churn, right? Which means wherever the name of the column of all, what this code will do is it will basically run through each column name within the customer churn data set, right, data frame, and it will try to find wherever the column name matches with total charges. Okay, wherever it matches, it will give you the index for it. So for example, if I do which names of customer churn is equal to total charges, then it will give you the index 20 as an output. Okay, so these are the two ways. I think column names will give you the index for each column, right? This will give you the index for a specific column for which you are trying to identify the index, right? And you can also use it within your code itself, right? If you write it, wherever the index has to be specified, if you just run this entire which function, if you just replace that index with this whole snippet, it will do the job for you. Okay, so these are the two ways in which you can find index. Let's see if column names works here. I think it should work. Yeah, so even if you write call names here, right, instead of writing names, it works. Okay, now coming to how to apply tapply on a function, right, where the function has missing values. Correct, that's what I think most of us were struggling to do. Your outputs are like whatever you're trying to do is correct, right? Which means like you're saying you should omit the NAs or you should replace it with zeros, right? That's what we are trying to do. That's what we will try to do as well. But how can we do it, right? Is something that most I think is slightly difficult to figure out. See, this is how you do it. So tapply customer churn total charges, customer churn internet service mean, and after a comma just write na.rm is equal to 2, right? Na.rm basically means that you're removing all the na values and then you're performing your operation. Okay, that's what a na.rm is equal to 2 does. Okay, I will show you another alternative of this. Okay, this is one of the ways in which you could do the operation, and it's I would say this is the most efficient way of doing it as well. A slightly different way in which you can perform the same operation is this, right? What you could do here is that you can write an if else condition. You could use a function called if else. Okay, if else, and see, the if else function works like this, right? This is the syntax on the top. If else test, then yes, comma no, right? It's exactly like you do it in Excel. The first argument is basically the condition, right? If the condition is true, then whatever you put in yes will be outputted. If the condition is false, then whatever you put in no will be outputted. Okay, that's how the if else condition works, right? The same way it works in Excel. Okay, so how do I do it now here, right? So I can use a function that's called is.na. What the is.na function does is that it basically goes to each value of total charges, right? And it will check whether the value is an na or not. If it's an na, it will output a true. If it's a non-na, right, if it's an actual value, it will output the actual value itself. Let me run this individually just to show you. It will basically just clutter my console, but at the risk of doing that, I'm going to just show you. If I run is.na of customer churn total charges, basically just repeat. It will basically just throw a bunch of trues and false. Wherever you see a false, it means that value is not an na. Wherever you see a true, it just means that this value is a na. For example, here probably the 487 something, right? 498 or something. That value is an na, right? That's why you return. That's why the output is true. Okay. Now, using the is.na function, right? We can just replace our na values with something else, right? Let's say we say that we want to replace all nas with 0, right? All the na values should be replaced with 0. We can do that, right? That's a decent thing to do because they're just 9 na values. So what I could do is that I could do an if else. The condition is is.na, which means wherever there's an na, it will give me a true. Wherever there's a non-na, it will give me a false. So wherever it's an na, I want to replace that value with 0. Okay, and wherever that value is not na, I just want to retain the original value of customer charge of total charges. Okay, and I close my parenthesis here. So this, what it would do is, if I run only this snippet, it will basically run the operation on each value of total charges, and wherever there's an na, it will replace that value with 0. Right. So as a result of this if-else operation, what you've done is that you've removed nas from your data, right, and you've replaced those nas with 0. Now you can basically just use this as part of your code, and then the index that you have to specify is internet service. Okay, and you could just say the function that I want to run is mean, and then you can remove na.rm is equal to 2. It's not required anymore because the NAs have anyways been replaced by zeros. Now if you run this, if you run the tapply function now, it basically gives you the correct output, right? What has happened now is that all the NAs from the total charges variable have been replaced by 0. And now after replacing those NA values with 0, the average of total charges across DSL, fiber optic and no has been calculated. Is this clear to everyone? So there are two possibilities. You can either run this. I agree, right? It's an easier thing to do. You just include na.rm is equal to 2 at the end of the code. That's an easy thing to do. If you want to be slightly more adventurous, run this. Okay, both will give you similar outputs. These are important functions, guys, right? Because otherwise you will have to write a complex loop, right, which isn't really the best use of anyone's time. I have not written a loop for a long time because it's not required, right? Apply functions just do the thing for me. So this is like, just practice apply a little bit. It has a huge use case, right? You can use apply anywhere within a long code, within a particular argument. You can use apply anywhere, right? You just do the thing every time. So please become comfortable with the apply function. That's really going to be useful for you. Now what we're going to do is that try and perform certain data manipulation tasks, right? Certain data manipulation tasks in R by using an external package, right? And that package is basically called dplyr. Dplyr, by the way, is a very, very popular package, everyone. It's one of the most widely used library when it comes to data manipulation. There are a couple of other libraries as well which you should probably explore. There's another one called tidyverse and there's another one called data table, right? We will get to them later. But the most popular one is basically dplyr, right? It's a data manipulation specific package. It helps you perform several data manipulation operations in a very, very efficient, in a very, very easy manner. Okay. So what we should do now is that let's try and install this package dplyr. Okay. There are two ways to do that. One, of course, you can run this install.packages, or you can go to the packages tab, go to install, search for this package dplyr, select it, and then run install. Okay, the next thing that you should do, right, once all of you have installed the dplyr package, the next thing that you're required to do is that you're required to activate the package, right? So what you've done so far is that you've downloaded the content of the package. It's available to you on your local machine. Now, to make it available for the current session, right, you have to run this function called library of dplyr, right? And then once you do this, the library gets activated for you, right? And you can now start using the content of this function, of this package. Okay, so make sure you first install the package and then run the library. By the way, tomorrow, let's say if you close RStudio today and you open RStudio probably some other day, right? Tomorrow, day after tomorrow, then you will, just to be able to access the functions from dplyr, you will have to run the library function again. You don't have to install it every time. Installation is one time, but library of dplyr has to be run in every session. So generally when we write code modules, what we generally do is that the first line of code that you would write is something like this, right? You would activate all the packages that you want. For example, if I want to activate dplyr, I'll write it on the top. If I want to activate, let's say, ggplot, right? If I want to activate, say, any other package, right? Let's say tidyverse or tidyr, right? I'll just run the library at the starting itself. This is only when you have these functions, these packages installed in your machine. Okay, it's only when you have installed it. Right? This is not a replacement to install.packages, right? You'll have to install the package once, but to activate the package, you'll have to just write the library function. Okay. So what dplyr typically does is that as I said, right, it's a package which will let you perform data manipulation and several kinds of data manipulation, right? There are a lot of functionalities within dplyr, but the ones we would explore are these, right? We would see how can we filter data based on multiple conditions, based on conditions of characters, based on conditions of numeric values, etc. How do we select several columns from a data set in an efficient manner? How do you mutate, which means how do you create new variables using existing variables? how do you summarize data, right? How do you aggregate data? How do you summarize data by grouping data by multiple variables, or summarize using multiple summary functions in just one line of code? We'd also see how do you sort data, right? And then finally, what we'd also see is that how do you like run a SQL like operation in R, right? Wherein you have all the different kinds of functionalities like select, from, where, having, group by, summary, all of that in just one code of RStudio. Like you have an SQL code, right? Where you have select star from a table where a particular condition is holding true, group by XYZ, having XYZ, all of that, right? Similarly, how do you do that in R using all of these functions is something we are going to explore, and that's only possible in DPL, right? You can write an SQL lookalike code here, right, which actually is more efficient as compared to a regular series of operations that you perform. Okay, before we do that, I think there's another library that we should be exploring, right, which I'm sure most of you might not have explored yet. There's a library in R, right, which basically makes a bunch of data sets available for you, right, just for practice, right? So there are several data sets that come preloaded, right, in RStudio. When you download RStudio in R, right, there are certain data sets that come preloaded in this software for you, right, so that you can explore them, so that you can practice your use cases with them. Okay, and that's what we're going to do as today as well, right? We're going to explore a couple of data sets from this library. You don't have to install it from anywhere; it's already present in your RStudio. Just that you'll have to find out where it's located, right? So there's if you just write data, okay, close open parenthesis, it basically activates this library, the data library, right? And this basically has a bunch of different data sets available for you, right? So if you see, there's a long list of data sets that come preloaded for you, right, which you could use for multiple data manipulation operations, or even like practicing with objects, right? These are all objects that you could potentially use. Yeah, and let's say if you want more information on any of these data sets, right? So for example, you have data sets on air passengers, which contains the monthly airline passenger numbers between 1949 to 1960. A lot of different data sets, right? And it also gives you a brief description about what this data set is. But let's say if you're interested in getting more information on any of these data sets, okay, what you could do is you can find help on these data sets. Okay, so for example, if I want to get help on this data set called, let's say, air miles, I could just search for air miles here. It can basically tells me that this is a data set which captures the revenue, right? The revenue passenger miles flown by a commercial airlines in the United States for each year between 1937 and 1960. It's a time series of 24 observations. And that's what this data set is, right? And if you want, you could also, let's say, plot this if required, right? Just to get a better sense of this. Let's see, I'm not sure if it works. It does. So you can also plot this this data set. Right? It also gives you how you can practice with these data sets, right? In the help section itself. Yeah, it's a useful sort of a functionality, right? You should explore some of these data sets, because a lot of questions that I get from a lot of students is we don't really have data sets to practice on, right? That's not correct. You do have a lot of data sets on which you can practice. Just explore these data sets more, and you'd essentially be able to get a lot of information, a lot of data. Okay. So from this data library itself, what we're going to do is we're going to explore a couple of data sets, right? There's this data set called empty cars here, empty cars. You can find it. Yeah, this one. We're going to explore this data set. It basically has the motor trend car. It's called the motor trend car road test data set. What this data set has is a bunch of performance and design specifications of multiple car models. Okay, some 24 different car models. Again, right, if you want to get more information of what this data set has, we can find help for it. You can go to help, search for it. It basically says that the data was extracted from 1974 Motor Trend US magazine and comprises fuel consumption and 10 aspects of automobile design and performance. for 32 different automobiles, right? So it has around 11 variables. It captures the miles per gallon, number of cylinders, displacement, a lot of design and performance parameters of some 32 variants of cars. Okay, that's what the empty cars dataset has. There's another dataset that we're going to explore, which is called the iris dataset. Okay, so if I search for the iris dataset, this is what the iris dataset has. This famous iris dataset gives the measurement in centimeters of variables sepal length and width and petal length and width respectively for 50 flowers, each from 3 species of iris. The species are iris setosa, versicolor, and virginica. So iris is basically a species of flower, right? And within this species, there are 3 other species of flowers, 3 subspecies of flowers: Setosa, versicolor, and virginica. This dataset captures the information of 50 flowers, 50 observations, each of Setosa, versicolor, and virginica, and it basically captures the length and width of the sepal of the flowers and the length and width of the petal of the flowers. Okay, so these are the 2 datasets that we're going to work with, right? And we're going to perform data manipulation on these datasets. Okay, so let's work with these 2 datasets, empty cars and iris dataset, right? You'll have to create 2 different data frames. The empty cars data frame or the empty cars dataset I'm loading in this data frame called my new data. Okay, and the iris, actually let me clear my environment. I'm clearing my environment and also my console. Okay, so I'm going to load the empty cars dataset in my new data and iris dataset in this data frame called my iris data, and we're going to perform data manipulation on each of these objects, right? First, let's see what is there in my new data. So this is the iris dataset, by the way. Okay, you have some 11 different variables: miles per gallons, number of cylinders, displacement, horsepower, rear axle ratio, weight of the vehicle, the 1/4 of the mile, what kind of engine is there, whether it's a straight engine or whether it's a V-shaped engine, right? What's the kind of transmission? Is it automatic? Is it manual? Gear, number of carburetors, etc. And then you have it for around 32 different car models, right? You have it for Mazda RX-4, Mazda RX-4 VAC, Datsun, etc. A lot of sort of vintage vehicles, right? Toyota Camry, not Camry, but Corolla, Corona, etc. So you have like this data set, which is the empty cars data set, right? It is mostly a numeric sort of a data set. So any numeric operations that you want to perform can be very easily be performed on this data set. And then you also have the my iris data set, right? The iris data set, which captures the sepal length, sepal width, petal length, and petal width for different flowers, right? Different species of flowers, 3 different species: Setosa, versicolor, and virginica. I hope all of you know what a sepal and a petal is. Let's say if you draw a flower, right? This is how a flower is, right? It has petals, right? And there's a green portion that sort of holds the petals together, right? This is called the sepal, right? This portion is the sepal, and this is your petal. This data set basically captures the length and width of the sepal and petal. Let's try and see what data manipulations can be performed using dplyr. Okay, the first function within dplyr that we're going to explore is the filter function. Okay, the filter is a function that helps you perform. It's like a subset function itself, right? If you guys remember the subset function that we explored yesterday, the filter functions more or less like the subset function, right? But it in a more efficient manner, and it has a bunch of slightly more advanced functionalities as compared to the subset function, right? So this is how you would use the filter function. It is basically used to subset your data based on a condition, right? Based on a filter condition that you want to specify. Let's say if I'm interested in filtering this data set, the my new data set, the car data set, only for those vehicles where the number of cylinders is greater than 4, then I can run it like this, right? I could just say filter. I could specify the name of the data set, the data on which I want to perform the operation, and then without doing the $sign, etc., right? You don't really need to reference the name of the variable through the name of the data frame. That's not required here. You can just directly write the name of the column and the condition, right? So you could just do number of cylinders is greater than 4, right? Run it, and you'd get the output, right? So all the observations where the number of cylinders is actually greater than 4, right? Here, second column gets subsetted. Okay, you can also put number greater than 6 so that you have fewer observations to look at. So yeah, wherever the number of cylinders is greater than 6, you get that in your output, right? Pretty straightforward, like you do it in subset. Okay, yeah, you have to remember the column names, or you could you could always get them from here, right? You can get them from here, or you could just use the function column names and it will give you the names of the columns. You can also apply filter on, by the way, it's not that if you reference it will not work, it will work that way as well, right? This will also work, but this, like, if you want to do it in a more simpler manner, you can avoid this whole referencing, right? It's not that it doesn't work with referencing, it works with referencing as well, but if you want to avoid the referencing, that's also an option that's available to you. Okay, if you want to apply multiple conditions, right, that's also something you could do. Let's say, for example, if you're interested in filtering data, wherein you want to filter data where the number of cylinders is greater than 6, right, greater than 6, and the number of gears is also greater than 4, right? Wherever both these conditions are holding true, that's where you want to filter the data. You could also do that. So for example, when I run there are only 2 observations, right, where I have both these conditions holding true, which means the number of cylinders is also greater than 6 and the number of gears is also greater than 4, right? Only 2 such cases. But if you put an OR condition here, right, which means that if either of these 2 conditions are holding true, right, I want to get my operation done, this works too. Okay, this works too. The other thing is, right, let's say if you want to, similar to subset, this is also something which we saw in subset, right? If you want to filter data based on a categorical variable, that's also something you could do, right? Just if you write filter species is equal to setosa, it will filter your data only for species equal to setosa. I'll do a view of this so that it shows up the VS in this window. So only the setosa observations get filtered here, right? And all other observations get removed. Okay, so this is how you can, like, it's of course a much easier way of running operations.
So let's get started. To start off with, what is Microsoft Excel all about? To explain this, let me just take an example. Imagine you are working for a company. You're working as a HR for that particular company. And your primary job is to ensure that you keep a record of all the employees in the company and against their particular department. So if you're working for a company, you have to note down all the employees, their departments, and also more details such as when they joined, which team, what shift they are doing, or any other information which could be helpful. So say your boss or your manager comes a day and asks you to give an employee detail of a particular department. If you have it in a particular notepad, you probably have to search it between many sheets to go to that particular department and get the employee details. Further to that, if he asks you for multiple details, and not just for an employee, but for many employees, imagine how difficult it can get. So the simple concept is, you use something like a row to column, or in lines, you mark it 1, 2, 3, 4, and then you put all the employee details and the departments and certain other information. Now this, it makes it comfortable on a piece of paper. But if you really have to use some information for a particular department, imagine how difficult it can get. So that is why Excel can be used for a lot of features, with its lot of features for a lot of useful information analysis. So one of the most important feature of Excel is for analysis, to utilize mathematical operations, inbuilt functionalities to get you the desired result. So what is Microsoft all about? Microsoft Excel all about? Well, in simple terms, it's a software applications. You can use it to perform a lot of logical mathematical statistic calculation on data. It has a basic feature of spreadsheet. Remember, I was talking about those lines, right, where you can put in the data. So similarly, in Excel, you have something called spreadsheets, and it is arranged in a grid of cells, which is in turn arranged in rows and columns. We will see more about this as we progress, but then simply put, Microsoft Excel is a spreadsheet where you can use data use inbuilt operations to analyze, sort, and do what you want with it. Not just that, with the data available, you could create charts. You could use those charts in a PowerPoint presentation and then represent that data graphically. So if the question for you in your mind is, what is Excel commonly used for? I would say, simply put, it is to utilize data, store data in an easier way, analyze it, calculate data according to your requirements, your process, your team important, and then you also use the data to create graphs, charts, etc. These are some of the most common features or usage of Excel, but then the Excel is an ocean by itself. You can create multiple things depend on what your requirement is, and we will see some of them in the coming chapters. Hope this got you excited, because I'm surely. And let's see what is Excel all about in the next topic. Okay, so now you've got an overview about an Excel. You understood what Excel is all about. We spoke about a spreadsheet concept where you have rows, columns. I'm sure you're excited to see, just in case you've not seen it till now. For a couple of minutes, I'll be showing you how do you launch in Microsoft Excel, how you could customize it according to your usage, and of course, once you launch, you might have to close it, right? Or you will have to close it. So how will we close, save it appropriately? So let me quickly go to the demo so that you could see and learn. Great. So now this is your first look of Excel, just in case you haven't seen it yet now. So the first thing which strikes you is, you see there are three sheets. There is sheet 1, sheet 2, and sheet 3. Now what is this? Of course, an Excel has some inbuilt features. You can see tabs, home, insert, page layout, and so on. But then the first thing which you might have noticed is the sheet. So to explain this, let me just take a notebook. So imagine a notebook. You have multiple sheets, right? Where you can write different topics, different subject, different information. Similarly, in Excel, you have multiple sheets for your usages. Now, it's not just that. It's just not limited to 3 sheets. We can add multiple sheets, and how to do that we will see in the later chapters. So all these sheets put together is called as a workbook. So you understood, right? Simple. These are sheets. All this put together, this whole content is called a workbook. Okay, so now I'm going to use this particular sheet. I'm just going to type in sheet 1. Let's go back to our example which we spoke about. I have joined a HR firm and I am the HR. So I am going to note down the employee details. So I'm just going to put a header over here called employee details. And just simple date of joining. Okay, so I have one new employee who's joined me today. So I'm just putting in the employee name and date of joining. It would be around, say, 1st of Jan 2015. Okay, so this is how I've entered data into Excel. Once you do that, you want to save it. But just before you save this, I just want to show you something else. If you noticed over here, every time you open Excel, the Excel opens up as book 1. If I open another Excel now, it will show that has book 2 and this has book 1. So as the default, Excel will have 3 sheets and it will always name it as book 1. So this is something which I have worked, right? So let me save this. So how do I save this? So I go click on the Windows button over here. As soon as I click that, I have a set of tabs which I can use. For now, I'm just going to use Save As, and there is another button called Save. So the difference between these two is very simple. Save As is used when you're using it for the first time, and thereafter, if you're using an Excel, modifying it, adding, removing data, then you just use Save. We will talk about shortcut as we proceed, but for now, just let me save my first Excel. So I click on Save As. There you go. And let me put this on my desktop. Okay, so what should I name it? I will name it as my first Excel chat. So that's my new Excel name. And if, as you can see, the extension or the way the Excel is saved as .xlsx. Okay, so I click it. As soon as I do that, notice the changes. So my book 1 is no longer book 1, it is my first Excel Jan. Okay, so that's simple. So we just saw how you launched an Excel and then you save it. Now let's take, there's another employee who's joined. I will put it as Saran 2, and he joined on 2nd of Jan 2015. Okay, so I have just modified the Excel. Now if I close this and I do not save it, this particular data will not be there. So please remember, always when you do some changes in your Excel, you need to save it. Again, how do you do it? Simple, either go to Windows, click on Save, or you noticed there was a shortcut which showed you. If I just hover over it, you could see that there was a Control S, and that's exactly the shortcut for saving an Excel. So you just click on Control and S, so it saves your Excel. So simple, we learned to save an Excel. So I was talking about some customization, right? How do I ensure that Excel becomes easier for me? There are so many tabs out here and I'm not sure which tab does what. I probably need some shortcuts or some customization, right? How do I do that? So again, for that, what you do is you go to your Windows button, click on the Office button. You have here your Excel options. So click on the Excel options. You get the Excel customization options. So we will review these in detail, but for now I'm just going to something called customize. Once you click on customize, you have a lot of menu prompt. So these are the different set of buttons which are available, but we'll not review any of these for now. I just want to show you one easiest quick access toolbar. So if you come down, you can see this show quick access toolbar, right? So just click on this. As soon as you click on this, there will be a that's an error, show quick access toolbar, and you will see that. I'll click OK, and as soon as I do that, notice this particular toolbar. There you go. So right now I have different buttons, but then I promptly want to have a save button over here, which is going to be useful. I'm just going to do that again to show how you add it. So I go again to Windows, I go to Excel options, and I go to customization or customize. I have my show quick access toolbar. And what are the tabs I want to show? So here is showing customize your quick access toolbar. For now, I'm going to go and use the save button and move it towards my right. So I have a save button. I also probably want to use, let's take a redo and add that. That's how simple. Oh, probably that's already there. That's why it's not. Oh, I don't want a redo, so I'm going to remove it. So that's how I just create and modify the buttons I want and remove the ones I don't. And I click OK again. So simple. There you go. You have your save button. So this is a simple way for you to navigate Excel when you're learning and to use your Excel as you begin. So going back to our slide, we have understood how to launch on Microsoft Excel. How do I customize this? We saw how we could create a quick access toolbar, and we saw how to save and close an Excel. Let me just go to my next slide. So here I want to take you all through some very important areas of working. I call it 5 important areas. It's spreadsheet, grid, ribbon, formula bar, status bar, which you will see. Now going back to my spreadsheet, we spoke about sheets, right? Sheet 1, sheet 2, sheet 3. So what are the 5 important areas? And let me show this again. Here you have your formula bar. Here you have your status bar. Here is your ribbons and some additional features for you to view it in a different mode. You have a page layout and you have your normal break view. So most importantly, I want to quickly take you all through the view of Excel. To start off with, what are these? You have A, B, C, D, E, F and so on. So basically these are columns in Excel. So you have columns which is numbered as A, column B, column C and D and so on. So anything which is represented by letters are called columns, and anything which is horizontally represented are called as rows. So they are numbered accordingly. If you see, rows are numbered as 1, 2, 3, 4, 5 and your columns are numbered as A, B, C, D, E or so on. Now important thing over here is a cell is nothing but a reference or an interface of column and a row. So simply put, this is nothing but it's in D column and 6 row. The same thing can be seen in the name box. So we're talking about 5 things, right? So this is also the 5th thing which is very important, a name box. So once again, if I move here, can you tell me what is the reference of this particular cell? Well, if you haven't, notice it is H7, H7, H7. Good. So we learned about cells now. Seeing some other important things. So here is your formula bar. Now what is this formula bar? Formula bar basically showcases the content of your cell, or if you want to insert a particular formula, you use the formula bar. I will explain this in detail, but just as a reference, if you click on FX insert function, you get your insert function which is represented in the formula bar. You could see an equal sign. That's what is going to happen. Now again, this has quite a bit of amount of significance. We will see as we progress. So we saw name box, we saw formula bar. Now what is the status? Here we can see there is a status called ready. So basically this status bar shows the status of the spreadsheet. It tells us what is actually happening in the spreadsheet. So right now it's telling I'm ready. What do you want me to do? So for now I'll just go to the data and see if it changes anything. We created the employee details, right? So let me just click on the employee details. Okay, it shows ready. I go to number and I just click on F2 and it shows edit. So basically what Excel is telling me is that you are inside a cell and you're editing a data. That is the significance of the status bar. So it now shows you're in an edit mode. Now let me just go and type in some other thing. So see, as soon as I type in anything in a new cell, it status shows enter. So basically what it is telling me is that you're entering a data. So every time I do something on the cell, it shows the status of that particular activity. You might be wondering that why is this important? It is important because there are times where you will be using multiple data and you will be using multiple functions. So when you're doing that, Excel might be showing whether it is ready, entering the data, editing, or in fact calculating the data. The last thing about status which I want to tell you is I just want to enter a formula over here. So how do I enter formula? I just click on equal to, or just let me do one simple math problem. I'm just going to put 2 numbers in these 2 cells and I'm going to add those 2 numbers in this particular cell E8. So as soon as I put equal to, I put a formula which means add this cell to this cell. Notice the status. It shows as point. So basically what Excel is telling that you are adding a formula, you are dealing with a mathematical function. That is where it is displayed as point. So understood with the usage of status bar, right? Great. So Moving on to a few other things, but important ones. What is this 100% out here? So it is nothing but you're looking at 100% of the view. You could either decrease or increase the view basis how much data you're working with. So simple, right? Now this is scroll, which I don't want to tell you. I'm sure you're very aware of that. And moving on to the most important things, ribbons. Now, till now, you'll notice that there are different tabs, right? We saw home, then we have insert, page layout, formulas, data, review, view, and then some other additional tabs which I have added. So what are these? Now these are nothing but these are called ribbons. Now what do these ribbons do? These ribbons just have all your common tabs, usage tabs put together. Let me explain that with an example. Now under your home tab you have font. So what is basically font? You have anything to do with your characters or text functions, or you want to increase or change the font, it's available under this font ribbon. There is a small arrow. Once you click, it expands. So you can see that you have the font type, you have bold, italics, or you want to underline, including coloring, filling the text with color, or just the text color. So basically ribbon is nothing but it combines the common used fonts under a particular ribbon. Under the home you have your clipboard, your fonts, your alignment ribbon, your numbering ribbon, your styles, the way you want to format and style it, we will see more about this, and some other insert and some arithmetic functions, and auto sum, fill and clear, which we will see. Similarly, if I go to insert, like the way it tells in terms of the word insert, you're basically inserting new things in Excel. So under the insert tab, you can basically insert a pivot into Excel. You could insert shapes, charts, hyperlinks. Hyperlinks is if you want to move between two Excels, you insert a hyperlink or any word art commonly used. Similarly, layout, as it says, it's basically page layout, more for printing, or you want to navigate it in terms of certain data only to be printed. That's when you come to page layout. Formulas. In the beginning of Excel, I did mention to you that we have so many different types of formulas, right? And Excel basically covers all of them. You have arithmetical, logical, date and time, trigonometry, anything which you want to know from a logical, you can get under this. And all that which we learned in school or college, you will find all those formulas. You just need to know how to use it. Then moving on to data. The word data is basically talking on whatever data you want to do some operations on data. That's when you come to this particular tab. You have sorting, largest to smallest or smallest to largest. You want to filter data, you want to remove duplicate, you want to consolidate, you want to validate. That's when you come to data tab. Review is basically it's about protecting the workbook. You want to review certain content, you want to check for some spelling, you want to search in the dictionary. That's when you come. And the last one, the view, is basically similar to what you observe over here. Zoom, or you want to freeze a particular row and move the rest, or freeze a particular column and move the rest, and you want to put a page break or change the layout. That's when you come to view. Just to remind you, all these tabs or all these ribbons which you can see out here can be added to your customized tab. So basis your usage, you could take any of this and put it out here. And you remember how to go there, right? Perfect. So that's some basic overview of Excel and some important areas which you need to work with. Formatting Excel and shortcut keys. So I'll directly go to a demo so that I could show you how you could use tips and tricks or navigations and few shortcuts. Here we go. We have a new Microsoft Excel spreadsheet opened. So as it's inbuilt, we have 3 spreadsheets. Okay, So how do I navigate this complex looking spreadsheet? Or is it really complex? It is till you work on it actually, and once you start working, it is very, very simple. So the main keys which I'm going to use in my navigation would be Control, Shift and arrow keys. So I'm just going to demonstrate how I navigate this particular columns and cells with the use of arrow keys. So right now I'm going to use the down arrow and you can see what happens. Yep, the cell reference, the highlighted box moves down. And when I click on the top or the up arrow key, I see that the box move on top. Very simple. And towards my right, right, and towards my left, left. Great. So what if there is a lot of data and I really have to go to, say, a particular column which is like DO? Should I keep clicking on the arrow key to navigate there, or is there a shortcut available? Yes, of course, that's where the tricks are available and which we can use. To showcase that, let me just come up with a particular table with some data. I'm going to randomly add some numbers out here.
Let's have a quick quiz question, guys. And your question is, amongst which are true about regression analysis? And your options are, it describes association within data, modeling relationships within data, answering yes or no questions about data, or all the above.
Just a quick info, guys. Intellipaat offers state-of-the-art data analytics course in association with IITM Pravartak. Through this course, you can learn all the important tools and concepts of data analysis such as Power BI, data wrangling, data mining, etc. from esteemed IIT Madras faculties and industry experts. With this course, we already have helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take a first step towards career growth in the field of data analytics.
To really go to P3, which is this particular cell, should I from here keep holding my arrow key to navigate, or is there any shortcut available? Yes, there is. So I'm going back to my home key, so that's where I came. And now observe what happens. I'm going to click on Control and my arrow key. So I directly move to the table where the data is available. Okay, I'll do that again. Home, Control, arrow key. So now if I have to move to the last one, the one which I've marked in the color yellow, I still click on Control and the arrow key. There you go. So Excel basically understands that I'm looking at the data and I want to go to the last cell where the data is available. And when I use the Control and the right arrow, it understands that, oh yeah, there's this data and let me move there. Similarly, if I click Control again and the left arrow, again Excel understands that I have to go to the first cell where the data is available and actually moves out there. So your question would be, what if I have to go to K3? Now in this case, of course, Excel will not understand that it has to move here and you have marked it in yellow. So you have to use your arrow keys to go to that particular cell. Okay, that's great. So we understood Control and usage of Control with the arrow keys. Now what is Shift all about? So let me just go to my first cell and click on Control, Shift and arrow. Please note that I have to hold all the keys together. Control, Shift and my down arrow key. So as soon as I do that, you can see that Excel understands that the data has available in that particular column has to be highlighted, and it does so. If I use Control, Shift again and my right arrow, it will subsequently highlight the complete data. Quite easy. So quickly, I'll just show it once again. Control, Shift, down arrow, highlights the data completely in that particular column. Again, I'm going back, Control Shift right arrow, it highlights that particular data in the row. So if you use Control Shift and the arrow keys, they are good enough tips and tricks for you to navigate Excel accordingly. You need to practice this because the various combinations of Control Shift works differently. So the more you practice and understand the functionalities, the easier it will become for you to navigate Excel. Hope you learned something in terms of navigation. Alright, moving on. So we spoke about navigation. What are these shortcuts all about? Everyone likes a shortcut, right? We always find ways and means to do work in a shorter way or find out shortcuts. So thankfully, Excel, there are plenty of shortcuts. I'll just show you the simplest shortcuts available. So if I click on Alt, you could see that suddenly there is some highlighted letters in the spreadsheet. So I'll do that again. I'm just clicking on Escape now, Escape key. And now I clicked on Alt key. As soon as I do that, there is a set of letters highlighted. Now I could use the combination of letters and Alt key to get to where I want. Which means, let's take I want to go to Home tab. So it shows H. So if I click on H, just observe what happens. I have the Home tab. And beautifully under the Home tab, all the respective shortcuts are highlighted. So you can see that I can use numbers, I could use letters, and I could actually use the combination of these two to not even use mouse, but I could do my stuff. Okay, just for an example, I will go ahead and use H again to see what happens. So it goes to color, and there again it shows the shortcuts. So if you keep using these shortcuts, right, what happens is just like how we learned riding a bicycle. Initially we had to remember so many things, but later it became automated, or it just your mind gets used to it. So similarly, consciously, if you want to use shortcuts, if you keep using this Alt and remember those letters which needs to be highlighted, your brain memorizes it, and then thereon it's very easy for you to use shortcuts. I'll just show you a small example of that. There you go. Did you see me moving my mouse or the cursor? No, right? I'll just do that again. There you go, because I have memorized the shortcut to close this particular workbook. So how did I do that? I again used Alt, I used F, which is your Windows. You could see that Windows can highlight it. And then under Windows, I used C, which is highlighted to close. And that's why it asked me whether I need to save or not. So that's how I use shortcuts. I could do my work very simply. For now, I'm not going to do anything. Let me close this particular workbook and go back to my presentation.
And this video is for beginners and there are loads and lots and tons of functions in Excel which the industry use. But in this video we have covered only few basics. So let's see what all we have under each headings, and the first topic is date and time. So as you all know, Excel is something that helps us to sort out data, clean the data and help us derive meaningful insights from data, right? So there are so many inbuilt functions. So under date and time, see, whenever a company HR is using, so they'll have loads of data about the dates, the date of joining, the date of birth of the employees, and there are so many things like that. So in order to help those kind of industrialists or those kind of people, there are so many inbuilt functions like date, where you can actually create a proper date from the year, month and day is given, and then comes the day. If there is a date but you only want a day from that, you can do that. And similarly, you can separate month as well as year from a particular date. And then comes the days, that is the number of days between the end date and the start date. Don't worry, we will just move on to the tutorial part, or the hands-on part, where you can see how all these functions works. I'm just giving you a summary here. And then comes the days, as I have already told. Let's say for example, an employee wants to know or a person wants to know how many days a person has worked. So what is the number of days between the joining date and resigning date? So all such data can be calculated from these things. So it's all about the days that actually used for easy filling of Excel sheets between two dates. So what is the fraction? So if we say it's just 6 months, it will be 1/2 or 0.5, right? So how, but if it is 6 months, it's very easy to calculate. But then if it is more complicated, how do they calculate it? It's very easy using Excel. So let's see how these functions are used. Yes, so here I have created some random data. I have given random year, day as well as month. So our first function was date. So we need to get a date from these three data, right? So how do you get that? Okay, so if you're a complete beginner, if you're new to Excel, this is how various functions over here, this is where you type. I can generate a date from these data. So I usually go by typing equal to and date. You might wondering, why am I going for date, equal to date? That's because if you simply type date, that will only end up data, not the function. So as you can already see here, when I typed equal to date, there are so many functions related to or related with the term date. These are all functions, and what we need is this function. So click on that. Shows that in order to receive the date, they need a year, they need a month, and they need a day. So let's see year, that is 1998, and then put a comma. Then the highlighted part, big letter is now on months. So the month is 5 and comma, and next comes the day. Choose the day over here. So, and close the bracket. That's how the syntax of the functions works. Whenever you are using functions, you need to close the syntax. That's how it works. I hope all of you are familiar with that. If not, just understand that now. So let's see, and just type enter. So see, you got the date 6/5/1998. Similarly, you can do this for all these many functions. Okay, I have created a lot of random data. But don't you think it's very difficult to type this data, select this for all these data? So what you can do is, so see, 31/8/2021, 5/7/2028, this same thing can happen. So let's see once again, it is equal to date, then year, comma, month, comma, day, close the syntax, enter to get the date. And then make, like, you can simply drag it down. It's like you need to click on the corner and see, get the plus value over there, and just scroll down so that you get the dates. That means this scrolling down means the function that we applied here is correspondingly applied to these rows. That is what it says. So now see, we have got, let's reduce this size. Yeah. So now we got the dates, we scroll down. So now the next function that we had was the day. See, if we want the particular day from this date, okay, the day is 18, the month is 1, and I just want to know on this particular cell, I want to know what is the day of this date. So I'll simply type equal to day. You can get that, and then serial number is the address of this, okay. So I close the syntax. See, I got 18. Similarly, if you go for a month, you get the month over here. There are lots of functions, okay. We are just covering only the basic functions. So if you want to explore, you can try enter, it's 1, and you can also go for year like that. If you search, then close that syntax, enter. So that is, oh my god, it's 1,83,000 days. Oh yeah, that's it. So if I want to find the days between, see, I applied the same function to all these two dates, but as you can see here, there's a negative value over here. The negative value happens because the end date and start date got exchanged. Because here the end date is 2500 and start date is 1998. But then see here, the end date is 1963 and the start date is 2028. That's the reason for this negative sign over here. Similarly, you can find the networking days. So let's see how this happens. And I said network days, the function comes, open the bracket. You have to open the bracket in case if they haven't opened it, okay? So there comes the bracket. Now you have to find the start date, that is 1998, comma, the end date is here. Let's say it's a huge number, so I hope so you can actually put a comma and give holidays. I'm giving 5 holidays, okay? And then there you go. Close the syntax. See, now you got the net working days. And if you drag it down, you get the number of net working days between, okay, this is pretty simple. See, the number of days between this number, that is January 1, 2021 and January 31, 2021. So the total days is 30 days. And out of that, there will be Sundays and Saturdays, that is weekends, and the holidays are reduced. We gave 5 holidays actually. So all those are reduced, and then the net working days is 21. So these kinds of information data is available. And yeah, now we have year fraction. So let's see that also. Here we'll say go for year frac. It's year fraction, okay? So start date is, okay, let's go for this, okay, this is just 1 month of 2021, right? So I'll go for this as start date, and then end date, that is 20. I'll just give 1 month. Let's see, it's 1 by 12, right? Let's see what is the fraction they are giving. If it is 1 month, it will be 1 by 12. So and basis is usually, we usually give 1 or 0, but now we'll give 1. So yeah, close it. So we got the year fraction for this particular cell, okay, this particular row, that is 2021, these dates. I have found the year fraction for that. Actually, you can find year fraction for only a particular year or particular time of a particular year. So 1 by 12 is 0.083. So that is what we got here. So maybe I'll try dragging it down and see what's happening here. Actually, these years are different. That's why we're getting 0, and we have actually found the value over here, and that's why we are getting a value error. The value is 0.082. That's fine. So year fraction can be applied to only that particular time period of a particular year. That is, the year of the end date and start date should be same in order to calculate the year fraction. So this January month, that is the 1st of January and 31st of January, that is 1 by 12. That is the fraction mathematically. So it has given us this fraction. So that's all about date and time. So now let's go back to our PPT. So next comes the engineering functions. So engineering function, the major engineering function is convert function, where you can convert a data from a particular unit to another unit. It can be from centimeter to meter, millimeter to meter, or a decimeter, picometer. You can convert to any data, and the formula is equal to convert, and you have to choose the number, the from unit and the to unit. There are particular codes for units which we will see, and the quotations are very necessary, because if you don't use it, it will show error. So this function is very important it's very helpful for all the engineers over there, all the students over there, and all the people who are working in labs. Because back in college, I remember I struggled a lot with converting these data from one unit to another, and Excel was the savior, and this function was the savior. So I'm pretty sure that it's going to help many people over there. So let's see that function now. So for engineering function, let's try a simple conversion right now. So now it's weight in grams. So now if you want to convert to pound mass, that's lbm, so you can use that equal to convert, you can get the function over here and the number, comma, then from unit, that's double quotes, that is in grams, right? Grams is represented as G, close the double quotes, comma, and the 2 unit is pound mass, that is lbm, close the double quotes and close the syntax, equal to. Oh, yeah, we got it. So that is 2 grams in pound mass will be this. So 4 grams and 6 grams, you can simply drag it down as we have already done, and that's it. So let's see how to convert that into kilograms. So it will be pretty much easy for you to understand the correctness of the value. Equal to or convert, and then the number, comma, open double quotes or quotations, from unit is gram. Oh, sorry, then comma, double quotes, comma, comma, and 2 unit, that is our kilogram. So that too in double quotes, kilogram, close the double quotes, close the syntax and enter. So now you understand that it's right? Because pound mass, it's not easy for us to calculate. So dragging it down, you can see it here. See? So we converted gram to kilogram. So now let's go back to our PPT. Yeah. So there are lots of units from which you can convert. Now we use the gram. So, but the thing is that when you're using this function, you have to understand how these units are represented, because for gram it's G and for kilogram it's kg. And for ton you have to type the whole thing. So that particular thing has to be known. So if you know that, you can win any kind of conversions in a very less time. See, you can convert the distance from meter to any unit like yard, foot, inch, angstrom, light year, parsec. Oh my god, there's lots of data. Then there is magnetism data like Tesla and Gauss. And there are other functions like time, pressure, area, energy. There are lots of data. So don't be overwhelmed by these data. There are more. Let's take a look into one more example here. Okay, so there is a time in hour, so we need the time in minutes. So 1 hour is 60 minutes, we know that. So just to see how it works, let's see, convert, and then the number. You can also give a 1, okay, instead of giving a particular cell, you can actually give it as 1, and then comma, double quotes, from unit is hour, HR, and then 2 unit is minutes, MIN. Close the bracket. So 1 hour is 60 minutes. So if you drag this down, you can also see 2 hours, 120 minutes, 3 hours, 80 minutes. So now let's go back to PPT. Yeah. So as you can see here is also another set of shortcuts or the term that you have to use while converting or while using the convert function. So yeah, there is units of speed, temperature, information like bits, and then volume, different units are available. So it's going to be a big savior for many people. So next comes the information functions. So information functions are those functions which actually check the information or the value is in a particular cell and then returns us with true or false according to the which function that we are using. So that's how information function works. So let us take a look into few basic information functions. Always remember that all the functions mentioned here in this video are simple basic functions which is always combined to form complex functions while using it in an industry or a project or anything. So since we have to clear the basics first, that's why we are going with the basic functions here. So the first function is NA, That is, this function, when we use this particular function, this function will check if any of the cell is containing NA or not available error. So if there is this not available error, then this function will give us true and false if there is no error or this particular error. Okay, and then is number checks if a cell contains a number or not, and then if there is a number, then they will give us true value, or if there is no number, then they will give us false value. And then there is text, similarly checks for text, and is blank checks for a blank value. And let's see how these functions are working, because explaining it is not going to make anything better, or you can't understand it. So let's take a look. Okay, so here we have, these are the different types of errors that can come in Excel. So in these types of errors, this is NA function will return a true value only for this error. So let us check if this function is able to do that. So as you all know, in order to call a function, it's equal to and is NA, you just type it and you get the function. So here I am using this particular value, closing the bracket, enter. So this function returned false because there is no NA error here. So I am going to drag it down and check for the rest of the cells. And as you can see, when there is NA error, they have returned, or this function have returned true value, and all the rest values are false. So that's how is NA function works. And let us check for is number function, which checks for the numbers. So similarly, calling is number function, you have to double click that, don't forget that, checking for the value, closing the bracket, and see, 1 is a number, so the number function return, is number function return true, and I have added so many numbers over here. So let's see that. See, when I applied the function, when there is only number, that is 1, 1 by 2, 0.5, whether it's a fraction, whether it's a decimal, the number is number function were able to recognize this, and they returned the value of true. When there was a mix of letters as well as numbers, then they returned as false, and when there was only letters also, then those functions returned false value to me. So that's how is number function works. Now let's see for is text. It checks for the text functions, okay? Equal to the text and then the value. Close the bracket, enter. Sorry, it's not text, it's is text. Just a second. Yeah, it's is text, okay, it's not text. So see, there is text and it returned me true. That means the cells, okay. So you might find it as, oh, it's very simple, can't you see, just it's ABC and it's text. So why is it necessary to use a function? You might think like that, but understand that this is only very short or very simple example that I made to in order to make you all understand. But when it comes to an industry level, there will be huge amount of data from which you have to understand which is the text, you have to sort the data. So when it comes to that, okay, let me explain it to you in a simple manner. This is simply a laboratory level where you manufacture only a small quantity, but when it comes to the reality or real life, the quantity will be very high, right? In the laboratory, you will manufacture only 1 gram of a particular chemical, and when it comes to the industrial level, the plants will manufacture around tons and tons, right? Lakhs and tons of product, right? So similarly, that's how this also varies. So, and let's just check this isText function for the remaining. See, when there was text, it was able to identify, and the text, the function returned me true value. And when there is a mix of text and numbers also, it was able to return me true value. But there was only numbers, it could return me false. So that's how this function works. And another function that we said is blank function. It checks if the cells are blank, okay. So let us see, equal to is blank is here, and then you click on that. There is a value over here, this cell is not blank, so this is blank function has to return me false value again over here. Let's see if this function is able to do that. Yes, it has. So let me drag it and check up to here. So as you can see here, it's all false here, but there is a blank value over here, because we are searching for, or we are using this isBlank function for these particular cells. So all these cells have values, but this particular cell have no value, or this particular cell is blank. So that is isBlank. So it has returned me the value of true. So that's how these function works. And there's another function called not available function, because, so let's see, you have a set of data of your employees, but one of the employees hasn't submitted a particular data or a particular maybe ID card, so you don't have their number available. So you want to give there as not available. So you can also give or produce this not available error by using this function that is equal to any. This doesn't require any argument for that. So you only have to close that bracket and simply put enter, and there it is. So that's how the information function works. And like as I have already mentioned in the video before, it's not only these few functions, there is lots and lots of functions like these which you can always explore. And since this is a beginner level, now let's go back to our PPT. So the next topic is logical functions. There are lots of logical functions, and I have included the basic logical functions of and, or, if and ifs, and not, XOR in this video. You can always explore more, as I always keep saying throughout this video. Okay, the first one is and. So and is to test if there are multiple conditions. If all the conditions are satisfied, then the and function returns true value. Okay. Or functions checks if only any one of the condition is true. If any one is true, then or functions return us true value, or the value true. The syntax or the formula is like you can use equal to, and it's like calling any other function. And when it comes to if function, it actually and or actually tests for a condition and they return the value true or false. If function is used to test a particular condition, and also we can determine, if actually gives us the freedom to determine what value should be returned when the value is true and when the value is false. See, the syntax for if value is if, then the logical test, the condition, whether a particular value is greater than one value or whether a particular value is true, whether there is a text, whether there is a if a cell contains a text value, if a cell contains number value, or anything. You can do anything based on your requirement. So if that is true, what value should be returned? That can be given here, and what value should be returned if the condition is not satisfied can also be given here. So that is what makes out if function much more better function. And when it comes to ifs function is actually a combined if function or a nested if function, and it is easy to use also. The ifs function check if one or more conditions are observed or not, and accordingly returns a value that meets the first true condition. And then the other functions are not function, true or false function, and exclusively or function. We'll come back to this after checking the examples for these four first, and then we'll return to the function. Okay. The remaining functions. Okay. So here I have like an example. I have made up an example where here we have the names of the employee and their age and their work experience. So there is John, Bob and Maria, their age and the work experience. So we are checking for AND function. So we need a situation where the age of the employee should be greater than 30 and the work experience should be greater than 3. That's what AND function. So if it is, my condition is satisfied, if an employee satisfies this particular condition, then it is true. That's what I want to check with my AND function. So let's see, call the AND function. See, so this age should be greater than 30. It's greater than 30, comma, and the second logical condition AND is work experience should be greater than 3. Close the bracket, enter. See, age is greater than 30 and work experience greater than 3. It returned me true value. And if I apply the same AND function, that is by dragging, I get for the rest. And for Maria, this condition is not satisfied and it's false. This is a small data, so it's easy to understand. But when it comes to very big data, consider having employees like 1000 employees. How will you do it? You can't do anything. So you can only apply it using this function. Okay. So when it comes to OR function, okay, so now I have given a condition where either the work experience should be greater than 2 or age should be greater than 35. So, okay, so there is some situation where these people are preferred. So, you want to know whether your employees are satisfying either of the condition. Either the work experience should be greater than 2 or the age should be greater than 35. So, let's see who are those employees using OR function. So, equal to or, double click on that. Either the age greater than 35, comma, second logic is work experience greater than 2 years. Any of the condition shall be obeyed. Enter and then true. Applying it to the rest conditions and then, okay, Maria doesn't satisfy this condition. Her age is not greater than 35 or she doesn't have work experience more than 2. So that's how OR functions works. And then comes the if function. Okay, I told that if function gives us the freedom to return whatever value that if the condition is satisfied or if the condition is not satisfied. Okay, so I have created a situation here where if the work experience is more than 3 years or if the employee has worked in the company for more than 3 years, the management decides to give a bonus for those people, okay, 3-year work bonus, okay, so for their commitment, maybe that depends on the company. Still, let's move on to this. So they have decided to give the bonus, so they want to know if these people are eligible for these bonus. So let's say if equal to if, so logical test, okay, so the test is work experience greater than 3, then you have to put the comma and give the value if it is true. If it is true, what we need, they are eligible for bonus. So that is, you have to use double quotes over here, bonus, comma, value if it is false. If they are not having experience more than 3 years, they are not eligible. So I'll give it as double quotes, no any for not eligible, and then I'll close it and end up. See, so now John is eligible, so bonus, you have to give him bonus, not eligible. See, if there is lots and lots of employees, this particular function is very useful, and also you can actually combine if this AND function, if age is greater than 30 and work experience is more than 2 years, then you can return. So actually you can combine the values, okay. And in the PPT we have told about ifs function, that is combining if function, right? So let us take a look into that here, ifs function. Okay, so imagine a situation where there are different marks. So there is 95, 90, 82, 80, like that in a class for an exam there are different marks. So what I have is, I have to decide grades for these marks. So I have already set in my mind that above 90 is A grade, above 80 is B grade, and above 70 is C grade. Similarly, I have made it. So here I have done it already, but still I'll just explain it to you and I'll do it once again for you. See, if the marks or the value here in this column or in this cell is greater than 90, the value that has to be returned is A grade. If the value is greater, then comma, put the comma, then the next if condition. I told you ifs are combined if values, right? So again, if the value is greater than 80, return the value B. If the value is greater than 70, then return the value C. The returning value should be in quotations or double quotes. So make sure you use the double quotes. If you make mistakes over here, you might not get the result. So let's check for this. I have already done this, but it will take a little time, but still we can see equal to calling the ifs function. Okay, so ifs function, if this value is greater than 90, the value that should be returned, okay, you should put a comma over here. Value if true is returned is A grade, comma, if this same value D63 is greater than 80, the value returned should be B grade. You can actually use this in different situations. I'm just using it for this example over here. And comma, if the value D63 or in the cell D63 is greater than 70, the value returned should be C grade. Okay, so since it's a small example, so now see, for 90 it's B grade. If it's only above 90, it's A grade, right? So let me apply the same thing to these different cells and I get my results. See, A, B, C. The thing is that if you take 80 is actually greater than 80 as well as greater than 70. So it actually determines the closest value. Okay, that's why it's for B grade. So, and let's move back to the PPT. So we have seen the example for AND with the work experience as well as the age. Similarly for OR, if and ifs with the class example. So let's see some more functions over here. That is not function, true or false function, and exclusively OR function. Not function is, these functions actually return the opposite value. So if a condition is satisfied, true value or the value true is returned. If you use not over there, instead of true, they'll return false. Okay, these functions will return false. And if the actual solution for a particular condition is false, but if you use a not value instead of false, the not or the opposite of that is false. The opposite of false is true. So true will be returned. Let's see that, okay. And then comes the true or false function. It is simply to generate the value true or false. The syntax goes like this. You don't have or you don't require any parameter or argument over here. And then comes the exclusively OR function, which we will look later. But first let's see not function as well as true or false function. Okay, so the condition is not greater than or equal to 4. So work experience not greater than or equal to 4. Here I have done the example as you can see here. I'll do it once again. If the function, this is how you give it, not, you can also see the function here, right? So not, this value should be greater than or equal to 4. So actually is the value here greater than or equal to 4? Yes, 5 is greater than or equal to 4. So that condition is true. So not function of true value is false, right? I hope you understand. Let's see for this function equal to not. See, the definition that Excel gives for not function is it changes falses to true and true to false. So I hope you understand and you're not confused. Not what? This value greater than or equal to 4. Close the syntax. Is this value, it's 4. Is 4 greater than or equal to 4? Yes. So the condition is true. So when we use not, true is changed to false. So applying it, see, is 2 greater than or equal to 4? No. That means the condition is not satisfied. The answer is false. When we use not, false is returned to true. So that's how not function works. And it has its own usages in different industries. And then comes the true or false functions where you can simply call this function without any argument, like true. Here you have true and you have to close this. See, they return the value true. This is only for the purpose of this. Now let's take a look into the truth table of exclusively OR function in order to understand what is said. So we talked about OR function, right? Whenever either the condition or either the statement is true, the function gives an output as true or the one value. Yeah, that's it. So that is an inclusive OR. So here it is exclusive OR or exclusively OR function. So what does it mean? Because in inclusive or general or simple OR function, whenever either one condition is satisfied, it gives a positive output, and even when both the conditions are satisfied, the OR function gives a positive output. But when it comes to this exclusive OR, it's not like that. When both the conditions are true, it gives it doesn't give a positive output. Okay, it gives a negative output, or there is no output. It's 0. There is no 1. And this considers only those situations or conditions where only either one of the statements are true. only then it gives a true value or a positive output. Hope you understand this truth table. If not, okay, let's go back to the example and you'll understand it then. Okay, so now we have a match. Those who want to go to match 3 and match 4 has to win at least one game. Okay, so let's say team A won both the match, so they don't have to play match 3. They directly go to match 4 or the next level or the higher level. And those who lost the game, they don't play match 3. But the people who won at least one game, that is or either match 1 or match 2, they are eligible for match 3. So that means according to exclusive OR condition, if we apply it to this particular situation of the game where this A, B, C, D are the 4 players, and if we are using XOR or exclusively OR function to determine which of the team is eligible to play match 3, then it should say B and C, because these two, they won both the matches, so they are not eligible for match 3. So I have typed the function already in order to save a little time, equal to if. I have added if in order to say yes or no, and added XOR, exclusively OR, that is, and F70, that is 70, F71 and G71, either match 1 or match 2. And then if they satisfy either this or that, then the function should give yes. And if not, then they should give the output as no. So that's we have here. So let's see, let's apply it to the next rest. See, so the team D lost both the matches, so they are not eligible, and the team A won both the matches, so they too are not eligible, or the negative output, or there is a false output, or there is a negative output here, but only true output is here when there is only this is known as exclusively OR function. Hope now you understand that this is how it works, and you can actually calculate, or you can actually check or use this function to any situation where this kind of loss wins kind of situations are coming, or any kind of situations where these can be applied. So that's all about the XOR function. So next comes the max and the statistical functions in Excel. Let's take a look onto the basic max and statistical functions. So here I have included the functions like Arabic function, which converts the Roman numerals to Arabic numerals. And then comes the degree, where the degree function converts the angle from radian values to the degree values. And then comes the pi function, which is most important for the people working like in engineering fields or scientific fields or research fields. Yeah, most of the fields, they require the value of pi, so pi function. And then comes the sum function, which is very basic, where you just count the values. And then comes the sum if. It is slightly a moderate level function where you apply a condition to find the sum. Okay, so and the next function which I have included is the trunc function. Trunc function actually reduces the number of digits in a number to a given precision. That's what they truncate the number to a given precision. And then comes the average, which is familiar to everyone. So we will take a look into the example where we do all of these functions. And we will also cover average if function. That is, we will just specify a condition in order to find the average. Then maximum and minimum, which is also familiar for all of you. So we will see how that is being done in Excel. And also we will see the slope. That is, when we have x values and y values, if that x and y is represented as a straight line, what will be the slope? That can also be found using the slope values. So let us move on to the sheet.
Let's have a quick quiz question, guys. And the question is, the process of quantifying data is referred to as, and your options are decoding, structure, enumeration, or coding.
Just a quick info, guys. Intellipaat offers state-of-the-art data analytics course in association with IITM Pravartak. Through this course, you can learn all the important tools and concepts of data analysis such as Power BI, data wrangling, data mining, etc. from esteemed IIT Madras faculties and industry experts. With this course, we already have helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take a first step towards career growth in the field of data analytics.
Equal to Arabic, here comes our function, choose our value, close the syntax, enter. So see 1, let's apply to all other values and see 1, 2, 3, 4, 5 and 10. So if you have further doubts, like let's make it XVI and see that has changed to 16. So that's how this Arabic numeral function works. So let's delete it for a better space. Yeah. And then comes our radian function, right? So, okay, the angle usually ranges between 0 to 2 pi or 0 to pi. So after pi, it is like multiples, right? So 0 to pi. So what is the value of pi? Pi is 3.14. So in radian, the angle varies between 0 and 3.14 when it is 0 and pi. 0 degree and 180 degree, that is 0 and pi, that is 0 and 3.14. So I have taken here random numbers between 0 and 3.14 and let us see what these numbers in radian represents them in degrees. Equal to degrees and our angle in radian. Oh yeah, I got all the angles in U is equal to sum. So here what we do is physics, comma, chemistry, comma, biology. Close the bracket or close the syntax. We got the arguments for the function, enter. See, we got the same answers. See, there is no difference. So even if you use the formula or even if you call for a function, the answer that you will be getting is same. So that's all about the sum function, and next comes the average function. So we need the average of these 3 students, right? Okay, wait, I will do one thing. To reduce the confusion, we will insert a row here. Yeah, so we need the average mark for physics. So we'll use the word average. We need the average of physics here, right? So we'll call for, you can actually see what will be the average. 85 plus 68 plus 88 divided by 3. As I have already told, this is a simple example. So summing all the 3 together divided by 3 is the average. You can actually create the formula by using the keys on the keyboard like plus and the division key, that front slash. So you can use that and create the formula, or you can call up the function. So let's look into the function part. Average of 1, 2, 3. Close the syntax. See, you got the average 80.33. So you can say this person B is below average, these two are above average. Such information can be understood from this average function, and that's how average function works. Okay, so here we have the data of a company where their sales for a particular region is given here. So we all know to calculate the sum as well as the average, as we have calculated here using the sum formula and the sum function. We can actually calculate the total here by calculating the sum. But what we need is, we have to specify it for a particular location, or we need to apply a condition before we are doing sum. There comes the use of function on a SUMIF. So that is what we are going to look next. So let's take a look into the SUMIF function. So I want the total sales in East. Okay, if you could remember. So the SUMIF function is that SUMIF that we should mention the range, then the criteria range 1, and then the criteria. So similarly, we have to use this particular formula. So let's see. So here let's use the SUMIF function equal to SUMIF. SUMIF is here the range. The range that we are applying this function is sales, that is the region as well as the sales, comma. What is the criteria? Criteria is East. We need East. We need to separate the data of East, comma. What is the range? Sum range. That is, we are only using the sales range. And then close it. Yes. We get the total sales in East as 270. Isn't it right? 100 plus 170, 270. Yeah, that's right. So we didn't go wrong. Now let's take a look into the average if. So similarly, we found SUMIF. So it's very similar to average if, where we are finding the average sales in the East region. So equal to, calling the function average if, the range is this, The criteria should be in quotes, east, and then comma, and then the range, that is this. Closing it, enter, and the average is 137.5. Yeah, that's true though. So that's how SUMIF and average if function works. And we actually forgot about the trunc function. Okay, trunc. So let's see how that works. Okay, I'm giving a random example here, maybe 6.2883698, something like that. So I want to reduce the number of digits of these part. Okay, so what I would do is call TRUN trunc data of this particular number, and I want to reduce the number into two values. Okay, after decimal I need two values, so I just typed 2 here and then closing the syntax, enter. So see, it's 6.28. So equal to, I'm calling the function again. I need to call the digit, this particular digit into, I need 3 digits. So that's it, and then see, so now it is 6.288. So now it's rounding off. So that's what trunc function means. Okay, let's see what happens if we use a number like 500, say, and let's say use the trunc function here in this number, trunc this number into 4 digits. Close the bracket, enter. It doesn't change, okay, I knew this actually. Since this is a number without a decimal place, it's 500.00, it doesn't change. So there is no much change, but when it comes to data like this, you can use that function to reduce the number after the decimal. Okay, and then the next function that we said is about the slope function. Okay, so if you have a range of values in the y and for a function, and you have given x, as you all know, we know the slopes maybe y is equal to mx plus c, and mathematically you might know to calculate and find out the slope value m. But how can we find it using this Excel? So let's see that. So just call the slope function equal to slope. So y's. So what they want is y's and what they want is x. So first they need y's. So I am just giving in the y's, comma, and what they need is x now. So x. Close the bracket, enter, and you get the slope as 0.72. So I hope I covered the basic mathematical functions. Okay, we left the maximum and minimum function. So let's go on to that. Okay, so yeah, we will do that over this data. I think this is better. We'll delete this. Okay, so we need maximum. So let's call the maximum function equal to max. So in this particular range, it can be number or it can be the range. Okay, I just want it in this range. So ABC, among ABC, I just want to know who scored better and what's the top mark. So the top mark is 88 and I got the maximum value as 88. Similarly, you can find out the minimum. So calling the function here equal to min. You can actually give the number as well as the range. For maximum we gave the range, so min, let's give the numbers. We put comma and give the numbers. But actually giving the range will be better and will save you a lot of time. But now for the tutorial, let me show you how the result comes. See, the maximum value comes in the range. So for the subject physics, the maximum marks in this particular range is 88 and minimum marks is 68. So that's how it works, and you can apply this at any point, anywhere. And you should keep in mind that we are not doing it for such a small data. We will be doing it for a huge amount of data in the industry while dealing with the real life projects. So that's all about the mathematical functions. Let's go back to the PPT. We have reached the last section of our video, that is the text functions. I have included very few basics of the text functions, that is concatenate, where this function is used to join together text, and left or right, that this function is used to remove or separate a particular number of characters from the right end or the left end of a given text string. Okay, you'll understand it better when we go for the example. And then lower or uppercase and proper case, that is changing the case of the text. These are the three basic functions. Please keep in mind that it's not enough. There are loads and lots of functions, as I keep saying throughout this video. You should explore everything, but as of now, let's see what are these three functions. So yeah, so here we have it. I'll just do it again. Okay, for concatenate, let's call the function concat. And then what we need is that we need to make a sentence here. Okay, that is, as it was there, student A received or got 25 marks out of 30. That's the sentence that I want to make, but I don't want to type it for each of these different students. So I'm going to type, let's see how we can do that. We need to add the term student, right? So student, comma, then the cell containing their name, that is C6, space, student got, then comma, their marks, D6, space, then okay, so student A got 25 marks out of 30. That sentence should be there, right? So marks out of 30. So that completes the sentence. Student A got 25 marks out of 30. See, we have got the sentence, yay! So when I drag it, see, student B got 28 marks out of 30, student C got 30 marks out of 30. So isn't that fun? Yeah. So now comes the left and right. So here I have a typical example of an ID number of an employee of a particular company starting with B. Let's say Bob's company. And what I have to remind you here is that this number series or this ID numbers of the employees are having a particular pattern. So the first letter stands for B, that's for Bob's company, and the second two digits 1718, 171514. These represents the year that they have joined the company. Okay, that is B17 means they joined the company in 2017, 18 means 2018, and 15 means 2015, and 14 2014. And the last two digits actually represents their branch that they are working in. CH stands for chemical, C civil engineering, chemical, BT for biotechnology, and then EE for electronics engineering. Okay, so that shows their department or the branch that they are working in. So this lower and upper function, what they do is that they separate the things. Okay, sorry, not lower and upper, it's left and right. Lower and upper comes under cases, which we are going to see next. But now we are dealing with left and right. So left, three characters, B17, they are those people who joined in 2017. So we need to separate the first three characters, means we can do that using this left and right. Okay, so first we will see for left equal to, call the function left. This is the text, and how many number of characters we need to understand that? The year. In this example, the first three characters gives the year. So how many characters? That is 3 characters, B17. Close it. See, we got it, right? Isn't that fun? For the left. And for okay, so now we want to know the branch from the employee ID. So we want to see what are all the different branches, or we need to separate it from their employee IDs. So maybe we can add the names also here, so it will be better. So maybe Mark, Bob, John. Yeah, similarly like that we can give names. So now we need their branch. So branch code. So now we can use the right function, call the right function. The right function from this number and from the right 2 characters in order to get their branch. Yes. So Mark's branch is chemical, Bob's is civil engineering. So isn't that cool? That's the thing with left and right functions. And now we are moving on to the last part, that is the cases. So we have some random names, very random names with there is no proper format for the text and the cases are mixed. So I just want to convert this into lowercase, complete uppercase and proper case, that is capitalizing each word. So let's see how that's done. Equal to, call the function, and then Yeah, we got it. See? So for uppercase, see, we got it. And for proper case, just call the function proper. You got it? Yeah. So if we drag it down, we get it. Yes. So we got everything. This is very helpful and handy for those people who are arranging data of the employees, of the students, like that. So every function in Excel has its own importance in various fields and projects.
When we talk about linear regression, something as simple as linear regression and concepts around linear regression. Linear regression is, of course, one of the most simplest implementations of your predictive models, so to say. It's been, again, it is a concept that has been evolving over at least a few hundred years now, at least 100 years or so, because linear regression has taken various forms. Linear regression is more or less like God, right? It's taken different forms in different eras, right? So currently we have one incarnation of linear regression. It could be something else in the next 10 years, some other version of the same thing can come up. So there are so many different variants of linear regression. And currently there's of course one primary way how people try to understand it, and we'll try to understand it in that depth. So first things first, the concept of linear regression of course stems from simple concept of trying to predict numeric outcome given a set of dependent variables. So there are two important things. The first one is you have dependent variables, and you also have independent variables, right? You have dependent and independent variables. Independent variables are the ones which typically are the target variables that we use to predict. Like for example, if I'm interested in predicting sales as a function of, let's say, money spent on ads, then sales is typically my target variable. So sales is basically in this example dependent on ads. In this case, sales becomes my dependent variable, and ads becomes my independent variables, so to say. So the thing, of course, is that when we talk about dependent and independent variables, there are, of course, you can take a couple of other examples as well. Let's take the example of I'm interested in predicting the stock price of a particular company as a function of let's say the sentiment of, or let's say the number of positive articles, sentiment, let's say the sentiment, the public sentiment, and let's say there could be numerous other reasons why the stock price could vary. So this becomes my dependent variable. Stock price becomes my dependent variable, and everything else, all the other variables, will become my independent variables. So in this particular case, as you could clearly understand, a dependent variable is basically that variable which is responsible, or which is the variable that we're interested in, or that particular feature that you're interested in trying to predict. It's also often referred to as a target variable. A common term is also a target variable. You will also come across terminologies like that. So do not get worried if you see terminologies like those. Okay, cool. Now, next thing is, let's take this particular simple example. Now, when we talk about linear regression, again, as I said, if you take a simple example like let's say we're trying to predict the yield of a crop based on the amount of rainfall that we have seen in that particular year. I'm trying to predict the yield of a crop based on the amount of rainfall. So if I want to solve this particular problem, what do you do? So what I'm saying is, historically, there is a relationship with the amount of rainfall, that there is a relationship between the amount of yield that we have seen for paddy, or let's say wheat, and one of the primary drivers for that particular thing is, let's say, rainfall. Mind you, rainfall may not be the only variable that is causing this. There could be 100 other reasons why in a certain year, certain crop has yielded a certain value. But one of the more popular, or one of the most primary reasons, of course, is the amount of rainfall. So let's solve it with a single variable, and I am hypothesizing that, or with my limited understanding about how agriculture works, I am hypothesizing that yield can be predicted. I'm saying yield can be predicted as a function of the amount of rainfall that we see. This is not a bad hypothesis, to be honest. This is a simple function, to say the least. But of course, I need to validate this particular hypothesis. What I would have to do is I'll collect historical data, right? And let's say I'll collect historical data from various markets, from various regions. So I'll have yield, and alongside yield, I let's say also collect the amount of rainfall. So from different regions for the same amount of land, right? Because I shouldn't be comparing the yield of 1 acre land versus yield across 100 acres land. That would be an unfair estimate, right? So I'm assuming that the yield that I'm talking over here is, let's say, per acre. So is number of kilos per acre or number of tons per acre, let's say, something like that. Okay, in a given year of 365 days. So I capture all the data points. Let's say I have 10 tons and the rainfall is, let's say, 250 centimeters in the complete year. Second is, let's say, 20 tons, 250 centimeters. Third is, let's say, 23 tons, 180 centimeters, and so on and so forth. Let's say I collect all of this data historically, and let's say I collect maybe 100 observations from different parts of the country. Now that I've collected all of this data, the next step is, of course, to go ahead and try and find if there is a way to extract a relationship between my yield and rainfall, right? So now what would you do? So you would simply go ahead and we'll try to, if you were to visually understand this, you can draw a simple scatter plot, rainfall on the x-axis, and then you can have yield on the y-axis, and then you go ahead and you create all these points. Whatever points that you have over here, you simply go ahead and create all these points, right? So different points that you think are possible. Now, given all of these points, the idea is you would want to identify the relationship. This particular function that you're seeing, what is this function? Linear regression says that this particular function that we have is a linear function, right? What I'm saying is that yield can be predicted as a linear combination of your rainfall, some linear function of your rainfall. So when you say a linear function, what do you mean? It is basically that I can somehow come up with a hypothesis which says, something like this, which says that yield is equal to, m times your rainfall plus c, something in this linear equation format. So for arbitrary values of m and c, when I say arbitrary values, for different values of a and m and c, this whole equation, from our knowledge from in mathematics, basically says that it is a simple straight line equation, something like that. It could be different straight lines for different values of m and c. It could be different straight lines. It could be a line like that or line like this. So different values of m and c will yield different straight lines. I am trying to identify that one single line, right? That one single line that cuts through as many data points as possible, or that is as close as possible to as many data points, right? I can create different values of m, and I can create different lines, but there is one specific value of m and c which is as close as possible to all the data points, right? But when I say close to all the data points, how do I measure close? How do I measure this proximity? So one of the most popular measures over here is that you would want to make sure that every point is as close as possible to the line. That is one way of looking at it. Or another way of saying the same thing is, for every value of x, there is a actual value of y. For every value of rainfall, there is an actual value of rainfall, and there is a predicted value of rainfall, right? This is the predicted value, this is the actual value. This is basically an error. That delta that you see over there is nothing but an error. So for example, if you take this point, or if you take this point, this is the predicted value, while somewhere here is the actual value. Somewhere in this particular range is your actual value. So this whole, that difference is the error for that particular data point. Ideally, what I want to ensure is that the difference between the distance from the line to every other data point should be as small as possible, or I want to make sure that this error prediction is as low as possible. Whatever value I predict, I want to make sure that the error is very, very small. Now the question is, this is great, the fact that I want the lowest possible error is great, but how do I make sure something like that happens? Okay, so to do that, it's actually pretty simple. There's nothing very complex here, and let me try to bring this up. It's quite simple to ensure that the actual values and the predicted values are not far away. So here's how it goes. Let's say this is how your data. This is your data. All that I'm saying is this is nothing but your predicted value. So this is your yield. This is your actual value. And then when you create that particular line, right? These are all your data points. That is a line. So, and line basically will have an equation. So yield is equal to 10 plus 5 times rainfall. Let's say you have a line like this, 10 plus 5 times rainfall. That's the, or let's say whatever, 10 plus 0.5 times rainfall or 0.1 times rainfall, whatever is the value. So there is a predicted value. This is the predicted value. What I want to make sure is that for every given value of rainfall, I substitute this value over here. So let me actually take a better equation instead of this. This equation could give me results which are haywire. Let's do it this way. Right? 0.5 plus 0.1 times rainfall. Let's say this is one particular equation. So what we're saying, if the rainfall was 250, what would be the predicted value? So if the rainfall was 250, so it'll be 0.5 plus 0.1 times 250. So this will be 25.5. So the actual value is 10, but the predicted value will be 25.5. Similarly, in this particular case, if the rainfall was 180, the predicted value of yield would have become 0.5 plus 0.1 times 180, so which would have become 18.5. So this value would have become 18.5. Right? So you have the actual value, you have the predicted value. Now we can always compute the difference between the actual value and the predicted value. This is the actual value and this is the predicted value. You can always compute the difference between the actual value and the predicted value. I want to make sure that I come up with that particular line where the summation of actual values minus the predicted value square for every term from I is equal to 1 to n. Right? For every value, the actual value and the predicted value. So whenever you see this means it's the predicted value. It's called y hat or y cap, right? So I want to make sure that this particular value, and I can take the mean. So this is referred to as mean squared error. Yi minus yi hat is nothing but error, square of the error, and the mean of that particular error if you observe over here. So what we are saying is, I want to make sure that this particular metric that we see over here, currently is minimum. Okay. I want to make sure that this particular metric is minimum. So just to let you all know, this metric is simply nothing but a measure of, if I were to put it, is simply a measure of how far away is this line from the data points. How far away is this line from the data point? The line is extremely far away, then what you will see is that the equation will have a very, very high value. If the line is very close, then you will see that this value will be a very, very small value. Okay, and first let's try and understand this. This is the most important part of the complete class. I mean, if you understand this particular equation, then we are all set to go ahead and actually solve this particular equation. So to give you a small intuition of what this actually means, just to kind of give you a feeler for what does this really mean, I have we're actually going to do a small Excel exercise just to kind of get a feel for it. So let's do a small exercise on it. Let's take a few values. Let's say this is yield, this is rainfall, and let's say 10, 20, 15, 30, 22. Let's take 5 data points for the moment. And yield is, let's say, 100, I don't know, 150. I've just taken the numbers a little differently for the moment, but 150. And then let's say we have 300 and let's say 250. Let's say these are the values that I have currently. Okay. And let's quickly insert a simple scatter plot. This is how the data points look like. As simple as that. Okay. 5 data points. Currently, this is how the thing looks like. Now, let me just add the axis titles. This is your rainfall and this is your yield. Remember, this is my dependent variable, also called as the target variable. So don't get confused. It's called independent variable, or also called as predictor variables. So they are all the same names for the same thing. So don't get confused. If you read content from different places, different names are going to be used. So do not get worried about it. So yield versus rainfall, or actually it's the other way around. Rainfall versus, my bad, yield versus rainfall. Cool. So now if you logically look at these this thing, I can have multiple data points. I can come up with different lines, so to say, right? One line basically if you look at it, let's try to do it here. So one of the lines could be something like this. Another line could be, I don't know, another line could be something like this. And then, maybe one more line which goes, let's say like this. Let's go completely bonkers on this, completely the other way around. So the point is there are 3 different lines. For simplicity's sake, let's actually take 2, just so that working with it becomes relatively easier. Let's take 2 simple lines. Red line, which goes like that, and then we'll take a green line, which goes the other way around. Let's go that way. Yeah? I have the red line and I have the green line. So quickly speaking, out of these 2 lines, each of these lines has a different slope and a different intercept value. Okay, has a different slope, because if you look at the red line, if you, for example, take this particular line, the red line, this has a positive slope, right? Almost a slope of 1, because if you observe, this is almost at 45 degrees to x-axis, almost at 45 degrees to x-axis. And logically speaking, slope is simply nothing but the tan of this particular angle. So if you go back to your trigonometry, the tan of this particular angle is nothing but your slope. So let's not worry too much about it. Essentially, this has a positive slope. And what we're saying is this fellow has a negative slope. Okay, that's number 1. Number 2, the second point is, if you look at this particular line, this has almost it's almost close to 0, but that's okay. It has a negative, this has a negative intercept. Intercept is simply nothing but the point at which the line cuts the y-axis. The point at which this particular equation cuts the y-axis. Here, the intercept is almost around 250. This is nothing but your intercept. This has a positive intercept, right? From your understanding of what you've understood till now, out of these 2 lines, which will have a lower MSE? Will the green line have the lower MSE or the red line have the lower MSE? The red line should have the lower MSE. Fair enough. So from my understanding over here, I am actually coming up with 2 equations. I don't know if these equations are going to be correct. I'm assuming that they are the best equations. So for the red line, let's go with the red line first. So the red line equation could look something like this, where I'm saying that yield is equal to negative intercept. So minus 20, I'm assuming minus 20 plus 1.1 times, plus 1.1 times, let's say, rainfall. Something like this. I don't know if this is even correct. I'm just taking a random guess at it, right? On the other hand, the green line could have something like this. Yield is equal to 250 plus, it'll have a negative slope, if mind you. So it could have a negative 1.2 slope or something, negative 45 degrees. If you look at it, it's sloping downwards times your rainfall. So 2 equations. I'm hypothesizing that these could be the 2 possible equations. And I am saying that this, out of these 2, the red one should have the lower MSE. And let's actually go ahead and simply prove it. So the way you do that is, let's say, first things first. This is the red line and red line prediction. And this is the green line prediction. Before I have the red line prediction and the green line prediction, let me simply make a note of the red line equation. So where I'm saying yield is equal to, predicted value of yield is equal to minus 20 plus 1.1 times your rainfall. Similarly, for your green line, I'm saying this is 250 minus 1.2 times rainfall. Just a random guess. Arnab has a question. Yield intercept equal to minus 10. So in such cases, what we generally do is we fit the intercept to 0. We make sure that the line cuts through the origin. So we force fit the line to go through 0. There are ways to do it. Basically, we make the intercept 0 in such cases. So for the red line, if you actually go by the prediction, so this is going to be minus 20 plus 1.1. So let me just do this. Plus 1.1 multiplied by my rainfall. What is rainfall? Rainfall is this. Actually, the slope would be a little larger. Okay, let's not worry about it too much. And on the green line prediction, this is going to be 250 minus 1.2 times your rainfall, which is this 238. That's the prediction of your green line. So you have your red line prediction and you have a green line prediction, right, at this particular point. And Yeah, currently I think I made a small mistake with this particular equation here because the red line needs to have a higher intercept cut through these data points. Let's just do a small change here. Let's make this 0. Let's make this 200. Let's make a small change. Instead of making it negative 200, let's make this 120. Just for kind of hypothesize it incorrectly. Plus, let's do it this way. These are my red line predictions and my green line predictions. Now what you could do is you typically compute the error now, and then you identify, so you compute your mean squared error of your red line, and you compute your mean squared error of your green line. And the way you do it is, this is your actual value. So let's come here. So to compute your MSE, what you're going to do is, it's going to be your average of actual value minus your predicted value squared. Essentially going to be the average of actual value and your predicted value whole squared. That is what your MSE is going to be all about, squared error. So this is my actual value minus predicted value. And then I'm simply going to do a square here. Yeah, average of variance, absolutely. So it's called sum of squared error. If it's R2, it has to be to the power of 2 square. Similarly, you do the same thing here as well. This time it's going to be, instead of E5, it's going to be 5. So in here now, what we're simply going to do is we're going to try and compute the mean squared error. So to do it, it's going to be average of these values, and similarly the average on looks like the green line has a lower MSE because the red line equation is slightly incorrect here. Let's do a small change. Let's make it 150. Let's make it 180. Let's go change a little. Yeah, done. So a small change. So now if you observe, the red line seems to have a slightly different equation with almost a mean square error of around 40. So out of these two, what we are saying is that this particular equation has a lower MSE than the green one. But then the whole point is that if I keep trying like this, there are infinite possibilities of M and C. There are infinite possible values of this 180 and the 1.5 or 250 or 1.2. I mean, logically speaking, because these are continuous values, there are effectively infinite possible values of this that I can get to. So where is the end? I mean, how do I find the best possible values of these two? There are infinite values of this and there are infinite possible values of. Then if I keep doing this continuously, there is no end to it. I might always find a particular value which is better than, let's say, the red line. As a matter of fact, I don't even know if there is a better value of M and C that would give me a lower mean squared error, right? And I would always ideally want a value that gives me a lower mean squared error. To actually show you how these lines look, I can actually plot those lines. It's not going to be very difficult. What we can do is we could try to plot all of these three together. Insert. I can change the chart type and just remove this from here. Okay. So for different values, and let me just change the chart type here. So between these two currently, it's a bad equation anyways. It's not giving us a straight line equation. Of course, it doesn't give you a straight line equation. But technically what we are saying is that each of these equations, this equation and this equation, out of these two equations, your red line seems to be, if you go back to this particular chart, your red line seems to be closer because your MSE is the lowest. In this particular chart, the red line is closer to all your data points than your green line. Your green line is probably a bad fit, red line is a better fit. That's the whole story in this particular chart, so to say. But then the question is, how do I make sure that I find the best possible line anyways? I mean, I don't even know if this particular equation is the best equation, or if I can find 100 other equations that will give me a best, I can find 100 other combinations that will give me better values than this. So to do that, we're going to employ a simple optimization concept. We're not going to do it via optimization, but we'll use simple differential calculus concept. It's called, we'll apply something called as minima and maxima to solve this particular problem. Let's go back to this particular step and let's actually take another problem, and we'll try to solve that particular problem with different equations. And I think we will get we should be able to get an easy hang of how to solve this particular problem. Let's take a simple set of data. Let's say this is x and this is y, and then 5, 8, 7, 14, 6, 10, and 3, 7. Let's say these are 4 data points, right? These are 4 simple data points, and I want to find a linear regression equation wherein I can predict basically this whole data point would look something like this. This is y and this is x, and these are my 4 data points, and I want to find that one single equation that cuts through all these 4 points, and I want to find the equation of this. I know one thing for a fact, that this looks like the form of y is equal to mx plus c form. I don't know what is m, I don't know what is c. I need to find the best possible value of m and c. But one thing that I know is that come what may, I want to make sure that the predicted value and the actual value, I want to make sure that for all the data points, I want to make sure that this whole equation is minimum, right? For any data point, I want to make sure that this whole equation is a minimum. I want to minimize my mean squared error. So how do I do it? So let's assume that my equation is y is equal to mx plus c, right? Or rather, your predicted value of y is equal to mx plus c. You don't know what this is, but then let's assume that this is your y equal to mx plus c. So for every data point over here, you can simply compute y hat. For every data point over here, you can simply compute y hat. So if you just draw this line over here, your predicted value is simply nothing but, in this particular case, m into 5 plus c. Similarly over here, m into 7 plus c. Similarly over here, this will be m into 6 plus c and m into 3 plus c. For this thing, it will be m into 3 plus c. All of us okay with this? Because I'm simply substituting mx plus c, right? M into 5 plus c, m into 7 plus c, m into 6 plus c, m into 3 plus c. Okay, so this is my actual value and this is my predicted value. I don't know what m and c is. We'll solve for m and c in a minute. So my mean squared error equation will simply look like this. For data point 1, my actual value is 8 minus my predicted value is 5n plus c, the whole square, plus for the second data point, this is going to be 7 minus 7m c, the whole square. Similarly, for the third data point, it's going to be 6 minus 10. Oh, sorry guys. This is going to be 14 and this is going to be 12, the whole square. And last but not the least, for my fourth data point, it is going to be, this is 10, right? It's 10. 7 minus 3m plus c, the whole square. 7 minus 3m plus c. Yeah, Jayant, Jaitirth, I've corrected it already. Yeah. Hope this is 10. Yeah, you're right. All of us okay with this? Yeah. So now if you actually expand this complete equation out, you can, if you actually expand this complete equation out, simply speaking, what you're going to get a polynomial equation with m and c. Can you think of it? You'll get a second degree polynomial equation with m and c. So let's actually solve for it. This is taking me back to my 11th standard or my 10th standard, but yes, that's the whole point. So if you actually expand this out, if you expand this equation out, 8 minus 5m plus c, if you expand this whole equation out, this is going to be, anyone? It's going to be 64 plus 5m plus c the whole square minus 8 to 16, 16 times 5m plus c. So a square plus b square minus 2ab. This is a square plus b square minus 2ab. Similarly, the second equation that you're going to get is 14 square. Anybody? What is 14 square? 100 and, okay, super. 196 plus 7m plus c the whole square minus 14 into 2 is 28 times 7m plus c. Similarly, for the third data point, 10 square is 100 plus 6m plus c the whole square minus 20 times 6m plus c. Last but not the least, 49 plus, what is this? 49 plus 3m plus c the whole square minus 14 times 3m plus c. Sorry, you're not going to get the square, just the 3m plus c over there. Sorry about that. Okay, so this is simply going to be 409 plus. Now let's come to this expansion in a minute. So let's expand this out. So 5m square is 25m square. So if you actually sum up all the m square terms over here from all of this, so this is going to be 25m square, 49m square, 36m square, and 9m square. So 25 plus 49 plus 36 plus 9, cool, very nice. 119m square plus, if you look at c square, 1, 2, 3, 4, this is going to be 4c square straight away. If you look at MC terms, anybody? What will be the MC terms over here? 5 2 is 10, 10 MC, 14 MC is 24 MC, 24 MC plus 12 MC is 36 MC, 36 MC plus 6 MC, 42 MC, spot on, perfect. So 42 MC, and you're going to get the M terms and the C terms quickly. How many M? Minus some M and some C. What will be that sum M? This is 80M. This is 96, 196, 80, 120, 42. Anyone? What about the M? N, M, and C both. 3M? Are you sure? It's 3M. It's all negative, right? So the whole thing. Okay. So this is going to be 438M, and the C term is what we're left with. And the C term is simply going to be negative 16, negative 28, 28, 20 is 48, 48, 14 is, so 14, 14 and 16 is 30. So 48 plus 30, 78. And that's it. So that's the complete equation. If you look at this, so logically speaking, what we are saying is we'll just rewrite this equation a little better. So if we were to rewrite this equation, what we're saying is this is 119m square plus 4c square plus 42mc minus 428m minus 78c plus 409 is your final equation. So your MSE equation is basically this whole thing. So we've all got equation, but now what to do with this equation? So what does this equation give me? This equation is basically, if you actually think of this is a second degree polynomial in M and C. So if you actually rearrange this whole thing, a second degree polynomial, or if you simply forget the C term, just forget wherever there is C. This looks like ax square plus bx plus c, if you observe. If you forget wherever C, or am square plus bm plus c. If you just forget the C term for a minute, what does this look like? Am square plus bm plus c. Anybody? If you simply forget the C term, just forget about C for a minute. If you just take the m terms wherever there is m, this one, and forget about this as well. Just take this and the final constant. 119m square minus 428m plus 409. Absolutely yes. This looks like a parabola. Just perfectly right. So this whole thing, it looks like a parabola, and it is actually a parabola. But this is a parabola in more than 2 dimensions. It is a quadratic equation. Spot on, correct. Parabola, basically a quadratic equation. If you were to just look at it in M or in C alone, if you just looked at it from an M or a C, it would look like this. If you forgot about M, you can think of this as M and this is your MSE. So this whole thing would look like a parabola. Or it could also be like this. If you imagine this was C and this is your mean squared error on a y-axis, this would look like a parabola, something like that. Okay. So basically what we're saying is that your mean squared error, your model has a particular value of M where your mean squared error is the minimum. Similarly, your model has a particular value, or your linear regression has a particular value of C where your mean squared error is the lowest. I mean, it cannot be 0, because if it has to 0, that means your line has to cut through every data point. So it's more or less impossible to have something like that. But what we're saying is there is a particular value of M. There is a particular value of M for which your MSE is minimum. If you see, this is a minimum most point. Similarly, over here also there's a minimum most point. Particular value of C where your MSE is sort of minimum, so to say. Now what we are going to do is we are going to try and find these values of M and C. What is the value of M? What is this value of C? We're going to try and find what these values of M and C really are. But then, now that this particular equation doesn't really look because we're not looking at it only in a C or only in a M. So how does this actually look like? what does this equation actually look like? You know how it looks like? It looks like this. But then let me give it a try. Right? So it looks like this. This is M, this is C, and this is your MSE. So think of this. I can only, of course, draw in 2 dimensions. Think of this as a bowl in that is kept in your room. On one side you have M, on the other side you have C, and on the y-axis you have, let's say, MSE. This is a value of M, this is a value of C, and this is MSE, and this whole thing more or less like a 3-dimensional parabola, which is like a bowl. Think of it like a bowl, right? So what we are trying to identify is we are trying to find a particular value of M and the corresponding value of C where your MSE is minimum. There is one specific point where your M and your C give you the lowest MSE, some specific value in this whole hemisphere. We are going to try and find that. But to find that, what we are going to do is we're going to employ a very simple concept. The point is to solve for corresponding values of M and C. What we're going to do is we're going to employ a very, very simple concept of maxima and minima, right? So if we remember long ago, once upon a time, we all learned about it, something called as maxima and minima. Maxima and minima simply is to find the maximum value or the minimum value of any particular equation. What we will simply do is we simply will differentiate that equation and we'll equate it to 0. So you have MSE. Let me try and simplify this for you. Let's start with a very, very simple equation. Let's say you have a simple equation like 3x square plus 2x plus 1. Let's say I have an equation that looks like this: 3x square plus 2x plus 1. So if I were to find the minimum most value of this particular equation, how do I find it? The best possible way is I differentiate this equation, dou y by dou x, or dy by dx, which will be 6x plus 2, right? This is 6x and this is 2. Differentiation. The ones who don't know, it's okay. Don't worry about it. Don't fret about it too much. Basically, 3x square will simply become, the power will reduce by 1 and this will get multiplied by this value. That's how differentiation works. Similarly, you have 1 here. This gets multiplied by this fellow and it reduces by 1. So x to the power of 0 is what it becomes. So 6x plus 2. So I am at 6x plus 2. I equate it to 0. I get, if I equate this to 0, I get x is equal to minus 2 by 6 or minus 1 by 3. So at x is equal to minus 1 by 3, this equation that you see over here is going to have the minimum most value of y. Okay, to simply identify the minimum most value of that equation, what you simply will have to do is just differentiate the equation and equate it to 0. When you differentiate the equation and equate it to 0, you compute the slope at a given point. Don't worry about it too much, but essentially what you do is you compute the slope. So if you have a parabola like this and you differentiate an equation, you basically identify the slope of that particular thing, right? You find the slope of that particular tangent, right, at different points. So whenever you differentiate, you basically get the equation of the slope. Okay, but then there is only one point where the equation of slope is equal to 0, and that's the minimum most point. So you differentiate and you equate it to 0. So when I differentiate, I get this equation, and when I equate it to 0, that's only this particular point. So that's the beauty about parabola, right? So what we're going to do is we're going to use something very, very simple. We're going to use the same concept and we'll try to solve this particular problem. We'll use the same concept of minima and maxima, and then we'll try to solve this particular problem. Okay, how are we going to do it? Let's go back to this equation that we see here, and in this particular equation, if you observe, I have 119m square plus 4c square plus 42mc minus 128m, blah blah blah. So the first thing, I'm going to differentiate this equation, dou msc by dou m. When I say dou m, I'm partial differentiating it with respect to m. That means all my c terms will become 0. So this will become 119 times 2, 200 and, guys, come on, 238m plus this becomes 0, 42m, right? So this will become plus 42c because m becomes 1. This is going to be minus 428, and this are constants, so the whole thing becomes 0. This becomes a 0 and this becomes a 0 because they're constants. That's the first one. Similarly, dou msc by dou c. This will become 8c. And what about this one? Plus 42m, right? Minus 78 is what I'm going to get. So I got two equations. This will be equal to 0 and this will be equal to 0. Yeah, when I'm differentiating with respect to m, c becomes a constant. So I get 42c. Now there is 42mc. M is still there. I still have the value of m, so that will never become 0. It will only become 42c. M will become, so think of it this way. So 42mc, when I'm differentiating with respect to c, this whole thing is now a constant except for c. So I'll just have 42m. And similarly, when I'm differentiating with respect to m, 42c will become constant. I'll only be left with m in that case. Yeah, I hope that made sense. I'm trying to actually solve the equation at the background. So you should typically getting my value of m. So m is somewhere around 1.057 and c should be 4.2. Yeah, perfect. C is 4. So these are the values. So net, my final equation looks like this. So what I'm saying is y is equal to mx plus c, right? So 1.057 times x plus 4.2. That is my final linear regression equation for the data points that I have seen here. It's 1.057 and 4.2. So anybody who's got values around in that particular sense. So for these data points, right, 5, 7, 6, 3, 8, 14, 10, and 7, if you look at all the values, if you actually compute your linear regression equation, the equation will look something like this. This is typically how one should solve a linear regression equation. You know, when somebody is given a linear regression problem, this is how one would solve a linear regression. Right? And in a lot of our exams, you know, when we attend, let's say you let's say you're doing master's degree or you're doing some kind of a degree, in a lot of our exams, we're essentially asked to solve this whole thing by hand. You know, we're given around data points, 8 to 10 data points, and we're expected to solve for linear regression completely by hand all the way through till the end. Okay? So this is a very common affair as far as regression is concerned, and this is one of the most popular ways of solving linear regression. This kind of a regression technique is called as ordinary least squares. Right? Let me just ordinary least squares. Right? Why least squares? Because we are trying to see least sum of squares or the lowest possible value of sum of squares. Sum of squares is nothing but your MSE. Instead of MSE, mean, basically that's also a mean. So instead of a mean, if you replace it with sum, it becomes sum of squared error. So we're trying to find a mean or no mean, doesn't matter. Nobody cares. So logically, what I could have done is, if you observe, you just simply, I said MSE, but I did not divide this whole thing by, did not divide this whole thing by total number of observations. I simply summed them. So though I call it mean square error, I actually solved it as sum of square error, because it does not matter, right? Because this is just a constant value. Nobody cares. Even if I imagine I divided this whole thing by a constant value, it wouldn't have mattered. So this whole technique is called as ordinary least squares. As simple as that. Now let's try and validate with Excel. Okay, this is one way of solving MNC. This is not the only way, by the way. There are numerous ways of doing this, but this is one of the most popular way. When the value of MNC are small, of course. But if the values of MNC are very, very large, when I say, I mean, if the number of data points are very large, I'll have too many equations. You know, it becomes very messy. Solving this whole thing for every data point at the same time becomes, you know, extremely irritating and very complicated. So things can get a little untidy with large number of data points, but that's okay. At least we know on paper how to solve it. We'll come to how to scale this out later on. Let's come to Excel. Let's take the same data points and let's try to validate this thing here. X and Y. I have X, I have Y, and the values of 5, 8, 7, 14, 5, 7, 14. What are the others? 6, 10, and 3, 7, 6, 10. Okay, so this is it. Insert. That's the simple line equation. Now what I can do is I can simply go ahead and I can try and add a trend line here. So we can go to chart options, add chart element, trend line. Under trend line, you see here, there are different kinds of trend lines that we can add, a linear, exponential, blah, 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 under different kinds of trend lines. We'll come to that in a minute. Let's add a simple linear trend line. And let me just display equation on chart. That's it. Yeah, your linear regression has been solved here. Your Excel says the value of m is 1.62, whereas we got a slightly different value. We got a 1.07 and 4. Are the points the same? Data points exactly the same? Maybe we made some small error somewhere. 5, 8, 7, 14, 6, 10, 3, 7. Yeah. So your linear regression equation according to your Excel is 1.6286 plus 1.2. That is what we are saying at this particular point. That's it. We've got a slightly different value of M and C here. I wonder why. Let me just try to understand this. One thing that we can validate if these two models are extremely different is 8, 14, 10, 7, 8, 14, 10, 7, 5, 7, 6, 3 is if I can compute the mean squared error on both the models, one that Excel has come up with and one that we've computed, and we can identify which is giving a better prediction. So this is, let's say, the Excel's prediction. So y is equal to mx, which is 1.628. This thing multiplied by plus 1.2. These are Excel's predictions, and prediction when we solved it by hand. This is simply nothing but, what are the values? It's 1.057 plus 4.2. 1.057 multiplied by x plus 4.2. And yeah, look at this. I think both almost have very, very similar predictions. Let's actually try and compute mean squared error. It's going to be average of squared error is going to be this minus this squared, actual value minus predicted value whole square. Similarly, you can do the same thing here as well, but this time it's going to be the actual value is minus the predicted value is this to the power of 2. So if you compute MSE, average of this, and similarly the average of this, the one that we've computed by hand has a slightly higher squared error. I think we made a small mistake somewhere, and that's probably the one that is causing this issue. But that's okay. I think we're not extremely far away from the actual predictions itself. Yeah, it's probably 1 or 2 data points. If you observe, certain data points were actually very, very correct. Like for example, if you see, this has been perfectly predicted. So is the case with 1 or 2 data points. This is the place where I think we went a little haywire, and I don't know. I think where we made a small mistake. We'll have to see where we made that mistake. Then net, I think we've been able to almost find the best possible equation somewhere, except for a small mistake. Arnab, I see a question. Srinath, what function did you use for getting the equation in Excel? What function did I use? Okay, so what I did was simple. So what you can do is, forget about this. Once you create this chart, right? Let's say this is axis titles. You can just set your axis titles over here. This is X, and this is your Y. So what you can do is, you can just go to, on the left top, if you observe, there's something called as add chart element. When you click on the chart, you go to add chart element, and you can go to trend line. If you see, there's something called as trend line, and you can go into trend line, and you can select any one of the trend lines that you want. What I would typically suggest is you can just directly select linear, or what you can do is just go to more trend line options, right? So just click on more trend line and go to, I don't know why it's, yeah. So if you observe, there's something called as format trend line, and in here, what you can do is you can now select all the things that you want over here. So for example, you don't want to set intercept, you want to display the equation on the chart, and you also want the R squared value to sort of come up. So, and I'll talk about what R squared is in a minute. This will take care of giving you the linear regression equation at this particular point. Now, the point is, I'll talk about what R squared is in a minute. Now, what you can also do is that in this particular example, we only had one single predictor. When I say one single predictor, you just had one value of X at this particular point. But at times you might also want, let's say you might want to perform linear regression with more than one single variable. What do? Right? You would want to perform this linear regression equation with more than one data point at times. So in such cases, we might have to perform something more than a simple linear regression. So currently, this is linear regression, but a simpler version of this equation called a simple linear regression. But then when you have more than one variable, more than one predictor variables, or more than one independent variables. In this case, there's only one independent variable, which is x. But at times you might have more than one independent variables. You might have x1, x2, x3, and so on and so forth. So in such cases, we will perform something called as multiple linear regression. So a multiple linear regression process remains the same. Of course, the process will remain the same. Then the only thing is that instead of fitting an equation that looks like this, we could typically generalize your linear regression equation into something like this. So if it is a single variable, predicted value is equal to beta naught plus beta 1 times x. So in our case earlier, beta naught was nothing but your simply nothing but your this was your c and this was your m, logically speaking. That is exactly what we had. But the reason why we move away from the terms m and c is because, if you were to generalize this for more than one predictor variables, then m and c values may not be good enough. So you say y is equal to beta naught plus beta 1 times x. This is a simple linear regression. But if you have more than one predictor variables, that means I'm trying to predict, let's say, the yield as a function of rainfall. Let's say I'm trying to predict based on the amount of fertilizer used, right? Amount of money that the farmer has, and I want to also predict it against the quality of soil, right? And blah blah blah, 100 other things, right? But this time I am not simply doing yield with rainfall, but instead I'm doing yield as a function of a lot of other variables, because now I'm thinking that, look, yield is not good enough. I might not be able to simply predict the yield based on one single predictor variable. I might need more than one. So in that case, what we do is we move away from a simple linear regression. We do something called as multiple linear regression. But in multiple linear regression, your equation would look like this. Your predicted value is going to be beta naught plus beta 1 times x1 plus beta 2 times x2 plus beta 3 times x3 plus and so on, beta n xn, where x1, x2, x3, and so on are nothing but your predictor variables. And beta naught, beta 1, beta 2, and so on. These terms are referred to as just like m was your slope, these terms are typically called as coefficients. We call these as coefficients, and this is still your intercept. Now I'll explain, in the case of a simple linear regression, what we are doing is we are simply fitting a straight line, right? So if you think of a simple linear regression, you have all your data points, and then you're simply fitting a straight line. But in multiple, and hence the equation is y is equal to beta naught plus beta 1 times x, a simple one-dimensional equation. This is y and this is x. But in multiple linear regression, things are a little different. x1, x2, and y, and what you're going to have is you may have a lot of data points, right? Hence, what we now do, instead of fitting a simple straight line, we fit a plane. Yeah, think of that plane that we're talking about currently. So imagine in your room you have a small sheet of paper that's kind of lying from one corner to another. So this equation that you see here, this, instead of a single straight line, this becomes a plane. So hence this will have the equation beta naught plus beta 1 times x1 plus beta 2 times x2. That is what this will be, right? Then what about if I have 3? Right? If I have more than 3, currently I just have 2. 1 is a straight line, 2 is a plane. But what if I have more than 2? Then we call it as this is a line, this is a plane. But what if I have more than these? So we call that as a hyperplane. So y is equal to beta naught plus beta 1 x1. This is beta, guys. This is not spare my plus and so on. We call this as a hyperplane. And how does it look like? It's hard to envision a hyperplane, but imagine, take a piece of paper in both your hands, right? No, it's not like a dice. Take a piece of paper in both your hands, right? Take a paper, and let's say you're holding both the edges, and let's say you twist your paper, right? Imagine somebody is holding this paper from this corner, right? And somebody is holding this paper from this corner. You rotate this in one direction, you rotate this in the other direction. Imagine you twist this paper a little. So what will happen? So this paper will now start to have some contours on it. This paper will start to have some kind of ups and downs. You think of that. In certain places it will be up, in another place it will be down, things like that. So the point is, with a single predictor variable, you have a very simple equation. With two predictor variables, you have a slightly complex model. With many predictor variables, this surface that you see over here will not be as straight as this. It'll start to become more and more complex. Mathematically, this space will become more and more complex. Think of twisting that paper more and more. The more and more you twist the paper, the more and more complicated the surface will become. The point is that linear regression with one or two variables is actually very simple, but with more variables, it actually could yield in a very, very complex, could yield in a very, very complex surface. And because when you have many variables and you have many data points, at times what happens is solving problems like we just did, right? This whole thing that we just kind of did a while ago becomes a little non-trivial. Yeah, solving it in this particular fashion becomes very, very difficult because there are too many variables. Then you'll have to perform too many partial derivatives. Too many partial derivatives means very, very complex solutions. Hence, the whole equation becomes very difficult for us to solve. Okay, so that more or less brings me to the end, except for one last point, which we will anyways be discussing later on, but I think it's worth talking about it. This concept of R squared. R squared, if you see observe over here, there's something called as R squared. So when you build a linear regression model, there are multiple ways of evaluating a linear regression model. One of the most popular ways of evaluating the linear regression model is using this particular term called as R squared. R squared is also referred to as coefficient of determination. A popular name for R squared is, so your R squared, a popular term for R squared, or another name for R squared is coefficient of determination, right? But basically what we are doing over here under R squared is R squared X talks about the proportion of target variable explained, portion of variance in the target variable or your independent variable, or your dependent variable, explained by the model, right? So what we simply mean by this is when you see your R squared is, when you see your R squared is 0.8, what we are simply saying is that 80% of the variability in your target variable has been explained in this particular model. The model that you see currently over here explains 80% of the variability in my target variable. My target variable is varying. So for example, over here, there's some variance, there is still some variance over here, there's some variance over here. There is still some variability in my target variable, which is currently not explained. My model had explained all the variability in my target variable, then my R squared would be 0. My R squared would be 100%, or rather 1, a value of 1. So intuitively, your R squared ranges between 0 and 1, where 1 means you have a perfect model, you have a perfect fit with almost an error of 0. Yeah? So it's highly unlikely that you'll get something like this. In reality, if somebody comes up and tells you that they have an R squared of 90%, then I'm very, very sure they're doing something wrong, because it's unlikely in a modern day, in a real time scenario, you'll get something like that. Right? We'll be hovering somewhere around the 70s and 60s and so on. So because it's impossible to get a model that kind of, or impossible is an incorrect word, improbable to get a model that gives you an R squared of 0.9. With the current data set, we can achieve, because this is a simple model. I'll show you how you can achieve it. Linear regression, probably it only gives you 80%. If you actually go to polynomial regression, look at that. Polynomial second degree equation, look at this. Instead of fitting a linear regression equation is 1.6286x plus 1.2. The same thing if you were to solve it using polynomial regression with a second degree polynomial, look at it. So the equation, if it were to be y is equal to 0.6591 x square minus whatever, blah, 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 your model would have got an R squared of 0.99. And you can try with more complex models as well. Look at this. Third degree polynomial will almost give you a 100% R squared. Just learn that R squared is basically a term that talks about how much of your target variable has been explained by the model. The current model, if it were a polynomial regression, not a linear regression, but instead of polynomial regression, it would have given you an R squared almost close to 1. We are only doing linear regression. Hence your R squared is 0.8 at this particular point. That brings us to closure on your statistics with Excel and your basic statistics and statistics with Excel. Just as a quick refresher, what we've covered until this particular point is we've learned simple statistics of how to descriptive statistics like your mean, median, mode, standard deviation, variance, and so on. And then we moved on from there into inferential statistics, where we learned quite a bit about normal distribution. We did some problems with z-scores, and then we moved on and we learned about hypothesis testing, and we learned about three important tests like your t-test, chi-square test, and ANOVA. And in all these three tests, especially in your t-test, we learned about p-value. I mean, in all these tests, we've realized that whenever we perform a test, there is a p-value associated with it, and the corresponding p-value will give you the probability of committing an error if you reject a null hypothesis and things like that. So we understood all of that quite well, to be honest. And then we moved on. And then we wanted to talk about the next thing in statistics, which is statistical modeling. One of the most popular statistical modeling techniques is your linear regression. So under linear regression, what we have explored is we've explored how to perform a linear regression. In today's session, we've explored how to actually solve a linear regression by hand, and we've also understood how to implement the same using Excel. Additionally, we've also looked at how to implement your t-test, chi-square, and ANOVA in your Excel as well. So that is where we are at this particular point. Let's take a quick example and we'll try to understand this thing better. So let's say this is X and this is Y. Let's say there are two classrooms, two students, or two sets of students, class A and class B, and both of them have written two different exams conducted by two different teachers, and they've got two different sets of marks. Or another way of evaluating on another typical problem could be, imagine you're currently performing, let's say you're in a production plant, and what you've realized is that currently you've taken a small sample of data points, a small sample of a particular batch. Let's say you're manufacturing a particular liquid or a drug, let's say, or it could be a food product. Take, for example, a food product, like let's say there's chips that you're manufacturing, or any manufacturing unit, any food manufacturing or any drug manufacturing unit. A typical quality control team, what they would do is they draw samples, right? They would draw typical, let's say they've drawn two different samples one from a batch that they know is very good, and the other is a batch that they would want to test against. So there is batch A and there's batch B. Batch A is basically the batch for whom they know that that's a very good batch, and batch B is the currently getting manufactured batch. So now what they want to do is they want to evaluate if the current batch and the batch that they know, if the two batches have significantly different means in, let's say, the amount of sodium levels, right? Because chips have a lot of sodium in them. Or let's say beer manufacturing, where there's a ton of sodium that's being added into beer. So you'd want to identify if there's a significant difference in the beer or not, in the sodium levels in the beer or not. So what you do is you go ahead and you capture it. I don't know the metric for that, but let's just identify that there are certain values. So let's say this is batch 1. Similarly, batch 2 is you get some other values. Why would I get 21? Let's say there are batches, batch A and batch B. This is not, so two separate batches at this particular point. I'd want to identify if the means are significantly different or not at this particular point. So when I say if the means are significantly different or not, what is my null hypothesis? So Raja, here is where we're trying to identify your null hypothesis and alternate hypothesis. I want to identify if these two batches are significantly different or not. Right? To prove that my batches are significantly different. So first things first, what is my claim? My claim is that these batches are significantly different. See, remember, when you perform hypothesis testing, when would you do hypothesis testing? You would do a hypothesis testing when you know that there's something wrong, or when you know that there's something different than the normal behavior. You have a feeling that it looks like this is different from the normal behavior. Right? You have a feeling that the current behavior is different from the regular behavior. So what that means is that when there are two different batches of a drug being manufactured or food being manufactured, whatever kind of food, somebody sensed that there could be something wrong, or somebody is assuming that there is something wrong, and they're trying to prove that these are wrong or these are different from each other. Right? So then in that case, what is the null hypothesis in general? The null hypothesis is that there's nothing wrong. Right? Null hypothesis says no difference. The hypothesis is you're nullifying the claims. The claim has been nullified, so no difference. And the alternate hypothesis, there is a difference in the mean. There is a significant difference rather in the sodium levels or whatever levels, I don't know what they are, in both the batches. Okay, so now this is my setup and I'd like to go ahead and perform a simple hypothesis test. So how do you perform a hypothesis test? So let's just go here and go to data and batch 1 and batch 2. What kind of a test are we talking about over here? Is it a paid sample t-test or is it a two sample t-test? What kind of a t-test is this? It's a two sample t-test. Spot on, correct? Yeah, it's a two sample t-test because there is no dependency between these two samples. So let's go ahead and click on data analysis, and here if you see data analysis t-test with unequal variances and equal variances. If you're not sure, just click one that is equal variances. The primary difference between these two is that if you know for a fact that these two are supposed to have the same mean and the same variance, right? If you want them to have the same mean and the same variance, that means both of them have to be more or less the same. In such case, we typically we just don't compare the mean, we also compare the mean with the variances. In the case of that, just go ahead and select a two sample t-test with equal variances. If you're not unsure, it is most likely equal variances. So just select that. Variable range 1, this is variable range 1, variable range 2. And there are labels. Hypothesized mean difference is 0 because I'm saying that both of them have no difference. So the difference in the mean is 0. And I'm going to select an output range where the output will simply come up. So I'm going to select this output and I'm going to hit OK. Boom, done. That's it. So that's my t-test output as you see here. Now remember, this is a two sample t-test, but is it a two-tailed t-test or a single-tailed t-test? One-tailed t-test. Two sample t-test. Am I directionally dependent or independent in this particular case? I mean, am I looking at should the mean be greater than 0 or less than 0, or the batch 2 mean is greater than batch 1? I'm independent at this particular point. So hence I'm more interested in a two-tailed t-test. I look at on both sides of the mean. I'll be performing a two-tailed t-test, and the corresponding p-value is 2.2. The corresponding p-value is 0.88. Basically saying that these two have a significantly different mean, right? This has a mean of 15.33 and this has a mean of 15.83. Though the number of data points are quite small, with the current data set, what we are saying is that with the variances, what we're currently saying is that these two have a significantly different mean. It's probably not simply because of the mean, probably because of the variance that we see that kind of an issue at this particular point. Let's say if I were to, if we just forget about this whole thing, and if I were to, let's say, change this to 21, I go to data analysis and perform the same thing. For this time, if you observe, I get a slightly lower p-value because again, the variance is significantly different from each other. I see that the p-value is still very, very high, saying that these two samples, though they look alike, they probably have a similar mean, but then because of the fact that the variance is very, very different, we're saying the p-value is very, very large. Again, remember, this is because we are assuming that there has to be equal variance. Imagine if you were to do the same thing with unequal variance. Yeah, let's go here for this time, unequal variances. And if you were to do the same thing, first one, second one, labels 0, this is my output. Even with unequal variances in this particular case, the p-value is actually quite high, simply because I think the difference in the means is quite significant in this particular case. Hence, it says that with the total number of observations that we see here, also the fact that the number of observations are quite small, it still says that the p-value is actually quite high. I would have rejected my null hypothesis if the p-value is less than 0.05. So somebody is asking that question, p-value is greater than 0.05. Therefore, you don't reject HA, you fail to reject your null hypothesis, right? So you by default are with null hypothesis, right? When you say reject alternate hypothesis, that is typically not the right terminology. You have failed to reject your null hypothesis. Rejecting null hypothesis is your aim here. So you either succeed in rejecting the null hypothesis or you fail to reject your null hypothesis. So currently we are failing to reject the null hypothesis. That's the right terminology. I mean, there's nothing wrong with what you're saying. Exactly. Yeah, you fail to reject null hypothesis in this case. Correct. Yeah. So I hope you're comfortable with this. Yeah. With this example. This is how you typically perform a t-test. Similarly, we've also done chi-square test and ANOVA in our previous session as well. Yeah. So it's the same thing, right? You just go here, select chi-square test, select ANOVA, and then or chi-square test. The point is ANOVA, we did ANOVA straight away. ANOVA single factor ANOVA is what we already did. Same example, similar example. You could also do the same thing with ANOVA as well. Imagine you had the third batch and you were to compare x1, x2, x3, or the three batches. You could simply identify what is the best approach over here, or you could identify if the p-value is less than 0.5 or not, 0.05 or not. Same thing ANOVA as well. You have a new way of, let's say, mixing text and let's say images and coming up with a completely different way of representing data. It's the research field that where all of this happens. It's the data science researchers at Microsoft, at let's say Google and Amazons of the world. They are the ones who are in the front. IBM, yeah, they are the ones ahead in the market. They are the ones building those very, very complex features. But that's more of an engineering. It is. I mean, see. So whenever you talk about a particular problem, right? There are three phases of how a product typically gets built. One is the actual research, the core research of how a problem needs to be solved. So I'll give you a simple question, right? So you have to perform language translation, right? So I give you a piece of English text. You need to convert it into Spanish. The first is, figuring out the underlying algorithms or underlying math of how you solve the problem. That's the most important piece. Next is scaling this up, right? Actually applying this at a large scale level. The third is once you've cracked how to scale it, then it's about applying this to larger applications, different kinds of applications. So performing language translation in text, performing language translation on top of OCR read documents, performing language translation from languages to, let's say, code. I have SQL and I want to convert ANSI SQL to, let's say, Oracle SQL, or Oracle SQL to, let's say, Teradata SQL. That's basically different applications of the same problem. But cracking the actual problem of converting, of representing text in some numerical format and then trying to solve that and trying to perform translation on top of it, or building architectures where something like this can happen, is a research problem. Once that's done, then you scale this up. So then it becomes an engineering problem. You scale this up, you apply this on large volumes of data, then you operationalize it. That's an engineering problem. And then it's the consulting teams who take this solution, pre-built solution, and apply it on different fields and try and solve the problems, because you have a semi-baked solution. So you take that semi-baked solution and do that final tinkering on different. They basically solve the last mile, so to say. So yeah, I mean that's generally how product development happens, and it's different in different organizations. But typically the research teams are the ones who are at the heart of building new algorithms. So when I say new algorithms, remember this is new machine learning algorithms, right? This is not the new. This is not the tip. This is not how can I read data quickly from the disk. No, that it's not those kind of problems. When I say algorithms, something like linear regression, a complicated version of linear regression. That's what I mean by algorithms.
Let's have a quick quiz question, guys. And the question is, which of the following standard probability function is applicable to the discrete random variables? And your options are exponential distribution, Rayleigh distribution, Gaussian distribution, or Poisson distribution.
Just a quick info, guys. Intellipaat offers state of the art data analytics course in association with IITM Pravartak. Through this course, you can learn all the important tools and concepts of data analysis such as Power BI, data wrangling, data mining, etc. from esteemed IIT Madras faculties and industry experts. With this course, we already have helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take a first step towards career growth in the field of data analytics.
Oriented programming language. So Object-oriented programming means everything you do in the program is an object. For example, if you take Excel, in Excel, the workbook which you work on is an object, and each and every sheet in that workbook is again an object. So this is how the concept of object-oriented programming works. VBA can also be used to manipulate other Microsoft applications in Access, Word, PowerPoint, and Outlook. No additional installation is required for VBA. If you have Excel on your computer, then you have VBA on your computer. So VBA is basically a programming language which is used to automate tasks in Microsoft applications. So basically we use it mostly in Excel for report automation and all that stuff. What is a macro? So a macro is a sequence of VBA commands to run a task automatically instead of manually doing it. So macro, what is a macro? So macro is nothing but steps of code that you write in VBA programming language in order to automate the task. And what macros can do for you? Macros help us to do the repetitive tasks and recurring tasks in less time with accuracy. So when we write the macros, we can automate the tasks that we are doing in Excel or MS Access. And what happens because of doing the automation is the time taken for doing the reports will reduce a lot. And again, the accuracy will be more. Because when you start doing a report which take hours together, there is always a chance that you might commit a error. So when you automate tasks, if you run the macro 100 times also, it will run the same set of steps without any monotony. So along with time saving, we will get accuracy. We will get accurate results with macros. Exploring Visual Basic Editor. Okay, so when you are in Excel, you need to press Alt F11 to go to the Visual Basic Editor. So this is the Visual Basic Editor which is embedded within the Excel workbook itself. And this is the on the left hand side you have the Project Explorer, and if you want to write the code, let's say I select this workbook, and then you have on the right side you have the code window. So as I go through the classes, I'll explain you more in detail what are the options we have in VBE. So we have all these menus: file, edit, view, insert. So I'll take you through in detail in the coming classes regarding the Visual Basic Editor. Okay, and one more thing I just want to mention here is the developer tab in Excel. So here if you see, you have the developer tab. Okay, in 2003 version we don't have the developer tab. From 2007 we have this developer tab. However, by default we don't get this developer tab. If you don't have the developer tab, I'll show you where you can add this. So we need to go to Excel options, and here you have under popular you have show developer tab in ribbon. If this is unchecked for you, you need to check this option, click on OK, then you will get this developer tab. So this developer tab is very useful for us when we are doing the macros, because if we go to the developer tab, we have the Visual Basic icon. If you click on the Visual Basic icon, it will again take you to Visual Basic Editor, same as Alt F11. And then you have macros. This gives you the dialog box with the existing macros. Currently I didn't have any macros in this workbook, so it's not showing up anything. And then you have all these record macro, all these macro related functionalities. So this developer tab is very useful. So we can add this from Excel options using macro recorder. So this is the most important thing, because we can record our macros. Every time you don't need to write the code, some of the things you can record. So how we can record the macros? So the easiest way to create a macro is to record your worksheet actions using a valuable tool called macro recorder. All you need to do is to turn on the macro recorder, perform the actions that comprise the task you want to automate, and then turn off the macro recorder when your work is finished. While a macro recorder is on, every action you do like selecting a cell, selecting a number, formatting a range, everything gets recorded and it is represented in the form of a VBA code. So if you see here, you have an option called record macro. So this is a really powerful tool because even if you don't know the VBA coding, you can record the set of actions and that will be shown in the form of a VBA code. So most of the times around 25 to 30% of the automation work can be done using the record macro option. However, record macro have its fallbacks. Okay, so I'll just show you some of the programs using the record macro option. Then we will see how it's actually working and what are the advantages and what are the disadvantages, few disadvantages we have in this option. So for that, let me just open the base data. Okay, you would have already done text to columns manually. So I will show you how we can record a macro for this, and next time we can use the macro to do this task. I'll open a new Excel sheet. Okay, as I already mentioned in my demo classes, if you want to save the macro and if you want to run the macros, the format of the file should be Excel SM. It should be a macro enabled workbook. Macros cannot be run on a normal Excel file. So let me just save this file. Alt F8, save. I will save this as macros1 and I'll save this as Excel SM, which is macro enabled workbook. Now this is the file where I am going to record the macro. So let me just use the data here. Okay, now I have the data. So here we have the data, everything is separated by a semicolon. Now what is your requirement is you want to get each individual user in individual columns, and you know how to do it. You can use the text to columns option. But let's see how we can record a macro for it and do this task with a macro. So for record macro, it's very simple. You just need to click on record macro and the macro name. If you want to change it to some other name, you can say, let's say you want to change it to, we can just keep it as macro1 here, and then you have shortcut key. Shortcut key is nothing but if you want to run the macro using a shortcut key, you can assign the shortcut key here. However, make sure that you are not using any of the existing shortcuts. For example, if you say, see here, Control C. So Control C is the default shortcut for copying an object in Excel. So it shouldn't be overwritten. So we should make sure that we are using a shortcut key that is not already used for the Excel default codes. So it's always better to take a combination of Control Shift. That would be good, because with Control all other alphabets are already used for the default keywords, I guess. So let's say I use Control Shift. I just press the Shift and again I just use L. So Control Shift L. So Control Shift L is the shortcut key I am assigning to this macro in order to run this macro. Store in this workbook is nothing but I am just storing the macro within this macro1 Excel SM workbook itself. Description, let's say this is text to columns macro. It's not a mandatory thing. It's better if you give it, because tomorrow if you want to know what is this macro for, you can just refer to the description. So I'll say OK. So now the record macro option, now if you see, it's showing as stop recording. That means currently the recording is on, and whatever actions we do on the sheet, everything gets recorded in the form of VBA code. So we need to be very careful. We are doing only the required action. Even if you scroll the mouse even if you do some other action, even that will get recorded. So you need to make sure that you are only doing the set of steps that are required. So first I need to select A1 where I have the data, and then I go to data, text to columns, and then you want to use the option delimited since you are using a character. So delimited, click on next, and then here you want to delimit based on the semicolon, and then click on next, and then finish. This is how you do manually. So our work is done and we recorded it. So I just want to stop the recording. I'll go to developer tab, stop recording. So now we have done the work. Okay, so let's see how it got recorded since we recorded it. So you want to go to the Visual Basic Editor, or you can press Alt F11. So if you see, now under the Project Explorer window, you have VBA project macro1.xlsn. This is the workbook we are using. And if you see here, sheet 1, sheet 2, sheet 3, this workbook, these are the default objects. Sheet 1 is for the sheet 1, sheet 2, sheet 3, and this workbook is the workbook object. Along with this, if you see, you have something got created here, what is called as modules. Okay, let's see what is this module now. If you go into the module, you have module 1. Click on module 1. So if you see here, macro 1 is nothing but the macro you have recorded, and this is the description you have given, and the keyboard shortcut you have given is Ctrl+Shift+L, and this is the code that got recorded for the text to columns action what we have done now. So if you see the code here, it is very long. This is one of the advantages. This is one of the disadvantages with recording macro. It records as it is. If we write a code for this, we can write it in 1 or 2 lines. But since we recorded the macro, we got the code this long. Okay. For now, just forget about the disadvantages and the advantages. Let's see how whether this code is working or not. So this is where this code is now. Let's go to our Excel again. I'll just delete this data. Okay, so let's copy the base data again into this macro template. So this is the base data. Okay, so previously, see now if you see, you have entire thing in one column with the semicolon separator. So previously we have done the action with we have done the action manually. Now anyhow we have the recorded macro. Let's see whether it's working or not. So how to run the macro? So we can run the macro by clicking on macros, and the macro which we have created is macro 1, right? And you can click on run. This is one way of running the macro, and other way of running the macro is directly you can run it from the Visual Basic Editor. So you have the module. I'll just minimize this. So this is the macro 1, and you can click on the run option here. This is the second option. So from view macros, you can select the macro and run it, and from Visual Basic Editor you can select the macro and you can run it. And the third one is we have assigned a shortcut key. So what is the shortcut key that we assigned for this? It's Ctrl+Shift+L. So let me press Ctrl+Shift+L on my laptop. So Ctrl+Shift and then I press Ctrl+Shift+L. See, as soon as I just press Ctrl+Shift+L, it has done the task for me. So whatever macro is recorded, it's working. So let me just run it again. Let me just clear off the entire data. Okay, let me copy the base data again. Okay, so now let me run the macro using the other option. Okay, so now you see you have all the data in A1. You don't have any data in other things. You have all the data in A1. So macros. So macro 1 is the macro which I created just now, and then click on run. See, Now the text to columns has worked. Now we have done this action with using a macro, and we have not written any code manually. We just use the record option, and we got the VBA code, and we are using the macro. So very simple this is, just recording the macro, and most of the time you can use the record macro option for 20 to 30% of your work. What are the disadvantages of using the macro recorder? I'll just show you. First thing, when you use a record option, the code will be too long because it will exactly convert the action into the VBA code. And second, and the most important thing, when you record a macro, it will work only for that specific range. So what I mean to say is, for example, if you have 10 rows and 10 columns and you recorded a macro for that, it will work only for that 10 rows and 10 columns. For example, tomorrow you have 11th row and 12th row and you run the macro and you will not get the desired output. So even if you have additional columns, if you have additional rows, you will not get the desired output, and if there is a difference in the format also, you will not get the desired result. So in a real world, in a real-time scenario, this will not be possible, because you cannot say the report should have only 10 lines every time, because sometimes you might get a report with 100 lines of data. So your macro should be dynamic. So whatever the range, whatever the number of rows, whatever the count, and what are the fields you have, the macro should be able to dynamically count the range, and it should do the action irrespective of the number of rows and the kind of data. So for that we need to learn the further concepts of VBA, and we need to learn how we need to write the code in VBA so that the macro will be dynamic. Okay, so these are the main things to keep in mind. I'll show you a few other programs as well using macro recorder. And then assignment of shortcut key to a macro, which I already showed, and then assigning a macro to a command button. So this is the same macro now we have. Let's see how we can assign this to a command button. Command button is nothing but it's a button which you can click. So you, instead of running it using a shortcut key or directly from the macros tab, you want to click on a button and you want this macro to run. So let's see how you can do that. Let me just clear this data. I'll again copy the data. Okay, so now I want a button here, like say some run macro. So if I click on that run macro, I want the output. So in that case, here on the developer tab you have something called insert. If you click on insert, you have form controls. So you can use these controls. Now in the first one you have button form control. Click on the button form control, and then you are getting this plus sign. You can draw this command button wherever you want. So I'll just draw the button. Just cancel this. Okay, if I want to change the name, I can just click. So I'll say run macro. So this is the command button which I have created now. So I want to assign the macro to this command button. So I'll just click on it and then right click. You have something here called assign macro. Okay, and the macro you want to assign is macro 1. Okay, so now we have the macro assigned to this command button. Okay, so when I click on this command button, it runs the macro 1 macro. So now this is the data which we have. So let's see whether it works or not. Run macro. So as soon as I click on run macro, it did the same action. It just run the macro 1, which is for text to columns. So now I'll show you one more program how to record the macros. I'll just delete this data. I'll just delete this for the time being. Okay, so let's see one more program. Okay, let's see the sorting. So you would have done sorting manually. Let's see how we do the sorting using the record macro option. So let's say this is the data we have, and our requirement here is we want the item column at the start, not the date. We want item column at the start, and then we want to sort the data using the item. So let's say this is our requirement, and I will use this macro template. I'll create one more macro here. So let me just copy the base data from here. Okay, so now I want to record the macro. So make sure whenever you are recording the macro, you are not doing the additional scrolling and everything, because whatever action you do, everything gets captured in the form of a VBA code and it will increase the code. Okay, so let's start. I'll click on record macro. So this one is coming as macro 2. I just want to keep it as macro 2. And if you want, you can give a shortcut key for this. Let's say I'll say Control Shift and then I'll say M, Control Shift M, and this is for sorting. Okay, so now it's showing stop recording. That means recording is already started. So what I want to do is I want column B item that I want in column A. So I'll select column B. I'll do Control X cut, and then I want it here, so I'll select this, just right click, insert cut cells. So now I have the item in column A. After that I want to do the sorting based on column A. So I just selected Control Shift right arrow, Control Shift down arrow. So I selected the entire range, and then I want to do the sorting, and I want to sort based on items values from A to Z. Okay, so this is the action I have done and I have recorded it. Now I want to stop the macro. I just stop recording. So let's go to the Visual Basic Editor and see how we got the coding for this. So if I see here again under module 1, now I have macro 2 and I haven't given and this is for sorting. This is the description I have given, and keyboard shortcut is Control Shift M. So this is the code I have got for it. So this is the code I have got. Okay, so now I want to test this macro, so I'll just delete this data. Again, I'll just copy the raw data here. Okay, see now the raw data, you have date in the first column and then item you have here. So now I want to run the macro. So I can run this macro using the shortcut key Control Shift M, or else I can go to Visual Basic Editor and from there I can run the macro, or I can click on macros here to get the list of macros. See, we have macro 1 which I have already done for text 2 columns, and macro 2 is the macro which I have done for sorting. So macro 2 I select. If I select, it's showing the description as well. Now select macro 1, it's showing text 2 column. So it is very easy for you to know which macro you are running. Anyhow, you can give the macro, or you can change this macro name, whatever name you want, you can always give for the macro. So macro 2, this is for sorting. I just want to run it now. Click on run. See, now you have the item in column A and it's sorted as per the alphabetical order. So you got F first, fridge, and then you got the laptop. So this is how we can record the macros for simple tasks. However, when you are doing a real-time report automation, then the record macro option would not suffice, because as I told you, the macro whichever you do, it should be dynamic. It should calculate every time how many rows you have, how many columns you have, what kind of data you have, and then it need to run the code accordingly. And you have decision making, and sometimes you need to repeat the task, you need the loops. So all these concepts you get in VBA programming. I want to show a few more things in Visual Basic Editor. Alt F11 is the shortcut key, or under the developer tab you have the Visual Basic Editor. So how you get this developer tab? You go to ribbon and then Excel options, you have developer tab. If you just switch it off, the developer tab is not here. If you want it back, Excel options, show developer tab. Okay, and then under the developer tab you have your all the icons related to macros. So you have Visual Basic Editor, and then you have macros, record macro. So let's go to Visual Basic Editor. Okay, one thing here is the module, which is new to you, because whenever we open Visual Basic Editor, you will have the project with the name of the workbook, and then these are the default options: sheet 1, sheet 2, sheet 3. This workbook, these are the default options which you use when you want to write a event. Event is nothing but basically whenever you want any change to trigger an action, then you write in the default objects. For example, if you want a macro to run when you open a workbook, then you write it under the workbook object using the open event. So there are so many events like sheet active, sheet before double click. So whenever you want any macro to run based upon an event, then you use this workbook Excel objects. So if you want, like for example, sheet, let's see what we have in sheet. Sheet activate, sheet double click, sheet right click. So whenever you want to run a macro based on any other action, then you use these events. So but however, if you want to run a macro manually, then you need to use the modules. So where you get these modules? Insert, you have your modules here. However, when you are recording a macro, it automatically creates a module and gives the code under the module. You don't need to manually insert a module. But whenever you are writing the VBA code manually, you need to insert a module. Let's say insert a module. Now it added one more module, module 2, and then you need to write the procedure or the VBA code in this module. So whenever you want the macro code to run automatically based on a action, then you use the events. Events are nothing but they're using the existing Excel objects, sheet 1, sheet 2, sheet 3, this workbook. And whenever you want to run the macro whenever you want to run the macro manually, then you use the module. Okay, so this is one more thing. I mentioned about the disadvantage of recording option. So now I'll just show you using the same sorting example. So let's just copy the data from this. Okay, so if you see here, we have 239 rows. Okay, so we recorded the macro and it worked fine. Okay, so let's say I'm just adding few more lines here. So till 239, this is what we have the data. Now I additionally added these lines. Let's say I just make everything as Jan 2012. Okay, so 240 from here. These are the lines which I additionally added from the base data. So now let's run the macro and see how it works. Previously, when we recorded the macro and we run the macro, it worked perfectly fine. So now let's run the macro again. So the macro which we have done for sorting is macro 2. This is the sorting. Let's run it. Okay, so it worked. Let's see. If you see here, till 239 it worked fine, but here if you see the laptop, we are getting it here. So first it should sort by item. So laptop should be coming after the fridge. So the laptop line, everything should come under laptop itself. But if you see the lines after 240 where we have laptop, it still come as laptop here only. Ideally, if the macro has run perfectly, it should have come after the fridge, right? So all the laptops should come here when you do the sorting, but few laptops, whatever is after 240, we still have it under 240 because the macro code, whatever we have written, it took the range till 239 only. So after whatever is there, it's not applying the sort. Let's see the code for the macro 2. You will come to know. Okay, this is the code for macro 2. If you observe the code here, if you see the sort range, it mentioned as A2 to A239. So this is what the drawback of recording. So it exactly takes the range whatever we are using. So initially when we record the macro, we had only 239 rows. So the code applied only for 239 rows. Even now, even if we have 247 rows, it is not dynamically taking 247 as the number of rows. It's still taking only 239 rows. So this is the major drawback which we have if we use only record macro option. So this is why record macro option can do only 20 to 30% of your automation work. Again, you need to edit the code and you need to write the code in your own way so that the code is dynamic and it works for any number of rows and any number of columns. So this is one thing we need to always keep in mind. And one more thing, whenever you are writing a macro, it's important that which version of Excel you are using. For example, if you are using an Excel 2007 version and you have done a macro, and if the other user to whom you have given the macro might have Excel 2003, then there is a chance that the macro don't run in his system. Okay, why? Because for example, in 2007 you have some features that are not available in 2003. So if you are using those options in the VBA code, that will not run in 2003. For example, in 2007 you have something called remove duplicates. But in 2003 you don't have this remove duplicates option. So in your VBA code while writing in 2007, if you have written a code related to this remove duplicates, using this remove duplicates, then that will not work in the 2003 version. So you always need to keep in mind who are the users who will be going to use this template, and you need to create the macro keeping that in mind so that it will run on all the versions. Okay, so first let's start. What is a variable and why do we need variables? VBA stores data in memory using a variable. A variable is a name given by you, to which you assign a piece of data that will be stored in computer memory that can be retrieved when you need it later in the macro. So what is exactly a variable? A variable is nothing but it is used to store the data in computer's memory and then reuse it whenever you need it in the macro. And you are going to give the name for your variable. Variables hold values of different data types that are specified when the variable is declared. So data types, I'll explain you in a bit, so you will know what is a data type. So variable can hold different data types, meaning you have variables which can hold numbers, you have variables which can hold strings. So there are different data types, and we will see in this session how we are going to define variables with different data types. How we declare a variable. So you declare a variable with declaration statement which contains 4 keywords in particular order. So when we need to declare a variable, and there is a syntax for that. So what is the syntax for declaring a variable? First we use the dim statement. Dim is the shortcut for dimension, and then after dim you give the name of the variable. So variable name can be anything, so you can give whatever name you want for your variable, and then we need to give the keyword as, and then you need to give the data type. So for example, here if you see dim my name as string. So what I am doing here is I am defining a variable called my name of data type string. That means my name is a variable that can hold a string value. Okay. However, there are few rules to be followed while giving a variable name. In this case, I have given my name as the variable name. Let's see what are the rules we need to follow while giving a variable name. So variables must begin with an alphabet. So always it should begin with a alphabet. They must contain only alphabets, numbers, or the underscore symbol. No spaces. So a variable name can contain alphabets, numbers, and underscore, but no other spaces and all special characters. They must not exceed 40 characters. A variable name shouldn't be more than 40 characters, and they must not be a reserved word. Reserved word meaning the keywords which the VBA program understand. Like when we said dim, it's a keyword, and the data type string is a keyword. So we cannot use those names as variable names. Let me show you in VBA editor how we just declare a variable.
Let's have a quick quiz question, guys. And the question is, which VBA functions returns the location at the second string which occurs within the first string? And your options are mid, CHR, ASC, or INSTR.
Just a quick info, guys. Intellipaat offers state-of-the-art data analytics course in association with IITM Pravartak. Through this course, you can learn all the important tools and concepts of data analysis such as Power BI, data wrangling, data mining, etc. from esteemed IIT Madras faculties and industry experts. With this course, we already have helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take a first step towards career growth in the field of data analytics.
Code. So now I want to declare a variable. So how I do it? I use the keyword dim and then the variable name. While giving the variable name, what are the rules we have? Variable should start with alphabet. It can contain alphabets, numbers, and underscore. No spaces should be used, and the variable should not be more than 40 characters, and it should not be a keyword. So let's say I give the variable name as test1, and then keyword as, and then data type. So I want test1 to hold a string value, so I say the data type is string. So this is how we declare the variables. So next we have implicit and explicit declaration. So what is the implicit declaration? You do not have to declare a variable before using it. You can just include the statement like the example I have shown here. like I'm taking a variable temp val is equal to 6. So here I never declare the variable, like I never did a like dim temp value as integer or string. So I never declare the variable temp val. However, I am directly using it in the statement. So this is called as implicit declaration, where we are using the variable without declaring it previously. So in this case, what are the problems with the implicit declaration? The problem with doing this is this can lead to errors in your code when you misspell the name of the variable in a later stage. So here the problem is, for example, now you have tempval as the variable. You never declared it, you directly used it. So at a later part in the macro, if you misspell it, tempval, if you just misspell, then what it do is it again creates another variable with that name. For example, if you, instead of temp val, if you just type temp val in the next part of the macro, then the system won't understand that temp val is same as temp val. Okay, so what the system understands is this temp val as a new variable, and it will create another variable called temp val. So now we have temp val and temp val, two different variables. So this is a major issue with implicit declaration, and during the runtime it takes a lot of time for us to correct these issues. Explicit declaration. So what is explicit declaration? To avoid the problems of misnaming variables, you can stipulate VBA to generate error message while compilation whenever it encounters an undeclared variable. Okay, so what explicit declaration means, we declare each and every variable before using it. So by doing this, when we create any variable or when we misspell any variable, it will throw an error message saying that this variable is not declared. Then we can check and correct the spelling. So in this way we don't get any errors. So how do we do explicit declaration? By using the statement called option explicit. When we use option explicit, it will make mandatory for us to declare every variable before using it. So in this way, if we use any variable that is not declared, it will throw us an error saying that the variable is not defined. Then we can go ahead and do the changes accordingly. Now I will show you in VBE how to do this. And option explicit we need to give in the module declaration. So here I say option explicit. Okay, so here I define the variable test1 as string. Let's say I haven't defined it. I'll just directly give test1 is equal to string, always need to kept in double quotes. So I say now. Okay, let's just run this code. Variable not defined. See, because test1 we haven't defined and we are directly using it. In case if we don't use this option explicit, now what we are doing here is a implicit declaration. We never declared it, however we are directly taking test1 and assigning it a string value. Let's run this. Okay, we didn't get any error. Let's say I just want to throw a message box, the name is, okay, and then I want to ampersand just to concatenate the sentence, and test1 I need to display.
So let's see, this is the implicit declaration where I have taken a variable test1 and assigned it to a string value ram, and then I'm just putting a message box to display the name is and then the name. Let's run this. So the name is ram, so the macro is running. So in this case we never declared the variable test1, but still macro is running fine. This is implicit declaration. However, for the same case, if I use option explicit and if I run this code, it's showing me the error message, variable not defined. So explicit declaration, when you do, it will ask you to declare the variable before using it. So what I do, dim test1 as string. So now even if I have option explicit, I already defined this, declared this variable, and then I am using it. So now the macro should run. So this is the difference between implicit declaration and explicit declaration. So the main use of this explicit declaration is, if a variable is not defined, it will throw us the error message. However, in case if you are not using the option explicit, here if we haven't defined this, so in this case it takes the ram into the variable. However, if we misspell this test1 by mistake, if we say test11 here see, we are getting incorrect result. We are getting the name is, but we are not getting anything, because what's happening here, it has created one more variable called test11. So test11 is not equal to test1, so we are not getting ram here. So test11 is a different variable which do not have any value. So this is the issue when we are doing a implicit declaration. Scope of a variable. So what is the scope of a variable? So we have three kinds of variables: local variable, module level variables, and global variables. So a local level variable is, if you declare a variable within a procedure, only code within that procedure can access that variable. The scope is local to that procedure. Local variables remain in existence only as long as the procedure is executing. So what is a local variable? A local variable is a variable that is declared within the procedure. So in this case, the procedure here is the subroutine, and here we are declaring test1 as string inside the procedure. So here test1 is a local variable. So this test1 will be in existence only as long as the test macro is running. So once the macro is done, this will not be available in the memory. So test1 is local only to this macro, and this will be in existence only during the execution of this specific macro. Then we have module level variables. A module level variable is declared in the declaration section of the module instead of within the procedure. Module level variables are available to all procedures within that module, but not to the rest of the application. Module level variables remain in existence for the lifetime of the application and preserve their value. So what are module level variables? So in this case, test1 we said is a local variable. If we want a module level variable meaning that variable is available to all the procedures within that module. So if I say module, I have here module 1. So let's say I have one more macro here, test 2. I take one more variable test3 as string. Test3 is equal to, let's say I just give a name Sam, and then MSG box, and then test3. So here test1 and test3 are local variables, but both these macros or procedures are in the same module. So let's say I want a variable which can be used by both these procedures. So in that case I can go for a module level variable, so that whatever macros in this module, whatever procedures in this module will be able to use that. So for that, where I need to do the declaration? In the declaration section of the module. If I do the declaration within the procedure, it becomes a local variable. So if I want it to be a module variable, I need to do it in the declaration section of the module. So where it will be? At the top. So here, let's say I define dim I will take it as mod test as a variable as and the string. Okay. So now here, if you see, as soon as I have done the declaration here, we got a line here. So this means this is at a module level. So this mod test, the variable, we can use it in the test procedure and test2 procedure as well. Okay. So let me use it in test. Here mod test is equal to the name is, and here instead of giving the text, I just use the variable mod test. So here this is a different procedure, test2. Since mod test is a module level variable, we can use this in this procedure as well. So here also I will just replace mod test. So mod test, I already have given the value, the name is, and then I am using mod test in test macro also and test2 macro also. So let's see how this is working. I'll go to the template, view macros. First let me run the test macro. Run. The name is Ram. Okay. So let me run the test2 macro. The name is Sam. So whatever mod test we assign the value, the name is, we are able to use it in test macro also and test2 macro. So in this case, we have defined the variable is a module level variable, and then we are using it in the procedures, all the procedures available under that module. So this is the advantages of module level variable, whereas local variables are the variables which are defined within the procedure and they can be used within the procedure. In this case, test1 can be used only in this test macro. We cannot use test1 in test2. However, the mod test is a module level variable, so we can use it in both test macro and test2 macro as well. So let's see what is the third type, global variable. Global variables are declared in the declaration part of a module with the global statement, and they can be accessed by any code within the application. Global variables exist and retain their value for the lifetime of the application. So now we have seen local variables which are local to the procedures, and then module level variables which can be used within the entire module. Even though there are different macros and procedures in a single module, we can use in all those procedures which are in a single module. And finally, global variables can be used within the application. This means if we have more than one module here, let's say I inserted another module, and let's say I have one more macro here. Okay, so this mod test I can use in any number of procedures within this module. However, this mod test I cannot use it here because mod test is a module level variable and it is defined in declaration section of module 1. So I can use it only in module 1 but not in module 2. So however, if I define this as a global variable, so how we define a global variable? By using the keyword global. Now this is a global variable which can be used within the application. Application is nothing but the entire program, entire Excel application. So even though in a different module also, even the module 2 is also existing within this VBA project, within this application itself. So now when I define mod test as a global variable, I will be able to use it even in module 2. So let me use it here. Let's run this. The name is Radha. So in this case, mod test is never defined in this module. However, since in the other module within the same application, it's defined as a global variable, so I'm able to use it in the other module as well. So global variables can be used within the entire application and they will be in existence throughout the application. So next, data types. So what are data types? Why we need data types? A variable can be given a data type that determines the type of data it can store. This can have an effect on the efficiency of your code. If you don't specify a data type, then the default data type is variant. So whenever we are declaring a variable, it's important that we define the data type, what kind of data the variable is going to store. Like in the previous examples, when we defined the variable as string, so their string is a data type. So the data type is saying that the variable defined as string means it will store the string values only. For example, if you want to store a integer value, then you need to define it as an integer. So the data type defines what kind of data that the variable is going to store. And if you don't define a data type, then the default data type is variant. Let's see what is a variant. A variant can store all kinds of data, whether it's a text, number, date. A variant variable can freely change its type at the runtime, which is not possible for other data types. So a variant it has data type, it can take any kind of data. Like when you define as a variant, when you define a variable as a variant, it can take text, it can take number, it can take date, any data type it can take. So then in that case we can use variant only in all the cases. Why we need other data types? So let's see what are the drawbacks of variant. Using variant data type reduces the speed of the program. Also variant data type occupies more memory compared to the other data types. So variant, when we use a variant data type, it reduces the speed of the macro, and also the variant data type consumes more memory space in the system. This is why we need to define the exact data type. This is the table which explains you with the type of data types we have and what is the values that the data type take and what is the memory that it consumes in the system. So we have, these are the few data types and the major ones. We have few other data types, I'll explain you later, but for now we can just go through this one. So we have Boolean. So Boolean data type usually takes only two values, either true or false. The memory it takes is 2 bytes. And then we have byte. Byte takes integers from 0 to 255 and it occupies 1 byte of memory. Currency. Currency is the data type that is used for currency values and it consumes 8 bytes. Date. So in VBA, for date and time also we have only one data type called date. So if you want to give any time or if you want to give any date, we need to use the date data type and it consumes 8 bytes. Single. Single is used for floating point numbers. So for decimals like 3.2, 4.6, if you want to use decimal point values, we use single and it consumes 4 bytes. And then double. Double is again for floating values, but it's of higher capacity. It can store higher values. So when it consumes 8 bytes. And then integer. Integer is the most commonly used data type because in our day-to-day macros we mostly need the numbers. So we mostly use integer. And integer range is from minus 32,768 to 32,767. So these are the numbers which integer data type can take. And the memory it takes is 2 bytes. Long, again long is also for integer numbers, but if you see the range it can take is more. So for example, if you have numbers in thousands and lakhs, so then you cannot use an integer because the highest value integer can store is 32,767. That's the number that it can store. So if you have a value higher than that one, you need to go for long, and long takes 4 bytes in the memory. And then string. String is again one more most commonly used one. String is used to contain the string values. So it can take up to 2 billion characters. And again the byte size would be 10 bytes plus storage for string. And here we have variant. So if we don't define any data type, it automatically takes it as a variant. And data type for all variables that are not explicitly declared as some other type which can be contain any kind of data except fixed length string data. So variant can take any kind of data and it takes around 16 bytes and 22 bytes plus storage for characters. So if you see the drawbacks of a variant, it reduces the speed of the program, and also if you see the memory size, the memory it's taking is very large compared to the other data types. Constants. So what are the constants? Now we have learned about variables. So what is a constant? A variable's value may often change during the execution of the macro. However, a constant is a value in the macro that does not change during the execution of the macro. Essentially, constants are variables that do not change. So variables in the execution of a macro, when you're doing the calculations, the values of the variables keep on changing. However, a constant is a variable that doesn't change. The value is constant. So a constant is declared by using keyword const, C-O-N-S-T. For example, you can see down const pi as double is equal to 3.14. So in programs, you might need to use a fixed value. So instead of hard coding it directly, we assign it to a constant and we use the constant in the program. A constant is used to store a fixed value and refer to that value multiple times in the macro without hard coding the actual value every time. So let me show you some of the programs using the variables and constants and data types, so it will be very clear for you. Okay, let's say I have name and then marks, and then here I want the output. Let's say here I give the name as Ram, marks as 80. Let's say this is the output. So what I want here is when I run the macro, I want the output like Ram scored 80. Okay, so let's see how we do that. So I go to the Visual Basic Editor. Okay, just delete this. So I'm writing it in module 2. I'm writing it in module 2. So every macro should start with sub, and I say this macro is output. Okay, so now here I have name and then marks. So I need to take variables to store this data. So name is a string, so I'll take a string variable name as. If you note, when you're typing the keywords, you will get the drop down to select from the list, so you can just select it. Okay, now I have marks, dim marks as. So marks, which one we will consider? Integer, because max we will get marks would be like 90, 80, so integer would be enough. We don't need long for this, so I say integer. So now I want to assign the name, whatever is there here, to the variable here. So name is equal to, so I want the value in A2. If you see Ram, it's under A2, so I want to assign the value in cell A2 to the variable. How I do that? I say range of E2. This is how always we refer to the cells. If I want to refer to A2, I'll write it as range, open bracket, in double quotes I give A2 and close bracket, dot value. So what this statement does is it picks the value in cell A2. So here it's getting assigned to variable name. In the similar way, marks is equal to range of, so this is in B2, so range of B2 dot value. So now we have assigned the name and marks to the variables here, name and marks. Now we want the output in C2. So what I do is range C2 dot value is equal to, so what you want here is Ram scored 80. So Ram, the name is stored in name variable, name, and then you want scored, so ampersand is used to join the sentences, same like how you do in Excel concatenate feature. It's the same, name, and then you want scored, the fixed string, and then what are the marks? Marks are stored in variable So let's run this macro. See, Tom scored 80. So if you just want the spaces, just use the spaces here. Ram scored 80. If I just send this to Sam, 90, run the macro, Sam scored 90. So this is how we define the variables, assign the values to the variables, and get the output. So let's see one more example using constants as well. So this is the macro which we have done, and then let's in the sheet 2 let me do another macro. Let's say we want to calculate the area and circumference of a circle. So let's say we have radius, and then we want to calculate area of circle, and then we want to calculate circumference of circle. Okay, so whenever we have the radius, we can calculate area and circumference. So for area of circle, formula is pi r square, and for circumference it's 2 pi r, where pi is a constant value. The value of pi is 3.141. So let's see how we can write a program for this. Let's say the radius is given as 10, and we need to calculate area of the circle and circumference of the circle. Let's write a program for this. I'll write one more macro. So I'll say calculation macro. Okay, so here we have radius, and then the area of the circle and circumference of circle. Let me take 3 variables: dim radius as double. Here I have taken double because we can have decimal values as well. We can have 10.2, 10.3 also, and then you can say dim circumference as a circum. Take it as double. Okay, so we can do one more thing. Instead of defining in different lines, I can just define it this way. Just give a comma, area is double, circumference as double. Let me maximize this. So instead of defining the statement in different lines, I have just given in one statement. So radius as double, area as double, circumference as double. Then I want the value of pi, and here pi, it's a constant value. We know it doesn't change, so I will define as a constant. Const pi as double is equal to 3.141. Okay, now I have taken the variables for radius, area, and circumference, and then I have taken a constant pi. Now I need to calculate area. Area is equal to pi r square. So instead of keying in the value return, I can use pi into r square. So radius into radius. So radius I have in A2. However, I have a variable here for radius. Okay, before that, let me just assign the value of A2 to radius. Okay, so pi we have the value assigned, radius I have assigned the value, and then now I'm calculating area. Area is equal to pi r square, pi into radius into radius. For example, if radius is too long, if you want to use r as a variable for radius, I'll just take r. Okay, and then circumference, circum is a variable, is equal to 2 pi r, 2 into pi constant we have into r. So I want to display the area in B2. Range of B2 dot value is equal to area range of B3 is equal to circumference. Okay, let's run this. I guess I just need to change this to r because everything we changed to r here. And then range of B2 you want area, and here you want, so this would be C2. Okay, not B3, this is C2. Okay, so you're good to go. So let me add a command button to run the macro. It will be easy every time to run it. So let's just insert command button. So let me just rename as just run, should be fine. Okay, and then I need to assign the macro. So CALC calc is the macro. Okay, so run the macro. So as soon as I run the macro, I got area and circumference. So let's see whether it's correct or not. So area would be pi r square, so 3.141 into r square would be 10 into 10 100, correct, and then 2 pi r, 2 into pi 3.141 into r is 10. So this is also correct. So we are getting the correct values. Let's say if the radius is 20, run the macro, it's calculating correctly. We just take it, let's take a small value 3, then just run the macro. So it's working. So this is how we use a constant, variables and data types in the program.
Firstly, what is decision making? So you all know that a macro is a set of steps, and you have the code starting with sub and ending with end sub. So you will have n number of lines in between sub and end sub. But sometimes you don't want your macro to execute all the lines. Based on the choice, you want your macro to execute a set of lines and ignore the rest. So this is called as decision making. Decision making controls the flow of the program. We have various control structures to control the flow of the program. So what decision making is, based on a choice, we would want our macro to execute few set of steps.
we don't want to run the entire lines. So in that case, we use decision making so that only a certain part of our code is run. We have various control structures which are used in decision making. Let's see one by one. So first one is if then. So let's see the syntax. If condition, then code if the condition is met, and if. So this is a very simple control structure. If condition, then set of statements, and then and if. So how it works is, if the condition is true, then the code between if and if is executed. If the condition is false, then the code between if and if is not executed. So here we need to remember one thing. Every if condition ends with and if. Like how we have sub ending with end sub, we have if ending with and if. So in this if then, we will have one condition, and if the condition is true, then the set of statements or the code which is there between if and if is executed. If the condition is false, then the macro doesn't execute the code which is there between if and if. Let's see an example for this. Let me take the macro template which we are using for our examples. Just enable the macro. We have seen this output macro just to print Sam's code 90. So let's just make few changes to it to see how we can use the if then control structure here. Let me open the Visual Basic Editor, Alt F11. So this is the program we have written for the output. Let's say here we have another requirement, like we have remark here. So we want a remark here. So however, we want a remark only when the score is greater than 90. And if the score is less than or equal to 90, we don't want any remark. Let's say this is our requirement. So how we are going to do the condition for this? Let's go to VB. Till here the program is the same. And then here, if. So if marks greater than 90, marks is the variable, greater than 90, this is the condition, marks greater than 90 is the condition. Then keyword, if marks greater than 90, then I want to give the remark. So remark, you want it under cell D2. So how we write it? Range of D2 dot value is equal to, I want to put a remark. Very good. And then and if. So what happens? We get the remark as very good only when the marks are greater than 90. And if the marks are not greater than 90, then this set of code will not be executed. So the remark column would be blank. Let's try this out. Let's say Sam got 92. Let's run the macro. It's the output macro. Run. So Sam got 92, which is greater than 90. So we got the remark as very good. So let's say Sam got 85. So this is less than 90. So greater than 90 condition will become false. So let's run the macro and see what happens. So Sam scored 85, output we got, but remark is blank. Why remark is blank? Because the if condition here is false and the statement under the if block is not executed. That's why we have remark as blank. Let me show this to you in step into mode. Step into mode is nothing but it shows how the macro is executing line by line. Okay, so let's see the first case here. Let's say 92, which is greater than 90. Let's see how the macro runs. So you need to place your cursor anywhere in the code of the macro and then press F8. F8. So once you press F8, the macro gets highlighted in yellow. So it started, and then keep pressing F8. Then again press F8. So you go to the first line of the code, skipping the declaration. So now we are at the first line of the code. If you press F8 again, this specific line which is there highlighted in yellow gets executed and it goes to the next line. Just press F8. See, now this line is executed and it came to the next line. Now if you place your cursor on name, you can see name is equal to Sam. So this specific line got executed and Sam got assigned to the variable name. Now the macro, the control is in this line which is highlighted in yellow. Now again press F8, came to the next line. Now press F8 and then range c2.value, this specific line got executed and we got the output displayed in our range cell C2. Now here is we have the if condition. So if marks greater than 90, so in this case it's true. So when we press F8, since the condition is true, it is going to execute the statement in the if block. So the control has gone to range d2.value is equal to very good. And when we press F8, that statement is executed and we got very good in D2. Then press F8 and if and sub. So this is how is step into mode line by line execution we have seen. So let's see in the second case. Again I'll do the F8 mode. F8, F8, F8. So name is equal to Sam, marks is equal to 85, range C2, the statement got executed. Now if marks greater than 90, here the condition is false. So let's see what happens if I press F8. See, once the condition is false, the control directly went to and if. The statements in the if block are not executed, and that is why we didn't get the remark field. The remark field is empty. So this is how the simple if then control structure works. Okay, let's see the next control structure, if then else. So here we have else one extra block. So the syntax is if condition, then set of statements, else we have set of statements, and if. So we have if block and else block. So how this works? If the condition is true, then the code under the if block is executed and the control transfers to and if, ignoring the else block. If the condition is false, then the code under else block is executed, ignoring the if block. So in this if then else, either one of the blocks will be executed based on the result of the condition. If the condition is true, then if block is executed and control transfers to and if. If the condition is false, then else block is executed and the control transfers to and if. So either if block or else block gets executed based on the result of the condition and the control transfers to and if. Let's see the same example with few modifications. So let's say if marks greater than 90, we are giving very good, but when this condition is not true, we are not getting any remark. So let's say I'll add here else range d2 dot value is equal to need to improve and if. So let's see what happens in this case. Let's say I gave the marks 92. Okay, macros, output, run. Okay, here marks greater than 90, so the condition is true. So it went into the if block and it gave the remark as very good, and then after that the control directly shifted to and if. So the else block is ignored. Why? Because the if condition is true, it executed only the statement under the if block and the control transferred to and if. Let's see the other case. Let's say 75. Now let's run this. Till here it's fine, it gave the output if marks greater than 90. So 75 greater than 90, no, false. So the condition is false. If you press F8, see, it skipped the if block, the statement under if block, and directly it went to else block, and it is executing the statement under else block and if answer. So we got the remark as need to improve. So this is how if then else works. Let's see the next control structure, if then else if. So if then else if we use when we have more than one or two conditions. So if you see if else block, we have a condition. If it's true, then the if block is executed, else the else block is executed. However, if we have more than one condition, then we need to use if then else if. So let's see the syntax of if then else if. If condition 1, then set of statements, else if condition 2, then set of statements, else if condition 3, then set of statements. Till then we have else if condition n, then condition if the else block is met, else code if none of the above conditions are true. So here if you see we have multiple conditions. So the code executes, the macro executes each condition, and whichever condition becomes true, the set of statements or the code under that block gets executed and the control transfers to and if. And if none of the conditions are true, then the set of statements under else block are executed and control transfers to and if. So if then else if we use when we have multiple conditions. So under whichever condition becomes true, then the set of statements or the code under that specific block gets executed and the control transfers to and if. If none of the conditions are true, then the code under the else block is executed and the control transfers to and if. Here we need to note that else block is an optional block. So let's see an example to see how if then else if works.
Let's have a quick quiz question, guys, and the question is, what is the shortcut key for AutoSum? And your options are add plus equals to, control plus shift, alt plus F1, or control plus equals to.
Just a quick info, guys. Intellipaat offers state-of-the-art data analytics course in association with IITM Pravartak. Through this course, you can learn all the important tools and concepts of data analysis such as Power BI, data wrangling, data mining, etc. from esteemed IIT Madras faculties and industry experts. With this course, we already have help thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take a first step towards career growth in the field of data analytics.
We want to give as need to improve. So let's say we have these many conditions. So here, let me just copy this so that I can just reuse it. If marks greater than 90, then very good. I'll say here else if marks greater than 75, then range d2 dot value is equal to good. Then again else if marks greater than 60, then d2 dot value is equal to average. And if less than 60, so if it is not satisfying any of these three conditions, that means it's obviously less than 60. So I'll use else block, range d2 dot value is equal to need to improve, and if and sub. So what this macro is actually doing is, if it checks whether the marks are 90, if marks are 90, then it will just give very good and the control transfers to and if. If the marks are not greater than 90, then it will check for the next condition if marks are greater than 75. If this condition becomes true, then the output is good. If this condition is also false, then it checks whether the marks are greater than 60. If the marks are greater than 60, then range d2 dot value is average. If this condition is also not true, then it goes to the else block and range d2 dot value comes as need to improve. So let's run this program and see. Let me give the marks like 76. Now let's run in F8 mode. Okay, till here it's the same. If marks greater than 90, so 76 greater than 90, no, false. So when you press F8, just go to the next condition. Marks greater than 75, 76 greater than 75, true. So when we press F8, it goes inside this else if block because the condition here became true. So range d2 dot value is equal to good. So this statement will be executed and then the control transferred to and if ends up and the macro is done. So let's see one more case here. Let's say the marks code are 45. Now let's run the macro again. F8 till here it's fine. Marks greater than 90, this would be false, so it goes to the next statement. Marks greater than 75, this is also false, this goes to the next statement. And then marks greater than 60, even this condition is wrong, so then it goes to the else block and then the statement under else block is executed and if and sub. So this is how the if then else if control structure works. Let's see the next control structure. Next one is select case. So select case structure is used to test for the true evaluation of a particular condition or set of conditions. You have as many case statements as you want and only the code associated with the first case that's evaluated to true will be executed. This can be used to replace multiple if-else structure. So select case, let's see the syntax. Select case, expression, and then case value 1 code, case value 2 code, till case value n code, and then case else we have the code and then and select. So how this select case works is you will have an expression or a statement at the select case, and wherever the value case value becomes equal, then the code under that specific case is executed and the control transfers to end select. So first the expression is evaluated and under which case value the value of this expression is equal, then the code under that case value is executed and the control transfers to end select. Let me show this in example. So we have already done example with if then else if. The same example, let's do it with select case. So I want to use select case instead of this if then else if. So how we are going to do it? So let me remove this if then else if. So for the same scenario I want to use select case. So SELECT select case. So expression here I want the marks to be compared and then accordingly I want to give the remark. So if case I give here marks as the expression and then case. First case is greater than 90. If case greater than 90. So as soon as I press enter, it came like case is greater than 90. That's the default syntax. When we are comparing, it will come as case is greater than or less than, whatever we want to do. So if case is greater than 90, then you want to put range d2 dot value is equal to very good, and if case greater than 75, then you want good. Case greater than 60. Average. If none of the cases are matching, then case else. Need to improve, then and select, like how if ends with end if, select ends with end select. So here what we are doing, select case, here we want to compare the marks, select case marks, here I want to compare the marks. If case is greater than 90, then d2 dot value is equal to very good. Case greater than 75, then set of statement. Case greater than 60, then d2 dot value average. Case else, need to improve and select and end sub. So let's run this program now. Let me give the marks as 62. Let's see how this is working. F8. So till here is the same. Select case marks. Marks here are 62. So first case it will check greater than 90. 62 greater than 90, false. So it goes to the next case value. 62 greater than 75, false. It goes to the next case value. Case is greater than 60. 62 greater than 60. So this is true. So the statement under this specific case value gets executed. So when you press F8, range d2 dot value is equal to average. So this is the statement executed, and the control transfers to end select end sub. Let's check for another value. Let's check for 76. F8 greater than 90, this would be false. Greater than 75, so this is true. So range d2 dot value is equal to good. So this statement is executed and the control transfers to end select end sub. So this is how select case works. So select case basically it evaluates an expression and the value of that expression matching under whichever case value that specific the statements under that specific case will be executed and the control transfers to end select. So we can normally use select case as an alternative to if then else if. Next we have input boxes. So this is again an interesting topic. So till now we are already giving the values in the Excel sheet. However, if you want user to input their values, you want to flash a message to the user and you ask the user to enter values. So that is where we use the input boxes. We use an input box when we need the user to input a value. Input box looks similar to a message box with the prompted text that tells the user what to do. OK and cancel buttons which cannot be reconfigured as a message box button. I'll show this to you in a while. And an optional title argument. An input box requires a prompt argument and it provides a field wherein the user would enter the kind of information as needed for the macro to continue. Let's see how an input box works. So here we are giving the values in the Excel cells and then we are running the macro. However, let's say our requirement is the macro should ask us to enter the values of the username and marks and then it should give the output and remark. So let me remove everything. Let's see how we can do the changes. So here if you see the code here, name is equal to range A2 dot value. So it's directly reading from cell A2. Now our requirement here is instead of reading it from Excel cells, we want the macro to give a box to the user where the user can enter the name. So how to do that is name is equal to, so this is the string variable which we have defined, and for this I'll say application dot input box enter the name. Similar to a message box, I have just given the prompt. So here name is equal to application dot input box enter the name. So what this does is it will just prompt an input box to the user to enter the name and the value will be stored in the variable name. Similarly for marks, application dot input box enter marks, then rest everything what is as it is. Only instead of taking the values, key in the values in Excel and take it from Excel, what we are doing here is we are just asking the user to input the values. So in this case A and B I'll just hide it because we don't need it. So here marks and even B we don't need. So output and marks will be the marks and the name will be inputted by the user and then we get the output and remarks. Let's see how this macro works. Let's just add a comment button and assign the macro so that it will be easy for us to do to run the macro every time. Developer tab, insert, command button. I'll just draw it here. Cancel. Just rename it as just want to run the macro. And then I need to assign the macro output. Okay. So let's just run the macro. As soon as I run the macro, so now I'm getting the input box saying the prompt enter the name. So enter the name Ram, and then I'm getting one more input box saying enter marks. I'll say 95. Okay, so I got Ram scored 95 and remark is very good. So this is working fine. So what we have done here, instead of taking the values from Excel, we are asking the user to enter the values. How we did it? By using the input box. So for the variable is equal to application dot input box, and then we are giving the prompt which should be seen by the user. So application dot input box, enter my name. So this statement is displaying a input box to the user and asking the user to enter the name. The name is entered. There is one more input box prompting the user to enter the marks. And once the name is entered in the input box, it is stored in variable name, and once the marks are entered in the input box, it's stored in variable marks, and then rest of the code remains the same. So this is how the input boxes are used, and this is the use of the input boxes. Next we have message boxes. So we have already seen message boxes. We use message boxes to display a pop-up message to the user. So previously when we are using the message boxes, we are just using the message boxes to display only the message. However, from the message box we cannot take any action. However, message box are flexible tools that allows you to customize the buttons while asking questions directly to the users that will force them to select one option or the other. Instead of OK, you can have a yes button and a no button on your message box and write the code that will be followed if the user clicks yes or the user clicks no. So message boxes are customizable. So you can customize a message box. Normally in the previous cases, whenever we are giving message box, we are just displaying the message and we have only OK button. However, we can customize the message boxes with buttons, different buttons like yes, no, and again, if the user clicks on yes, it should do specific action. If the user clicks on no, it should do some other action. So here, message boxes, we are not only displaying message, we are also giving the options to the user, and based on which option the user clicks or selects, the code runs accordingly. Since we have the message box here with options like yes, no, and different kind of buttons we can give. So here we need to know which option the user selected. For example, if the message box popped up with yes, no options and the user clicked any button, so the VBA should know whether the user clicked yes or no, so that it can take the action accordingly. So how VBA know whether the user clicked yes or no? So we have a table for that. So depending upon the option the user clicked, it returns a specific value, and we store that value in a integer variable. So here, if these are the buttons and these are the return values, if the user clicked OK, then it returns the value 1, cancel, it returns value 2, abort, it returns value 3, retry 4, ignore 5, yes 6. So this is the yes and no are the most used options. So if the user clicks on yes, then the message box returns a value 6. If the user clicks no, then the message box returns value 7. So this value we store in a variable, and then we can use a if condition to specify the action and to specify the flow of the control. So I'll show you now how we can use the message box. So in the same program, so I want the output every time, but remarks, I want to pop up a message box saying you want a remark or not. If the user clicks yes, then only the remark should come, or else the remark shouldn't come. So let's see how we can do this. Okay, so input box, we gave the name and then we give the marks, and then range c2.value. So this output I want every time. However, this remarks, before this remarks, I want to pop up a message box saying that you want to display the remark. If I click yes, then this code should execute and I want the remark. If the user clicks no, then the remark should be blank. So here what I will do, I need to add a message box. Since I need to capture the value yes or no, I need to have a integer variable for that. For that I'll take one more integer variable dim. I'll take variable response as integer, and I say response is equal to msg box for the message box, open the bracket, prompt, do you want to display remark? To maximize this, do you want to display remark? And then as soon as you press comma, you're getting so many options: VB abort, VB critical, default button. So we will have VB yes no, VB yes no. So what this will do, here it will pop up a message box asking, do you want to display remark mark? Do you want to display remark? And then you will have VB yes okay. So the message box contains, sorry, VB yes no. So the message box contains yes and no. So whether you click yes or no, the corresponding response will be stored in the integer variable response. And if the user click yes, then we want the select case statements to be executed, and you want the remark. So if response is equal to, so if the user clicked yes, so for yes, what is the response we get? For yes, it's 6. So if the user clicks yes, then the response would be 6. So if response is equal to 6, then we want the remark. So all these statements should be executed. And if the response is 7, that means no, then this condition will becomes false and the select statement is not executed and the remark will not be populated. So this is the logic. Let's go to the macro, enter the name RAM, okay, let's say marks 64, okay. So as soon as you clicked okay there, here we got the output, that's fine, and then we didn't get the remark here. So instead of that, we are getting a message box saying, do you want to display remark? So if you click on yes, the remark will come. If you click on no, the remark will not come. Let's see. If I click on yes, see, I got the remark. Let's run it again. Let's say Sam marks 54, okay. We want to display the remark. If I click on no, the remark should not come. The remark didn't come. So how it is working? Let me minimize this. Let me do it in F8 mode. F8 name, I'm getting the input box, RAM, okay, and then F8 marks 89, okay, and then the control comes to message box statement. So do you want to display the message, yes or no? F8, see what happens if I click yes. So when I clicked yes, response is equal to 6. So it took the value of response as 6. And then if response is equal to 6, here it becomes true. Then it will execute the select statement. So it goes into the select statement, and in this case it's true. So it displays good, and if, ends up, and that's the program. So for the other case, let's see. Name, okay, marks 56, okay, just output the value. Then, so do you want to display the remark? I'll click on no. So once I click on no, see what the response is. So response is equal to 7. So now if response is equal to 6, so 7 is not equal to 6. So here the condition becomes false. So the control transfers to and if, skipping the select statement. So the remark, we will never get the remark, and if answer. So this is how the message box works, and we have the written values here. So in the message box we have several other options. Currently I showed you only yes no option, but if you want to see, let me just show you. In this case, if you want, let me maximize this. VB yes no. If you see here, we have VB yes, we have yes no, cancel. If I select this, okay, so let's see the difference here. It would be the same if I just run the macro. Previously we were having only yes and no. If we click on cancel, the action gets cancelled. So similarly we have many other kind of buttons, not only yes no cancel. We have different kinds of buttons which we can use depending upon the situation. Okay, so if I say yes, just I get the remark. So this is about the message boxes.
Alright, so these are all the shortcuts that we are going to discuss today, guys. And let's start with the first one. So let's say you want to know how many rows you have in your Excel. Have you ever wondered what is the maximum amount of rows that you have in your Excel sheet? So if you want to know that, the simple trick to do that is by pressing Control and down button. So if you press Control and down, you will reach the last row of an Excel sheet, which is 10,48,576. Similarly, if you want to know how many number of columns do you have, then you have to simply press Control right, and then you will reach the last column, which in our case is XFD. Right. So again, if you want to come back to the first column, you will press Control left. You will reach the first column, which is the A column. And if you want to reach the first row, just press Control up and you will reach the first row. So this is how you can navigate to the four corners of an Excel sheet. All right. Moving forward, if you want to know how you can move to the next sheet, then the shortcut is Control plus page up or page down to basically navigate between sheets. If you are on a Linux machine or if you are on a Mac, in that case, the shortcut is going to be the Alt key and then the arrow keys. Right. So if you are on Windows, it will be Control page up, page down. If you are on Mac, it will be Alt plus the arrow keys. So let's say if I want to toggle between the two sheets that I have in this Excel workbook, I will go Control page up, and this way I can go to the next sheet, Control page down, and then I can go to the previous sheet. So this is how you can navigate between the sheets. Next thing, if you, let's say, want to hide certain columns, so how can you do that? All right. So if you want to hide certain columns, let's say I want to hide, let me make it a little zoomed out. Okay. So let's say I want to hide the C column. So the command for that is Control 0 in case I want to hide columns. If I want to hide rows, it is Control 9. So let's hide the C column. So Control 0, and you can see the C column has now been hidden. Similarly, let's say if I want to hide rows, so let's say I want to hide these 3 rows, so Control 9, and these 3 rows will be hidden. If you want the rows or the columns back, just select where the hidden rows or columns were. In case of rows, the command is going to be Control Shift and then 9. You will get the rows back. And if you want the columns, just select that range and it is Control Shift and then 0. So this is how you can get your hidden columns or rows using the keyboard. Now next thing is a pretty neat trick. How can you have borders to your data, right? So if you're on a Windows machine, the command is going to be Control Shift and the End key. However, if you're on Mac, the command is going to be Option Command and Arrow, right? So let's say I want to add arrows over here. So now what I can do is I can add the borders. Now the thing is that when you're adding borders, it will add borders to one side of the data, right? For example, if you press Control Shift and End, it will add columns to the below part of the data like this, right? Now let's say you want to add columns to the right hand side. So then in that case, you will have to press the right arrow, and in that case you will get the borders on the right hand side, right? If you want to get borders to the left hand side, again select it and then the left arrow along with Control and Shift, and that's how you can get borders to the left hand side. Let's say you want to remove the borders, then again just select it and then press Control Shift and underscore, and with this the borders will be removed. So guys, this is how you can play around with the borders in Excel. The next trick is pretty neat. So let's say you have a row of data, right? So let's say I have 12, 123, then I have 567, then I have some other data. Let's say these are some random values that I've put. Now I want to convert these values into currencies, let's assume. So how can I do that? Now the shortcut for converting a row or a column of data into currency is Control Shift and then dollar, right? So just select this, press Control Shift dollar, and in this case, whatever your native currency is, that the data will be converted in, and along with that .00 will also be added. Okay, so this is how you can convert a column or a row of data into currency. Okay, now next thing is if you want to make a percentage column, let's assume, right? So let's assume whatever data I should be entering in this C column, it should be percentage. So in that case, what I'll have to do is I'll have to type in Control Shift and then 5 or percentage. And now what will happen is whatever data I enter over here will automatically be in percentage. Neat, right? So this is how you can basically convert a column into percentage. Okay guys, next thing is if let's say I want to go ahead and convert a certain column or a row or a cell into date. How does that basically work? So if I have to do that, so first you will have to understand a very important concept. So in Excel, the dates basically they start from the 1900 year, right? So let's say if I enter 1 over here, and if I do a Control Shift and then hash, you will see the date that I see is 1st January 1900, right? Now let me tell you one more thing, and with that it will become more clear to you. So if I enter 123, let's say, right? So now if I do Control Shift hash, you will see it's now 2nd of May 1900. So what does this mean? It means that whatever data that you're entering over here, right, whatever number that you're entering over here, once you convert it into date, it adds that number to the 1st January 1900, and whatever corresponding date you get, it basically displays that. So let's say I enter 50,000 over here, and then I do a Control Shift hash over here, then you will see I have reached 21st November 2036. Okay. Similarly, let's say if you want to come to the current century, just enter 41,000 some number, 41,396, let's say. And now if you convert, you will see it's 2nd May 2013. Right? If I enter 43,000 number, you will see that control shift hash will basically give you 22nd September 2017. So this is how the date basically work, right? So it basically works with numbers, and the numbers, if you will have to enter, and once you do a control shift hash, it will basically convert those numbers into date. So that's how you can play around with the date data type in Excel. If you want to get the current date or current time, if you are on Windows, if you do a control shift and then colon, you will get the current time. If you are on Mac, if you do control shift and colon, you will get the current date, right? And with this current date, if you basically convert it into, let's say, number, you will get the number 44209. So if you enter 44209 over here, right, and if you do a control shift hash, you will get the current date, right? So if you convert this date into the number column, then it will give you the number which is corresponding to days after 1st January 1900. Okay, so remember that. Okay, after that, the next thing that you want to look at is how you can copy from above. Okay, so let's say I am on this row, this particular cell, and I want to copy this number, right? So what I can do is Control Shift and double quotes. So when I do this, whatever number is above that cell is basically copied, right? This works for percentage as well, and this works for dates as well, right? So whatever is the number above, it basically copies that. Great. Next thing is how you can display all the formulas on a current sheet. Now this is very important, right? So let's say I have these currencies, right? So what I'll do is I'll enter a formula over here. So sum, and then I want to enter, let's say, A1, and then I want to enter A13, and then I'll close this. Okay, so this is the sum that you got, right? And let's say I just make it a little bold so that we know that this is the sum. Now let's say you are on the sheet, and now you want to understand all the formulas which are there on the sheet. So in order to do that, you will have to enter control plus the tilt button, which is just below escape. So when you do that, the sheet will convert into this kind of a format, and here you can see the formulas which are mentioned on the sheet, right? So for example, you had percentage, so you can see it's 0.23, 0.24. Then this was the row, this was the cell wherein the sum was basically shown. So this is being shown. If you want to come back to the normal view, again press Control plus tilt button, and you will get back the normal view. So this is how you can display all the formulas. And again, another neat trick to basically do an auto sum of all the numbers is by basically going to sheet 2. Come to the sheet where you want to do the auto sum. Let's say I delete this cell and I want to do an auto sum of this number, right? So if you are on Windows, the formula is going to be Control and then plus. If you are on Mac, the command is going to be Command Shift and T. So just select all of them, or don't select them, and then just do Command Shift T, and that will give you the sum of everything which is there in that particular column. Okay, if you are on Mac or if you are on Windows, you just have to do Control and then plus, and then you will get an auto sum of all the values which are there in the Excel sheet.
So let us discuss the trends for data analytics. So if we look at the Google trends for the term data analytics in specific from the year 2004, we will realize that the term data analytics was not at all searched for or looked at during those times. But eventually, over the last 16 years, we can see that the trend for data analytics has gradually risen from 0 to about like 100 with a peak at 2019-2020 beginning. So we can derive from this insight that data analytics is an ever-evolving term, and it is also one of the most popular job profiles of the decade. And the demand for a data analyst is not dwindling anytime soon. So it's one of the hot topics for this decade and probably 21st century in general, with data science and data analytics being the most popular job. So if we move on, and we can see a survey by Gartner to understand the top 10 technology trends in data analytics. So we can see certain terms like augmented analytics, continuous intelligence, explainable AI, augmented data management, natural language processing, blockchain, graph analytics, data fabric, AI, ML, and persistent memory servers. So we can look at all of these topics that are emerging, and basically the advantage of data analytics is it could be done on a small scale as well as a big scale, and there are endless ways in which we can enhance the way we perform data analytics to be more efficient and in general fast in nature because of the ever evolving demand for data analytics, the ever evolving trend, and how much businesses require data analytics to be efficient and fast in that regard. So as we can see, there is a quote by Gartner: by 2020, augmented analytics will be a dominant driver of new purchases of analytics and business intelligence. So in the field of business intelligence, which is essentially a subroute of data analytics, augmented analytics, a new emerging topic, a new emerging technology, which is being implemented as we speak by the year 2020, which is the current year, it would be the most dominant driver of new purchases in the field of commerce. So businesses which require big data analytics or data analytics in general would be using this particular type of analytics, which is augmented analytics, and a lot more quantity than before. So if we just look at some of the insights that we have gained from data analytics as a current job profile, as a current job term, business intelligence for commercial organizations like e-commerce organizations or product-based organizations, data analytics is important. It's mandatory for commercial success in this competitive environment. So it is a given that every big business organization which sells a product or a service, even in that regard, they use data analytics or big data analytics in some way or the other, because in order to compete with other organizations, in order to compete with competitor organizations which are using data analytics, by the way, it is very important that every organization finds a fast and efficient way to implement data analytics in their day-to-day business cycles. So then we move on to competitive customer satisfaction as well. So the only way a customer or a client is going to take your service or buy your product is if they are being provided with customer satisfaction. So competitive customer satisfaction in the 21st century is another point. There aren't monopolies anymore in most businesses. So even if there are organizations that sell an exclusive product, almost 99% of the time those organizations will have a competitor. And the way customers decide which organization to choose from where to buy their product or service is dependent on customer satisfaction. So how does an organization drive customer satisfaction? How does an organization determine and basically move towards customer satisfaction in their business practices? So that is also determined by data analytics. So basically, if you're using Amazon, if you're using YouTube, if you're using even Google search engines, so the reason Google is the most popular search engine in the world, more popular than Yahoo or Bing, is because it has the most customer satisfying experience among all. So you might have noticed that if you've used Bing or Yahoo searches, that if you search for a particular term, you might not get the most appropriate results for that term. That is because Yahoo or Bing don't use as good as robust data analytics algorithm or a data analytics system or a regime which surpasses Google. So naturally, when we are using Google, we get a better customer experience from it because it gives us the most apt and relevant search results that we would be needing at the moment. Google does so by using a good UI, first of all, and the second thing, the most important thing, the core of it all, good data analytics and good data science in order to determine what you're actually looking for and which search results might be relevant to you, which ads might be relevant to you. So all of those things. So competitive customer satisfaction. If you are being competitive in your customer satisfaction approach, you will get the most business out of your customer. So next we have big data. So obviously data analytics is a term that is a broad term, which is basically for small data sets and big data sets. It basically depends on a lot of things. Data could be static in nature, data could be small in nature. We could be just analyzing some data that is available to us in a static format, and we're just running some processes on it, some analytics on it to determine certain insights. But in today's world, data analytics, the most used form of data analytics, so to speak, is big data analytics from a commercial standpoint, because websites like Amazon, YouTube, Google, Facebook, all of these have large user bases, customer bases, and these customers and users have accounts on these particular websites, and they keep generating user data in exabytes and exabytes of size and continuous in nature, and that way also. So in order to process this data, it cannot be done in a traditional data analytics way, where we are processing static data, which is of much smaller size. We need technologies that help us implement big data analytics as well. So this is a subcategory of data analytics, but the most relevant subcategory of data analytics today. So if you're wanting to get involved in data analytics, it is recommended. It is highly recommended that you get into big data as well, because in order to get into the companies that are having large customer bases today, you need to be very well acquainted with big data analytics as well, because of the large data size and the continuous data input, the continuous data flow that these organizations have. And then obviously the hot topic for today, the hot topic of today's age is artificial intelligence and machine learning. So naturally, wherever you have manual ways to perform data analytics, there's always a way to do it in a much more efficient format, which is with the use of artificial intelligence and machine learning. So artificial intelligence and machine learning are some technologies that are related to each other, which are basically replacing all sorts of manual work. So say data analytics is done manually up to a certain standpoint, up to a certain point, and then these technologies come in. You implement certain algorithms using artificial intelligence and machine learning to implement data analytics, and you basically remove the middleman from the equation. So you basically could gain your insight, gain your skills in machine learning and artificial intelligence, understand the traditions of the trade in data analytics, and implement those traditions in your algorithms for AI or ML. So in that way, you're basically being relevant in today's world by using technologies such as AI and machine learning, and still having the insight for data analytics and implementing data analytics in the most efficient way using these technologies. So you'll get the highest package if you are able to implement these data analytics using these particular technologies, because you're essentially saving your organization a lot of manual cost. Then we move on to the industry look for data analytics. Look at some industries, look at some companies which use data analytics. So Google, Bank of America, Tesla, Apple, Amazon, Netflix, Facebook, and IBM. These are only some of the organizations which use data analytics in today's world. There are obviously countless organizations and companies that are product-based or service-based which use these technologies. So if basically every big organization that you see today, almost 99% of every organization that you see today that you know of that are popular use data analytics in order to analyze their customer bases and cater to the customers and drive profits, drive advertisements towards them. So this is very important. Then we basically move on to the importance of a certification in today's industry. So a certification is basically a stamp of excellence. So basically whenever you get a certification in a particular technology, when it's a relevant certification, when it's a good and credible certification, what happens is organizations are always hesitant in hiring people, regardless of the resume that you may have and regardless of the skill sets that you may have acquired. Unless you have hands-on experience in the technology that you have certification for, 99% of the time, the company would want to put you in a probation period or would want to test you before they actually give you a high package or basically hire you for a certain job role, because they're not confident if you are capable of that particular job role. In this case, a data analytics job role. So when you get certification in a particular technology which has hands-on and project work, a company can be sure that you worked on projects and hands-on. So you're basically familiar, even though you're not an expert at it. You might be familiar with the technology. You might know how to implement it with hands-on, and that is the most important factor that comes to hiring. So it's a stamp of excellence. Essentially, it's a certification. You are certified to be well acquainted with the technology. It helps you get hired, obviously. Those two are correlated points. A substantial increase in pay. So if you are currently working in a different job profile, if you want to increase if you want to upscale your job profile, if you want to go to a higher job profile which pays more, you can obviously get a certification, and you can basically apply for that high job profile in the same company that you may be working for right now, or a different company that you wish to work for in the later future, which requires you to have that particular skill. And in your own company, it could help you clear some corporate requirements that are needed of you in order to advance in your job profile or your job rank. And most of all, knowledge plus projects. So all of the four that we discussed before this were corporate benefits, but knowledge plus projects is something that you gain permanently. It is not something that you would ever lose, even if you don't get that particular dream job that you're looking for. The knowledge plus projects is something that you gain for a lifetime, and even if you don't get that particular job that you're looking for, you can still keep on working on yourself, keep on working on hands-on and projects, and eventually land another job that you might prefer more than the previous job that you were looking for.
Just a quick info, guys. Intellipaat offers state of the art data analytics course in association with IITM Pravartak. Through this course, you can learn all the important tools and concepts of data analysis such as Power BI, data wrangling, data mining, etc. from esteemed IIT Madras faculties and industry experts. With this course, we already have helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take a first step towards career growth in the field of data analytics.
So, exploratory data analysis, or EDA for short, is the process of performing initial investigations on data so as to discover patterns, abnormalities, or anomalies and assumptions with the help of summary statistics and graphical representation. Basically, when we have some data on which we want to perform data science and statistical analysis and machine learning modeling, we first need to make sure that we understand what the data represents, shape of the data, what are the different kinds of things that are available in our data, different data types available in our data. If we could visualize our data and understand relationships between individual columns or individual features in our data, that's really good. And all of that and more, such as visualization and all, is done in a step called exploratory data analysis. So that's what EDA is all about. Now, EDA allows us to get a better understanding of our data and make important observations on it. In order to understand this, let's understand with an example. If you have a data set which you have no understanding of, you don't understand what the data it contains is, what do the columns represent, how do the columns relate to each other, and which columns are important for the particular task that you are trying to solve. In cases like this, it is very difficult to understand how you are going to solve the problem, how you're going to build the model, how you're going to perform statistical analysis, so on and so forth. So in this sections, what happens is we would like to perform exploratory data analysis in order to get a better understanding of our data. This also helps us understand whether or not the data that we have needs some sort of boost. So, for instance, if we have some data set that's highly biased on one result, for example, we are trying to predict whether or not a particular internship is going to convert into a job. Let's say we have a data set and we want to figure out whether or not we can create a predictive model in which we can feed in some data about an intern and figure out whether or not we should give them a job. Although it's a very specific use case, if all we have is data where people did not get converted into full-time employees, our data set is completely biased, and this is something that we could miss if we don't take time to analyze our data using exploratory data analysis. So if that is the problem, then we would have to get more data.
so that we can balance out both the probabilities and then teach our model about these things so it has better understanding of what features lead to what results. So now we come to why EDA. Why would you want to perform exploratory data analysis? We've understood what it is, but why exactly would you want to do it? Well, exploratory data analysis is one of the most crucial steps in data science. It allows us to achieve certain insights and statistical measures that is essential for the data scientist. A good understanding of exploratory data analysis process allows us to make some important observations and early decisions that could help us reduce or that could help us not take steps that are not needed. So as we discussed in the previous example, if our data set is biased, then performing modeling and using multiple algorithms and trying to figure out the accuracy of each model is not going to be a good idea, mainly because the data set we have is not good. If you don't have a good data set or don't have a data set that's representative of the reality in the current world, then your model is not going to be good. It's not going to perform really well. So exploratory data analysis helps us perform as fewer steps as possible in order to get the best result. This is why exploratory data analysis is so crucial a step in our data science process. So it performs certain steps to define and refine our important features and variable selection. So it could be that you have a data set that contains 25 different columns, but for what you are trying to predict, only 3 or 4 columns are going to be enough. They explain most of the things or most of the variation in the data or in the column that you're trying to predict. So you only need to use 4 variables. Now, which 4 of those should you use, and if indeed are there 4 variables or are there 5 variables that explain it better? For that, exploratory data analysis is important. It allows us to select features that are going to be useful for us. In case we don't use the correct features, we end up with a model that's highly bloated, contains data that's irrelevant, requires users to fill in data that's relevant, and could lead to incorrect or highly improbable results. So we need to be very careful when we're trying to take model columns or columns on which we are trying to model our data on to make the prediction. Now, why would you want to perform exploratory data analysis with Python? There are many other languages out there, including R. You can even perform exploratory data analysis in JavaScript and Java and C++. So why should you use Python? Well, exploratory data analysis using Python is very easy. First of all, Python is probably one of the easiest languages to get started with. This is why Python is so popular in data science community, because many people who perform data science operations or machine learning operations on a particular data set are people who come from the academic world. They don't have much understanding of what programs are, what variables are, what classes are. They only need to write code to get the things that they want to get done be done. This is where Python comes into play. It fills the gap. So since Python is so easier to use, and another advantage that Python provides is that it has a number of libraries that allows us to perform tasks related to exploratory data analysis. In case we are performing these tasks ourselves, it's very, very important for us to make sure that the libraries we are using are trusted and used by multiple people, because if it's a library that someone has created, our confidence in it is going to be really low. For example, if it's a library to perform data visualizations, but it's a library that not a lot of people have used, then you cannot be sure that the library is going to give you accurate visualizations, and it's always going to be a bit problematic. In Python, however, there are libraries that have been used by millions of developers and academic people. What they do is they just understand the basics and then they import the data and visualize it and perform the task that they need to perform right at the step. And that's really important for our data set. So this is why Python is such a good candidate for exploratory data analysis, mainly because it's easy to understand, easy to read, it's got a really clear syntax, as well as because it's got so much good tools and libraries around exploratory data analysis and data science in general. It's just a really good experience for developers or people who are getting started with exploratory data analysis or data science, or even professionals. Now, Python has libraries to perform all kinds of tasks relating to exploratory data analysis, such as visualizations analysis, etc. Visualize the data, there are libraries available, not just one library, but multiple.
Depending on the features that you're trying to use, you can import either one of the libraries that are available. There's libraries for data analysis, libraries for numerical manipulation. There are libraries for many other different kinds of tasks, such as creating neural networks, defining the structure of a neural network, visualizing neural networks, so on and so forth. So this is why Python is so popular. Now, some of the most popular libraries to perform EDA are NumPy, Pandas, and Matplotlib. Now, since I'm assuming that many of you are beginners and you have no understanding of what these libraries are, we will cover what these libraries do in a later point in the presentation. Also, again, if you wish to learn more about these libraries and more about data science and exploratory data analysis and Python in general, stick with us till the end of the presentation and will help you will help guide you through some of the resources that can help you out there. Now let's take a look at some of the advantages that exploratory data analysis provides us. So it provides us with several benefits. First advantage is that it allows us to spot missing data. Using exploratory data analysis, we can easily find null and missing values. So in case we have a data set in which certain columns have null values or certain columns have certain proportion of the data is missing, we can remove the data, we can fill the data. Although removing the data and filling the data is not part of exploratory data analysis, spotting the missing data is definitely a part of exploratory data analysis, and it allows us to do the same. It allows us to find the underlying structure of data. So on the surface, what we can see is the number of columns, the columns that we have, and the data that we have in them. Underneath the row and columns and the tabular structure of our data, if indeed it is tabular, what we can do is we can understand what the underlying structure is. Underlying structure means what are the different data types that a particular column holds. Are they in the correct format to be processed? What is the range of data that is contained in a particular column? Do columns relate or correlate with each other in the data set? And if so, is it helpful or harmful for the task that I'm trying to perform? So on and so forth. Then there's variable importance. Exploratory data analysis helps us to figure out which variables in our dataset are the most important ones. So in that case, it helps us understand which variables have the highest influence on the thing that we're trying to predict or on the column that we're trying to predict. That way, we can just drop the rest of the columns and only use the ones that have influence on our columns above a particular threshold. And finally, data visualization. Now, we can sit and talk about data a lot, but one of the issues that exploratory data analysis solves is that when we show these statistical measurements to people, first, especially people who are not statistically literate, it's going to be really difficult for them to understand, mainly because they have to firstly scan through the data, then understand which data has higher value, which data has lower value, and then understand the implication of each of them. It's much easier to visualize this data and understand the characteristic of the data that we possess. In this scenario, exploratory data analysis is really, really helpful. It allows us to perform visualizations and explain our data in a better capacity, even to people who may not be that familiar with the data that we have, as well as the statistical analysis that we are performing. Now let's take a look at the libraries that we had discussed earlier and what in exploratory data analysis. I would just like to mention that these are the three libraries that I have picked. These are the most one or at least some of the most common libraries that are being used. Not necessarily the case that these are the only libraries that will be used, or also not necessarily the case that these are the libraries that are going to help you in a particular problem. It could be that there are better alternatives available, and to understand about the alternatives, you need to firstly look at all the options that are available. So I recommend before starting any exploratory data analysis process, take a look at the tasks that you want to perform, take a look at the libraries that are available. These libraries are the most popular ones and for good reason. So these should help you out, especially if you're a beginner. But as you become more and more advanced and more into the exploratory data analysis and data science community, you understand that there are better tools available for the one particular task that you're trying to perform, and it's better to use those tools. All right. So the first one is NumPy. NumPy, or many people call it NumPy as well. It is a numerical manipulation library. In Python, we can perform numerical manipulation using raw Python itself, but it contains a lot of the information that are not relevant for our purposes. Since Python is an object-oriented programming language, which it's fine if you don't understand what that is. But in case you do understand, it stores a lot of information that's not relevant. So when we try to perform complex mathematical operations, those properties about the object orientedness of the particular variable come into play, and they negatively affect the or negatively impact what negatively impact the performance. So in situations like this, NumPy is quite useful. It firstly just keeps all the relevant data. Secondly, it has a lot of functions that allow us to perform these numerical manipulations. Inbuilt functions for calculating the sine waves, the cosine waves. For fast Fourier transform is also available, and many different kinds of numerical manipulations that are difficult to implement by hand are already implemented in NumPy. So you don't have to worry about implementing these things. You just have to worry about using them when the need be. Then there's pandas. If you have done data science with Python for any period of time, pandas is a library that you must have come across. Pandas is great for data analysis, data summarization, and many other tasks relating to data. It allows us to load data in our Python program using something called data frames. Data frames is a special object or a special way of representing data in pandas, and it affords us a lot of benefits. It allows us to perform a lot of complicated tasks on our data, such as joining two data frames, filtering our data frame, manipulating data, dropping data, and a lot of different kinds of tasks that by hand are going to be very difficult. So it's a layer of abstraction over these complicated tasks, so you can perform them yourself, and it's very efficient as well. Then we come to Matplotlib. It is a visualization tool, or is a visualization library, allows us to create charts and graphs, and allows us to perform a lot of visualization. Many different visualization libraries, such as Seaborn, use Matplotlib underneath the hood. So in case you wish to become a data scientist and want to perform exploratory data analysis by visualizing the data, Matplotlib is a library that you might need. You can also use other libraries, but Matplotlib is probably the best one to start with because it's very easy. It exposes you to some of the fundamental concepts that you need to understand when you are dealing with in IronPython visualization or graphs or charts. They can help you out with that. All right, so we have reached the demo section. Now for the demo, I have already written the code so that I don't write the code and you have to then follow along and look at the errors that I make. I'll explain the code to you now. I told you that you only need to import the libraries that you need. In the current scenario, I didn't need to use any numerical manipulations because the data is already manipulated for me. Then I can use this. I'm using Pandas, Seaborn for interactive visualizations, and also Matplotlib. These are two different visualization libraries. Seaborn is great for creating summarizations of our data sets, and Matplotlib is great for visualizing individual columns. This bit of code here is telling the Jupyter notebooks. Let me just zoom in on it because it may be possible that you guys aren't able to see this. Now, in Matplotlib, it's possible to use it with multiple backends. In this scenario, we're using it with Jupyter Notebook. We're just trying to tell Matplotlib that whatever visualizations that you produce, make sure that they are optimized to be rendered inside a Jupyter Notebook. Now, many people say it's not necessary to do this step. It was necessary previously, but now it's not. But I like to keep it in just in case. Then I am importing a data set. And to give you some context, this is a data set that I have downloaded from Kaggle. You can download it yourself. I would recommend it that you do it afterwards, and you can play with it as well. This dataset and many other datasets are available on Kaggle for you to perform exploratory data analysis with. You can do it on Kaggle as well. And when you're doing it, you can, using that exploratory data analysis notebook that you have created, you can share it with people. Kaggle is a great platform for that. So you can use it for that. And now we take a look at the first 5 columns, first 5 rows of the data. Now, as you can see, the shape of the data is 5 rows in 81 columns. Now, 81 columns is probably a lot. As you can see that even our pandas library is refusing to show all of this because it knows that it's not possible for us to show everything. So we have this. Now, we take a look at the information of the data. This tells us about the data set that we have and gives us information about each column, right? So we have 1460 non-null columns, non-null data points with of type int64 in the ID column. And you can take a look at everything. Here, as you can see, in the alley column, we only have 91 data sets. That means that majority of the data is null. We'll deal with that in a moment. As you can see, the data is quite disparate. Sometimes it's 1460, sometimes it has 1452 data points. So we are dealing with a data set in which we can have null values quite a lot. For instance, pool QC has only 7 values that are not null, others are all null. And as you can see, the data set is quite disparate as well. Some are objects, which are basically string or some other data set other than numerical data set. Some are integers and some are float. Float are basically real numbers. These are numbers with decimal points. So currency could be considered float, and real numbers are considered integers. So your mobile number could be considered an integer because it's not going to have a decimal point in that. Right. So I don't want you to get bogged down into the specifics of the code. What I'm trying to tell you is how we are going to do this. So here what we're doing is we are taking all the columns in which our data is greater than or equal to 30%. So any column that contains less than 30% data, which is it has 1460 columns, but only 30 or less percent of the values are present in that, and we are going to drop it. So any column that contains less than 30% of the data, we're not going to consider it at all because it could have negative implications. So we do that. Now what we do is we also delete the ID column from our data set, mainly because ID is just something that is generated by the database in which it was stored, or maybe not by the dataset, but by the people who.
Just a quick info, guys. Intellipaat provides online data analytics course in partnership with IBM and Microsoft. The course link is given in the description below. Now, let's continue with the session. Just a quick info, guys. Test your knowledge of data analytics by answering this question. Which of the following method creates a new array object that looks at the same data? A. View. B. Copy. C. Paste. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Collected this data. It's not really important for us. It's important for storing the data, but for analysis of the data, ID is just a number that was randomly assigned to a person. It has no significant value. Now we will print the list of columns that were dropped. As you can see, alley, pool QC, fence, and miscellaneous features are the columns that are dropped. ID is the one that we have dropped manually, even though it contained a lot of data. Now we try to do two things here. First thing, we take a look at the sale price, which is a column that we are very interested in because that's the column that we're trying to model our scientific process across. So we describe the data, which is we count the number of columns. As you can see, it contains every bit of data that is available. The mean is 1,80,921 point some value. Standard deviation, minimum value, 25th percentile, 50th percentile, which is here, then 75th percentile or the third quartile, and the maximum value in the column. This is, by the way, this is something that Pandas is doing for us. We didn't have to write functions to loop over the data and figure out the min, max, 25th percentile, and all of that. So it tells us the name of the column, sale price. Data type is float. And now what we do is we try to visualize it. So as you can see, the majority of our data lies in this region. Yeah. So here and here. This is what is known as a histogram or distribution plot. Since Seaborn allows us to do it pretty easily, we do it. Don't worry about the code. Stick with us till the end of the presentation and we'll show you how you can learn to write the code. Right now, we're trying to understand the process of exploratory data analysis. So as you can see, even though we have a maximum value of 77,55,000, majority of our values are lying between somewhere around these values. Right. Now we take a look at the different data types available in our data set. We have integer. We have O, which stands for object. Object basically means that this is something that's not a number. And we have float. This 64 is basically how many bits are used to represent the data. This means that the data could be of high size. You can, by the way, change this all yourself. So here what we do is we say, okay, give me all the numerical data that we have. This is done mainly because we want to be sure that we are only dealing with numerical data. Dealing with data that is not numeric, firstly we'll have to convert the data into numerical formats and so on and so forth. So we're trying to firstly estimate the task ahead of us. We take the numerical data that contains float 64 and int 64, basically not selecting the object data types. We take a look at the head. As you can see, it has 37 columns, which is a massive drop from what we had earlier. Earlier we had 81 columns, out of which we dropped, I think, 4 or 5 because they had a lot of null values. This one is by far something that we have done only to understand what the data is about. Now we take a look at the distribution of our data using histograms. What we do is we basically create a histogram for all the columns. So again, we didn't have to do it ourselves. These are all 31 columns with histograms, and you can take a look at the data. As you can see, it contains a lot of some columns contain a lot of data that's centered around a particular data point. Others are very separate, such as this one. This only contains values that are 0, so that's fine. And you can take a look at the data and analyze it. We're not going to analyze it right now. This is just for you to understand how to generate these visualizations. Then we take a look at correlations. Correlation basically is a number that allows us to understand how much of our data is how much influence does one column has on a particular column. And we remove the last column because the last row is basically sales, or the last column, sorry, I'll just remove the comment. So the last column is sales, so we don't have to worry about that. From here, we basically just take all the columns with correlation greater than 0.5. We call them golden feature list. Any column that has a higher value than 0.5 on correlation means it has good correlation for our data. We're taking the absolute value, which means we don't care whether it's negative or positive. Correlation ranges from -1 to +1. -1 means if the data in this column decreases, data in the other column which is negatively correlated with it will increase. Positive correlation means data in this column increases, data in other column which is positively correlated with this increase. So we take that and we sort it in ascending values. Now after doing this, we take a look at the correlations. So these are the correlations. The highest correlation we have is overall quality and GR live area. It's around 80 to 70%. Now what we can do is we take a look at all the numerical columns and we generate for the first 5 for all fifth values. What we're trying to do is we're trying to create visualizations to understand how a particular column relates to first 5 columns. So for instance, sales price relating to MS subclass, MS lot range, lot area, and so on. And as you can see, we're doing it for everything, and we're doing it 5 plots at a time. Now that we have done that, here is a bit of a code that's going to be a little difficult to understand. So I'm not going to try and explain it to you. But basically here, what we're trying to do is we're trying to create individual data frames or individual feature data frame as I've named it. Create some temporary data frames based on particular sections, such as we take the column name and the sales price, and then using that data frame we check whether or not the column's value is not equal to 0, and we create or we add it to the data frame. Then we create an all correlations matrix, and then we try to print it. Now we come to the interesting part. So these are all the 11 strongly correlated values that we have, right? For this one, since we had 81 columns and now we have reduced it down to only 11 columns that have really high influence on our sales price column. Now to visualize it, what we have done is we have created something called heat map. Let me just zoom in so that you guys can see. I think I zoomed in a little too much. Yeah. And also you can manipulate the size of this plot by when you're writing code. I'm not going to do it right now, but as you can see that some columns have correlation of 0.4, some have, and this is negative, by the way. As you can see, these are color coded. So any column with light color such as blue or purple are negative. Any columns with light the color such as yellow or green are positive. As you can see, we have 0.83% of correlation with GR 11 area and fireplaces. And so this allows us to understand what are the particular columns that are highly correlated with each other. allows us to understand whether or not a column has influence on not just one column but multiple columns, and how does that affect our purposes.
Just a quick info, guys. Intellipaat offers state of the art data analytics course in association with IITM Pravartak. Through this course, you can learn all the important tools and concepts of data analysis such as Power BI, data wrangling, data mining, etc. from esteemed IIT Madras faculties and industry experts. With this course, we already have helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take a first step towards career growth in the field of data analytics.
Introduction to IPL auction data. So the IPL auction data consists of various players that have been sold in the IPL auction 2022. The dataset contains all the batters or the batsmen that have been sold in the IPL auction. It contains all the bowlers that have been sold in the IPL auction. Amongst those are the all-rounders and the wicket keepers as well, because these are the categories in which the players are being sold in the auction. And after that, we also have the uncapped players who has not yet played any IPL matches. So we are going to filter those out later on in the session so that our analysis is foolproof to the point where we don't have to consider those players for now. Alright, so this is the information about the IPL auction data. And with all these players, we have parameters like nationality. There's a parameter of runs they have scored in all these matches. And amongst those are the average and the strike rate for the batsmen. And there are parameters like bowling average and bowling strike rate for the bowlers. And then again, we have parameters like catches, stumps, and runouts made for the keepers as well. So this is a brief introduction to what the IPL auction data contains. And we'll quickly go through the summary of whatever we're going to discuss in the session, and then we'll move on to the hands-on part. Before we begin, let's quickly introduce data analysis. So whoever is not aware of what exactly is data analysis can get on the session as well. Data analysis is where you gather, clean, transform, and reduce useful information from any unstructured set of data. So we can define data analysis as, let's say, for example, we have unstructured data. We will gather that data. We will then put it to some use. Through computations, we'll clean that data of the noise and reduce redundant values. And then we'll transform the data into something that can be used in a programming language. Or we can use, let's say, for example, Python to analyze that data. And after that, we'll reduce the useful information or insights from that data through visual representations. We can use machine learning models and other things that are being covered in the data analysis part. So now that we have a basic idea of what exactly is data analysis, let's move on to the next part, which is how many steps are involved in analyzing the data. For example, let's say we have this IPL auction data. How are we going to analyze this? First of all, we have to gather the unstructured data. After that, we move on to transforming the data into something that we can load onto a program. For example, if we are using pandas, we'll have to make sure that if we are loading the data into our program, it has to be in a compatible format so that we can actually make use of that data. After that, we are going to clean the data of all the redundancies, which can be null values, which can be irrelevant values that are not needed for our analysis, and all those things that we have to clear in the step 3, which is cleaning the data. After that, we analyze the data. For analysis, we can just use basic computations, and for that, we'll figure out how many parameters are useful for us and how we are going to derive any useful insights from that. And visual representations also help a lot in analyzing the data. Once we have cleaned the data, transformed it, and have loaded the data on our program, we can gather visual representations using matplotlib and cmon library in Python. And we'll get a clear idea of how our data looks like and is there any relationship between the parameters that we have inside the data. So these are the basic steps we can use to derive any useful insights from any structured or unstructured data. So after this, let's also take a look at how we have analyzed the IPL auction data in our session that we'll begin in just a short while. First of all, we have gathered the IPL auction data from various sources, and we have consolidated all the information in a CSV file where we have the player names, the nationality, and what kind of a player that particular person is. Is he a batter, bowler, keeper, or an all-rounder? Then we have also mentioned values like capped or uncapped. Have they played an IPL match before or not? Those values. And after we have gathered all these data points, we have cleaned the data and removed the noise. For example, since we are not going to be analyzing the uncapped play because there is not enough information on those players about the statistics related to the game, we have decided to remove them from the data for now. And that is basically how we have reduced the noise from the data. And any null values or redundant values, we have also reduced them to either 0 or we have completely removed them from the data set. After that, we analyze the data for useful insights, in which we basically gather is there any relation between the parameters that we have used. For example, if we want to see how many players have average more than, let's say, for example, 130, we'll have separate computations for that, and that's how we are going to analyze the data. Similarly, when we have analyzed the data through these computations, we'll put visual representations to good use, and we'll visualize the entire analysis so that we'll be able to make our decisions more efficiently. And finally, when we have gathered all the insights and we have looked at all the visual representations of all these parameters, we'll come up with the best 11 according to the analysis. So that's how this session is going to go, and let's move on to the hands-on part where I'll explain you how the code works for the IPL analysis. So this is a simple notebook we have curated for this problem statement, in which we have consolidated the data that, like I have told you, for all the sold players in the IPL 22. And in this data set, we do not have the unsold players, and we also have accumulated all the retained players from all the franchisees and put them with these players again. And then again, the data contains information like matches played, runs, wickets, average, strike rate, bowling strike rate, economy. Then there is a number of wickets they have taken, catches, run out, stumps, etc. That we're going to take a look at those data points just in a short while. And our end goal is, based on these data points, whatever we have mentioned until now, we will try to create the best 11 from these set of players from the current campaign. And basically, I'm just going to summarize whatever we're going to do in the session in these 5 points. First of all, we are going to extract and load the data. Extraction, we have already done, consolidated the data set. And after this, we have to clean the data and remove all the noise, which is the redundant values and all the data points that we do not need for our data set. And then again, we are going to analyze the data on different parameters, visualize the important statistical findings that we are going to get from the data. And after that, we are going to make the best team of 11. Now, this is the fun part. What we have done is we have consolidated the information from the winning team from the ICC T20 World Cup, which was Australia, and how the squad formation was there for them. And then again, for the last IPL campaign, whoever has won, the squad formation that they had used in the final match, we have considered those, and according to those, we will put our best 11 in the exact same squad formation. So now we can begin. First of all, we will import all the necessary libraries which we are going to need for this particular data analysis. First is NumPy. Then we have to import pandas, matplotlib, and seaborn. So NumPy is going to help us with any computations related to numbers, and then again, pandas is going to help us load the data and display with data frames and everything else. Matplotlib and seaborn is primarily going to be used for data visualization. So after we have imported all these libraries, we'll move on to the part where we load the data. So to import the data set, we have used the package from the Python programming language, which is I have just told you about these packages that we have loaded, and PD, which is an acronym for the pandas library that we have imported over here. We are using the read CSV method to import the IPL dataset that we have curated or we have extracted from various sources. Now to look at the data, or the first look, here it is, guys. I'm just using the head method, which is going to return the first 5 rows of our data set over here. Now this is the first look at our data set. So you can see we have all these players, then there is a team which they belong to in the current campaign. There is a nationality we have used because we want to make sure that only 4 overseas players are going to be in our best 11, and that's how the analysis should be. Before we were going down this path, because we want to make sure that at the end of the analysis only 4 players should be in the best 11. Then player type, basically just to segregate the number of batsmen, number of bowlers, and number of wicket keepers and all-rounders we are going to keep in our analysis. So these are going to be 4 different analyses based on the player type. After this, we have the capped information, which means they have already played an IPL campaign, and if it is 0 or if it's 2 for some, for example, in the entire data set, there are 3 values we have used for capped. One is for players who have already played IPL campaigns, and 0 is for those who do not have any prior experience of playing an IPL campaign. So we'll filter those out later on in the session. After this, we have the information like matches played, the runs they have made so far in their campaigns, how much they are averaging, the strike rate, number of wickets if they have, and the bowling average, the economy, everything, bowling strike rate, catches, runouts, and stumps. So these are the values, and as you can see here, you can notice the NaN values, which is basically the noise in our data set, and this is what we have to figure out later on, so that there is no noise in our data also. Moving further, this is the describe method, which basically gives you the information regarding the count, the mean value, the standard deviation, minimum, all these values. This you can check just to get a vague idea about what the entire data set looks like. And we have already checked the number of null values using the is_na method. So if you use this is_na method, it will tell you if you have any null values in the data set. And then again, we are using the sum method over here, which returns the number of NaN or NA values in the data set. As you can see in the matches played, we have a lot of NaN values, and then for runs also we have, for average we have, strike rate, and all these values. For catches, runouts, and stumps, we have more than 208 values, because we have only consolidated the information regarding these 3 parameters for wicket keepers. For bowling strike rate and bowling average, economy, wickets is entirely for the analysis of the bowlers, and including these and the batting average, strike rate, runs, and matches played is going to be used for all-rounders and batters. So now that we have a vague idea about how our data set looks like, how many null values are there, and what is the mean and standard deviation of all these values we have in the data set, we can also get the data type of each of the elements or each of the columns. So for player name and all, we are getting object here. Then for the rest of the values, the data type is float, and it's actually returning us with all the non-null values. So for player name, there is no null values, because we have 235 rows in the 16 columns, and we have 235 non-null values. So we have the entire information regarding the player name, which we got from the IPL auction from various sources. Now for team also, we have the exact data, the nationality, the player type, we have the exact data. If they're capped or not, we have also. For matches played, we don't have a few values. There are 20 null values here. Then for runs also, there is some inconsistency, because we have not mentioned that for bowlers. And then again, for strike rate, we have some redundancies for wickets and all those things. So since we have a clear idea about the data, we have loaded it into our program. The extraction loading has been done. Now comes the part where we'll transform our data, basically clean the data from all these redundancies and narrow our analysis to a point where we don't have to worry about these things. So in the above data, as you can see, players have been segregated on the following parameters. First is capped. There are batters, bowlers, all-rounders, and wicketkeeper. So we are going to focus on these players only. The uncapped players, since these players do not have a lot of statistical data available from the internet, or let's say wherever we have gathered the information from, we have decided to keep these out of the loop, so that we can only focus on capped players for now. So the uncapped players basically are playing IPL for the first time. So these players, if you do your further analysis, can be the surprise package for any franchisee. And since we have only limited our parameters to just the basic statistical figures, our analysis is not foolproof, because there has to be number of parameters that we can include. For example, let's say batters. We have to consider how many runs they're making in the power play, how many runs they are making in, let's say, for example, the death overs, and how many times they have been, caught out, or how many times they have been out on, for example, a full length delivery, or how they are playing the short length deliveries. These are the other parameters that people also can consolidate and consider for their analysis. But we have stuck to only the basic parameters, so that it's easier to explain to everyone, even though they are a beginner or not. So let's begin where we clean our data set. So cleaning the data set basically is getting the only values that are going to be required for our analysis. So here we are just segregating the capped batters, which means the batsmen that have already played an IPL campaign. So how are we going to do that? So we are going to locate only those rows and put the entire data frame in a data frame called batters, where the player type is a batter. So this will limit our search from the data frame and create an entire data frame for just the batters. After this, what we have to do is filter out the capped and uncapped players as well. So for all the batters that we have consolidated in batters, we have created another data frame called batters new, in which we have located all the rows where capped is equal to 1. So this will create a new data frame which will contain only the information about batsmen who are capped. And after that, we have created a final capped batters dataset in which we only have the columns that are going to be required for our analysis, which is player name, team nationality, matches played, runs, average, and strike rate. Because to analyze how a batsman will play, we only need these parameters initially. I mean, we can further narrow down our analysis by adding more parameters, but that's for later. We're just going to stick to these parameters for now. Now, when I get the information about the capped batters, this is how the dataset looks like. We have all these batters, their team nationality, matches played, runs, average, and strike rate. Similarly, we have done that for bowlers also. Then again, bowlers, we have changed the bowler type or the player type to bowler. And we have located all the capped players. For the parameters, we have taken player name, team nationality, which has been in the batters data also. And then we have stuck to matches played, wickets, then there is bowling average, economy, and bowling strike rate. So these are the parameters that we want our bowlers to focus on for our analysis. Now then again, the final capped bowlers dataset looks like this. So this is how we have consolidated the information for the bowlers. And then after this, we have the capped keepers. Now for keepers, we are using only the data which will showcase their batting performances and how they have kept the ball behind the wickets, which is basically how many catches, runouts, and stumps they have made. So this is how we have consolidated the information about the keepers by using the keeper as the player type over here. Then the capped is equal to 1 because we only want the capped players and all these parameters. So this is how our data looks like. So we have all these keepers that were sold in the IPL auction. We have all these matches played that they have, the runs, average, strike rate, catches, runouts, and stumps. Similarly, we're doing this for the capped all-rounders also. Basically, what we have done is the type or the player type is the all-rounder over here. We have done the capped is equal to 1 and we have got all the capped all-rounders, in which now this is a fun part. We have kept the batting and the bowling performances for the all-rounders because in the game they're going to be used for both of these options. So we have kept all the batting parameters and the bowling parameters as well. And this is the first look at our all-rounders data. So we have all these all-rounders, and this basically this entire data set for all the capped all-rounders is the longest because these have the most number of elements or the most number of columns where we'll do our analysis. Now, since we have segregated the data, we have done only the first part of the entire cleaning the data part over here. After this, we move on to filling all the null values with 0, because we don't want to keep it as a NaN value because it may cause redundancies in our data. So we just kept it to 0 so that it doesn't make any difference at all. So we have done that for capped batters, for capped bowlers, all-rounders, and keepers also. Here you have used the fill NA method, which basically fills all the NA values to whatever we have provided over here in the argument, which is 0 for our case. Now, to check if you have made the corrections completely, without any mistakes, you can check if there is any null values in your final batters, bowlers, and all-rounder data. So we have used the is NA method that we have done previously also. So here you can see there are no null values, or even if there were, they have been replaced with 0. After this, we come back to our initial analysis. So now that we have all these data sets which have only the batters, bowlers, all-rounders, and keepers data, now what we'll do is start with the analysis of batters data or batsman data. So here what we'll do is we narrow down our analysis to the batters only who are averaging more than 32. Since let's say for example from out of the 235 columns, let's say there are 100 batsmen, and for our team what we are going to aim for, we only need let's say 3 or 4 batsmen. So we don't want to analyze all the batsmen. So to just narrow it down to only a specific group, we have used the average of each of those players, and whoever has more than 32, the average, we are using then again the LOC or the log method over here, which is going to segregate the data further to only those players who have average more than 32. And now we sort the data based on each of the parameter, right? So for that we are going to use the sort values method, and this is basically going to sort the entire players who have average more than 32 into ascending or descending orders. So this can help in our initial analysis before we visually represent all these values. So we have done this for averages, we have done this for strike rate, we have done this for runs and for matches played. So let's take a look at how each of these data frames looks like. So first of all, we have the top batters average. In the top batters average, you can see we are going down in the descending order. So the most average anybody in the campaign who have been sold has 47.43, and the last one who has more than 32 average is 32.90. So we have narrowed it down to how many? I think 8 players over here which we need for our analysis, and out of these 8 players we'll choose let's say 3 or 4 batsmen that will be in our best 11. So we know for sure that out of these 8 players, the top 3 are KL Rahul, Ruturaj Gaikwad and David Warner, who have the top 3 averages among these lot. Then again we do this for strike rate, and we have all these values for strike rate, where the highest is 139.97 and the lowest is 126.60. Now based on this, we can figure out some similarities in our data, like who is going to top these charts. If we just analyze the strike rate and average, the top 2 players we have already got, which is David Warner and KL Rahul, because both of these players are in the top 3 here. So we know for sure that these 2 players are going to be there if we just consider the strike rate and the average. Now since we are using 4 parameters, we have to keep our analysis not limited to just 2. We have to do it for the other 2 parameters as well. So now we check the batsman's run again in descending order. So the most are from this gentleman Virat Kohli over here, and the least are from Ruturaj Gaikwad over here. So this also creates a little bit of imbalance in our analysis. Right now we were looking at let's say David Warner and KL Rahul. Now we want to consider Virat Kohli, Shikhar Dhawan, and David Warner again is in the top 3 over here. So this basically means that David Warner is going to be in our batsman list when we come up with the final 11, because he is already topping the 3 charts over here. And now again we look at the 4th one, which is the how many matches the batsmen have played, and here then again Virat Kohli is topping the chart, then we have Shikhar Dhawan and David Warner. Since David Warner is in all 3 or 4 of the parameters that we have used, we're going to keep David Warner in our team first of all. After that, if you just rank down these players from 0 to let's say 10 on each of these parameters, for averages, for strike rate, for batting runs and for batting matches, you will come up with a list where you'll have 3 top players, and those are going to be David Warner, KL Rahul and Virat Kohli. Since Virat Kohli is topping the charts in 2 of these 4 parameters, and then again he was somewhere around the 7th position in the strike rate, and in the averages he was also not very behind. So that's why we have kept Virat Kohli. And KL Rahul also, again, the number of matches he's down the middle somewhere, and for the runs also. So this is how our initial analysis looks like. Then again we'll visually represent all these information and look for better insights. For now, we are keeping David Warner, KL Rahul and Virat Kohli in our batsman list that are going to be in the final 11. Now we move to the bowlers data. Now we do the same thing again. For top bowlers, we have done one thing. For bowling average, whoever has less than 24, we have kept only those players in the top bowlers list. The reason for doing this is because The more the average, it's not looking good. I mean, it doesn't look good for the bowlers. The average has to be less, which means they are basically getting more wickets. And now we have done the exact same thing, sorting values for the bowling average, the bowling strike rate, and for wickets, economy, and matches. As you can see, I'm not mentioned the ascending parameters in these three values because we want these values to be in a ascending order. Now after this, we take a look at each of these parameters one by one. So for the top bowling average, we have all these values. Now again, there were a few redundancies when we were extracting the data. That's why we have all these values over here, because they've only played 1, 2, 1 matches, and this gentleman has also played just 3 matches, and that's why they are showing on top of the chart over here. So we'll consider players from, let's say, here. So all the values are for bowling average. So the most efficient is the guy Joseph, who's in the Gujarat team. And after that, the least is Varun Chakravarti from the Kolkata side. So these are the top bowlers for the bowling average. Then again, we do the analysis for top bowlers strike rate, and we have done this for ascending order as well. So you can see we have Joseph and Varun Chakravarti at the end. We have players like Angidi, there is Kagiso Rabada and Arshdeep Singh, and all these players who have the strike rate over here mentioned. Now we have done the same thing for the economy as well. Now this is where the chart actually changes. So for the least is Chakravarti over here. The gentleman has only played 31 matches. And then we have Jasprit Bumrah. Then we have Nathan Kuntal, there is Yuzvendra Chahal, and at the end we have Alzari Joseph, because we're not considering Rasik Dar and Sean Abbott. There's one more player we're not considering, which is Kuldeep Yadav. So these 3 players, I think we have missed it during the extraction, the data extraction. These players are not capped. I mean, they have not played IPL. I may be wrong, but I'm not pretty sure about these values. And since there are only very limited information about their matches and the statistics, we are going to negate these values for now in our analysis. For the next part, we analyze the wickets that these people have taken. Then again, we have different values. This gentleman, Kagiso Rabada, has been showing consistently. So we'll keep Kagiso in our top bowlers list for now, the number 1. And then we have players like Jasprit and Yuzvendra Chahal, which have been showing in economy. They've been showing in the number of wickets that they have taken. Then again, if we take a look at the matches, Yuzvendra Chahal and Jasprit Bumrah again, they top the chart. So we'll keep our bowlers, or the analysis, the initial analysis tells us that these 4 bowlers are going to be in our best 11, which is Kagiso Rabada, there is Jasprit Bumrah, Yuzvendra Chahal, and Nathan Coulter-Nile. So all these gentlemen will be in our best 11 for now. We will take a look at the visual representations of these parameters, and we'll get a best idea about how these people are performing accordingly. Now we'll take a look at the all-rounders again. So all these all-rounders, we have narrowed down our search, or narrowed down the top all-rounders according to the strike rate. Because any all-rounder is, let's say for example, plays in the middle order, and there we actually need, or they are going to play in the death overs. Like that's the best probability we have with the all-rounders. So we have kept the strike rate as a parameter over there. So we'll have all the bowling all-rounders and the batting all-rounders, which we can help in our top all-rounders list. So according to that, we have kept the multiple parameters here, which are basically the batting parameters and the bowling parameters. So we have average, strike rate, runs, matches, and then we have bowling average, bowling strike rate, wickets, economy, and matches again. Okay, so we have done the matches twice, which we can only use once, because this is exactly the same value, which we can ignore one of this. And then again, we have done only the ascending for a few of them. Bowling average and bowling strike rate and the economy is in ascending order. The other all parameters are in descending order. So this is the final data set that looks like according to the averages. So we have this gentleman Kieran Pollard, and this is also one of the redundancies from the data set, which we have not which we have got wrong during the extraction. This gentleman here, I think, haven't played a lot of matches in the IPL, and we have missed that during the extraction. And then we have players like Krishna Pagautam, then there is Jofra Archer, Mohammad Nabi, Andre Russell, Hardik Pandya. All these all-rounders are in our top list according to the averages. Now this is how we segregated them into the top all-rounders list, which is according to the strike rate. And this is how it looks like. The most is 178.57 and the least is 140.44. Since we have already taken the values above 140. Here averages also I'll tell you once. I think the average is starting from 29.98. This gentleman has a very good average, and then it goes down to 13.3, or we'll take 14.3 as the least amount of average. After this we have parameters like all the runs they have made. So this gentleman again tops the chart with 3,268 runs, and in the least we have Mohammad Nabi, which has 180 runs. And then we have Glenn Maxwell, Andre Russell, Hardik Pandya and Sunil Narayan, and all these people respectively. When we take a look at the matches over here, we have all these values for the number of matches they have played, where again Kieran Pollard actually tops the chart. And then we take a look at the bowling average, where the statistics have changed a little. So now Kieran Pollard is at the place third from the last, and the most number of bowling average, or the most average from a bowler, has been from Jofra Archer, who has played 35 matches, and the bowling average is somewhere around 21.33, and it goes down from here. The last is Krishna Bhagautam, who has 43.23. Now we have the bowling strike rate again. Here also the statistics have changed a little. So the strike rate goes, the least is for Andre Russell, and then we have the most bowling strike rate is for Krishna Bhagautam. And now we have the all-rounders wickets. So the most wicket goes to Sunil Narayan, who has somewhere around 143 wickets. The least is for Mohammad Nabi, who has 13 wickets. Now looking at all these information from these data, just by visually checking, or just by doing the initial analysis, you can figure out a few players who are going to top these charts. What you can do is rank these players starting from the first chart itself from 0 to 8. So whoever is on the, let's say, first rank, that's kind of how you can narrow your initial analysis. So that player, how many ranks he is getting among all these 8 parameters, that's how you can decide. Whoever has the least can go down in the final list. So this is for the economy. Then again we have Sunil Narayan, and the least is for Hardik Pandya. So from the above analysis, we can rank down from the place from 1 to 10, just I've told you how you can do that. And the top all-rounder options are Andre Russell, Sunil Narayan, Hardik Pandya and Jofra Archer. So these 4 players are going to be amongst the best 11 that we are going to decide after this. Now analyzing the keepers data is also the similar task that we have done, but we have narrowed our search based on the average that these people are scoring. So we have kept it for more than 25, and according to that, these are the players who are in the list. So the most goes to Johnny Bairstow, who has the average of 41.50, and the least goes to Dinesh Karthik, who has an average of 25.80. After this we have the parameters like strike rate, then there is keeper runs, and we have matches, catches that they have taken, the runouts and the stumps. Now this one is an easier analysis for us, because in most of these parameters only one person is going to top the chart, but we have narrowed it down to 3 still. So for the keeper strike rate, then again we have Joss Butler, who is topping the chart with 150 strike rate, and the least goes to KS Bharat, who has 122.40. After this we have the top keeper runs, where MS Dhoni has 4,746 runs, which is the most, and then we have Dinesh Karthik and Ambati Rayudu. And at the least we have KS Bharat, who has only played 8 matches and has scored 191 runs. After this we have the top keepers matches, how many matches these guys have played. Then again we have KS Bharat at the bottom with just 8 matches, and MS Dhoni topping the chart with 220 matches played. And Dinesh Karthik has played 213, then 175, and then again we have the second last at Johnny Bairstow, who has 28 matches in his kitty, and he has already scored 1000 runs with the most average. Now again we have these people who have made the most catches and the most runouts and stumps as well. So without any doubt, we have MS Dhoni topping the chart in all these three. Then again, we have Dinesh Karthik at the second spot, and the third spot keeps changing according to the parameters. For runouts, it's Ambati Rayudu. For catches, it's Sanju Samson, and for stumps, it's Quinton de Kock. So these are the parameters and the players that we have initially analyzed through these findings, and we have narrowed our search down to three players, which is MS Dhoni, Dinesh Karthik, and Rishabh Pant. So according to the matches played, the runs scored, the average, strike rate, catches, runouts, and stumps, we have ranked them down from 1 to 10 according to where they are standing in the list, and according to that we have come up with the three players. So we have done the same thing for all these players. We have basically ranked them based on where they are standing in the list according to one parameter, and adding all those positions or the ranks, whoever has got the less or the least rank is topping the charts in our findings. So this is the basic initial analysis that you can do for any data, and you can find the relationship between how these elements will perform on different parameters. Not only, since this is a very simple data set, we have curated this according to our analysis, and it's very easy to just make out these findings. Otherwise, if you are using some complex data, for example, the analysis has to be somewhat extensive. It has to be a little bit more complex, where you will use more relationship wise on how each of these parameters are aligned towards each other. For example, let's say the number of matches somebody is playing is going to be linearly related to how many runs they're scoring. Because, for example, let's say somebody has played 500 matches, so they have got more number of chances to score runs, and let's say they have scored 5,000, 6,000 runs. So that's how the relationship will go inside the data. So matches played, runs, or let's say, for example, if somebody is making 126 catches, that is because they have played more number of games. Now if we average it down to how many catches per match, then that is another question which we can use in our extensive analysis, where we use more number of parameters. Like I've told you, for batsmen, you can do the same for keepers, you can do the same for bowlers, you can do the same for all-rounders as well. Like these parameters will keep on growing if you narrow down your analysis to a point where you want the exact results, or you want the exact information about any of these statistics. And now that we have done the initial analysis, let's move on to the visualization of each of these parameters, so that we get a clear understanding of these findings that we have done. For visual representation, we are going to do it on the segregated data we have done so far, and we are going to plot the exact same graphs we have done for our initial analysis. That's what we have done in our basic initial analysis, which is nothing but getting the information about averages and strike rates and all those things. So first of all, we are going to visualize the batters data. Now the plot shows here the top batter's strike rate. So here, instead of looking at the data set with all these values of top strike rates, what we can do is just visualize them, and based on this we can just figure out which player has the highest strike rate. So David Warner, then we have KL Rahul somewhere along the same lines, and then we have David Miller also. So we can do the same thing for runs. So this is how it looks like. So the most runs is by Virat Kohli, and then we have David Warner, there is Shikhar Dhawan, KL Rahul is also among the top 4 here. Faf du Plessis is also just behind KL Rahul. So this is how easy it becomes to just visually analyze the data using Matplotlib, or we are using the bar plots here from Seaborn library, where you just give the x-axis, which we have used the player name from the data set, the top batters, and this is basically the runs we are getting. We just change the values over here in the y-axis. Now we are getting the averages from each of these players. Now if you take a look at this, the most number of the highest average is with these two people, KL Rahul and Ruturaj Gaikwad. Then somewhere down the lane we have Kane Williamson, who also has a good average. There is David Warner. So if I take a look at just Warner's finding in these three charts, or let's take a look at fourth one and we'll figure out. Fourth one is for the number of matches played. Here Virat Kohli is topping the chart. Then the second one is Shikhar Dhawan. Then there is David Warner, and KL Rahul and Faf du Plessis looks like just above each other. Maybe a few numbers are here and there. Somewhere around 100 matches both of these players have played. Now the question is, just by looking at David Warner's data, can we not just figure out he's actually in the top 5 of all these 4 and almost topping the chart in one of them? And then again, if we take a look at Virat Kohli, he's also somewhere around in all the 4 charts over here. And the third player that we have with KL Rahul, he's topping the chart here almost. Then we have him here also, where we have mentioned all the runs. Then we have him here at the average, which is the highest with any batter. And then in the matches also, he's not the one exactly in the top, but he's not at the end also. He's somewhere in the middle. So that's how we have narrowed down our search for the 3 batsmen like that. We have KL Rahul, Virat Kohli and David Warner. Now we visualize the bowlers data. Now again, for bowlers data, we have a few redundancies where we have null values which we replaced by 0. So that's why we are not getting enough values in these 3 columns. Otherwise, we have the values for other bowlers here. So first of all, we have the bowling average. So the lowest bowling average sits with these 3 people. And Alzar is Joseph. There is Kagiso Rabada, Lungi Angidi and Hendrik Nokia. And the highest is with Varun Chakravarti and Jasprit Bumrah. So from here we can figure out that these 2 people might be in our list. Now we go down the second parameter, which is the economy. So who has the lowest economy among this lot? So we have Varun Chakravarti, Nathan Coulter-Nile is also not doing so bad. Then we have Yuzvendra Chahal, Jasprit Bumrah and Hendrik Nokia. So these people are lowest in the economy section. Then we analyze the bowling strike rate. So the lowest sits with Lungi Angiri, Alzari Joseph, Kagiso Rabada, and then we have Hendrik Nokia. Arshdeep Singh also has a bowling strike rate which is considerably low compared to these people. And then we go to wickets. Here, Yuzvendra Chahal and Jasprit Bumrah are topping the charts by considerable numbers. For matches played, if we consider, the same thing happens. So from this lot, we have analyzed our 4 players according to these particular parameters that we have used for bowlers. Then for all-rounders, we are considering more number of parameters, which begins with strike rate. So we have Andre Russell topping the chart over here. Then for average, we have Kieran Pollard, who is having the most number of average. And then we have players like Hardik Pandya, who's I think at the top 3 over here. Here also he's somewhere around the top section, but let's say in the middle. Krishna Bhagautam here is actually having a good strike rate, but in the second one he's considerably low compared to the other people. So similarly, when we take a look at matches played, 2 people have considerably higher number of matches and the others are not there exactly. Then when we come down to runs, of course, since Kieran Pollard had more average, more number of matches played, he has also created a lot of runs. And that's the exact same thing with these people also, Glenn Maxwell, Hardik Pandya and other people who have played more number of matches compared to the others. And that's how these 2 parameters are actually related to each other, number of matches and runs. We have the bowling average where the lowest is with Sunil Narayan, Jofra Archer, and then the highest is with Krishna Bhagautam. And then again for the next parameter that we have, which is the economy, the lowest I think is with Sunil Narayan. Then we have Moeen Ali. Aman Khan we are not considering because this was kind of an outlier, we can say, or a noise in our data which we could not get rid of, because during extraction this was the anomaly we could not get rid of. And there is Jofra Archer, Mohammad Nabi, but Andre Russell and Hardik Pandya are actually not very efficient when it comes down to economy. But when we rank them down, let's say for example Hardik Pandya, if we consider in these charts, he's actually, let's say, amongst the top 5 players that we are getting. Only in the section where we have economy, the bowling strike rate and all these criteria, there I think he's lacking a little bit and coming in the middle. Otherwise, he's actually topping the charts in all these parameters. That's why we have kept him in our list of all these bowlers. Now if we take a look at the wickets also,
Sunil Narayan, compared to any other player, has the most wickets over here. Then we have Andre Russell. Hardik Pandya also has a lot of wickets. Kieran Pollard is there, and Jofra Archer also is having a lot of wickets. And here also the economy, I think the bowling strike rate is very low for Jofra Archer. Economy is also among the middle over here. And then if you take a look at the bowling average, it's considerably the most efficient over here. And that's why we have kept Jofra Archer in our list also. After the wickets, we come down to analyzing the keepers data. Now here, let's say this is MS Dhoni in the olive color over here. He's going to top at least all the charts over here, because he's considerably the most dominating keeper in this section, and that's why we have kept him in our best 11. The other players which we kept, like Rishabh Pant and Dinesh Karthik, if we see for the average, Rishabh Pant has a very significant amount of average over here. Although Dinesh Karthik is not topping the chart here, he is considerably ahead of all these people in runs. Rishabh Pant is also among the top 5 here, and MS Dhoni is again topping this chart. When we take a look at strike rate, Dinesh Karthik might not be in the top 5 over here, but Rishabh Pant is actually among the top 3, with MS Dhoni just below, or we can say just above Dinesh Karthik over here. The most sits with Joss Butler. And then again, if we take a look at the catches, Dinesh Karthik and MS Dhoni are topping the chart over here, with Rishabh Pant being in top 5, compared to Sanju Samson and Ambati Rayudu, who are also doing considerably good over here. So visually representing the data helps you in analyzing it much more efficiently, because ranking down players like that can be a little bit trickier, and you can just look at the data from these charts and decide on your own. So over here, if we take a look at the runouts, most sits with the MS Dhoni, and then Rishabh Pant is among the top 5. Some of them have no values over here. Ambati Rayudu, Dinesh Karthik also I think is the second highest over here. That's why we have kept Dinesh Karthik in our top 3 list, because except 1 or 2 in all the parameters, considering stumps, runouts, catches, Dinesh Karthik is actually at number 2, and that's why we have kept him with Rishabh Pant in our top 3. For matches played also, Dinesh Karthik is at number 2, MS Dhoni at number 1, Ambati Rayudu at 3, Sanju Samson 4, and Rishabh Pant at 5. So considering all these visual representations, we have narrowed down our search, where we have finalized 3 batsmen, 4 bowlers, 4 all-rounders, and 3 wicket keepers. Now from these people, we will visualize some more information, and according to our problem statement, we'll come up with the final 11. So now to form our best 11, we have to focus on a few things. First of all, we have to consider the number of players from each category that the T20 World Cup winning team had in their squad. And I also told you we'll consider the IPL's winning team for the last campaign. So Australia won the T20 World Cup, and they had 3 batsmen, 3 all-rounders, 4 bowlers with 1 spin option and 1 wicket keeper in their squad in the final match. And for Chennai Super Kings, the squad had consisted of 4 batsmen, 3 all-rounders, 3 bowlers, and 1 wicket keeper. So taking into account these 2 statistics, we can narrow down our search for the best 11 according to 3 batsmen, 3 all-rounders. We keep 4 bowlers with 2 spin options, or we'll try to stick to 2 spin options, and we'll have 1 wicket keeper. So now after this is a very simple representation of all the batsmen with all their parameters that we have analyzed them on. So for example, we finalized David Warner, Virat Kohli, and KL Rahul for our batsman category. So we have stored all the values in whatever information they had in their data frames, and visualized them on our graph over here. For each graph displays certain information, which is matches played, runs in the IPL, average, and strike rate. So for the top 3 over here, KL Rahul has the least number of matches, but he has the second highest strike rate and the highest average over here. Even though David Warner has the matches played in the range of let's say 150 matches only,
The strike rate is the highest among the three, and the average is also in the middle. And when we consider Virat Kohli, for the number of matches he has played, he has been consistent with the average, and there is enough data on strike rate which is more than 120 and 6,000 IPL runs. So this is how we have just narrowed our analysis to just the parameters we want our three batsmen to look for. Similarly, we have done the same for the all-rounders. So we had finalized Andre Russell, Sunil Narayan, Hardik Pandya, and we left out Jofra Archer because we are only allowed to keep 4 overseas players in the best 11. That's why we have kept Andre Russell, Sunil Narayan, and Hardik Pandya only. Now we have gathered all their values for specific parameters from the dataset top all-rounders. I forgot to mention this for batsman data. So we are just locating these rows where these people or these batsmen have been placed in the dataset and extracting that information so that we can display it on the graphs. And we are using the subplots to plot these graphs in the same space. And we are using the bar plot from the Seaborn library. If you have any questions, you can mention them in the comment section below, guys, because this might be a little bit complicated for a few beginners, how we have used these axes and all. We have just declared this subplot 2 by 2 where this is 0 by 0, this is going to be 0 by 1, this is going to be 1 by 0 and 1 by 1. So this is how we are subplotting these 4 plots in just one big image. And we have done the same for this also, where we have used 4 by 2 subplots where we have 2 subplots each side, and this is one big image where we are getting all these information. So we have done this for bowling average, wickets values, and economy values, and all these parameters we used the all-rounders to analyze. So for these 3 players, we have matches, the runs they have scored, considerably how many number of matches Sunil Narayan has played. The runs are a little bit on the lower side, but the number of wickets are on the top here, and that basically shows that Sunil Narayan is kind of a bowling all-rounder and a spin option again. That's just additional information I'm giving out here. That's not mentioned in the dataset anywhere, guys. Also, if we take a look at Hardik Pandya, we have the number of matches played more than, I think, 80 mark over here, somewhere around 100 or less than 100, and the runs he has made is almost as good as 1400. The strike rate, the average, the bowling average is on the higher side. So this basically shows that he is kind of a batting all-rounder, but he has been taking wickets, which is kind of around 40 wickets he has taken. The economy is also on the higher side here. Andre Russell is a complete package in that sense, because the number of matches played, the runs, the wickets he has taken, economy is a little bit on the higher side, but the bowling average also is a little bit lower, because we have narrowed it down to just 3 people. That's how we are getting these values for just the 3 of these all-rounders. Similarly, we have done the same thing for the bowlers. So the bowlers are only analyzed on 3-4 parameters, which is the number of matches they have played, bowling average, strike rate, wickets, and economy. And this chart basically has been left empty because we had initialized the 3 by 2 plot over here, and we didn't initialize anything for here. Alright, so this is how we can just represent our analysis, or these are the findings we got from our analysis. We are putting it down to our visual representation so that we get a more clear idea on how these players are looking like according to these parameters. Similarly, if we do it for example, let's say, so we had 3 players in the data over here for wicket keepers, but we have narrowed it down to just 1 because only 1 player will play as a wicket keeper in the entire team. So we have narrowed it down to just the top player, which is MS Dhoni. And if we take a look at the matches and the runs, so this guy has played somewhere around 220 matches, and the runs are more than 4,000, closer to 5,000 mark over here. If we take a look at the average and the strike rate, average stands somewhere around 40, and the strike rate is more than 130. Then again, the keeping stats, number of catches is 120 plus. If we take a look at we can compare these values to matches according to our analysis. We can add hue over here, add a number of matches, and compare the values of catches, stumps, and runouts to get a better picture of the analysis. This is how you can extend your analysis based on more parameters. You can figure out how many catches per match or statistics like that. Now, after we are done representing all these values or all these statistics about our final 11, we consolidate that information in a single data set, and that's how we have done it over here. We have used the concatenation function from pandas to concatenate all these different data frames. We have consolidated using the LOC method for pandas, and we have consolidated final team and dropped all these different values or parameters like matches played, which we have analyzed them upon. Now we just need the team that they are playing for and the nationality, because we have to decide how many overseas players can play in that team. So coming back to our presentation, guys, so results from our analysis shows that these are the final 11 according to the parameters that we used in our analysis. That stands a good chance. So this is the best 11, which consists of KL Rahul, David Warner, Virat Kohli as batsman, Andre Russell, Sunil Narayan, Hardik Pandya as all-rounders, MS Dhoni as keeper, Nathan Coulter-Nile, Kagiso Rabada, Jasprit Bumrah, and Yuzvendra Chahal as bowlers. And we still have two bowling options that are going to offer spin, which is Sunil Narayan and Yuzvendra Chahal.
Just a quick info, guys. Intellipaat offers state-of-the-art data analytics course in association with IITM Pravartak. Through this course, you can learn all the important tools and concepts of data analysis such as Power BI, data wrangling, data mining, etc. from esteemed IIT Madras faculties and industry experts. With this course, we already have helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take a first step towards career growth in the field of data analytics.
So now, coming to the first question, what are the steps involved in data analysis? There are several steps involved in data analysis. So now, talking about the first step in data analysis process is to define your objective. And in data analytics, this is sometimes called the problem statement. Now let's move to the second step, that is collecting the data. Once you have established your objective, you will need to create a strategy for collecting and aggregating the appropriate data. A key part of this is determining which data you need. This might be quantitative data or qualitative data. Moving ahead, the third step is data cleaning or pre-processing. Once you have collected your data, the next step is to get ready for analysis. This means cleaning or scrubbing it, and it is crucial in making sure that you are working with high quality data. Key data cleaning tasks include removing major errors, duplicates, and outliers. Also, it is used to remove unwanted data points and bring structure to your data. So now, moving ahead, we are having next step as data exploration. Data exploration is used to explore and visualize data to uncover insights from the start or identify areas or patterns to dig into more. Next, we are having data modeling. Data modeling is the process of analyzing and defining all the different data your business collects and produces, as well as the relationship between those bits of data. The next step is data validation. Data validation is the practice of checking the integrity, accuracy, and structure of data before it is used for a business operation. And last, we are having implementation. So in this, we're going to implement our business operation. So these are the important steps for data analysis. So now, let's jump into the second question. What are the key differences between data analysis and data mining? Talking about data analysis, it involves the process of cleaning, organizing, and using data to produce meaningful insights, whereas data mining is used to search for hidden patterns in the data. Also, data analysis produces results that are far more comprehensible by a variety of audiences than the results from data mining. So this was the difference between data analysis and data mining. Now moving to the question number 3, what is data profiling? Data profiling is a methodology that involves analyzing all entities present in data to a greater depth. The goal here is to provide high accurate information based on the data and its attributes such as the data type,
frequency of occurrence, and more. So this is all about data profiling. So now, moving to the question number 4. What are the top tools used to perform data analysis? So there is a wide spectrum of tools that can be used in the field of data analysis. Here are some of the tools. The first one is the Microsoft Excel. As we know that Microsoft Excel is used in major companies for the data analysis. Along with that, we are having Power BI, Tableau, RapidMiner, and many more. So these are the top tools that are used to perform data analysis. So now, let's check out the next question. What is an outlier? Outliers are the data points or observations that are significantly different from other data points because of their abnormal distance from the rest. Here you can see that in this graph, we are having the outlier present, that is marked with an orange color, right? So as I told you the formal definition, that outliers are the data points that are significantly different from the other data points. Here you can see that the data points are having some pattern, right? But this is an outlier that is significantly different from other data points. Now talking about the outliers, there are two types of outliers. The first one is univariate and the other one is multivariate. So this is the basic idea about an outlier. Now moving ahead, what are some of the popular tools used in big data? There are multiple tools that are used to handle big data. Some of the most popular ones are as follows. The first one is Apache Hadoop. Moving ahead, we are having Apache Spark, Apache Storm, Flink. You can also use MongoDB and RapidMiner. So these are the popular tools that are used in big data. Moving to the next interview question. What is the use of pivot table? So this is a question of Excel, right? So talking about pivot tables are one of the key features of Excel. They allow a user to view and summarize the entirety of large datasets simply. Most of the operations with pivot tables include drag and drop operations that aid in the quick creation of reports. So this is the idea about pivot tables. So now let's move to the question number 8. Explain different types of data validation techniques used in data analysis. There are many types of data validation techniques that are used today. Some of them are field level validation. Talking about the field level validation, it is done across each of the fields to ensure that there are no errors in the data entered by the user. The next one is form level validation. Here, validation is done when the user completes working with the form but before the information is saved. The third one is data saving validation. This form of validation takes place when the file or the database record is being saved. And the last, we are having search criteria validation. This kind of validation is used to check whether valid results are returned when the user is looking for something. So this is the basic idea about different types of data validation techniques. Moving to the next question, we are having what are the top Apache frameworks used in a distributed computing environment? So we already know that Hadoop and MapReduce are considered to be the top Apache frameworks when the situation calls for working with a huge dataset in a distributed working environment. So we are using here Hadoop and MapReduce for the distributed computing environment. Moving to the next question, what are the ideal situations in which t-test or z-test can be used? It is a standard practice that a t-test is used when there is a sample size less than 30. Now, coming to the z-test, it is considered when the sample size exceeds 30 in most cases. So this is the situation in which we use t-test or z-test. When the sample size is less than 30, we use t-test, and when it is greater than 30, we use z-test. Now, moving to the question number 11. What are the disadvantages of data analytics? Compared to the plethora of advantages, there are few disadvantages while doing data analytics. Some of the disadvantages are listed below. The first one is data analytics can cause a breach in customer privacy and their information such as transactions, purchases, and subscriptions. Moving ahead, some of the tools are complex and require prior training. So this is the biggest disadvantage of data analytics. And the last point, it takes a lot of skills and expertise to select the right analytics tool every time. Alright guys, it's time to move to the next question. Moving ahead, how can one handle suspicious or missing data in a dataset while performing analysis? So let's suppose if there are any discrepancies in the data, a user can go on to use any of the following methods. The first one is applying several strategies together to find missing values and using approximation if needed. Moving to the second point, user can replace the invalid data with the corresponding valid and up-to-date data. Moving ahead, It can create a validation report with details about the data in discussion. And the last point is that escalating the same to an experienced data analyst to look at it and take a call. So this is a way to handle missing data. Also, you can replace the value with mean, median and mode. So these are the ways to handle missing data. Moving to the next question, what is the difference between the concept of recall and the true positive rate? So let me clarify you, recall and the true positive rate are totally the same. Talking about the recall, recall is a metric that quantifies the number of correct positive predictions made out of all positive predictions that could have been made. So when somebody is asking you the formal definition of recall, you can say that out of the total positive, what percentage are predicted positive. Now talking about the formula of recall, it is true positive upon true positive plus false negative. Now moving to the question number 14, what is the simple difference between standardized and unstandardized coefficients? In the case of standardized coefficients, they are interpreted based on their standard deviation values, whereas the unstandardized coefficient is measured based on the actual value present in the dataset. So this is the difference between standardized and unstandardized coefficients. So basically it is asking what are the ways or techniques that are used to detect outliers. So the first one is box plot. So we know that while using box plot we can easily find outliers, right? The second technique is z-score and the last one is interquartile range. So these are the techniques to detect outliers. Moving to the next question, what are z-test, chi-square test, f-test and t-test? As I already told you about the t-test is used when your sample size is small, basically when the sample size is less than 30. Alright guys, so now after understanding what is t-test, now let's see what is z-test. So z-test is used for large sample. Basically when your size of the sample exceeds more than 30, we are using z-test. Now coming to the chi-square test, people used to pronounce it chi-square test also. This kind of hypothesis testing is used when there is a requirement to find out the level of association between the categorical variables in a sample. The test of significance is to determine the difference between observed and expected frequencies of certain observations. Now, moving ahead, we are having f-test. So in f-test, hypotheses of interest are about the differences between population means. So this is the idea about z-test, chi-square test, f-test and t-test. Moving ahead, we are having what are the advantages of using version control. There are numerous benefits of using version control. Now let's see. The first one is it establishes an easy way to compare files, identify differences and merge if any changes are done. Moving ahead, it creates an easy way to track the life cycle of an application build, including every stage in it such as development, production, testing, etc. It also brings a good way to establish a collaborative work culture. Along with that, it makes ensure that every version and variant of code is kept safe and secure. So these are the numerous benefits of using version control. Moving to the next question, what is collaborative filtering? Collaborative filtering is an algorithm used to create recommendation systems mainly considering the behavioral data of a customer or a user. For example, when browsing the e-commerce sites, a section called recommended for you is present, right? This is done using the browsing history alongside analyzing the previous purchases and collaborative filtering. So this is the idea about collaborative filtering. Moving ahead, the next question is what are the properties of clustering algorithms? Any clustering algorithm when implemented will have the following properties. The first one is hierarchical or flat. Moving ahead, we are having iterative and the last one is disjunctive. So these are the properties of clustering algorithms. Now moving to the question number 20, explain the term normal distribution. Normal distribution is also known as Gaussian distribution. It is a type of probability distribution that is symmetric about the mean. It shows that the data is closer to the mean and the frequency of occurrences in data are far from the mean. In normal distribution, mean, median, mode are equal. So this is the basic idea about normal distribution. Now moving to the next question, that is question number 21. What is the difference between overfitting versus underfitting? Overfitting and underfitting are the two main problems that occur in machine learning and degrade the performance of the machine learning models. Now talking about overfitting, it occurs when our machine learning model tries to cover all data points or more than the required data points present in the given dataset. Because of this, the model starts catching noise and inaccurate values present in the dataset, and all these factors reduce the efficiency and accuracy of the model. The overfitted model has low bias and high variance. The chances of occurrence of overfitting increases as much we provide training to our model. The more chances of occurring the overfitted model. For example, the concept of overfitting can be understood by the above graph of linear regression output. For example, you can see this graph. In this graph, the model is trying to covering all the data points, hence it results in the overfitting. Now after understanding overfitting, let's see how to avoid overfitting in the model. So there are several ways by which we can reduce the occurrence of overfitting in our model. The first one is cross-validation. The second one is you can train with more data. And the last one is removing features. And there are some other techniques such as ensembling, regularization and many more. So after understanding overfitting, it's time to understand what is underfitting. It occurs when our machine learning model is not able to capture the underlying trend of the data. To avoid the overfitting in the model, the fed of the training data can be stopped at an early stage, due to which the model may not learn enough from the training data. As a result, it may fail to find the best fit of the dominant trend in this data. In the case of underfitting, the model is not able to learn enough from the training data, and hence it reduces the accuracy and produces unreliable predictions. An underfitted model has high bias and low variance. For example, in this graph, you can see that the model is unable to capture the data points present in the plot. So this is the basic idea about underfitting. Now let's see how we can avoid underfitting. So we can increase the model's training time, and also we have to increase the number of features to avoid underfitting. So this is the basic idea about overfitting and underfitting. Now moving to the question number 22, what is RMSE in a linear regression model? RMSE stands for root mean square error. It is computed by taking the square root of MSE. The lower the RMSE, the better the model and its predictions. So this is the basic idea about root mean square error. Moving ahead, we are having the question number 23, what is naive Bayes? Naive Bayes classifiers are a collection of classification algorithms based on Bayes' theorem. It is not a single algorithm, but a family of algorithms where all of them share a common principle. That is, every pair of features being classified is independent of each other. The fundamental naive Bayes assumption is that each feature makes an independent and equal. So this is the basic idea about naive Bayes. Moving ahead, we are having the question number 24, that is, explain univariate, bivariate and multivariate analysis. So now, talking about the univariate analysis involves analyzing data with only one variable, or in other words, a single column or a vector of the data. This analysis allows us to understand the data and extract patterns and trends out of it. For example, analyzing the weight of a group of people. Now, let's move to the bivariate analysis. Bivariate analysis involves analyzing the data with exactly two variables, or in other words, the data can be put into a two-column table. This kind of analysis allows us to figure out the relationship between the variables. For example, analyzing the data that contains temperature and altitude. Now moving to the last one, that is multivariate analysis. Multivariate analysis involves analyzing the data with more than two variables. The number of columns of the data can be anything more than 2. This kind of analysis allows us to figure out the effects of all other variables on a single variable. For example, if you want to analyze data about house prices, which contains information about the houses such as locality, crime rate, area, the number of floors, etc. So this is the basic idea about univariate, bivariate and multivariate analysis. Now, moving to the next question, what are the different statistical techniques used in data analysis? The first one is the correlation. It establishes and measures relationship between different variables. For example, let's suppose if you are having a data set, so in that data sets you will be having features as well as the output variable. So basically the correlation will establish the relationship between the features and the output variables. Now talking about the regression, it allows identifying if the evolution of one variable affects the other. So we are having different types of regression such as linear regression, multiple regression, right? So in linear regression we can see that one variable can affect the other dependent variable. For example, you can consider experience versus salary. So as the experience will increase, your salary will also increase. So this is an example of linear regression. Now, the last one is time series. It predicts future values by analyzing sequence of past values. So basically, you can use the time series for the forecasting, right, based on the past data. So this is a basic idea about the different types of statistical techniques used by data analysts. Moving next, we are having type 1 and type 2 error. So the question is, what is type 1 and type 2 error? Talking about the type 1 error, so type 1 error is also known as false positive. Basically, it occurs when a null hypothesis is rejected based on the statistical findings, even if it is true. For example, if a person is having a symptoms of COVID and he knows that he is COVID positive, but in the end the results come negative. So this is a type of false positive case, right? That is type 1 error. Now talking about the type 2 error, it is also known as false negative. It occurs when the null hypothesis is not rejected based on the statistical finding, even it is false. So this is the basic idea about type 1 and type 2 error. Now moving to the question number 27, what is the difference between where and having? So the first difference that I will tell you about where, that in where you are not allowed to work with the aggregate functions, whereas talking about the having, you can work with the aggregate functions. Now where is a clause which is used to filter records prior to grouping, whereas having clause is used to filter values within a group. Also, where is implemented in row operations, whereas having is implemented in column operations. So now talking about the last point of where clause, this clause can be used with the select, update and delete statements, whereas having clause can only be used with the select statement. So this is the difference between where and having. So now let's move to the next question. Next question is, what are the different types of methods to create a data frame? Now you can create a data frame with the dictionary, with the list. Also you can create a data frame by uploading the CSV file or Excel file. So now let's see the first way, that is dictionary. So here I will create a dictionary with the variable name as dict1, right? So as you know that dictionary will have key as well as value pair, right? So this is the key. So the key is here as student and the value is here Gaurav, Nilesh, Rishabh, Vaseem and Priyansi. So the another key that we are having as marks. So this is a key and the values are here, right? Now if you want to create a data frame, then I have to upload the library, right? So I will just simply write here import pandas as PD. Okay, so here I am writing here as PD. So PD is an alias. So I'll just simply write here PD dot data frame function. Make sure that D and F are capital, and inside that I will put the dictionary, right? So this is a dictionary variable name dict1, right? So when I'm just writing this, you can see that the output will be displayed with the student and marks as the column, right? And here the value of the key will be displayed, that is nothing but Gaurav, Nilesh, Rishabh, Vaseem and Priyansi, and so as the marks. Okay, so this is the way to create a data frame via dictionary. Now if you want to create with the list, so what I will do here, simply I'll just create a list with list1, and here I will simply write Gaurav and 82, right? And then I will just simply write the another name with the marks. So you can see that when I'm writing here PD dot data frame list1, so there will be no column, since I'm just writing here the records. So now if you want to print the column, so I'll just simply write PD dot data frame, and inside that I will pass the list, and I will just pass another parameter with the name columns, and inside that I will just write student and marks. So what will happen when you are executing it, you will see that student and marks are the columns, right? And these are the records. So this is a way to create via list. Now another way, as I already told you, that you can upload a CSV or Excel files to create a data frame. So for that, let's suppose if you are having a CSV file, so you have to write pd.read_csv and inside that the file name. And for the Excel file, you have to write pd.read_excel. So in this way, you can create a data frame even through the CSV or Excel files. So these are the ways to create a data frame. So this is the basic idea about how to create a data frame. Now moving to the next question, that is question number 29, extract, store and type columns from the data frame. So here you can see that this was our data frame, right? And from this data frame, I want to only extract, store and type, right? So our data frame variable name was df. So I'll just simply write here df, and inside that I'll just create a list and I will just write the column name, that is store and type. So you can see that this is a way to extract, store and type columns from the data frame. So now coming to the question number 30, is telling that fetch the records where size is greater than 50,000 and type is B. So you can see that it's basically a condition based statement, right? You have to write here condition. So first I have to write here the data frame, and our data frame is having the variable name as df. So inside that df, I will just write the column name as df size and greater than 50,000, and here I will use the AND operator. And what is the type here? Type here is B, right? So simply I will write here df type is equal to B. And when you are writing this code, you can see that here we will get the type that is of B type and size is greater than 50,000. So this is a way to fetch the records where size is greater than 50,000 and type is B. Now moving to the question number 31, is telling that add a new column with an address. So in our data frame, let's suppose if you want to add any new column. So the data frame variable name is df. So I'll just simply write here df, and inside that I will just write here address. So our new column has been generated. Now I have to put the value there. So I'll just simply write random values. Let's suppose Bangalore, Chennai, Gurugram, Mumbai and Delhi. So when you are writing df.head, then it will display the new column also along with the records inserted in it. So this is a way to create a new column. Now moving to the question number 32, what are the different types of sampling techniques? So there are different types of sampling. So now let's see the first one, that is simple random sampling. In a simple random sample, every member of the population has an equal chance of being selected. Your sampling frame should include the whole population here. To conduct this type of sampling, you can use tools like random number generators or other techniques that are based entirely on your choice, right? So this is the basic idea about simple random sampling. Now, let's see what is systematic sampling. Systematic sampling is similar to simple random sampling, but it is usually slightly easier to conduct. Here, every member of the population is listed with a number, but instead of randomly generating numbers, individuals are chosen at regular intervals, right? Moving ahead, we are having the cluster sampling. Cluster sampling also involves dividing the population into subgroups, but each subgroup should have similar characteristics to the whole sample. Instead of sampling individuals from each subgroup, you randomly select entire subgroups. So this is the idea about cluster sampling. The next one is the stratified sampling. It involves dividing the population into subpopulations that may differ in important ways. It allows you to draw more precise conclusions by ensuring that every subgroup is properly represented in the sample. Alright guys, after that we are having the purposive sampling. Purposive sampling refers to a group of non-probability sampling techniques in which units are selected because they have characteristics that you need in your sample. So these are the different types of sampling techniques. Now coming to the question number 33, what are the different types of charts that Tableau provides? So there are several charts that Tableau used to provide, starting from bar chart, line chart, pie chart, maps, Gantt chart, scatter plot, tree map, box plot, density maps and many more. Okay, let's move ahead. Now coming to the question number 34, explain hypothesis testing. Now let me give you an idea about the hypothesis testing. Talking about the hypothesis testing, it is the process of testing assumptions for a population parameter on a sample of data. The process involves different hypotheses and statistical proof to accept or reject the hypothesis. Here, the null hypothesis is represented by H0, whereas alternate hypothesis is denoted by H1. Now, let's see the steps involved in hypothesis testing. The first one is stating the hypothesis. Moving ahead, we are having the collect data. Then we will see the evidence to fail or accept the hypothesis. Then we will test the hypothesis, and according to that, we'll make the decisions. For example, let's suppose there is a student with height more than 5 feet have BMI more than 20. So this will considered as a null hypothesis. Now, what will be the alternate hypothesis? The students with height more than 5 feet do not have BMI more than 20. So this is our alternate hypothesis. Now, what we'll do, we'll apply here a statistical test to support the hypothesis, whether we have to accept null hypothesis or reject null hypothesis, right? And at last, we'll make our decisions. So this is how hypothesis testing works. Moving to the next question, what do you mean by the term data wrangling? Data wrangling, also called data cleaning, data remediation or data munging, it refers to a variety of processes designed to transform raw data into more readily used formats. The exact methods differ from project to project depending on the data you are leveraging and the goal you are trying to achieve. Now let's see some examples of data wrangling. It is used to merge multiple data sources into a single dataset for analysis. It also identifies gaps in data and either filling or deleting them. It deletes data that's either unnecessary or irrelevant to the project you are working on. Data wrangling can be manual or automated process. In scenarios where datasets are exceptionally large, automated data cleaning becomes a necessity. That being said, this is the basic idea about the data wrangling. Now, moving to the question number 36, what is the difference between count, count blank, and countf in Excel? The count function in Excel is used to count cells that contains numbers. Talking about the count blank, it is used to count cells that are blank. Now what about the countf? Countf is used to count the cells that meets a specified criteria. Now moving ahead to the next question, we are having what is the difference between correlation and covariance? Talking about the covariance, it indicates the direction of the linear relationship between variables, whereas correlation is a statistical measure that indicates how strongly two variables are related. For example, in a data set, we are having the feature and the dependent variable. So what will correlation do here? It will see how much a variable. So here, the correlation will tell the collinearity between the two variables. Now, next point is covariance range from minus infinity to infinity, whereas correlation ranges from minus 1 to 1. Right? Now talking about the covariance, it is affected by scale of a variable, whereas correlation is not affected by a scale. So this is the difference between correlation and covariance. So now let's see when do we use normalization and standardization. So first I will discuss about the normalization. Normalization is used when features are of different scales. Also, it scales values between 0 to 1 or minus 1 to 1, depends. Along with that, the important point is note here, it is really affected by outliers. Now, if you want to implement normalization, then there is a library known as scikit-learn. So using scikit-learn, you can apply a transformer called min-max scaler. Now, it is useful when we don't know about the distribution. So now, after understanding what is normalization, let's see standardization. So the most important point of standardization is that it is useful when the feature distribution is normal or Gaussian. Talking about the standardization, it is used when we want to ensure zero mean and unit standard deviation. Also, it is not bounded to a certain range like normalization. In normalization, the range was from 0 to 1 or minus 1 to 1. But here, it is not bounded to a certain range. Along with that, it is much less affected by outliers. So here also there is a scikit-learn library that provides a transformer called standard scaler. So if you want to standardize your data, you can apply this library. So this is the basic idea about normalization and standardization. Now let's move to the question number 39. So what is the use of p-value? We use the p-value to understand whether the given data really describe the observed effect or not. Basically, p-value is the measure of statistical importance of an observation. It is the probability that shows the significance of output to the data. If the p-value is less than 0.05, we will reject the null hypothesis, or we will accept the null hypothesis if it's greater than 0.05. So this is the basic idea about p-value. Moving to the last question for this top 40 data analyst interview question. What is a skewed distribution? A skewed distribution takes place when one tail is longer than the other. So there are basically two different types of skewed distribution. The first one is left skewed distribution and the other one is the right skewed distribution. Talking about the left skewed distribution, it occurs when the long tail is on the left side of the distribution, whereas in right skewed distribution, it occurs when the long tail is on the right side of the distribution. Now, let's see the figure to understand in a simpler way. So here you can see that in this graph, the tail is on the left side, right? So what is it? This is a left skewed distribution. And here the tail is on the right side. So this is a right skewed distribution. Okay. In left skewed distribution, mode is greater than median and median is greater than mean. You can clearly see that mode is greater than median and median is greater than mean. Now talking about the right skewed, here the mean is greater than the median and the median is greater than the mode. Also talking about the left skewed distribution, it is known as negatively skewed distribution, whereas right skewed distribution is known as positively skewed distribution. So this is the basic idea about the skewed distribution.
Just a quick info, guys. Intellipaat offers state-of-the-art data analytics course in association with IITM Pravartak. Through this course, you can learn all the important tools and concepts of data analysis such as Power BI, data wrangling, data mining, etc. from esteemed IIT Madras faculties and industry experts. With this course, We already have helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take a first step towards career growth in the field of data analytics.
Technology is thriving and it is impacting each and every business sector, be it healthcare, education, research, or innovation. And since the world is moving towards a new age of technology, the possibilities of employment are increasingly abundant. But people are not just looking for employment these days. In the context of past, never has there been such a large exodus of people seeking better prospects that include potential for high salary, remote work opportunities, flexible working circumstances, and office respect, etc. Data science, analysis, or engineering end up being one of the most sought after positions of current times. While all these three disciplines appear to be the same, the credentials and job descriptions differ greatly. But for those looking to make a quick switch to a different field without having to spend years studying, becoming a data analyst may be the right fit. And today, with this video, we are going to explore how you can launch this journey of becoming a data analyst. But before we do that, make sure you guys hit that subscribe button and bell icon so that you never miss any update from Intellipaat YouTube channel. First of all, let me help you contemplate what this field of data analysis is all about. Since all of us use mobile phones, we know that different companies are collecting loads of data all the time. But in its raw form, this data doesn't really mean anything. This is where data analytics comes in. Data analytics is the process of analyzing raw data in order to draw out meaningful, actionable insights which are then used to inform and drive smart business decisions. A data analyst will extract raw data, organize it, and then analyze it, transforming it from incomprehensible numbers into coherent, intangible information. Having interpreted the data analyst will then pass on their findings in the form of suggestions or recommendations about what the company's next step should be. You can think of data analytics as a form of business intelligence used to solve specific problems and challenges within the organization. It's all about finding patterns in a dataset which can tell you something useful and relevant about a particular area of the business. How certain customer groups behave, for example, or how employees engage with a particular tool. So if I have to put forward who data analysts really are, then I would say data analysts are the people who have capacity to convey a story that data entails. They take existing data and utilize technologies like SQL, Excel, and data visualization tools like Tableau to create visuals and reports that represent the current state of data. Besides that, while dealing with complex data, they also require a fair bit knowledge about R and Python programming. Not only the coding expertise, but this role demands a great understanding of mathematical skills, especially about statistics and probability. I hope you guys now understand the basic responsibility of data analyst. Moving forward, let me tell you guys about the career prospects this field brings to the table. According to the research done by careerfoundry.com, there are currently more than 86,000 open jobs worldwide that are seeking data analytics skills coupled with massive shortage of data talent. In many cases, these positions are no longer simply titled as data analyst. That's because nearly every industry benefits from data analysis, and data jobs are branching off into a variety of different niches. Niches such as finance, business, healthcare, e-commerce, and marketing. To help you visualize major types of organizations hiring data analysis, we have divided them into 5 categories. Those categories are business intelligence, finance, sharing economy services, healthcare, and entertainment. Business intelligence is one of the top 3 industries hiring data analysts right now. While doing a thorough sweep on Indeed, we found out that almost 20% of data analytics jobs currently open globally are in the business intelligence sector. Companies such as Amazon, VMware, Netflix, Paytm, Wipro, Hitachi, Oracle, LTI, EY, HTC, and many more are currently hiring candidates who possess strong analytical skills. Data analysts in BI sector combine data gathering, data storage, knowledge management, and data analysis to evaluate and transform big data into actionable insights that can be used to inform business strategies, operational optimizations, and other important decision making. If I have to talk about the paycheck about BI analysts, then in USA it averages around 87,000 US dollars per annum, and in India it averages around 8.33 lakh rupees. Then we have finance. Finance was truly the first industry to take full advantage of big data to advance their business ventures. Finance positions, especially fintech positions, are rather lucrative for data professionals. Plus, finance is responsible for a large chunk of jobs in the northern hemisphere. Finance companies like investment banks, venture capital firms, and consumer banks use data analytics to conduct risk assessment, inform investment decisions, spot trends, and make predictions. The big banking tycoons such as PayPal, Barclays, Morgan Stanley, JP Morgan Chase, Bank of America, Citibank, Deutsche Bank, BlackRock, Vanguard Group, Goldman Sachs, Allianz, and many more consistently hire data analysts who understand how the financial market works. The salary for financial analysts in USA averages around 83,660 US dollars per annum, and in India it averages around 9 lakh rupees. Third up is sharing economy services. This field is kindly hot right now, and they are hiring data talent in nearly every urban area. Now you must be wondering what exactly are these sharing economy services are. Well, think about Uber, Lyft, Rover, Airbnb, Verbo, Zomato, Swiggy, Rapido, eBay, or Ola. All these companies fall under the category of sharing economy services. If you look into their apps and web platforms, you'll find services from ride sharing to grocery delivery to a room rent for night or pet care. And in all of them, data is used to sort tasks for workers, set prices, grow their use bases, drive advertising, catalog data, and recommend services. Furthermore, roles in this industry are usually simply titled as data analyst, data scientist, or data engineer. These jobs are essentially tech adjacent because the service that most of these firms are delivering is actually an application and web platform. The salaries for data analysts in the field averages around 83,600 US dollars per annum in USA, and in India it averages around 8 lakh rupees. Next up is healthcare. Data analytics is rapidly being employed in healthcare, an area that has historically depended mainly on paper data systems. Data in this context can drive insights on practitioner performance, determine drug makeups, sort clinical data, identify diseases present in images, analyze patient behavior, and much more. Healthcare is actually one of the slowest to turn to big data, but most certainly the industry that could benefit most from data analyst insights. With the rising stars like the ever-improving electronic health record systems, healthcare and pharmaceutical apps, online patient portals, telemedicine and teletherapy, healthcare is blossoming into a data-heavy field with an abundance of career options. Companies such as CVS, Healthcare.com, Aster, United Health Group, McKesson Corp, Care Partners, Humana, Siemens Healthineers are consistently looking out for healthcare analysts. The salary for healthcare analysts in USA averages around 79,715 US dollars per annum, and in India it averages around 9.8 lakh rupees. Finally, we have entertainment. The entertainment sector is developing at a breakneck pace. Streaming services are dominating this sector and they are fueled by big data. Netflix uses data so well that they can propose movies to its viewers with an 80% success rate and save over $1 billion each year. Each user of a digital streaming service is churning out tons of data while they consume the content that subscription services offer. Everything from when a user paused, scrolled, clicked, what time they used the app, what the weather is like where they are, their demographic information, which advertisements they click on, and more is being collected continuously. This data is further used to drive revenue, tailor recommendations, and improve the offerings of streaming companies. Companies such as Amazon, Netflix, Disney, Comcast, Sony, Apple, AT&T, Tata Communications, HBO are always on the lookout for skilled data analyst professionals. The salaries for data analysts in entertainment industry averages around 79,715 US dollars in USA, and in India it averages around the whopping amount of 12 lakh rupees. Well, now that we know data analytics has abundant job opportunities in the market right now, and it's quite a lucrative job role that you guys can take on. Not only that, but its challenging nature allows you to gain that sense of satisfaction as well. So moving forward, let's try and understand how you guys can approach and launch your journey of becoming a data analyst. Well, actually there are two ways you could go about this career choice based on your experience. First scenario is when you are a fresher, and the second scenario is about when you have few years of experience on your back. Let's first discover how you can become a data analyst if you are a fresher with no knowledge about the field of data analysis. Well, the position of data analyst requires strong analytical skills. So being fresher, it's best if you start your data analysis preparation by revising concepts of mathematics. If you have completed the first few years of college, you already have learned all the mathematics required. Cool, right? Unlike data science, where you need to have a deep understanding of linear algebra, calculus, and further mathematical disciplines which can take years to master, most data analyst positions will require just the basic mathematics that you learned early on in your education. Therefore, this phase should be just a review of what you have already learned and possibly knocking the cobwebs of statistics and probability knowledge. After gaining some confidence in math, it's time to move on to the next phase, that is programming. Programming requirements for data analysts can vary widely across fields and positions. However, most data analyst positions can be fulfilled with the knowledge of Excel, SQL, and some simple Python or R. While Excel may seem old school, it's still much used and very valuable tool that is easy to learn and produces quick results that explain the current state of your data. Excel is mostly used for analyzing the data to determine summaries and trends. SQL is used to retrieve data for analysis from databases, whereas Python and R are essentially the two go-to data analysis programming languages used to derive insights from complex datasets. At the end of this phase, you should be able to write codes. It's not like that you require extensive knowledge about these programming languages, except for the parts that are necessary for conducting the analysis. Third phase we have is understanding data analysis. Data analysis is the meat and potatoes of what a data analyst does. As a result, it's critical to understand how this procedure is meant to work. The process of carrying out this data analysis can simply be broken down into 5 parts. First one is determining driving question. This is important because recognizing the driving question or overall objective of the data analysis helps you set the stage for what data you need and what the results of the analysis should reveal. Then the next stage is data collection. It's important to understand what sort of data you need to collect, and defining the feature or parameters you need to answer your driving question will help you collect the right data for the job. Then comes third stage. Third stage in data analysis is data cleaning. This is the stage where we convert the collected raw data into something that can be analyzed. This involves amending or removing incorrect or irrelevant data, checking for data completeness, removing duplicates, or producing important values such as mean and average. Next stage we have is data analysis. Here you'll look out for insights within the data, including patterns, relationships among features, and possibility of predictions. Finally, we have interpretation. In this step, you can actually produce the visualizations of your findings, generating easy to understand dashboards, creating presentations that provide thorough key performance attributes are the major tasks involved in this stage. Well, just knowing these things is not enough. You will require hands-on exposure to take on difficult industry projects. So it's always a better option to go for bootcamp certification, which can help you become the master of all these stages.
Let's have a quick quiz question, guys. And your question is, in order to find the best fit linear line in linear regression, the slash of the coefficient and the intercept of error is minimized. And your options are optimal values, linear lines, linear polynomial, or none of these.
Having said that, let's move towards the next phase, that is data visualization. I know, I have already covered visualization among the 5 points of data analysis. But it gets its own special phase here because it plays such a large part in daily tasks of data analysts. Being able to create compelling, accurate visualization is one of the fundamental cornerstones of this career. Therefore, special attention should be paid to these skills. You should learn about frameworks such as Tableau, Power BI, Data Wrapper, Plotly, etc. Alright, now that brings us to the 5th stage, that is gaining industry knowledge. By now, you have learned how to perform the data analysis, but we saw that data analysis expands across multiple fields from finance to healthcare. So it is critical that you gather the insights into what are the KPIs of industries, what sort of data you'll get to analyze, and how the industry functions, etc. After that comes the next stage, that is building portfolio. Building your personal portfolio is the most enjoyable aspect of this roadmap. You'll have the opportunity to create personal data analysis projects that will display your talents and convince companies that you deserve a place in their team. These projects should incorporate all of the abilities you have acquired thus far and be relevant to your intended industry. These projects should be one of a kind, inspired by one seen on the internet or pro bono work done for a small business in your region. A fast search on the internet may provide you with a plethora of ideas and datasets to get this done. Finally, the last phase we have here is creating job application and preparing for interviews. Well guys, by now you have developed the skills. You have built your portfolio. Now you just need to tie it all together and get that job. Mention your project's technical skills on your resume. Apply for different job openings on different web portals. Be patient. You'll get that interview schedule call. Meanwhile, start preparing for that interview. Go through different interview preparation questionnaires and also do mock sessions with your friends to gain more confidence. Now that we have gone through the roadmap for total beginners, it's time we divert our attention towards people with experience. For experienced people, the process of transition is a tad bit easier since they have been into the industry for long and they have sensed how it functions. All they have to do is master the hard skills and provide the demonstration of the same through their portfolio. Well, let's look at the roadmap for experienced people step by step. The first step we have is getting familiar with fundamentals. This first step is all about immersing yourself in the world of data analytics and getting familiar with some of the key tools and principles. Actually, you can split this step into 2 parts. Part 1 will be embracing the theory behind data analytics, and part 2 will be getting hands-on with some key data analytics tools. Before you do anything else, absorb as much theory as you can about data analytics. Familiarize yourself with the kinds of analysis that data analysts must perform. Discover concepts such as regression analysis, cluster analysis, time series analysis, cohort analysis and factor analysis, etc. Next stage is commit to the process with structured course. Now it's time to get serious about your career change. While the internet is full of wonderful and free resources, it won't give you the structured approach or the hands-on practice that you need. If you want to become an employable data analyst, the most effective way to do so is through a specialized program or course. Intellipaat thus provides state-of-the-art certifications that are designed accordingly to different sets of industries that data analytics spans across. And it can definitely act as a ladder for your career change with an exciting salary hike. That being said, let's move to the next step, that is build your portfolio. Your portfolio is arguably the most important asset you'll have when it comes to applying for jobs. It showcases how you work and demonstrates to employers that you have not only mastered the right practical skills, but that you know how to apply them in the real world. Being an experienced person, make sure that you take on some of the complex projects out there in your targeted industry. Kaggle is one of the biggest resources of datasets, from where you can look into the number of problems uploaded by multiple companies. Try to tackle them and produce insights that can contribute towards the business. After done with that, the last phase will be networking, creating job applications and preparing for interviews. Networking can really speed up your process of career transitions or change. So make sure you build that camaraderie with your colleagues and friends from the industry. After that, develop your resume and write emails querying about referrals. Be patient with the process. And meanwhile, arrange mock sessions with the people from the same field to gain insight into what improvements you need to make. That will allow you to contemplate the best way to showcase your skills and get that offer letter from the employer sitting on the other side of table. That's all we have for this video. I hope this video was informative for all of you guys out there willing to take your career to new heights with data analytics. I wish you all the best in your journey of becoming data analyst. Thank you for being here till the end of this video. If you have liked the video, make sure to hit that thumbs up button and also don't forget to enable subscribe button to never miss any update from Intellipaat YouTube channel.
Just a quick info, guys. Intellipaat offers state-of-the-art data analytics course in association with IITM Pravartak. Through this course, you can learn all the important tools and concepts of data analysis such as Power BI, data wrangling, data mining, etc. from esteemed IIT Madras faculties and industry experts. With this course, we already have helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take a first step towards career growth in the field of data analytics.